Hi everyone, welcome to PrepFusion. So finally we are going to start our most awaited subject, that is communication system. So we are starting with random variable and random process. There are basically 4 chapters. First chapter is analog communication, then random variable random process, then digital communication, and then there is information theory and line coding. So we are starting with random variable and random process because people consider this is the toughest topics, right? In communication system, those who have already studied this subject, they would feel that random variable and random process are the toughest topics of this particular subject. So we are starting with that so that you can understand that toughest subject in a easier manner. Okay, in the easiest manner you will be able to understand the toughest topic. So yeah, these 4 topics we are going to cover in this particular video: introduction to random variable, PMF, PDF, CDF. Then we will see some basic mathematics. Then we will study about 2-dimensional random variable, and then we will see the statistical parameter of random variables. Okay. So this is not the complete random variable. One marathon is of random variable. Another marathon will also come for random variable only. Okay. So this will be roughly around 10.5 hours of video. So one marathon for random variable, another marathon for random variable will also come, and then for random process the marathon would come. Okay. So this will be the flow, right? And what is our expectation and all these kind of things. So first thing is, where will be the notes? So notes will be in our Telegram group. So you can go to the description, there the link will be pasted, or you can go to Telegram and you can simply type PrepFusion. So you will get the group. Okay, you need to type PrepFusion, you will get the group. So from there notes you can access. So there I will put the notes. I am expecting that I will get 10,000 views before the next marathon. Just as we get 10,000 views, look, next marathon will surely come. Random variable and random process will be completed on YouTube for sure. There is no doubt about that. Okay, but if I am putting so much of effort, you will realize what kind of content is there. So first I am asking you, you watch the content, and after that you share with the people. Share with your batchmates, share with the aspirants, and let them know what kind of content is being taught here. So 10,000 views we are expecting. Okay, just as we get the 10,000 views, I will upload the next marathon as well. And likes target, I expect you 400 people can at least like this content. I'm not asking you to like right now only. First study it, and then you see what kind of content is there, and based on that you like it or you dislike it, whatever you want to do, right? So yeah, so that's it. Let's get started now. So we are going to start our subject, random variables. What all are the prerequisite? Everything I will talk about that. Okay. So there is no major prerequisite, but everything, whatever that you need to know before starting this subject, everything I will talk about in the lecture video only. So let's get started. Yeah. Thank you very much. Hi everyone, welcome to PrepFusion. So finally we are going to start our most awaited subject, that is communication system. So in communication system, like on top level you guys would be knowing, there are 4 chapters: analog communication, then there is random variable random process, then there is digital communication, and then there is information theory and line coding. So on top level these 4 chapters are there, right? So usually people start communication from analog communication, right? Usually it is started from here, but it is the easiest topic. It is the easiest topic of complete communication system. Like it is very easy, very straightforward. But people find random variable random process tough, right? They find it very tough. And then toughness level goes to digital communication, and then toughness level goes to information theory. And from these 3 chapters only 90% of the question will be asked. 10% could be coming from here. So they are very important, right? And in these 90% only, this is the most important chapter, RVRP. Because if you don't study random variable random process, then you will not be able to study digital communication as well, right? So out of these 90%, 50% question would be coming from here only. So this is the most important chapter, random variable and random process. So first we are going to cover this particular chapter because you guys would be very like energetic right now, right? You guys would be thinking that, okay, yes, we are going to start communication system now, so we will do in a very good manner. And this is the toughest topic which you will be able to do in a very easy manner. So don't even think that it is a tough topic, okay? Random variable, random process, a very easy chapter. Very straightforward, it is just mathematics. So for first few hours, okay? First few hours you might feel like that, sir, it is going towards mathematics. For first few hours you might feel like that, sir, it is not engineering, it is mathematics. Yeah, it will feel like mathematics, but once we get into digital communication, you will realize that why we spent so much of time on random variable and random process. So for first few hours it might feel like mathematics, but surely it will not be boring. 100% it will not be boring, it will be very interesting. Secondly, if you are comfortable with signal system, then it will be advantage for you. Okay. Along with that, if you are comfortable with engineering mathematics as well, then more advantage. So if you have covered signal system, engineering mathematics, if not engineering mathematics, then at least that EMFT part. In the EMFT there is first chapter, right? Vector algebra, coordinate system and vector calculus. In EMFT there is a first chapter which is common for electrical and EC both. That chapter is vector algebra, vector calculus, integral calculus. Okay, and coordinate system as well. So if you are comfortable with that particular chapter, then it will be an advantage for you. Okay, if you are comfortable with engineering mathematics, then it is advantage for you. So signal system is must. You should have done signal system. After that, either engineering mathematics or EMFT, one of them. EMFT first chapter, only first chapter, not transmission line, all these kind of things, no. Only EMFT first chapter or engineering mathematics. If you are done with engineering mathematics, then also it is fine. If you are done with the first chapter of EMFT, then also it is fine. Are you able to understand this point? So these are kind of prerequisite. Signal system should be covered and engineering mathematics. Okay, and if not engineering mathematics, then at least the first chapter of EMFT. Fine. Now let's get started with our chapter that is known as random variable. So we will see what is random variable, but before that, let's see some basic terms. So the first term is random experiment. What do you mean by random experiment? So any experiment which is random. What do you mean by random? Random means you don't know the result. You don't know the final result. If I toss a coin, head may also come, tail may also come, right? If I toss a coin, head may also come, tail may also come. So when I am tossing a coin, I don't know what result would come. So this is a random experiment. When you roll a dice, 1 can come, or 2 can come, or 3 can come, 4 can come, 5 can come, 6 can come. But you don't know which of these number will come. So this is also a random experiment. But if you toss a coin which is both sided head, that means you surely know that head only will come. Right? If you toss a coin which is both sided head, that means you know that only head will come. That means it is not a random experiment. So what is the definition of a random experiment? So a setup where you know all possible outcomes, but you can't predict the exact outcome before it happens. So here you know that either head will come or tail will come. Either 1 or 2 or 3 or 4 or 5 or 6 will come, but you don't know what exactly the number would come. So this is the meaning of random experiment. A very simple definition, right? Now what do you mean by sample space? So sample space means set of all possible outcomes. So when you toss a fair coin, what you can get? Either head or tail. So it is the set of all possible outcomes, head and tail, right? Head or tail. When you roll a dice, what you can get? 1, 2, 3, 4, 5, 6. So what is the definition of a sample point? What is the definition of a sample space? Sample space is list of all possible outcome of a random experiment. You did this random experiment. What is the list of all possible outcomes? So 1, 2, 3, 4, 5, 6. When you toss 2 coins simultaneously, so what all possible outcomes you can get? Head you can get, head tail you can get, tail head you can get, and tail you can get. What does this mean? That means on first coin you got head, on second coin you got head. Or it may happen that on first coin you got head, on second coin you got tail. On first coin you got tail, on second coin you got head. On first coin you got tail, on second coin you got tail. So this is the meaning of sample space, that all the possible outcomes have been listed in a set. Possible outcome of what? Possible outcome of a random experiment, right? And what do you mean by sample point? So each element of a sample space is known as sample point. So this is a sample point, head is a sample point, tail is a sample point, 1 is a sample point, 2 is a sample point, 3 is a sample point. So each element of a sample space is known as sample point. So this is the definition. Each element of a sample space is known as sample point. Very, very simple thing. Random experiment. You do an experiment where you know all the possible outcomes, but you can't predict the exact result. What do you mean by sample space? Listing out all the possible outcomes of a random experiment. What do you mean by sample point? Each element of a sample space is known as sample point. Very, very simple thing, very straightforward. Now let's go to our chapter, which is random variable. So let's understand the meaning of random variable with example. So what we are saying, X is a random variable. You can understand random and it is a variable. So x is a random variable that represents the number of heads appearing when two coins are tossed simultaneously. So when what you are doing, what is the experiment here? What is the random experiment here? Two coins are tossed simultaneously. So this is your random experiment, right? What x is representing? X is representing number of heads appearing when two coins are tossed simultaneously. This is how you are defining your random variable. Now what is your random experiment? Random experiment is you are tossing two coins simultaneously. That means what will be your sample space? That you can get head head, head tail, tail head, tail tail. Now what random variable x is saying? Random variable x is saying that whatever the outcome that I am getting, I will pick those outcomes. I will pick those outcomes and I will count the number of heads. So let's just say I got head head. So what this random variable will do? It will pick this head head and it will count the number of head. What is the number of head? 2. What if I got head tail? What this random variable will do? It will pick this head tail. That means it will pick this sample point and it will count the number of heads. What it will count? It will count the number of heads. So how many number of heads are there? 1. It will pick tail head. How many number of heads are there? 1. It will pick tail tail. How many number of heads are there? 0. That means this random variable x can take the values 0, 1 or 2. Are you able to understand this point? This random variable can take value 0, 1 or 2 based on the random experiment that you have done. What is the random experiment that you have done? The random experiment is you are tossing two coins simultaneously. If I toss two coins simultaneously, my sample space is head head, head tail, tail head, tail tail. So what this random variable will do? It will take up all the sample points and it will ask them how many number of heads you are having. So this sample point will say I am having 2 heads. This sample point will say I am having 1 head. This sample point will say I am having 1 head and this sample point will say I am having 0 head. So what is the formal definition of a random variable now? So a random variable is a function that assigns a real number to each sample point of a random experiment based on some predefined condition. What is the condition? The condition is the number of heads. So this is the complete definition. You can write it down on your own. A random variable is a function that assigns a real number to each sample point of a random experiment based on some predefined condition. That predefined condition is the number of heads here. Are you able to understand this point? So let's just say my sample space was lambda 1, lambda 2, lambda 3 and so on. So here lambda 1, lambda 2, lambda 3, what these are? These are my sample points. This is a sample point, right? This is also a sample point. This is also a sample point. So all these are sample point. Now what your random variable x will do? Your random variable x will go to this sample point. It will go to this sample point and it will assign a value to this particular sample point. So it went to this particular sample point. It went to this particular sample point and it assigned a value 2 to this particular sample point. So it will assign a value, let's just say 2. Now it will go to another sample point. It will assign it a value. Let's just say it assigned it a value 1. It will go to another sample point. It will assign it a value. Let's just say it assigned the value 1 only. It will go to another sample point. Let's just say lambda 4. It can assign another random value. Let's just say that random value is 0. So x here was taking values 0, 1 or 2. Are you able to understand this point? So these are the values which x was taking. Why I am putting small x? Small x because I am saying that my capital X, which is my random variable, is taking small x values. These small x values are 0, 1 or 2. Okay, that's why I am putting small x here. Are you able to understand this point? this random variable x is taking 0, 1, 2 values, and those values I am calling by small x. So every random variable will take some real values. It could be 0, 0.1, it could be negative as well, it could be positive as well, it could be rational as well, it could be irrational as well. It will take up some real values. A real random variable will take up some real values. We will see more examples, it will become more clear to you. Okay. So as of now, what we are saying, x was a random variable which was representing the number of heads appearing when two coins were tossed simultaneously. So when two coins were tossed, we got the sample space. From that particular sample space, we got the random variable values. Now what if in the question they are asking, find the value of px equals to 0. That means you need to find the probability such that your x is taking the value 0. What do you mean by that? When your x will take the value 0, what they are asking, probability of x taking the value 0. That means if you get telltale only, when your random variable x takes the value 0, when you get telltale only. So if you toss a coin, if you toss two coins simultaneously, what is the probability of getting telltale? That is 1 by 4. That's it. What they are saying, find the probability of a random variable taking the value equals to 0. What does that mean? That means number of heads should be 0. What is x here? X is number of head. So number of heads should be 0. And when you toss two coins simultaneously, what is the probability that number of heads should be 0? That is 1 by 4, because your desired condition is only getting telltale. Let's see the next question. What is the probability of random variable x taking the value 1? What is the probability of random variable x taking the value 1? What does that mean? What is the probability when you toss two coins simultaneously? What is the probability of getting number of heads equals to 1? When you toss two coins simultaneously, what is the probability of getting number of heads equals to 1? That means either you can get head tail or you can get tail head, right? In probability, whenever I say or, that means plus, and whenever I say and, that means multiplication. Okay, or dot I can put. Okay, whenever I say or, that means plus, whenever I say and, that means multiplication. Very basic of probability. I hope you know very basics of probability, right? So what I am saying, the number of heads should be 1 when I toss two coins simultaneously. That means my desired condition would be head tail or tail head, right? So what is the probability of getting head tail? That is 1 by 4. And what is the probability of getting tail head? That is also 1 by 4. So what will be the probability? 1 by 2. Or basically, when you toss two coins simultaneously, what is the probability of getting number of heads equals to 1, which is head tail tail head. So 2 by 4, that means 1 by 2. What about x equals to 2? What is the meaning of that? What is the probability of random variable x taking the value equals to 2? What is the probability of random variable x taking value equals to 2? What does that mean? What is the probability that when you toss two coins simultaneously, the number of heads should be equals to 2? Number of heads should be equals to 2. So when I toss two coins simultaneously, the number of heads should be equals to 2. That means I want to find the probability of getting head. So out of 4, only one case is there. So 1 by 4. Now px equals to 3. What is the meaning of this? When you toss two coins, what is the meaning of px equals to 3? What is the probability of random variable x taking the value equals to 3? What is the probability of random variable x taking the value equals to 3? What does that mean? When you toss two coins simultaneously, what is the probability that number of head should be equals to 3? I am tossing two coins, but I need number of heads equals to 3. Is it possible? No. So what is the probability? 0. You are tossing two coins, but number of heads should be 3. Maximum head you can get 2 only, no? And here also you saw that x can take only values 0, 1, 2. That means what will be the probability of x taking the value 3? That would be 0. Are you able to understand this point? Right? What about this one? probability of random variable x, probability of mode of x less than equals to 1. Can you solve this inequality? I hope you know how to solve these kind of inequality. You will get minus 1 to 1. In basic mathematics we studied. Okay. Mode of x less than equals to 1. That means x would be between minus 1 to 1. So your x would be between minus 1 to 1. But equal to sign is there. That means you need to find the condition for all the values of x lying between minus 1 to 1. But you know one thing, that x can take value 0, 1 and 2 only. That means what I need to find? I need to find x equals to 0 or x equals to 1. Basically, I need to find the probability. What does this statement say? What is the probability such that random variable x takes the value between minus 1 to 1? What is the probability such that random variable x takes the value between minus 1 to 1? That means random variable x can take value either 0 or 1. It cannot take minus 1 value, which I already know. Look, it can take x equals to minus 1 value, but I know that probability of taking x equals to minus 1 is 0. So why should I write that? Someone will say that, sir, it can take the value x equals to minus 0.333 as well. But you know that you will never get number of heads equals to minus 0.33. It doesn't make any sense. You know that either I will get 0 head or I will get 1 head between minus 1 to 1. Here two condition will not come, because you know that the value of x should be between minus 1 to 1 only. That means 2 will not come. So only these two probability will come. Either you can get x equals to 0 or you can get x equals to 1, right? Why plus sign came here? Why not multiply? If I say give me a value between minus 1 to 1. So if you give me 0, then also I will be happy. If you give me 1, then also I will be happy, right? What I am saying, give me a value between minus 1 to 1. So if you give me 0 or if you give me 0 or if you give me 1, in both of the cases I will be happy. That means you don't need to give me 0 and 1. You need to give me 0 or 1, right? Are you able to understand this point? Why plus came? In case of or, always plus will come. In case of and, always multiplication will come. So if I say my x should be between minus 1 to 1. So either x could be 0 or it could be 1. It could be 0.33. It could be minus 0.33. It could be 0.5. It could be minus 0.5. It could be minus 0.7. It could be plus 0.7. It could be plus 0.8. It could be plus. It could be minus 0.8. It could be plus 0.9. It could be anything between minus 1 to 1, including minus 1 and 1 as well, because there is equals to sign. So that's why or, right? So now you know that what is the probability of random variable x taking the value 0. That means what is the probability such that number of heads are 0, 1 by 4. And what is the probability such that number of heads are 1, that is 1 by 2. So answer is 3 by 4. Is that clear to you? So right now we are just understanding the basic meaning of random variable. I hope it is being clear to you. Well and good. Let's see another example. Y is a random variable that represents the number of heads appearing when 3 coins are tossed simultaneously. So what is the experiment here? 3 coins are tossed simultaneously. So what all outcomes you can get? Head, 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 tail, head, tail, head, head, tail, tail, then tail, head, head, tail, head, tail, 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 head, and tail, tail, tail. So these are the outcomes you can get, right? I hope how to write down these outcomes. Like 4 times you write down head, then 4 times you write down tail, then 2 times head, 2 times tail, 2 times head, 2 times tail, then head, tail, head, tail, head, tail, head, tail. So in basic 9th class, in standard 9th or standard 10th, we understand all these kind of things, right? Or you might have seen in the engineering as well, or in first year you would have studied all these kind of things, or even in class 11, 12th as well you have studied these kind of things. So these are the possible outcomes. Now what is your random variable x? So what is the random variable y? This time our random variable is y. So our random variable y is number of heads again, number of heads appearing. So what this y will do? It will go to each sample point and it will ask them how many number of heads you are having. 3, right? It will go to this particular sample point. It will ask how many number of heads you are having. It will say 2. Same will be said by head tail head as well, and same will be said by tail head head as well. Are you able to understand this point? If your random variable y is going to head at tail and ask them how many number of heads you are having, it will say 2. If it goes to head tail head, how many number of heads you are having? 2. If it goes to tail head head, how many number of heads you are having? 2, right? Now if it goes to head tail tail, so how many number of heads you are having? 1, right? And same will be said by tail head tail as well, and same will be said by tail tail head as well, right? And now what if it goes to tail tail tail? How many number of heads you are having? 0. So y can take values which are 0, 1, 2, 3. So every time you don't need to write down this step. Our important part would be this particular step. Y belongs to 0, 1, 2, 3. Basically, if I give you this particular statement that y is a random variable that represents the number of heads when 3 coins are tossed simultaneously, and now I ask you, random variable y can take what values? So you will think, okay, if I toss 3 coins simultaneously, if I am tossing 3 coins simultaneously, that means either I can get 0 head, or I can get 1 head, or I can get 2 head, or maximum I can get 3 head. So these values y can take. So every time you don't need to write down this sample space, every time you don't need to go to each element and ask them what is the value you will get. In the mind you can think, no, that if I am tossing 3 coins simultaneously, then the possibility of getting number of heads, either I can get 0 head, or I can get 1 head, or I can get 2 head, or I can get 3 head. Are you able to understand this point, right? And if I want to explain the concept of a random variable here, so what it actually did, although this concept will not be used anywhere, right? The diagram that I am making here, this will not be used anywhere. What it is doing is that it is going to each particular element, right? It is going to each particular element. More elements are there, and it is mapping these elements on a real value. So this head has been mapped to 3. This head tail have been mapped to 2. This head tail head is also mapped to 2. This head tail have been mapped to 1, and there would be tail as well, right? This tail would be mapped to 0. More points are there, right? More sample points are there. They are also mapped on either on 0, or on 1, or on 2, or on 3. So y can take values 0, or 1, or 2, or 3. Is that clear to you? Okay. Now if I ask you this kind of question, that what is the probability of getting y less than equals to 3? That means what is the probability that y takes the value less than equals to 3? So y can take either 0, or 1, or 2, or 3, right? So what they are asking? What do you think, what will be the answer of this? Without even calculating y equals to 0, without even calculating y equals to 1, without even calculating y equals to 3, and without even calculating y equals to 3, what do you think, what should be the answer? You know that all possible values of y are coming. This random variable either can take 0, or 1, or 2, or 3. So all possible values are coming, no? So this particular answer will be 1, and we can check as well. Probability of getting y equals to 0, that means probability of getting number of heads equals to 0. Which desirable case? Only desirable case will be tail. That means out of 8 cases, only 1 desirable case. Probability of getting 1 head, which desirable case would be there? Head, tail, tail, head, tail, head. So 3 out of 8 cases. What about this one? Number of heads should be 2. So head, tail, head, tail, head. So 3 cases out of 8. And what about this? Number of heads should be 3. That should be head. So 1 case out of 8. What you are getting? 1 only. Now what about this one? You need to solve this inequality. Y square plus 2 less than equals to 6. That means y square should be less than equals to 2. Sorry, y square should be less than equals to 4 because 2 goes here. That means y will be between minus 2 to 2. Do you know how to solve these inequalities? Y square minus 4 should be less than equals to 0. So y plus 2, y minus 2 should be less than equals to 0. Wavy curve method, right? In basics of mathematics, you might have studied it. Right? So this will be plus, minus, plus. So this will be the desirable condition between minus 2 to 2. Very basics of mathematics. Mathematical foundation. In mathematical foundation, you would have studied all these kind of topics, right? So y should take the values between minus 2 to 2. That means I know that y cannot take the value negative. In our case, y can take only values 0, 1, 2. So what will be the desirable cases? Y is taking 0, y is taking 1, and or y is taking 2. These are the desirable case. 0 or 1 or 2, right? So 1 by 8 plus 3 by 8 plus 3 by 8. What is the answer? 7 by 8. This is the answer. Okay, well and good. Next question. You roll a pair dice. Random variable x is number appearing on the dice. Random variable x is defined as number appearing on the dice square minus 6. Are you able to understand what they are saying? When you roll a dice, what will be your sample space? You can get 1, 2, 3, 4, 5, 6. So what is your random variable x? It will take the number that is appearing on the dice. It will do its square and then minus 6. So what all values your random variable x can take? Think about it. Whatever the number that is appearing, do the square minus 6. So 1 square minus 6. If number appearing is 2, 2 square minus 6. If number appearing is 3, 3 square minus 6. If number appearing is 4, 4 square minus 6. If number appearing is 5, 5 square minus 6. 6 square minus 6. So these are the values your random variable x can take. So random variable x can take 1 minus 5, minus 2, 3, 10, 25 minus 6 will be 19 and 30. So your random variable x can take these values: minus 5, minus 2, 3, 10, 19 and 30. Is that clear to you? What is your random variable x is doing? Whatever the number that is appearing, doing its square minus 6. So these are all the possible values that your random variable x can take. Is that clear to you? Now what they are asking you to find? X square plus 2 minus 10 should be greater than 0. So can you solve this inequality? I am solving this inequality here. Okay, because we don't have space left. So x square plus 4 divided by 2 minus 10 should be greater than 0. So can I do this thing? 10 goes here. So x square plus 4 should be greater than 20. So x square should be greater than 16. That means x should be greater than 4 or x should be less than minus 4. Is that clear to you? Again, same thing will happen here. You will get two poles, minus 4 plus 4. So plus minus plus. You need the condition greater than, that means this desirable condition and this desirable condition. That means either your x should be greater than 4 or your x should be less than minus 4. Okay. So what they are asking you? Here they are asking you probability of x greater than 4 or x less than minus 4. 4 should not be included, minus 4 should not be included. Now you know that my random variable x can take these values. So what will be the desirable condition? X should be greater than 4. Let's talk about this one. X should be greater than 4. So is it greater than 4? No. Is it greater than 4? No. Is it greater than 4? No. Is it greater than 4? 10 is greater than 4? Yes. 19 is greater than 4? Yes. 30 is greater than 4? Yes. So probability of x getting 10, 19 or 30, right? Basically your x should be either greater than 4 or less than minus 4. That means it can take the value either 10 or 19 or 30. And next they are saying x less than minus 4, less than minus 4, less than minus 4. Minus 2 is less than minus 4? No. 3 is less than minus 4? No. 10 is less than minus 4? No. Less than minus 4, only this condition. That means probability of x getting value minus 5. Are you able to understand this point? Right? Now let's write down the probability. Probability of x getting the value 10. So when your x will get the value 10, your x will get the value 10 corresponding to this particular thing. What I am saying, probability of your random variable x taking the value 10. So when your random variable x will take value 10, when the number appearing on the dice is 4. Is that clear to you? When the number appearing on the dice is 4, then your random variable x will take the value 10. That means when your number appearing on the dice is 4, what is the probability of number appearing on the dice equals to 4? That is 1 by 6. Are you able to understand this point? Basically, here what I am saying is that probability of x taking the value 10 is equals to probability of number on the dice is 4. Say yes or no? Because if the number on the dice is 4, then 4 square minus 6, then you are getting x equals to 10. So x equals to 10 corresponds to number on the dice equals to 4. Are you able to understand this point? And what is the probability of getting 4 when you roll a dice one time? When you roll a dice, what is the probability of getting a 4? That is 1 by 6. X equals to 19. X equals to 19 corresponds to this one. That means the number on the dice should be 5. And what is the probability of getting number 5 on the dice? That is 1 by 6. Probability of x getting 30. Probability of x getting 30 corresponds to the number on the dice should be 6. And what is the probability of getting number 6 on the dice? 1 by 6. X equals to minus 5. X equals to minus 5 corresponds to number on the dice should be 1. What is the probability of getting number 1 on the dice? That is also 1 by 6. So what is the answer you are getting? 4 by 6, that is equals to 2 by 3. So now the concept of random variable is being clear. You can define the random variable in any manner. I did an experiment. I got some sample space. Now I can define the random variable in any manner. I defined the random variable. Previously I was defining as number of heads, right? Number of heads here, number of heads here, or number of tails. But now I defined whatever the number you are getting on the dice, do the square minus 6. So now your x can take values minus 5, minus 2, 3, 10, 19, 30. Then I asked you the probability in inequality. So you should know how to solve the inequality. You got the condition that x could be greater than 4 or it could be less than minus 4. Now x could be greater than 4, that means x should be taking the values 10, 19, 30. Less than minus 4, that means it should be taking value minus 5. Right? Now x equals to 10 correspond to getting number 4 on the dice. What is the probability of getting number 4 on the dice? That is 1 by 6. What is the probability of getting number x equals to 19? What does that mean? It corresponds to getting number 5 on the dice. Right? So in the same manner we got the probabilities and we got the final answer, that is 2 by 3. Is that clear to you or not? This is the final answer. Now the concept of random variable is being clear to you. Say yes or no. Now till this point you can see that your random variable x was taking minus 5, minus 2, 3, 10, 19, 30 value. Here it was taking 0, 1, 2, 3 value. Here it was taking 0, 1, 2 value. So these values were discrete. What is the meaning of discrete? Discrete means 0. Then directly I am taking 1 by 2. So in between 0 to 1 by 2 no number is there, right? Then directly I am taking 2. In between 1 by 2 to 2 there is no number. Then directly I am taking 3.5. Then directly I am taking 4. Directly I am taking 5. Directly I am taking 6. That means these values are discrete. 0, 1 by 2, 2, 3.5. There is a jump from 0 to 1 by 2. 1 by 2 to 2. 2 to 3.5. In between 2 to 3.5 there is no number, right? This is the meaning of discrete. And what is the meaning of continuous? That means you are taking all the values from 0 to 1. So whatever the value from 0 to 1 that is coming, that is known as continuous. 0, 0.001, 0.00001, 0.00001, 0.0002. So infinite values are there between 0 and 1. So this is the meaning of continuous. So till this point, whatever the example we took, those were the example of discrete random variable. What I am saying, till this point, whatever the example that we took, those examples were of discrete random variable because values were discrete here. X equals to 0, x equals to 1, x equals to 2. Here x equals to 0, 1, 2, 3. Values were discrete. Values were minus 5, minus 2, 3, 10, 19, 30. But now what I am saying, this is an example that a group of students typically take 30 minutes to 60 minutes to solve a particular quiz. A random variable x is defined such that it represents the time taken by a randomly selected student to solve the quiz. So what do you think? What values x can take? So you know that this particular group will solve the problem from 30 minutes to 60 minutes. Some guy will be solving the problem in 30 minutes. Some guy may solve the problem in 31 minutes. Some guy may solve the problem in 31.2 minutes. Some guy may solve the problem in 59 minutes. Some guy may solve the problem in 48 minutes. So any value between 30 to 60 they may take, no? Any value. 30.0001 minute also they can take. 30.002 minute also they can take. 41.003 minute they can also take. So any value, x could be any value between 30 to 40. 30 to 40. What is the meaning of this? 30 to 40 including 30 and 40. Do you understand the meaning of this particular presentation? When I represented x like this 1, 2, 3, that means x could take 1, 2, 3. Curly bracket was there. If I am making this large bracket, that means whatever the values are there between 30 to 40, all the values will come including 30 and 40 as well. But here 30 to 60 is there, no? So random variable x can take any value between 30 to 60. Say yes or no. Okay. Well and good. Now what they are asking? Find the probability such that x equals to 35. So what is this? This is known as continuous random variable. Okay. And what was this? All these things here. This was known as discrete random variable. This was also your discrete random variable. This is also known as discrete random variable. Okay. Right. Now what they are asking? Probability of x equals to 35. What is your x? X is defined such that it represents the time taken by a randomly selected student. So what they are saying? Find the probability such that the time taken by a randomly selected student is 35 minutes. There is a group of students. They are solving the problem between 30 minutes to 60 minutes. It is a very, very important point. Okay. So keep your full concentration. So there is a group of students. They are solving the problem between any 30 minutes to 60 minutes. So how many sample points are there? What do you think? Infinity, no? Are you able to understand this point? They can take any time. You don't know which time they will take. They can take 30 minutes, they can take 30.2 minutes, they can take 30.3 minutes. So in all this time window, you are asking that the student would be solving the problem at exact 35 minutes. The student can take any time between 30 to 60. But what you are saying, that exactly 35 minutes you tell me. If you were asking me that between 34 to 35 minutes, what is the probability? What is the probability that a student will take time between 34 to 35? Then it is considerable that you can find the probability. But if you are asking me the probability at a single point, which is like from infinity points, you are choosing one point, isn't it? That means probability at a point would be 0. You are asking me a single point. From infinity point, you are asking me to choose one point. Probability will be 0. So in case of continuous random variable, probability at a point is always 0. Here I asked you P of x, let's just say here I ask you P of x equals to 10. So probability at a single point I am asking, which was 1 by 6. Probability at x equals to 19, which was also 1 by 6. So in case of discrete random variable, you can find non-zero probability at a point. But in case of continuous random variable, probability at a point will always be 0, because it's like that you can take any time, and in those infinite time window, I am asking you only one particular time. That at 35 minutes you let me know that what is the probability that at 35 minutes student is solving the problem. But student can take any time between 30 to 60 minutes. So it's like between infinite time windows, you are asking me one particular time. You could ask me one particular time window, that between 34 to 35 minutes, what is the probability that student is solving the problem. That is considerable, that will be non-zero. But if you ask me at a particular point, that would be equals to 0 only. And we will prove that with other theorems as well, like with other examples as well, we will prove it. But this is the point which student usually mug up, or they solve by the PDF. We will understand what is the meaning of PDF. They will say that from minus a minus to a plus fx of x dot dx, if it is continuous, then it will be equals to 0. So they will just remember it, that probability at a point in case of continuous random variable is 0. But why it is 0? Are you able to understand the meaning? That why probability at a point in case of continuous random variable is 0. Okay, those who don't know about PDF, they don't need to worry. We will study that. We will study right from 0. But as of now, you understood one important point, that is, in case of continuous random variable, the probability at a point is always 0. Because in infinite time window, you are asking me one particular time. Right? So there are two kind of random variables: discrete random variable, continuous random variable, and mixed random variable could also be there. Let's write down the example. What is the meaning of discrete random variable? That it can take any discrete values. Minus 2 it can take, 3 it can take, 4.5 it can take, 6 it can take. Or it may also happen that it is taking infinite number of values. What do you mean by infinite number of values? That it is taking discrete values only. Minus 6, minus 4.3, 2, 4, 7, 11, and it will keep on taking these values till infinity. 13, 15, 19, 21, 37, 42, 1001, 1 lakh 1, 1 crore 1. It will take these values, but discrete values it is taking, and it will keep on taking these values. So this is also discrete random variable. This is also discrete random variable. DRV. In short form, what we will write down? DRV. Here, what do you mean by continuous random variable? That x is taking values between minus 20 to 40. X is taking values between minus 20 to 40, including minus 20, including 40 as well. X is taking values between minus 2.5 to 3.5. What is the meaning of this small bracket? That it is taking values between minus 2.5 to 3.5, including minus 2.5, but excluding 3.5. It will not take 3.5. Before 3.5, it will take all the values. So between minus 2.5 to 3.5, including minus 2.5, excluding 3.5. And what is the meaning of this? That it is taking value from 3 to 3.2. So it is taking all the values between 3 to 3.2, but excluding 3.2 and excluding 3 as well. So this is the meaning of continuous random variable. Now some random variable could be, here this is wrong, this should be capital X, right? Capital X random variable is defined by capital X. So this should be capital X. Capital X is taking values between minus 20 to 40. Discrete random, mixed random variable could be like this, that X can take value 1 and 2, and sorry, X can take value 1 or 2, or it is taking value from 3 to 6, including 3 and 6 as well. Are you able to understand this point? Between 3 and 6, it is taking all the values, including 3 and 6 as well, and then it is taking two discrete values which are 1 and 2. Right? It could be somewhat like this as well, that it is taking two discrete values like minus 3 and 4. Two discrete values it is taking, and it is taking all the values from 6 to 70, including 6 excluding 70. So 2 discrete value it is taking, and then 6 to 70 all the values it is taking. Is that clear to you? Okay. So this is known as mixed random variable. An important note, the probability at a point is 0 in case of a continuous random variable. In case of continuous random variable, if I ask you probability at a point x equals to a, that will always be equals to 0 in case of a continuous random variable. This is very important only in case of continuous random variable, because it's like from infinite point you are choosing one point. Is that clear to you? Okay. Now we need to study about probability mass function. So I will take a break, then we will study about probability mass function. You also can take some break if you want to drink some water. So I will drink the water and then I will come back. We will study about probability mass function. Okay. Yeah, welcome back. So now we need to study about probability mass function, PMF. So it is a function only, probability mass function. So it is a kind of function. If I say define a function of x, so how will you define it? Fx. If I say define a function of y, how will you define it? Gy or hy. In any manner you can define the function, right? So it is also a function which defines probability at a point. Probability at a point. So you already know everything about PMF. You already know everything about PMF. So what is the meaning of this particular thing is that this is how it will be written. Small p, capital X, small x. What is the meaning of this? It tells the probability of random variable x taking the value small x. Px small x. This is the notation of PMF. This is how PMF is represented. This is the notation of PMF. Small p, capital X, small x. It tells the probability of random variable x taking the value small x. What is the meaning? Let's just say in place of small x I am putting 10. So px of 10. What is the meaning of that? Probability of random variable x taking value 10. That's it. So this is the meaning of PMF. Let's see an example. When you toss a coin, when you toss 3 coins simultaneously, your random variable x is number of heads. You already know what all values x will take, because these examples we have already seen, right? So x will take, number of head could be 0, 1, 2, 3, right? Now you need to find PMF of a random variable x. You need to find the PMF. So what does PMF do? It tells the probability at a point. Tells the probability at a point. That means it will tell probability of random variable x taking value 0. What was that? 1 by 8. Right? All these things we have already seen, right? What is the probability that number of heads will be 0? 1 by 8. What is the probability that random variable x will take the value 1? What is the probability that number of heads will be 1? 3 by 8. What is the probability that number of heads will be 2? 3 by 8. And what is the probability that number of heads will be 3? That will be 1 by 8. So this would be the PMF. This is nothing but the PMF. So whatever the value your random variable x can take, whatever the value your random variable x can take, it will write down all the values and it will write down its probability. X will take 0, x will take 1, x will take 2, x will take 3. So this is how I can make a table that capital X can take the small values of x which are 0, 1, 2, 3. Their probabilities are started with 0, 1 by 8. Their probabilities are 1 by 8, 3 by 8, 3 by 8, 1 by 8. Okay, and I can draw the graph as well. Px of x versus x. When x value was 0, your probability was 1 by 8. When x value was 1, your probability was 3 by 8. When x value was 2, your probability was 3 by 8. And when x value was 3, your probability was 1 by 8. 1 by 8. This particular thing is 3 by 8. So 1 by 8, 3 by 8, 3 by 8 and 1 by 8. So this is how you can make the graph as well. So this is nothing but PMF. So PMF you already knew. This is just a new term. So in the question, if there is mentioned that this is the PMF of random variable x, that means you would understand that it will define the probability at a point. So if this particular graph is given, what will you understand from this particular graph? That probability of random variable x taking the value 0 is 1 by 8. Probability of random variable x taking the value 1 is 3 by 8. X equals to 2, probability is 3 by 8. X equals to 3, probability is 1 by 8. So you should know how to read the graph. Now here this was a discrete random variable, right? So you just let me know for CRV, for continuous random variable, probability at a point is 0, right? What I mean to say is that for continuous random variable, probability at any point is 0 only. That means For continuous random variable, you cannot define the PMF. And if you define, that means at all the point, PMF would be 0 only. Are you able to understand this point? What I mean to say is that for continuous random variable, PMF will always be 0. What is your PMF? Probability at a point such that your random variable capital X is taking capital X. Your random variable capital X is taking small value x. So probability at a point is 0 for any continuous random variable. That means this PMF is only defined for discrete random variable. For continuous random variable, you define something else. What do you define? That we will see. But this particular PMF concept will be only defined for discrete random variable. For continuous random variable, we will define PDF. That we will see later on. But as of now, this is the point which you can mention. Okay, very simple point, very simple definition. Let's go to the next one. So let's see a basic mathematics problem. So as of now, forget about random variable, random process, just a basic mathematics question we are going to see. You need to discuss the concept of continuity at x equals to 1, 2, 3, 5. I hope you know what is the meaning of continuity. What is the meaning of continuity? If I need to check continuity at x equals to a, what I will do? I will check the value at a plus, I will check the value at a, I will check the value at a minus. What is the meaning of a? That means a could be any value. Let's just say it is 3. What is the meaning of a plus? A plus means just ahead of a. Just ahead of a. And what is the meaning of a minus? Just behind of a. Right? So let's check the continuity at all these points. So at x equals to 1. At x equals to 1. If I ask you, if I give you this graph and I ask you what is the value of G1, that means what is the value at x equals to 1? You will say, sir, it is not defined. In signal system, I told you that if there is a sudden jump, you cannot define the value. But in the question, what is given? That G of 1 is equals to 1. What I mean to say is that if this particular thing is not mentioned, and I ask you directly that what is the value of G of 1, that means at x equals to 1, what is the value you are getting? You will say, sir, I cannot define it. Because there is a sudden jump, no? But in the question, they are saying that G of 1 is 1. That means you actually need to consider the next value. So G of 1 is 1, that is given. Now let's talk about G of 1 plus. What is G of 1 plus? Just ahead of 1. What is the value you are getting? 1 only. So G of 1 plus is equals to 1. And what is the value of G of 1 minus? Just below 1. What is the value you are getting? 0. So here what do you see is that G of 1 is equals to G of 1 plus, but that is not equals to G of 1 minus. That means it is not continuous at x equals to 1. Are you able to understand this point? So your graph is not continuous at x equals to 1. Let's check at x equals to 2, 3, 5. Everywhere we need to check, right? We don't have much of space. So what we can do is that we can put all these upward. Let's check at 2 now. So if I ask you, if I directly give you this graph and this information is not given, if I ask you what is the value at x equals to 2, you will say, sir, not defined, because there is a sudden jump. So value is not defined, but in the information that is given that G of 2 is actually 2. G of 2 is 2. What is the value of G of 2 plus? Just ahead of 2, that is 2. And what is the value of G of 2 minus? Just below 2, that is 1. Again, not continuous at x equals to 2, right? Let's check at 3. What is the value at 3? There is no sudden jump. So value is simply 2 only. Value is G3 is simply 2. What is G3 plus? Just ahead of 3. That is also 2. And what is G3 minus? Just below 3. That is also 2. So yes, it is continuous at x equals to 3. Right? At x equals to 5, let's check. There is no sudden jump. So at x equals to 5, the value is 3. At 5 plus also the value is 3. At 5 minus also the value is 3. So it is continuous at x equals to 5. So this is the concept of continuity which I just wanted to revise. But one more point I would like to tell. Here what do you see? Although it is not continuous at x equals to 1, right? At x equals to 1, the graph is not continuous. But here you can see that it is continuous from the right hand side. Basically, g of 1 is equals to g of 1 plus. That means I can say that it is continuous from the right hand side. If your g of 1 was equals to g of 1 minus, I would say that it is continuous from the left hand side. This is purely continuous. This is also purely continuous. This is purely continuous. This is also purely continuous. But this is not continuous. But in mathematics, just for the theory purpose, they can say that it is continuous from right hand side, because g of 1 plus is equals to g of 1. G of 1 plus is equals to g of 1. So it is continuous from the right hand side. So this terminology can be used somewhere in your notes or in your some textbook. You will find that this particular graph is continuous from the right hand side. So you should know what is the meaning of continuous from right hand side. What is the meaning of continuous from right hand side? That means g of a plus is equals to g of a. So the point is, if g of a plus is equals to g of a is equals to g of a minus, if this is the condition, that means it is continuous at x equals to a. If this is the condition, that g of a plus is equals to g of a and not equals to g of a minus, that means it is continuous from right hand side. Okay, and if this is the condition that these are not equal but these guys are equal, so the meaning is continuous from left hand side. If nothing is equal, then not continuous at all. Although this is also known as not continuous, but in some mathematics, in some books, you can find that continuous from right hand side, continuous from left hand side. So you should be knowing the meaning of all these three. Is that clear to you? So this is just some mathematics that we wanted to discuss. Now we are going to study about cumulative distribution function, CDF. Very, very important. What is the meaning of CDF? What is the meaning of CDF? Not CDS. What is the meaning of CDF? So what was your PMF doing? PMF was telling probability at a point. Now cumulative distribution function, this is also a function which is represented by capital F. Here you write down capital X and inside you write down small x. So it tells the probability of a random variable x taking values lesser than or equals to small x. This is what it tells. Are you able to understand this point? Let's just say I write down fx of 2. What is the meaning of this? Probability of random variable x taking values less than or equals to 2. So this is what your cumulative distribution function tells. What was your PMF? You remember PMF? Probability of random variable x taking value equals to x. Probability of random variable x taking value equal to small x. But your CDF will tell probability of random variable x taking value lesser than or equals to small x. Is that clear to you? Let's see a question. With respect to question, it will be more clear to you. Number of heads appearing when 3 coins are tossed simultaneously. The same example we are taking. You need to draw the CDF of random variable x. So what all values x can take? So let's find something very random. Let's find fx of minus 1. Can you let me know what will be the value of fx of minus 1? So what does it mean? Probability of random variable x taking values lesser than equals to minus 1. Can it take value lesser than equals to minus 1? No. It can take only value 0, 1, 2, 3. So it can never take value lesser than minus 1. So what will be the probability? 0. Let's find another random thing. Let's find fx of minus 0.5. Again 0, right? Because random variable x cannot take values lesser than minus 0.5. If I ask you fx of 0, what will be the value of fx of 0? Probability of random variable x taking values lesser than or equals to 0. Lesser than or equals to 0. So it cannot take value lesser than 0, but it can take value equals to 0, right? So it will be equals to probability of random variable x taking value 0. That is equals to 1 by 8. So what do you get to know here? That fx of 0 is coming out to be 1 by 8 for the first time. Let's find out fx of 0.5. What that would be? Probability of random variable x taking values lesser than equals to 0.5. So x should be less than equals to 0.5. What does that mean? That means x can be 0 only, right? So probability of x taking value 0. Again we are discussing discrete random variable only. A lot of example on continuous random variable will also come. So have some patience. So that would be equals to again 1 by 8. So till what point it will remain 1 by 8? You let me know. Look, if your x was less than 0, the probability was 0 only, right? Don't care about that. When it became equals to 0, it became equals to 1 by 8. When it was 0.5, again it is 1 by 8 only, because value of x taking less than or equals to 0.5 would be equals to x equals to 0 only, right? Because it cannot take 0.4, it cannot take 0.3, directly it can take x equals to 0 only. So till what point it will remain 1 by 8 only? Till x equals to 1, right? Because if I find fx of 1, what does that mean? Probability of random variable x taking value lesser than or equals to 1. X taking value lesser than equals to 1. That means it can take 0 as well, it can take 1 as well, right? It can take 0 as well, it can take 1 as well. So 1 by 8 plus 3 by 8, that would be equals to 1 by 2. This is 1 by 8, this is 3 by 8. 1 by 8 plus 3 by 8 would be 1 by 2. If I ask you fx of 1.5, what that would be? Probability of random variable x taking values lesser than or equals to 1.5, right? So x can take 0 or it can take 1, right? Fx of 2, probability of random variable x taking values lesser than or equals to 2. That means probability of random variable x taking value 0, taking value 1 and taking value 2. What that would be equals to? This is 1 by 8, this is 3 by 8 and this is 3 by 8, right? 7 by 8. If I ask fx of 2.5, so probability of random variable x taking value lesser than equals to 2.5. So it cannot take 2.4, it cannot take 2.3, it cannot take 2.2222, it cannot take 2.3333. All these values it cannot take, it can only take 0, 1, 2. So again the answer would be 7 by 8. And what would be fx of 3? So probability of random variable x taking values lesser than equals to 3. That means 3 will also be included now, right? 1, and you let me know what will be the answer of this particular thing. That will be 1 only. If I ask you what will be fx of 4 for this particular question, if I ask you what will be fx of 4, so probability of random variable x taking values lesser than equals to 4. So it can take 0 as well, it can take 2 as well, it can take 3 as well. 0, 1, 2, 3, everything it can take. That means again the probability will be 1. Fx of 5 will be 1. Fx of 10 to the power 6, probability of random variable x taking value lesser than equals to 10 to the power 6. What that would be? 10 to the power 6. From 0 is lesser than 10 to the power 6, 1 is lesser than 10 to the power 6, 2 is lesser than 10 to the power 6 and 3 is lesser than 10 to the power 6. That means it will always be 1. So starting with 0, it goes till 1. So what kind of graph we are getting? Initially 0, 0, 0 only. Suddenly at 0 you get 1 by 8. So let's draw the graph, right? Let's draw the graph. So it was 0, 0, 0 only. Just 1 second, guys. Yeah, it was 0, 0 only, and at 0 only suddenly it became 1 by 8. So here it became 1 by 8. But if I draw the graph like this, and if I ask you what is the value of fx at 0, will you say, sir, 1 by 8? If I ask you this question in mathematics, that, sir, what is the value of fx, what is the value of this fx at x equals to 0? What you will say? Sir, it is not defined, right? But even in the examination, in a lot of textbook, in the test series, in the class notes, everywhere you will see that graph is drawn like this. I will also draw the graph in the same manner, but you should know here what you should know, that fx of 0 is actually equals to fx of 0 plus. If I ask you fx of 0, then you should think, okay, at a point you are asking, that means I need to look ahead. If there is a sudden jump, I need to look ahead only. Are you able to understand this point? Ideally, graph should not be made like this. Are you able to understand this point? This line should not be there, right? Why this line should be there? This green line should not be there. This particular green line should not be there. Because if I make this green line, that means I am telling that there is a sudden jump at x equals to 0. And if there is a sudden jump at x equals to 0, that means I cannot define the value at x equals to 0. But actually it is defined, because here we saw that fx of 0 is actually coming out to be 1 by 8. It is not undefined. It is actually coming out to be 1 by 8. So although we will make the graph like this, although in the examination as well the graph will be made like this, but since it is CDF, so since it is the graph of CDF, so in the CDF you should know that if I am talking about probability, if I am talking about the value at a point, if I am talking about value at a point, that means I am talking a plus. If I am talking the value at a, that means I am talking about a plus. So in case of CDF, fx of a plus will always be equals to fx of a. It might not be equals to fx of a minus, but this will always be there. Is that clear to you? Okay, fine. Yeah, so 1 by 8. Then at 1 what was happening? Till 1 it was remaining there only, like 0.5 was also giving 1 by 8. Then fx of 1 was giving 1 by 2. So from 1 by 8 you made a jump to 1 by 2, right? Then when you got the value 2, then again you made the jump to 7 by 8. So it was there 1 by 2, 1 by 2 only. When x became 2, when this small x became 2, when this capital X took the value 2, then it became 7 by 8. Then it became 7 by 8. And then when x took the value 3, it became 1, right? And then it always remained 1. So this kind of graph we are getting. So 1 by 8, 1 by 2, 7 by 8, 1 by 2, 7 by 8, and 1. So this kind of graph we were getting. Now if this particular graph is given you, let me know all these things. First thing is this, you need to remember this particular thing. Although this graph is not correct, but everywhere in the test series, in the textbook, in the examination as well, this kind of graph will be made. So you should know one particular thing, that if I am asking you the value, let's just say if I am asking you the value at x equals to 2, then you should not be saying that the value is undefined. No, you should be knowing that the value is actually, I need to look ahead. So the value actually is 7 by 8, right? The value is 7 by 8, right? And this is the value is, this value is there at x equals to 1. So this is how you need to remember. And at x equals to 3, this is the value. So CDF doesn't tell the probability at a point. Probability at a point is told by PMF. CDF will tell that, well, probability of a random variable x taking values lesser than equals to small x. This is what your CDF will tell. Is that clear to you? Okay. So this is the graph of CDF that we are getting. Now if I randomly ask you from this graph, what is the value of fx of 3? What you will say? Sir, as per the graph, it looks like it is not defined, but actually it will be fx of 3 plus, which is actually 1. If I randomly ask you, what is the value of fx of 0? So sir, as per the graph, it looks like it is not defined, but actually I need to look ahead. 1 by 8. If I ask you, what is the value of fx of 1.33? So sir, 1.33 would be somewhere here. The value is actually 1 by 2. Is that clear to you? So this graph we took, this example we took, and there I said that g of 1 actually looks like it is not defined, but it is actually equals to 1. So I was referring to CDF only. Are you able to understand this point? So can I say that CDF is always right continuous? Like if I ask you fx of 1.33, that is 1 by 2. Fx of 1.33 plus, what that would be? That will also be 1 by 2. So fx of 1.33 minus, what is that? That is also 1 by 2. So it is completely continuous at x equals to 1.33. But if I ask you, what is the value of fx of 0 and fx of 0 plus, that is 1 by 8. But what is the value of fx of 0 minus? That is equals to 0. So here what did you get to know? That 0 plus is equals to 0, but that is not equals to 0 minus. So it is always continuous from the right. It might not be continuous from the left. It may be continuous from the left, it might not be continuous from the left, but it will surely be continuous from the right. So your cumulative distribution function is always continuous from the right. This kind of statement could be there in true or false. Okay, so that's why I was referring to this particular concept, continuous from the right hand side, continuous from the left hand side. Is that clear to you? Although we will write down all these points later on, but yeah, as of now in the graph you can see this. Okay, all fine. So let's solve this question. So we will solve this question, and from here we will make a very good conclusion. So whatever the conclusion that we are going to make, that is more important. Okay, so let's solve the question. You will not be able to solve on your own. So see the solution and then we will see the conclusion. So probability of random variable x taking values between -1 to 4, including 4, excluding -1. This is what you need to find. Okay, so first question, what we need to find? Probability of random variable x taking value between -1 to 4, including 4 and excluding -1. Can I write it down in this manner? So let's make the line first. What do we need? We need, this is our -1, this is our 4. So -1 to 4, including 4 but excluding -1. So this is what we need. We don't need -1, we need 4, right? So can I write it down in this manner? Probability of random variable x taking values lesser than 4. That means all these values it is taking. But we don't want all these values. We don't want these values, right? We only want these values. So what I need to do? Minus probability of random variable x taking values lesser than equals to 1. Is that clear to you? Here equals to will come. Why is that so? Because I don't want values lesser than 1, including the 1 as well. Because I don't want -1, sorry, not 1, -1, really sorry guys. I don't want values lesser than -1. It was -1 only, no? Yeah. I don't want values lesser than -1, including the -1 as well. I don't want -1 as well. I want the values between -1 to 4. Is this clear to you or not? If I want the value between -1 to 4, that means I want values lesser than 4, including the 4, right? But I don't want -1. So can I write it down in this manner? That this is fx of 4 minus fx of -1. Is that clear to you? Can I write it down in this manner? Because what is your fx of x? Fx of x is probability of random variable x taking value lesser than equals to small x. So this is your fx of 4. That means probability of random variable x taking value lesser than equals to 4. And this is your fx of -1. And one thing you already know. What do you know? That in case of CDF, fx of a plus is equals to fx of a. So this can be written in this form as well. Fx of 4 plus minus fx of -1 plus. Is that clear to you? So that plus sign could also be given. So anything could be given. This can also be mentioned in your examination and this can also be mentioned in your examination. Although you can calculate the value, fx of 4 plus is 7 by 8. Fx of -1 plus that is 2 by 8. So 7 by 8 minus 2 by 8. 7 by 8 minus 2 by 8. What is the answer you are getting? 5 by 8. Okay. Let's see the second one. It is a very, very important concept. Okay. And very good conclusion we are going to make from here. -1 to 4, excluding both of them. -1 to 4, excluding both of them. Right? So what I need to write? Probability of x less than 4. Again, let's draw the graph here. What do I need? I need values between -1 to 4. -1 to 4. I don't want 4, I don't want -1 as well. I want only these values. So can I write it down in this manner? Probability of x less than 4 minus probability of x less than equals to 1. Is that clear to you? Because I don't want 1. I don't want 4, I am not taking 4 here. Values lesser than 4. And here values lesser than 1, excluding 1 as well. Basically, if I am subtracting it, that means values lesser than, again I am writing 1, it is -1. Really sorry guys. So values lesser than -1, also -1 should also be excluded. So I am getting between -1 to 4. Is that clear to you? Right? Can I write this down? Can I write this particular thing in this manner? That it is your probability of x less than 4 minus probability of x equals to 4. What I am doing is that probability of x less than 4 I am writing down in this manner. Probability of x less than equals to 4. That means 4 and less than that. That means 4 is included. But actually what I want, x less than 4 only I want. That means 4 should not be included. So what I am doing, x equals to 4. Very simple thing, very basic mathematics. Is that clear to you? You don't need to remember all these things. We will make some conclusion out of it. And from these conclusion, you will be able to solve the problem within 5 seconds. But are you able to understand the concept here, what I am doing? Is that clear to you? Why I am putting this equal sign? Because I need to write down in terms of CDF. And in CDF, there is equals to sign is also there. That is very important. Equal to sign is very, very important. So if I want this equals to sign, because of that, I need to follow this particular process. Is that clear to you? So what I did, probability of x less than 4, I am putting as x less than equals to 4 minus x equals to 4. Is that clear to you? Right? Minus probability of x taking value less than equals to minus 1. So what is this? Fx of 4. And what is this? Fx of minus 1. And what is this? And you know one thing, fx of 4 is equal to fx of 4 plus fx of minus 1 is equal to fx of minus 1 plus. So most probably this option will be mentioned in your examination. This particular option will be mentioned in your examination. Most probably this particular option will be given. Okay, but we will write down another point. We will see it in another manner. What we will do, let's talk about this particular thing, fx of 4 minus probability of x equals to 4. Let's talk about this particular thing. What this can be equals to. If I ask you, find me fx of 4 minus, what you will do? Probability of random variable x taking values lesser than equals to 4 minus. What does that mean? What is the meaning of 4 minus? Just before 4. Are you able to understand this point? Fx of 4 minus. If this is your 4, if this is your 4, this would be your 4 minus. That means it is telling that probability of random variable x taking values lesser than equals to 4 minus. That means 4 minus is included until minus infinity you can go. Minus infinity to minus 4, everything you can tell. But 4 should not be included. So can this be equals to probability of x less than 4? Are you able to understand this point? Fx of 4 minus is equals to probability of random variable x taking values lesser than equals to 4 minus. And that would be equals to probability of x less than 4. Because 4 minus is just before 4. And what this is telling? From 4 minus to minus infinity, everything you can take. That means you cannot take 4. And this is what you want from this. Is that clear to you? So this is the first way that this is how the option could be mentioned. What could be the other way? From here you write down probability of minus 1 to 4. The other way could be, this particular thing can be written as fx of 4 minus this particular thing could be written as fx of minus 1. This can also be mentioned in your examination. Both should be clear to you. You should have the habit of writing down both. We will see the conclusion. With respect to the conclusion, you will be able to write down very, very, very quickly. Is that clear to you? All good? All fine? Right? Okay. And one thing you already know, that fx of minus 1 will be equals to fx of minus 1 plus. So again, another form I can write down, that would be between minus 1 to 4. Another form I can write down, fx of 4 minus fx of minus 1 plus, because I know that fx of a is equals to fx of a plus. So this could also be one of the possible form. So 3 forms I have written here. And have patience. In the examination, you will not have to follow this process. I will tell you very simple method. By that particular method, you will be able to write down the expression. But as of now, you should know how we are solving these kind of problems. Between -1 to 4, excluding the 4. Excluding the 4, if 4 was not included, then all these problems, this is how we will write it down. Is that clear to you? All good? Let's see the next one. Let's see probability of x equals to 4 first. What I am asking? Probability of x equals to 4. Let's find out this particular thing. Although, what will be the answer of this particular question? Fx of 4 minus. Fx of 4 minus. That was 4 by 8. Fx of 4 minus. Right? This was your 4. 4 minus. That was 4 by 8. Fx of minus 1 plus. Minus 1 plus. That was 2 by 8. So, answer was 2 by 8. That is 1 by 4. Okay. What about this one? Probability at x equals to 4. Probability at x equals to 4. Can I write it down in this manner? You let me know. X less than equals to 4 minus x less than equals to 4 minus. You let me know. Probability, this is 4 and this is 4 minus. X less than equals to 4. That means including the 4, everything. And what is the meaning of x less than equals to 4 minus? Excluding the 4, everything. Basically, probability of x less than equals to 4 minus is equals to probability of x less than 4. Do you agree to this point? Yes, x less than 4 or x less than equals to 4 minus. That means including minus 4, everything. That means excluding 4, everything. Is that clear to you? Is this statement clear to you? Surely it is clear to you. So it could be written as fx of 4 minus fx of 4 minus. Right? Or it could be written as fx of 4 plus, because fx of 4 is equal to fx of 4 plus, fx of 4 minus. So this is your probability at a point. Don't worry about all these things. I will tell you a method as well. By that method, you will be able to write down very quickly. So in two forms, the answer could be mentioned. Although in the examination, what they will do, they will ask these forms. They will not give the graph or anything. They will just ask these forms, right? So what will be the answer? 4 plus 4 minus 7 by 8 minus 4 by 8. 7 by 8 minus 4 by 8. The answer would be 3 by 8. Right? Let's see the C question now. Now you should be able to do everything on your own. Let's see the C1. Minus 1 to 4. Minus 1 to 4. So how will you write it down? Probability of x less than 4 minus probability of x less than 1. There you go. Right? Why is that so? Because what do you need? You don't need 4, but you need 1. You don't need 4. That means x less than 4. But you need, again it is minus 1. Again I am doing the same thing. But you need minus 1 as well, right? You need minus 1 as well. That means x less than minus 1 you need. This particular thing you need. Less than minus 1 you need. Is that clear to you? Are you able to understand what I am saying? Less than 4 and less than minus 1. That means minus 1 you need. You need minus 1. Minus 1 has to be there. So less than 4, that means 4 will not be there. And less than minus 1, that means minus 1 will be there. Right? Are you able to understand this point? So what it could be written as? Can I write it down as x less than equals to 4 minus? Say yes or no. Minus probability x less than equals to minus 1 minus. Can I write it down in this manner? X less than equals to 4 minus probability of x taking value less than minus 1 minus. Because here what do we show? Basically the general point is probability of x less than a minus is equals to probability of x less than a. Do you agree to this point? Probability of x less than equals to a minus is equals to probability of x less than a. Do you agree to this point? Surely you agree to this point, right? Less than a less than equals to a minus. That means a minus till minus infinity. From a minus to minus infinity. And what does this say? From a minus to minus infinity only. This is also say the same thing. This is also saying the same thing, right? So what this could be written as? Fx of 4 minus fx of minus 1 minus. So this is the first way of writing it down, which probably will not be mentioned in the options. Okay, this might not be mentioned in the options. What could be mentioned in the option? Let's go here again. Okay, so probability of x less than 4. So you know what is probability of x equals to 4? That is, probability of x equals to 4 is fx of 4 plus minus fx of 4 minus. So from here, fx of 4 minus can be written as fx of 4 plus minus probability of x equals to 4. So yes or no? You know this particular thing already. Probability at x equals to 4 is fx of 4 plus minus fx of 4 minus. So from here, fx of 4 minus could be written as fx of 4 plus, and this goes here, minus probability of x equals to 4. So what this could be written as? Fx of 4 minus. Fx of 4 minus could be written as fx of 4 plus fx of 4 plus minus probability x equals to 4, right? Minus. What about this one? Fx of minus 1 minus. Similarly, fx of minus 1 minus could be written as fx of minus 1 plus minus probability of x equals to minus 1. So here what I will write down? Fx of minus 1 plus minus probability of x equals to minus 1. So what you are getting? Fx of 4 plus, which can be written as fx of 4, because you know that fx of 4 plus is equals to this fx of 4 plus is equals to fx of 4 only, because fx of a plus is equals to fx of a. So fx of 4 plus could be written as fx of 4 minus, this can be written as, this minus sign, this can be written as fx of minus 1 minus probability of x equals to 4 plus probability of x equals to minus 1. So this could be mentioned in the option. Like high chances are there that this particular thing will be mentioned. High chances are there that this particular thing would be mentioned in the options. Okay. 4 minus 1, probability at x equals to 4, probability at x equals to minus 1. Now you are able to think, right? What fx of 4 will say? Including the 4, everything. Including the minus 1, everything. So in this particular thing, what do you see? That 4 has been included and minus 1 is not included. In this particular thing, what do you see? That 4 has been included and minus 1 is not included. But what do you want? 4 should not be included. 4 should not be included, but minus 1 should be included. That means you will add up the probability of minus 1, but you will subtract the probability of 4. So you added up the probability of minus 1, you subtracted the probability of 4. Is that clear to you or not? Fx of 4 will say that including the 4, everything. Minus 1 will say that including the minus 1, everything. That means if there is a subtraction sign, that means minus 1 is also gone and rest of the things is also gone. Right? So that means 4 is included, minus 1 is not included. But what do you want? You want that 4 should not be included, but minus 1 should be included. So you will subtract 4, but you will add up minus 1. Is that clear to you? A very good concept we are seeing here. Okay. Let's see the last one. In the last one, what do we want? And surely we will write down the conclusion. It will be just a cakewalk for you. Within 1 second, you will be able to write down everything. Minus 1 to 4. Minus 1 to 4, including the both. Minus 1 to 4, including both. So what do you think? How will you write down? Think about it. If I write down fx of 4, what does that mean? Just 1 second, guys. Just 1 second. One call is coming. Yeah. So what I was saying. So minus 1 to 4, right? So basically, you need 4 as well this time, and you need minus 1 as well. You need both of them. You need 4 as well, you need minus 1 as well. So if I am writing fx of 4, what fx of 4 is saying? That it will include 4. So yeah, our job is done. Including the 4, our job is done. Now let's just say if I write down fx of minus 1 here. So what it will do? It will kill minus 1. It will kill minus 1 and rest of all the things. But what do you want? You need minus 1. If I subtract fx of minus 1 here, what is the meaning of fx of minus 1? fx of minus 1 means probability of x taking value lesser than equals to minus 1. That means it will kill everything including the minus 1 as well. So minus 1 is also gone, but you need minus 1. That means probability of x equals to minus 1 you need to add. There you go. This would be one of the possible options mentioned, right? What could be the other option mentioned? You know that what is your probability of x equals to minus 1. Basically, I need to kill this probability of x equals to minus 1. So I know that it would be equals to fx of minus 1 minus fx of minus 1 minus, right? Or you can say that fx of minus 1 plus, because fx of minus 1 plus is equals to fx of minus 1 only. So this is your probability of x equals to minus 1. So x equals to minus 1 could be replaced with probability of x equals to, yeah. So probability of x equals to minus 1 is this. So in place of 1 plus, let's write down, in place of minus 1 plus, if just write down minus 1, right? So what I will get is that if I do, I am taking this towards this side. So what you will get? Probability of x equals to minus 1 minus fx of minus 1 is equals to minus fx of minus 1 minus, right? So what is this? Probability of x equals to minus 1 minus fx of minus 1. So from here, what do you see? This is fx4, and what this is equals to fx of minus 1 minus, right? And this 4 could be equals to 4 plus as well. So here if I am writing down minus, here I am writing down plus. So this could be the other option mentioned. Is that clear to you? We will surely write down the conclusion now, but the concept is clear to you, no? That how we go to these particular answer. So let's write down the conclusion. What do we need to do? So probability of random variable x taking values from a to b, including the b, excluding the a. How will you write it down? So always you will remember this condition, that on the lower limit I don't want the equal sign, on the higher limit I want the equal sign. On the lower limit I don't want the equal sign, at higher limit I want the equal sign. If this is the condition, then no problem is there. Directly it will come. There you go. And this could be equals to fx of b plus fx of a plus, right? Because you know that fx of alpha is equals to fx of alpha plus in case of CDF, right? So this condition you will remember, that on the lower limit I don't want the equal sign, on the higher limit I want the equal sign. Here on the lower limit I don't want the equal sign, but at the higher limit I want the equal sign. That is not there. That means there is some problem at the higher point. There is some problem at the higher point. That means you will write it down as fx of b minus fx of, on the lower limit I don't want the equal sign and it is not even there. That means I don't have any problem. And that can be written as fx of b minus fx of b minus fx of a plus. So here there was no problem, but here there was problem. Because there was a problem, so b minus came. Now in the examination it might happen that they will not give b minus. So what you will do? So now you will think that I know that probability at x equals to b will be equals to fx of b minus fx of b minus, or it can be written as b plus as well, right? It can be written as b or b plus, whatever it can be written. So fx of b minus would be equals to fx of b minus would be equals to fx of b minus probability at x equals to b, right? And this could be written as fx of a only. Okay, so usually in the examination when the question comes, they don't put plus minus here. This kind of option would be mentioned. Neither here plus is there, here also there is no plus. This is simple probability. But here I am putting minus, here I am putting plus. All these plus minus will not be mentioned. If this particular question is coming, then this answer would be mentioned. If this particular question is coming, then this particular answer would be mentioned. Are you able to understand this point? And or you can think as well, no, that if I write down fx of b, that means I am taking everything including the b, but I don't want b because here I don't want b. So what I will do? I will simply subtract the probability, right? Or if you don't want to think, just remember this particular first expression, that B should be included and A should not be included. Here, both are having the problem, that on the higher limit I wanted the equal sign, on the lower limit I did not want the equal sign. That means both are having the problem. So what would be the answer? Fx of B minus Fx of A minus. But in the examination, this might not be mentioned. In the examination, what will be mentioned? What is your Fx of B minus equals to? It is equals to Fx of B minus probability at x equals to B. Because Fx of B will say everything including the B, but you need to kill the B. Now minus, what is your Fx of A minus? Fx of A minus is Fx of A minus probability at x equals to A. Since this there will be bracket, so if you open the bracket, this would be equals to plus. Is that clear to you? So this particular option could be mentioned in the examination. This might not be mentioned. There is very high chance that this particular option would come. Fx of B minus Fx of A plus Px of A minus Px of minus B. And you will be able to think, including the B, now B is excluded. Here, A is excluded. A is excluded, but because of this, A is included now. Is that clear to you? So all this discussion we have done just to understand these particular answer. Now here, on the lower limit I am having the problem, but on the higher limit I am not having any problem. On the lower limit I am having the problem, on the higher limit I am not having any problem. So Fx of B will come as it is, but on the lower limit there is a problem. So here in place of B I can write down B plus as well. On the lower limit there is a problem, so A minus. This could be written as what? So Fx of B plus can be written as Fx of B only. Fx of A minus could be written as what? Fx of A minus could be written as Fx of A, but you don't want probability at x equals to A. You don't want probability at x equals to A, right? Am I doing it correctly? Fx of B, Fx of minus A, yeah. Or forget about it, don't think like that, no. What you will think? Okay, from here I will start thinking. From A to B, including A as well, including B as well. So what I will think? That I need B, okay, yes, I need B. If I subtract Fx of A, that means A is also gone and less than A is also gone. But you don't want A to be go. You don't want A to be gone, right? You want A. That means you will have to add probability of x equals to A. And if you don't want to think in this manner, what you will do? You will write down this very easily. This you will be able to write down very easily, right? Fx of B plus minus Fx of A minus, very easily you will be able to write down, because on the higher limit there is no problem, or on lower limit there is a problem. So this is what you can write down, and then you will think that probability of x equals to A is equals to Fx of A minus Fx of A minus. So Fx of A minus would be equals to Fx of A minus would be equals to Fx of A minus probability of x equals to A. So from here you will just put Fx of A minus from here, right? And that would be equals to minus Fx of A plus probability of x equals to A. So this particular answer you will get. So here you are using your brain. If you don't want to use your brain, then direct method also I am telling you. Is that clear to you? And what is the probability at a point? Then probability at a point is actually given as Fx of A minus Fx of A minus, or it could be written as Fx of A plus minus Fx of A minus. Is that clear to you? So these expressions are very, very, very important. Okay. Now you know one thing. What do you know? In case of continuous random variable, probability at a point would be equals to 0. Px of A is equals to 0. So you just let me know this particular thing. All these will be equal or not, and they will be equals to Fx of B minus Fx of A. Why is that so? Because you see this particular expression here, directly this is coming, no issue. You see this particular expression, see here, Fx of B, this particular thing will be 0 in case of continuous random variable. So what you will be getting? Fx of B minus Fx of A. You see this particular expression, this will be 0, this will be 0. What you will be getting? Fx of B minus Fx of A. You see this particular expression, this will be 0. What you will be getting? Fx of b minus fx of a. Is that clear to you? So in case of continuous random variable, you don't even need to think of this equal sign or unequal sign. But in case of discrete random variable, you need to think about these equal sign and not equal sign. Is that clear to you or not? So basically in continuous random variable, there will not be any staircase. Here you saw this particular diagram, no? There was a staircase. Here also there was a staircase. So if you see the staircase, that means they are talking about discrete random variable. But if you see a continuous graph like this, that means it will be continuous random variable. Are you able to understand this point? Okay. So if there is a discrete, if there is a staircase like this, that means it is discrete random variable. If there is a continuous graph like this, that means it is continuous random variable. Is that clear to you? Continuous graph, continuous random variable. Staircase like this, that means discrete random variable. Is this clear? Right? So this particular question that we have seen, and this particular conclusion was also very important. So fx of alpha is always equals to fx of alpha plus. Probability at a point is given by fx of b, fx of minus b minus. You need to remember this condition that at lower limit I don't need the equal sign. At higher limit I need the equal sign. Then directly answer will come fx of b minus fx of a. Here lower limit was having the problem. Higher limit was having the problem. Lower limit was not having any problem. So higher limit was having the problem. So fx of b minus came. But usually this particular thing will not be mentioned. Fx of b minus could be replaced from here. Fx of b minus probability of x equals to b. So this is how I can replace it. I can get the answer. Or I can think directly as well, that if I write down fx of b, that means I am taking b into action as well and less than b as well. But I need to kill the probability at x equals to b, so I will subtract it. Then I need to kill the probability at x equals to a as well, then fx of a. So either you can think, which is very easy to think, or you can, if you don't want to think, if you just want to apply some formula or method, then this is how you can apply the formula as well. Is that clear to you? Everything is crystal clear. Every single point is clear to you, right? Because this is very important. I am expecting that question will come from this particular topic, and we have put a problem as well. Right? We will solve a lot of questions. So in those questions, we will solve this kind of problem. Okay? Their options will not be mentioned like this. I have seen that people will mug up these formula. Fx of b plus minus fx of a plus fx of b minus fx of a, but they will mug up this particular formula, but they don't even know that this is how the option will be mentioned. So you should care about the options as well, no? Right? So this point is clear to you. Let's go to the next one. You need to see the properties of CDF. So if I ask you fx of infinity, what is the meaning? Probability of random variable x taking values less than equals to infinity. What do you think? What will be the answer of this? 1. Because x will not take value greater than infinity, no. Every value is less than infinity only. So x cannot take value greater than infinity. So probability will be 1. What about fx of minus infinity? Probability of x taking values less than equals to minus infinity. What do you think? What will be the answer? Can x take any value lesser than minus infinity? No. Answer will be 0. So fx of minus infinity is 0, fx of infinity is 1. Let's see these graphs. 0 to 1. Starting with 0 to 1. And always in the non-decreasing manner. The graph is non-decreasing. You cannot say it is increasing. Here the graph increased, then it remained constant, then again increased, then again remained constant, again increased, constant, again increased, constant. But it never decreases. The graph never decreases. So CDF is a non-decreasing function. You cannot say increasing, but you can say non-decreasing function. So CDF is a non-decreasing function. What is the value, minimum value? That is 0. What is the maximum value? 1. So it can never be negative as well, right? Minimum value is 0, maximum value is 1. So from 0 to 1 it will go, because it is representing probability only, no? Although it is representing probability less than or equals to a particular value, but surely it is representing a probability only, and probability will always be between 0 to 1. So CDF will always be between 0 to 1 only. It is a non-decreasing graph. If x2 is greater than x1, that means fx2 would be greater than equals to x1. You see this graph. Let's just say this is my x1 and this is my x2. So you know that x2 is greater than x1. So values are equal here. Fx of x2 is equals to fx of x1. Are you able to understand this point? Here, if I say this is my x1, this is my x2. So I can say that fx of x2 is equals to fx of x1, which is equals to 3 by 8. And if I say my x2 is here, where is my x2? My x2 is here. So x2 is greater than x1. x2 is greater than x1 and this value is also greater than this one. Basically, if x2 is greater, then fx of x2 cannot be lesser. It can be equal or it can be greater. Are you able to understand this point? Because graph is non-decreasing, no? Graph will either remain constant or it will increase. It will either remain constant or it will increase. It will never decrease. So if x2 is larger, then the function will also throw either larger value or equal value. Is that clear to you? Very simple point. Okay. And fx of a plus is equals to fx of a, that means continuous from right hand side. And how will you write down this probability, this particular thing? Fx of b minus fx of a, right? So these are the properties of CDF, and this conclusion also should be there in your mind. So this slide and this particular slide is conclusion of whatever that we have studied till now in case of CDF, right? Let's see the questions now. Which of the following CDF is valid? So for CDF, what will happen? The graph will rise up from 0 to 1. It can remain constant but never decrease. Decreasing is not allowed. Decreasing is not allowed. So here graph is decreasing, not allowed. In rest of the cases, it is not decreasing. It will start from 0 and will go to 1. Starting from 0? No. Will go to 1? Yes, it is going to 1. Will go to 1? It is going to 2. Wrong. Now, starting from 0, going to 1. Yes. In a non-decreasing manner? Correct. Starting from 0, going to 1 in a non-decreasing manner. Here it increased, then again increased. So it never decreases. Increased, 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 constant. So this is also correct. So which of the following CDF is valid? So these two CDFs are valid, rest or are invalid. Starting from 0 will go to 1. Starting from 0 will go to 1. Going to 2, starting not from 0, starting from 1 by 2. And here it is decreasing, which is also wrong. Here it is going from 0 to 1, but it is decreasing. So what all are the condition? Should go from 0 to 1 in a non-decreasing manner. That's it. Should go from 0 to 1 in a non-decreasing manner. So this is about CDF. Let's see this question. CDF of random variable x is shown. You need to find the probability at x equals to 1, x equals to 2, x equals to minus 2 and then in these ranges. So quickly you let me know the answer. Probability at x equals to 1. What that would be? Fx of 1, or you can write down 1 plus minus fx of 1 minus. So what is the value of fx of 1 plus? Here is 1. 1 plus, the value is 3 by 4. And what is the value at 1 minus? The value is 1 by 2. So what you are getting? 1 by 4. 3 by 4 minus 1 by 2. 1 minus is 1 by 2. 1 plus is 3 by 4. Probability at x equals to 2. So fx of 2 plus fx of 2 minus. Fx of 2 plus, what is the value? 1. Fx of 2 minus, what is the value? 1 only. 2 minus just before 2. 1 only. What is the answer? 0. And you can see that graph is continuous here. Whenever the graph is continuous, the probability at a point would be 0. If the graph is continuous, no? But here at x equals to 1, there was a sudden jump. If there was a sudden jump, then probability at a point could be non-zero. Otherwise, it will be 0 only. Let's see the third example. Probability at x equals to minus 2. So let's see the graph at x equals to minus 2. The graph is continuous. It will be surely 0. You can check fx of minus 2 plus fx of minus 2 minus. Minus 2 plus, what is the value? 1 by 4. Oh, sorry. The graph is not continuous, no? At minus 2, there is a jump. Really sorry. At minus 2, there is a jump, no? Minus 2 minus value is 0. Minus 2 minus value is 0. And minus 2 plus value is 1 by 4. So at minus 2, graph is not continuous. There is a sudden jump. Here also there was a sudden jump. But here there was no jump. If there is a sudden jump, answer will be non-zero. So what do you think this graph will be made for which kind of a random variable? Like what will be the nature of x? It will be mixed random variable, right? Say yes or no. Why it is mixed random variable? Because you can see the sudden jump as well and you can see the continuous graph as well. You can see the sudden jump, continuous graph, sudden jump, continuous graph, right? So it will be a mixed random variable. Otherwise, if it was only discrete, then staircase would be there. If it was only continuous, then only continuous graph would be there. right? But staircase is also there and a continuous graph is also there. That's why it is mixed random variable, right? Now between -1 to 3, you need to find the probability between -1 to 3, including the 3. So higher limit included, lower limit not included. So this is the desirable condition that we want. So fx of 3 minus fx of -1, and this would be equals to fx of 3 plus, this would be equals to -1 plus, right? And how do you, and you can think about it, you can think as well, fx of 3, that means everything including the 3 as well, and this is what I want, minus fx of -1, everything excluding the -1 and rest of the things. That means between -1 to 3 including the 3 as well. So fx of 3 plus 3 would be somewhere here, fx of 3 plus would be 1, fx of -1 plus, fx of -1 plus, that would be 1 by 2. So answer is 1 by 2. Okay, so this is the answer, A, B, C, D, right? What about E? -1 to 3, -1 to 3. So fx of 3 plus is 1, fx of -1 plus, fx of -1 plus is 1 by 2. So 1 minus 1 by 2 would be 1 by 2. What about E? 1 to 4. Here I don't want the, sorry, here I want the equal sign and here I don't want the equal sign. So problem is there at higher limit as well and lower limit as well. Fx of 4 minus fx of 1 minus. So what is the value of fx of 4 minus? That is 1 only, because 4 will be somewhere here, here will be 3, here will be 4. So the value is 1. Fx of here 1, no, 1 minus is 1 by 2. So here also the answer is 1 by 2, right? Because 1 minus is 1 by 2, 1 minus is 1 by 2. So this is the answer. So this is how you can answer very easily, right? If the graph is given, this is how you can answer, right? So all the discussion we are solving now with respect to the questions. Now we need to study about probability density function. We will study about it and then we will solve questions as well. A lot of questions we are going to solve. Just we will see the concept of probability density function and then we will solve the problems. But I need to take a break. I will take some break. I will drink some water and then I will come back. So you in this time just revise everything. Whatever that I have taught, just revise everything. Just revise this slide and revise this slide. Try writing down all kind of expression on your own. This expression is very important. This expression is important for solving the problems if graph is given. If graph is given, then this expression will be useful. Here graph was given, this expression was useful. But if graph is not given and directly they are asking this kind of question, then this particular expression will be useful. So we will see that, right? But first let's study about PDF, then solve some problems, right? So let me take a break and then I will come back. Yeah, welcome back. So now we are going to study about probability density function, PDF. Last time what we studied, probability mass function and cumulative distribution function. What was probability mass function? Probability at a point. This was your probability mass function. And what was your CDF? That was random variable x takes value lesser than or equals to small x. This was your PMF. This was your CDF. Now what is this PDF? So PDF is not the probability at a point. A lot of people have this doubt that sir, PDF represents the probability at a point. No, PDF is not the probability at a point. So this thing should be there in your mind. So what does the PDF show? PDF shows the density of the probability around a particular point. What it shows? Density of the probability around a particular point. Let's understand this with respect to example. Okay, let's understand with respect to example. So a group of students typically takes 30 minutes to 60 minutes to solve a particular quiz. This kind of example we have already seen. A random variable x is defined such that it represents the time taken by a randomly selected student to solve a particular quiz, right? So x can take continuous values from 30 to 60. X can take continuous values from 30 to 60, right? So the PDF of random variable x has been shown. So this is how they have shown the PDF of random variable x. Between 30 to 60 they have shown. So if what this PDF is representing, so this PDF will tell you that around 40 minutes there is maximum amplitude. No, what I mean to say is that fx of x, this is how you represent the PDF. Okay, how we used to represent the PMF? How we used to represent the PMF? PMF was represented by small p x of x, right? How we represent CDF? This is how CDF was represented. And how we represent the PDF? So PDF is represented small f, capital X, small x. Okay, so this is how we represent PDF. So this particular PDF function have been made. So what do you see? Fx of x is maximum when x is around 40, not x equals to 40. When x is around 40, you are getting maximum amplitude of the PDF. You are getting the maximum amplitude here. That means in the class, most of the students are solving the quiz around 40 minutes. What I am saying, in the class, most of the students are solving the quiz around 40 minutes. This is the meaning of a PDF, a probability density function. So it is showing the density. It is showing the density that most of the students are lying in this range. After that, most of the students are lying in this range. After that, minimum of the students are lying in this range. And none of the student is lying in this range. That means no one is taking more than 30 minutes, no one is taking less than 30 minutes. Are you able to understand this point? So it shows the density. It doesn't show the probability at a point. If I ask you what is the probability such that the student is taking exactly 40 minutes, that would be 0. But around 40 minutes, it would be the maximum. Are you able to understand this point? That most of the students are solving the quiz around 40 minutes only. Some are solving in 39 minutes, some are solving in 41 minutes, some are solving in 39.5 minutes. But around 40 minutes, you are getting the maximum value. Is that clear to you or not? Okay. So let's go to the previous slide. So what is your PDF actually? So PDF is nothing. It is just the differentiation of CDF. It is just the differentiation of CDF with respect to x. So whatever the CDF graph you are having, if you just differentiate it, you will get your PDF. Okay. So CDF is nothing but the differentiation. PDF is nothing but the differentiation of CDF. So when you differentiate the CDF, you will get the PDF. Are you able to understand this point? Okay. We will see more points. Everything will be clear. Have some patience. So CDF of random variable is represented by capital Fx of x, and PDF is represented by small fx of x, right? And differentiation of CDF is equals to PDF. What I am saying, differentiation of CDF is equals to PDF. From this equation, if you want to get fx of x, what you will do? This differentiation will go this side, it will turn into integration. Let me know what will be the limit. If you have studied signal system, you will be able to tell the limit. The limit will go from minus infinity to x, right? So from PDF, if you want to get CDF, from PDF, if you want to get CDF, that means you need to integrate taking the limit minus infinity to x, and from CDF, if you want to get PDF, then you differentiate the CDF. Is that clear to you? So differentiation of CDF is equals to PDF, and integration of PDF is equals to CDF. Is that clear to you? PDF dot dx I will write down is equals to CDF. Is that clear? Okay. So first we understood the meaning of PDF. Secondly, we saw that what is the mathematical expression. Mathematical expression is just you get the CDF and then you differentiate it. This is the mathematical expression. We will see a lot of concepts, we will see a lot of problems as well. We will see the properties as well. So let's see this particular question. Probability such that your x is between A to B, including B, excluding A. So that can be written as fx of B minus fx of A, or it could be written as, because at higher limit I want the equal sign, at lower limit I don't want the equal sign. So this is the desirable condition, and I know that fx of B is equals to fx of B plus, and it is equals to fx of A plus. Now what do you know? That your fx of x is equals to minus infinity to x small fx of x dot dx. Do you know this? Right? So what would be your fx of B equals to? That would be equals to, in place of small x you need to put B. Say yes or no. Are you able to understand this point? Look, here I am writing down this particular thing that is not actually correct. Why it is not correct? Look, you are putting the limit in terms of x, and here also you are writing down x only. This point I explained in signal system as well, and here also I am explaining. Let's just say I am doing this particular differentiation, and then I say that I am putting the limit of x from 0 to x. Does that make sense? Although you can get the answer x cube by 3, 0 to x you will put, so answer will be x cube by 3. Or you can take minus 1 here, whatever you want to take. But it actually doesn't make sense. No, you are integrating with respect to x, and the limit you will put of x only in terms of x only. This doesn't make any sense. Although answer will be x cube by 3, you can get the answer. But actually it should be written in this form, no? That in place of what was the differentiation? What was the integration? This was the integration. But actually this should be written in this manner, t square dot dt. So in place of x I am just putting t. So what I will get? T cube by 3, and now I can put the limit from 0 to x. So I am putting the limit of t now in terms of x. I am putting the limit of t in terms of x. So what answer I will get? X cube by 3 again. So writing this down is not making much sense actually. It is not making much sense, right? So here the important part is this should not be written in this manner actually. Although in textbook as well or in a lot of notes as well, you will find out that PDF and CDF relation is written like this, but actually this should be written in this manner, that always you need to change the variable. So I am changing the variable by u, because here people will have a doubt that sir, in place of x if you are putting b, so here also you need to put b. No, this is just your function, and here also u, right? F of u, u du. This is the capital U, this is the capital U, and these are the small u. So I need to differentiate. This is the capital U, these are the small u. Are you able to understand this point? So here also I should have taken care that instead of writing x here, I should put u. Are you able to understand this point? Just mathematics it is, nothing else. It is mathematics, nothing else. U does not look like good, right? Because here you cannot differentiate. Let's put q here. Okay, let's put q, because q you can make small q and capital Q differently. So in place of x I am putting q. So here also in place of x I will put q only. Right, minus, what about this one? Minus infinity. In place of x you need to put a, because here you are having a, here you are having x. So in place of x you are putting a, right? You agree to this point? Let's take it downward a bit. So this does not make much sense. This makes the sense. Now what I will do? What I will do is that I will interchange this limit. In the integration, you know that if you interchange the limit, minus sign will turn to plus sign. So this minus sign will be turned to plus sign if I interchange the limit. So how will I interchange the limit? So this minus infinity to a, I am writing down a to minus infinity. Is that clear to? A to minus infinity. Fq of q dot dq. This negative sign has become to positive sign because you are interchanging the limit. And what about this one? This remains as it is. What you can see from here? A to minus infinity and then minus infinity to b. What does that mean? Do you remember this particular thing? A to b plus b to c. That means the limit of integration can go from a to c, right? You are going from a to b, then you are going from b to c. So it can go from a to c as well. So what is the answer you are getting? A to b, fq of q dot dq. So this is the answer of your probability taking value. And one more thing, in place of a, what you can put? In place of a, you can put a plus. In place of b, you can put b plus. So a plus, b plus, fq of q dot dq. So this is the answer you are getting, which you will be remembering, right? What about this one? What do you think? Okay, here just the conclusion I need to write down. So on the higher limit you want the equal sign, on the lower limit you don't want the equal sign. That means yes, this is the desirable condition. You are going from a to b, you are going from a to b. What you will do, you will just calculate the area of the PDF. Let's just say this PDF is given. What we can do is that we can kind of make a diagram as well. Let's just say this particular PDF is given. These are two any random point. What you need to find? From a to b you need to find. You need to find the probability such that your random variable x is lying between a to b. So what you will do? You will calculate the area. Taking the limit from a to b. Taking the limit from a to b. This is the PDF given. PDF will be given in terms of x, right? PDF will be given in terms of x. Now since the limit is constant, so now I can write down x, no? Are you able to understand this point? What I am saying? Since the limit is constant now from a to b, so now I can write down x here. I am just replacing q with x, nothing else. So from a to b you need to calculate the area, nothing else. Here what will happen? On the higher limit you want the equal sign, but on the lower limit you don't want the equal sign. That means lower limit is having some problem, but higher limit is not having any problem. But always remember in your mind that a is equals to a plus, b is equals to b plus, b is equals to p plus, right? What about this one? Again the integration, fx of x dot dx, again you need to integrate. On the higher limit you want the equal sign, on the lower limit you don't want the equal sign. So lower limit is not having any problem, but higher limit is having any problem. On the higher limit you want the equal sign, but it is not there. On the lower limit you don't want the equal sign, but it is there. That means both are having some problem. If both are having some problem, that means there you go. Is that clear to you? All good? All fine? Right? So the same way that we wrote down in case of CDF, in the similar manner we can write down in terms of PDF as well. So what if the diagram of PDF is given and they ask you the probability at probability in some range? Then you will be able to tell the probability in some range as well, right? And here I did not write one point. What if they ask you probability at a point? What if they ask you probability at a point? So what will be the answer for this one? Probability at a point, you will go from a minus to a plus, right? Fx of x dot dx. So they are asking me probability at a point. So I will go from a minus to a plus, and then I will calculate the area. So PDF simply means calculating the area, nothing else. PDF simply means calculating the area. I will go from a minus to a plus, and just think about it. If your PDF is continuous, then what will happen? You go from a minus to a plus. What will be the area? If I am making this particular graph, and let's just say this point is 2, and I ask you, I am going from 2 minus to 2 plus. What will be the area? 0 only, no? 2 minus to 2 plus, that means there is no width. There is height, but there is no width. If there is only height, what is the area? 0 area, right? So probability at a point for continuous random variable will be 0. So we will see all these examples, everything will be clear to you. As of now, you just keep on seeing what I am telling. So I am telling probability in a range from a to b. B is not having the equal sign. Sorry, B is having the equal sign, but A is not having the equal sign. This is our desirable condition. That means both A plus B plus. But this is not the desirable condition for the lower limit. That's why A minus. This is not the desirable condition for higher limit. That's why B minus. And this is not the desirable condition for lower limit as well, for higher limit as well. That means A minus, B minus. Well and good. Let's see the properties. So what do you know? That your PDF is just the differentiation of CDF, right? PDF is differentiation of CDF. And you know one particular thing, that your CDF can never be decreasing. It can be constant. It can be increasing, but it can never be decreasing. That means slope will always be positive or 0. Slope will always be positive or 0. That means what is the meaning of differentiation? Differentiation means slope only, right? The meaning of differentiation is slope. What is the meaning of differentiation? Differentiation means only the slope. So if your fx of x is non-decreasing, that means slope will never be negative. Slope will be either 0 or it will be positive, because it will either increase or it will remain constant. So here the slope is 0, here the slope is positive, here the slope is 0. So slope will either be 0 or it will be positive. So your PDF will never be negative. What is the meaning? PDF will never be negative. It can be 0 or it can be positive. If I want to find probability from minus infinity to infinity, let's just say here I put the equal sign. So what I will do? Fx of infinity minus fx of minus infinity. What is the meaning of fx of infinity? That means probability such that random variable x is taking value lesser than or equals to infinity. The value is 1. And what is the meaning of fx of minus infinity? Probability such that random variable x takes value less than equals to minus infinity. That would be 0. So between minus infinity to infinity, your probability will be 1. And it is very obvious, no? Just think about it. Your random variable will take any value between minus infinity to infinity only, no? If it is taking 0 value, it is taking some continuous value, whatever the value it will take, it will always be between minus infinity to infinity only, no? Are you able to understand this point? And how this particular thing could be written? This particular thing could be written in this manner, right? We have seen it, right? Fx of b minus fx of a. Fx of b minus fx of a was written as a to b and then integration. Here fx of b minus fx of a, it was written a to b and then the integration. Similarly, from minus infinity to infinity, then this is how it will be written, that you need to integrate from minus infinity to plus infinity. So what that would be equals to? So this particular thing is equals to 1. That means this particular thing will also be equals to 1. That means area under the PDF curve will be equals to 1 only. Are you able to understand this point? Basically, whatever your PDF is drawn, let's just say any PDF is drawn, any kind of PDF could be drawn. The area under the PDF curve will be 1. This kind of, let's just say this kind of a PDF is drawn. It could be decreasing as well. Never ever I said that PDF could not be decreasing. PDF could be decreasing, but it should be positive. That's the only condition, that this is how your PDF is drawn. This is how your PDF is drawn. It is your fx of x versus x. So if you calculate this particular area, if you calculate this particular area, this particular area will always come out to be 1. This area will be 1. Why is that so? Because you know that from minus infinity to infinity, x will take all the values. That means probability should be 1 only. Is that clear to you? And how do you write down this particular thing? You write down this particular thing as, you go from a plus to b plus fx of x dot dx. So this slide and this particular slide both are very important. So for PDF, what did you understand? It can never be negative and the area under the curve should be 1. That's it. Only 2 conditions. What are the 2 conditions? For CDF, what was the condition? For CDF, what was the condition? It will rise from 0 to 1 in a non-decreasing manner. What will be the condition for PDF? Always not negative. I am just writing not negative and area under the curve is 1. Not negative and area under the curve is 1. This is the condition for PDF. So let's solve a question. X is again the number of heads appearing when 3 coins are tossed simultaneously. So this we have already seen. That means x will take values from 0, 1, 2, 3. Right? So we know how to draw the PMF. Right? This was equals to 1 by 8. This was equals to 3 by 8. This was equals to 3 by 8 and this was equals to 1 by 8. So can you draw the PMF? Yes, we can draw the PMF. Where is the PMF that we have drawn? So PMF was drawn here. This was the PMF that we have already drawn. So this is how the PMF will look like. And can you draw the CDF as well? Surely I can draw the CDF as well, because for the same example we have seen the CDF as well, right? For ditto same example we have seen the CDF as well. So this is how I can draw the CDF as well. Next task would be to draw the PDF, right? So this is the CDF that we have drawn. Now we need to draw the PDF. What did I tell you? What is your PDF? PDF is fx of x. What that would be? Differentiation of CDF. So what you will get? Can you differentiate this particular curve? I hope you know how to differentiate. So starting from here, 0. Then there is a sudden jump of 1 by 8. That means here what will come? Impulse of area 1 by 8. Then 0, 0, 0, 0. Here what is the slope? Here what is the slope? If I ask you the slope here, slope is 0. But here there is a sudden jump. Here there is a sudden jump. Here there is a sudden jump. Here also there is a sudden jump. So wherever there is a sudden jump, slope is infinity. But in electronics, how do we show infinity? We show the infinity by impulse. Impulse of some area. Impulse of area 1 by 8. Okay. Then impulse of area 1 by 2 minus 1 by 8, what that would be? 1 by 2 minus 1 by 8, that would be 3 by 8. Now 7 by 8 minus 1 by 2, what that would be? 7 by 8 minus 1 by 2, that would also be 3 by 8. And then 1 minus 7 by 8, that would be 1 by 8. So slope 0, 0, 0, everywhere 0, just only you need to see the sudden jump. So 1, 2, 3. 3 by 8, 3 by 8, 1 by 8. So wherever there is a sudden jump, you will have an impulse of area equals to the jump. So jump is equals to 7 by 8 minus 1 by 2. How much jump is there? 3 by 8 jump is there. Then again 3 by 8 jump is there. Then 1 by 8 jump is there. And here in the beginning as well, 1 by 8 jump is there. Right? So this kind of a PDF you are getting. So this is your PDF. If you closely see the graph of PDF and the graph of PMF. So it is the same, just these discrete sequences have become impulses. These discrete sequences have become impulses. But this is true for your discrete random variable. For discrete random variable, we have drawn PMF as well, we have drawn CDF as well, and we have drawn PDF as well. For continuous random variable, your PMF will always be 0. But for continuous random variable, PDF will not be always 0, right? For continuous random variable, we have seen this kind of PDF, no? This kind of PDF we saw. So for continuous random variable, PDF will not be 0, but it will never have the impulse. Whenever you see impulse, in case of CDF, whenever you see sudden jump, what will you understand? That the random variable is discrete. And in case of PDF, whenever you see impulse, because in CDF if there is sudden jump, that means in PDF there would have been impulse, no? Because if you differentiate the sudden jump, what do you get? You get impulse. When I differentiate the sudden jump, I get impulse. So in your CDF if there is sudden jump, or in your PDF if there is impulse, that means it is discrete random variable. And if the graph is continuous, then it is continuous random variable. Are you able to understand this point? Continuous means continuous random variable. And if you see sudden jump in CDF, that means it is discrete random variable. And in PDF, if you see impulse, that means it is discrete random variable. Is that clear to you? Although it will not be asked, I'm just telling you that looking at the PDF, can you let me know what kind of random variable we are going to study? Yes. So we saw this example. This was purely discrete random variable. So only impulses were there. Are you able to understand this point? Right? Okay. And if someone asks you from this particular PDF, if someone asks you what is the probability at x equals to 1, what you will do? From 1 minus to 1 plus, you will calculate the area. From 1 minus, here there will be your 1 minus, this will be your 1 plus. So from 1 minus to 1 plus, you are having an impulse of area 3 by 8. This would be your answer. Are you able to understand this point? Right? So probability at a point is non-zero for discrete random variable. This is a discrete random variable. So probability at a point is non-zero for discrete random variable. But if it was a continuous random variable, then probability at a point would be 0 only. We will see the example. It will be more clear to you. Let's see this question. So can you let me know what kind of random variable we are studying here? What kind of random variable x would be? X would be what kind of random variable? So here you can see that graph is continuous as well. Along with that, you are having an impulse as well. So surely 3 by 2 a different value it will take. Otherwise, it will take the continuous values. Here, what do you understand? How much values your random variable x is taking? So x is taking one discrete value, that is 3 by 2, and continuous value between minus 2 to 2. Are you able to understand this point? Okay. So this is a kind of PDF is given for random variable x. So continuous values are also there, discrete values are also there. So it is your mixed random variable. Although this doesn't make much sense, but yeah. Okay, practically this example will not be possible. Theoretically you can make any kind of curve, but practically this example will not be possible. Theoretically it is fine. First you need to find the value of alpha. What do you think? How will I find the value of alpha? I know one thing, the area under the curve will be 1. For PDF, area under the curve, what I need to find? I need to find the value of alpha. So for PDF, area under the curve is always 1. That means what do I know? From minus infinity to infinity, fx of x dot dx would be equals to 1. So we need to find this particular area, this area, this area, and then there is an impulse as well. So let's find the area. Okay. So between minus infinity to minus 2 everything is 0, between 2 to infinity everything is 0. So I need to care about only between minus 2 to plus 2. So what will be the area? Here this is a triangle. So half into base is 3, height is alpha, plus what about this? So this particular structure will have an area of half into addition of parallel side alpha plus 0.7 into the height which is 1. That's it. This is the area. No, this particular area is also there, no, because this is impulse plus alpha by 10. So this will be equals to 1. This is triangle. Then this particular structure, this will have the area of half into, or you can find it out in this manner, that this is a triangle and this is a rectangle. In that as well you can find. In that manner as well you can find. So you will get the same answer only. 0.5 plus half into base will be 1 into height will be 0.2. Wait a second. Yeah, sorry. Here I did a mistake, no. Here I did a mistake, sorry. Let's not do it. Like basically find the area like this, that there is a triangle and then there is a rectangle. So what will be the area of the triangle? Half into base. What is the base? 0.2. Sorry, base is 1. And what is the height? This height is 0.2, right? This height is 0.2. Plus, what about this rectangle? So will you take alpha or 0.5? Basically this is the rectangle, no? So I need to take 0.5, no? I took alpha previously. So 0.5 into 1, that will be the area of a rectangle, right? Are you able to understand this point? So this is how I need to write down. I could have applied this formula as well, half into addition of parallel side. So parallel side would be these two sides, 0.5 plus 0.7, that would be 1.2 into the height, that would be 1. So 0.6 you will get. So in both of the cases you will get 0.6. So what you are getting actually, you are getting 1.5 alpha, 0.1 alpha, 1.6 alpha, 1.6 alpha plus 0.6 is equals to 1. So alpha value you are getting as 0.25, right? Yeah. So alpha value is coming out to be 1 by 4. This is the value of alpha that you are getting. Okay. Next question. Probability at x equals to 1. Probability at x equals to 1. Probability at a point. So what you will do? 1 minus to 1 plus fx of x dot dx. What will be the answer? 1 minus to 1 plus. That means the width is 0. Look, basically if there is no impulse, and I ask you that I am calculating the area from a minus to a plus. So this particular width is 0 only, no? Your answer would be, sir, this amplitude, whatever the amplitude is, alpha, into the width. A minus to a plus, what is the width? 0 only. So what is the answer you are getting? 0. But if there is an impulse, and I ask you the area from a minus to a plus, then that would be equals to the area of this particular impulse, and that impulse, let's just say it is having amplitude of 3 by 2, so the area will be 3 by 2. So if the graph is continuous, then there is no meaning of area between minus a to minus 1 minus to 1 plus, the area would be 0 only, and you can directly see the graph is continuous. That means probability at a point will be surely 0. This area is 0. How will you find probability at 3 by 2? So you will take the area from 3 by 2 minus 2, 3 by 2 plus. Now here what you can see, here you can see that there is this impulse present. From 3 by 2 minus 2, 3 by 2 plus, this impulse is present, and this impulse is having an area of alpha by 10. So alpha by 10 would be the answer, and that would be equals to 1 by 40. And what about the last one? In the range minus 1 to 3 by 2. Probability not minus 1, it is 1. From 1 to 3 by 2. Now you let me know one thing. At 3 by 2, do you want the equal sign? Yes. At 1, do you want the equal sign? No. That means you are having problem at both of them. So what you will take? 1 minus 2, 3 by 2 minus fx of x dot ds. 1 minus would be this point only. That means 1 minus is equals to 1 plus only basically. 1 minus, what will be the amplitude at 1 minus? That would be alpha. What will be the amplitude at 1 plus? That would also be, amplitude at 1 plus will be different. And what will be the amplitude at 1? That would also be different. Basically 1 minus would be this. You need to calculate the area from here to 3 by 2 minus, 3 by 2 minus, but the impulse is there at 3 by 2. That means this impulse will not come into action. Are you able to understand this point? A very, very important point. This impulse will not come into action, no. You need to calculate the area from 1 minus to 3 by 2. 1 minus to 3 by 2. 1 minus 2, this is your 1 minus. To 3 by 2 minus. So impulse is there at 3 by 2. So this impulse will not come into action. Right? So what all things will come into action? So this area I need to calculate now. Say yes or no. So this is your alpha. This was your alpha, but area you are calculating, no, basically this area you are calculating. This area you are calculating. Right? This particular area you are calculating. So here what will be this amplitude? 0.5. And here what will be this amplitude? What is the slope? Slope is 0.1. So this amplitude will be 0.6. Like, have you studied mathematics? If you have studied mathematics, you know that what is the slope here? 0.2 divided by 2. The slope is 0.1. That would be equals to y2 minus y1, y2 minus y1 upon x2 minus x1, x2 minus x1, x2 minus x1, y2 minus y1. y2 value you don't know. So 0.1 is equals to y2 minus 0.5 divided by 0.5. So this will be 0.05. 1 say 3 by 2. You are covering the half distance. 0.5. What is the slope? So, sorry, slope is 0.2 only, no, really sorry guys. The difference 0.2 divided by 1, slope is 0.2 only, no, slope is 0.2, slope is 0.2. This divided by this, the slope is 0.2. So 0.2 is equal to this, so y2 is coming out to be 0.6. So this particular width is 0.5 to 0.6. So this particular area I need to calculate. So what is this area? This area is half into addition of parallel side, that would be 1.1 into this width, that would be 1.1 divided by 4. This would be the answer. We will not add alpha by 10 here. This is the very, very important point. Here this 1 by 40 will not be added. This will not be added. Okay, because what they asked, 3 by 2 should not be included. The probability at 3 by 2 should not be included. So just before 3 by 2, just before 3 by 2. So from 1 minus to 3 by 2, this area we need to calculate. Look, someone will say that, sir, from 1 minus to 1, what will be the area? You are actually calculating the area from 1 to 3 by 2. Yes, I know that I am calculating the area from 1 to 3 by 2. But from 1 minus to 1, what will be the area? That would be 0 only, no? If I need to calculate the area from 1 minus to 3 by 2 minus, so I can calculate the area from 1 to 3 by 2 as well, no? Because at 1 there is no impulse. If there is an impulse, then there is a difference between 1 minus to 1. If there is no impulse, then there is no difference. So area from 1 minus to 1, that would be equals to 0 only. From 1 to 1 plus, that will also be equals to 0. But from 3 by 2 to, from 3 by 2 minus to 3 by 2 plus, the area would be different. What I am saying, from 3 by 2 minus to 3 by 2 plus, the area would be different. The area is alpha by 10. But from 1 minus to 1 plus, the area would be 0 only. Here we have seen 1 minus to 1 plus, the area would be 0. But from 3 by 2 minus to 3 by 2 plus, the area would be different. And then we calculated this particular answer. Right? We calculated the area here. The important part was what will be the amplitude here, that would be 0.6. Okay. You solve this question. Which of them are valid PDF? I will take a break. I need to drink some water and then I will come back. Okay. So you solve this question. Yeah. Welcome back. So did you try this question? So what is the condition for PDF? We already wrote down that it cannot be negative. It cannot be negative and area under the curve should be 1. There is nothing about increasing, decreasing, right? There is nothing about increasing, decreasing. It can decrease as well. Only two conditions are there. It cannot be negative and area under the curve should be 1. Is it negative? No. Area under the curve is 1. Yes. Is it negative? No. Area under the curve is 1. Yes. You can see 10 into 0.1. That would be equals to 1 only. Correct. Is it negative? No. Area under the curve is 1. Yes. 0.75 plus. Is it negative? No. Area under the curve is 1. Yes. 1 by 4 into 2 plus here 0.5. So 0.5 plus 0.5, that would be 1. Is it negative? No. So that means this is also valid. What about this one? Negative. Negative. Forget about the area under the curve. It cannot be negative. If it is negative, then not valid. Right? Area under the curve could be 1, but it cannot be negative. That is the required condition. Let's go to the next question. PDF of random variable x is given. Now you will say that, sir, PDF of random variable x is written by this particular thing. But the examiner can show the function in any manner, no? What I am saying, examiner in the examination, the examiner is showing the function like this. Although usually it is shown by like this, but examiner can show the function in any manner, right? So what they have given? They have given the PDF. What you need to find? You need to find the value of k. So what you will do? You already know one thing. Area under the curve should be 1. Area under the curve should be 1. And here limit also you need to see. It is going from minus infinity to infinity only. So that means yes, this limit will be from minus infinity to infinity only. Minus infinity to infinity. K e to the power minus 3 mod of x dot dx. Is it a even function? Yes, it is a even function. So how you can break it down? 2 into 0 to infinity k e to the power minus 3x dot dx. So what will be the answer? This should be equals to 1. This should be equals to 1. So what answer you will get? When you solve this particular integration, you will get 2k by 3. That should be equals to 1. So value of k is coming out to be 3 by 2, which is 1.5. Very simple. Whenever you need to find out any constant value, just remember area under the curve is 1. So calculate the area and equate that equals to 1. So area was coming out to be 2k by 3. That should be equals to 1. So k is 1.5. A random variable PDF of random variable x is given. You need to find the CDF. So what is the relation between PDF and CDF? If PDF is given, you just need to integrate it. What you will get? You will get the CDF. So you need to integrate. What is this? Ramp. And this is also ramp only. So when you integrate a ramp, what you are going to get? Linear graph? No. Parabolic? No. When you integrate a ramp, what do you get? Parabolic. Integration of t dot dt. What that would be? T square by 2. So basically square kind of relation will be there. Linear relation will not be there. Square relation will be there. So this kind of relation will be there. So this answer is correct. Right? Very simple questions. Right? And this answer would be wrong. PDF is given, you need to find the CDF. Again, this time expression is given. A is greater than 0, B is greater than 0. You need to find the CDF for x greater than 0. Condition is for x greater than 0, you need to find the CDF. So what I need to do? What will be my CDF? that will be integration of PDF. Can you draw the graph of PDF? Surely I can draw the graph of PDF. Will it be an even graph? Yes. At x equals to 0, the value will be a. At x equals to infinity, value will be 0. And the graph is even because in place of x, if you put minus x, you get the same graph. So graph is even. So this will be the graph of your PDF. Here what they are saying, here if I am putting the limit of x, so here I should not put x, right? I should put q. If I am putting the limit of x, sorry, if I am putting the limit in terms of x, then here I should put q, right? So here I will say that I have drawn the graph of, basically I know fx of x, then I know f, if I know fx of x, then can you let me know what will be your fq of q? That would be equals to a e to the power minus b q. So you need to find the CDF such that your x is greater than 0. That means I need to find the CDF such that your q is greater than equals to 0. So this is my q. So fq of q I am drawing with respect to q. And this q is here. Or sorry, the thing is, really sorry guys, the x should be greater than 0. That means this limit is greater than 0. This is what they are saying. Basically you are integrating from minus infinity to x. You are integrating from minus infinity to x. So x should be lying here. It should not be lying here. So x is lying here. X is greater than 0. So can I break down this limit something like this? Minus infinity to 0 fq of q dot dq plus 0 to x f q of q dot dq. Do you agree to this point? Because x is greater than 0, no? That's why this information is given. Because some guys may understand that x is here. That means they will consider only this particular graph. But x is greater than 0. That means this graph should be considered. Also this graph should also be considered. So between minus infinity to 0, what kind of relation, what kind of expression you are having? What I mean to say is that, can you write down the expression of fq of q in this manner? That what do you get x greater than 0 and what do you get x less than 0? So when x is less than 0, so this graph will be opened, mode of x will be opened with minus x. These kind of calculation we have done when we studied convolution, right? And for x greater than 0, it will be opened as plus x only. So this is the graph. Okay, it will be opened as minus x, so this will become, x will be replaced with minus x. For x less than 0, mode of x is minus x, right? So this will become a e to the power bx, and this will become a e to the power minus bx. Is that clear to you? And since here in place of x we are putting q. Is that clear to you? Surely it is clear to you. So minus infinity to 0 a e to the power bq dot dq plus 0 to x a e to the power minus bq dot dq. So what you will be getting? Do you have the page? No, I have to add a page. So you are integrating with respect to q. So a e to the power bq divided by b. So minus infinity to 0. You are putting the limit of q now, right? And then again here as well, a e to the power minus bq divided by minus b from 0 to x, right? So what I will get? A by b is constant. So from the first one I can take out a by b. Now I am putting the limit of q. So 0 I will put and 1 I will put. So e to the power 0 minus, here I will put infinity. So this will be 1 minus. I can take out minus a by b because minus sign I am taking out, a by b I am taking out. So here I am getting a by b. So put the limit of x e to the power minus bx and then put the limit q equals to 0, you will get 1. A by b minus sign I took out. So here it will be a by b. Here what you are getting? A by b e to the power minus bx minus 1. So this is the answer you are getting. Or what you can do, So this will actually become 2a by b minus a by b e to the power minus bx. Can you understand this point? Basically minus a by b is there, a by b e to the power, what I mean to say is that let's keep a by b as it is, minus a by b e to the power minus bx plus a by b. So that would be equals to 2a by b minus a by b e to the power minus bx. So a by b 2 minus e to the power minus bx. So your fx of x is coming out to be, just it was purely based on integration, nothing else. With this particular question, I just wanted to test the integration, nothing else. There you go. This is what we are getting. Is this correct? Like, is there any calculation mistake? Let me check. E to the power minus bx, power minus bx minus 1, minus 1, minus sign is there outward. A by b minus a by b to the power minus bx. This minus sign will become plus sign to a by b. A by b 2 minus a to the power minus bx. Yeah, there you go. This is the answer you are getting. Considering the fact that you are taking x greater than equals to 0. So what could be the other way of writing it down? The other way could be a by b 2 e to the power minus x u of x. But considering x greater than equals to 0, for x less than equals to 0, the answer would be different, right? Are you able to understand this point? This is the answer that you are getting for x greater than equals to 0, because this is what is asked in the question. But in the question, what if they have mentioned x is less than 0? For x less than 0, what answer you will get? For x less than 0, you will integrate from minus infinity to x till this point. Are you able to understand this point? Basically, your fx of x would be, I will sorry, what you need to find, this is, sorry, really sorry guys, this was your CDF, right? This was your CDF, not PDF. This was your CDF, right? So what you will do for x less than 0, what you will do, I will integrate from minus infinity to x only. I will integrate from minus infinity to x, but now your x is less than equals to 0. If it is less than equals to 0, that means somewhere here it will be lying. If somewhere here it will be lying, then that means your fx of x or fq of q will be this particular function only, right? So it would be a to the power bq, because only in this range you are integrating. So this particular function is a to the power bq, and this particular function is a to the power minus bq. So a to the power bq dot dq. So when you integrate it, what you will get? A by b e to the power bq minus infinity to x. So what you will be getting? A by b e to the power bx. This is what you are getting for x less than 0. So now what is your complete expression of fx of x? Let's not put this in the box. Complete expression of fx of x. Although this is a gate PYQ, so in the gate PYQ they only asked for this condition, but this is the answer that you are getting for x considering less than equals to 0. Are you able to understand this particular analysis, right? X could be greater than 0, x could be less than 0, because x is a varying limit, no? The limit is varying. So it could be greater than 0, could be less than 0. If it is greater than 0, that means this graph is also coming into action and this graph is also coming into action. So this particular graph is coming into action from 0 to x, and this particular graph is coming into action from minus infinity to 0. So we got this particular answer, and here we have got this particular answer. Answer for less than 0 is coming out to be this, and answer for greater than 0 is coming out to be this. So this is your complete fx of x that you are getting. So for less than 0 you are putting u of minus x, for greater than 0 you are putting u of x. So this is your complete fx of x. This is the complete answer. In the examination only this particular thing was asked. but the complete expression can also be asked. Is that clear to you? Right? And here someone will say that, sir, what is the value of fx of minus infinity? So if you put fx of minus infinity, that means this is already gone, because u of x is 0 at x equals to minus infinity, and if you put minus infinity here, what you will be getting? A by b e to the power minus infinity, that would be 0 only. So fx of minus infinity is coming out to be 0 only. And what is your fx of infinity? Sir, if I put fx of infinity here, that means in this expression I will put fx of infinity. Basically, this particular expression is valid for x less than 0, and this particular expression is valid for x greater than 0. So if I put x equals to infinity, then I will care about this particular expression. If I am putting x equals to minus infinity, then I am caring about this particular expression. So here I put x equals to minus infinity, I am getting 0. Here I put x equals to plus infinity, what I am getting? 2a by b. If I put plus infinity here, so e to the power minus infinity, that would be 0. So I am getting 2a by b. And actually, what should be the value of fx equals to infinity? That should be 1. So your 2a by b should be equals to 1. And surely it is 1 only. Why is that so? Because what will be the area of this particular thing? Can you let me know what will be the area of this particular thing? The area of this particular expression, basically what I am saying is that minus infinity to infinity fq of q dot dq. You do this particular expression. Basically, you find the area for this particular expression from minus infinity to infinity. What you will get? This will throw 1 by v. This will throw 1 by b. And here amplitude is a. So answer will be a by b. But the same thing will be happening towards the negative side as well. So your answer would be 2a by b. And that should be equals to 1. So 2a by b should be equals to 1. And here what you are getting? 2a by b only. And that should be equals to 1 only. Yes. So if they can ask this particular question as well, that what is the relation between a and b? So the relation is 2a is equals to b. Or this expression also they can ask. Or this only expression they can also ask. So a lot of questions can be asked from this particular question. Are you able to understand what we are doing? They could have given this particular expression and they asked you what is the relation between a and b. So what you will do? Area under the curve is 1. So you calculate the area, what you will get? A e to the power minus b mod of x dot dx. In signal system, I told you, just remember the answer of this particular thing. That will throw 1 by b. So this particular area is 1 by b. Amplitude is a. If amplitude was 1, then answer would be 1 by b. If amplitude is a, so here answer would be a by b. And similar thing is happening towards the negative hand side as well. So answer would be 2a by b. Is that clear to you? Right? And that should be equals to 1. So 2a by b should be equals to 1. And then we find out the expression of fx of x. Here also I can check that I know that fx of infinity should be 1. And what is fx of infinity is coming out to be? 2a by b. So that should be equals to 1. Right? Let's go to the next question. Find the probability in the terms of CDF and PDF. Okay, just this is kind of repetition only. So how you can write it down? Probability of x less than equals to 2 minus probability of x equals to 2. Is that clear to you? Why I put this less than equals to sign? Why I am always interested in this less than equals to sign? Because I know that this can be converted into CDF. So this would be fx of 2 minus fx of 2, probability of x taking values lesser than equals to 2 minus probability at x equals to 2. Because what this is saying, everything less than 2 but not 2. So that's why I subtracted the probability at x equals to 2. So this is how I can write it down. And in case of PDF, how I can write it down? I need to find probability less than 2. Probability less than 2. That means from minus infinity to less than 2. 2 should not be included. Probability less than 2. So minus infinity to 2 minus, I will calculate the area. There you go. What about greater than 2? Can it be written as? Say yes or no. Do you agree to this point? X should be greater than 2. So it can be written as 1 minus p x less than equals to 2. Because you know that probability x greater than equals to 2 plus probability x less than equals to 2 should be equals to 1. Because this will take all the values, no? If here is 2. So greater than 2 and less than 2, here including 2 as well. So 2 is also included, greater than 2, less than 2, everything is coming. So can I write it down probability of x greater than 2 as 1 minus probability of x less than equals to 2? Because if everything is included, that means probability will be 1. If I ask you probability from minus infinity to infinity, what is that? That is 1. And it can be broken like this. x greater than equals to 2 plus x less than 2 should be equals to 1. So probability of x greater than 2 would be 1 minus probability of x less than equals to 2, and it can be written as 1 minus fx of 2. And what about in terms of a PDF? So what you need to do? You need to go from 2 to infinity. 2 to infinity. You need to go from 2 to infinity, but excluding the 2. No, sorry. 2 plus to infinity, right? You are going from 2 to infinity. 2 to infinity, but 2 should not be included. That means you should go from 2 plus to infinity, right? This is your 2 minus. Here, why I am going from minus infinity to 2 minus? Because here 2 should not be included. So this 2 should not be coming into action. So I am going from minus infinity to 2 minus. And here 2 should not be included. So I will go from 2 plus to infinity. Is that clear to you? Or how you can write it down? Say yes or no. Can I write it down in this manner? This particular thing can be written in this manner. Say yes or no. 2 to infinity, greater than 2, less than equals to infinity. X is greater than 2. So when lesser sign is there, I don't care about the equal sign. That means this is perfect. So 2 plus 2 infinity. If this is something that I required, then here 2 plus would be coming. If here this was the thing, then what would come? 2 minus would come, right? So this is how you can compare, or you can directly think as well. So this is how I am thinking as well. In short manner, you can write down here that what I just told. Similar question you could have solved in this manner as well. Right? Let's remove this equal sign, because infinity, at minus infinity, if you put equal or not equal, both are same. Now just let me know, this particular thing I am writing down as this, minus infinity to 2. Here you needed the equal sign, but it is not there. That means here I need to put a minus, which I am putting directly here. Is that clear to you? Right? All good? All fine? Okay, yeah, that's it. Now x greater than 2. So this can be written as probability of x greater than 2. But I need to write down in terms of less than 2. So this can be written as 1 minus x less than 2. Say yes or no. Right? All good? But if I put an equal sign here, that means I am killing the 2 as well. But I don't need to kill the 2. I need probability at 2 as well. So this is perfect. Do you understand this point? What you need? Greater than 2. Everything including 2 and greater than 2. So what I did, complete is 1. Complete is 1. 1 minus everything less than 2 including the 2 I subtracted. Everything less than 2 and including the 2 I subtracted. So now what is subtracted? 2 is also gone and less than 2 is also gone. But what you need? You need 2 as well, no? So that's why I need to add probability at 2 as well. Is that clear to you? And why I am caring about this equal sign? Because you know, what do you know? You know that I care about this particular thing a lot. Which particular thing? This particular thing a lot. Right? And how you could have solved it? If you don't want to use the brain, x greater than 2 you need, no? Right? That means x should be greater than 2, it should be less than infinity. So what will be your answer? Fx of infinity minus fx of 2 minus. Basically at infinity you put this or not, that doesn't matter. But here at the lower limit you don't need the sign. But at the lower limit you are getting the sign, that means 2 minus you need to put. What is fx of infinity? That is 1. So fx of 2 minus you are getting. Now I need the answer in this form. What I will do? I know that fx of 2 plus minus fx of 2 minus is equals to probability at x equals to 2. So now I need to replace fx of 2 minus. So what that would be? That would be equals to probability at x equals to 2. So fx of 2 minus probability x equals to 2 would be equals to fx of 2 minus. So this fx of 2 minus you can put here. Fx of 2 minus you can put here. So what you will be getting? This sign will become plus and this sign will become minus. So this is something you will get. So here no brain is used. Are you able to understand this point? We are not using our brain. Directly whatever that we know, from there we are solving the problem. So okay, I will write down all these points again. Okay, so on the next page I need to add a page. I will solve all the problem with respect to what? With respect to whatever that we remember. What is the first question? Probability of x less than 2. X less than 2. That means it can be written as from minus infinity to 2, right? So lower, no issue, but higher there is an issue. So 2 minus fx of minus infinity. What is fx of minus infinity equals to? That is equals to 0 only. So what is the answer you are getting? Fx of 2 minus. But you know one particular thing. What do you know? That probability at x equals to 2 would be given as fx of 2 plus, or 2 you can put, minus fx of 2 minus. So fx of 2 minus could be given as fx of 2 minus probability at x equals to 2. So what is the answer you are getting? Fx of 2 minus probability x equals to 2. So this was the answer we were getting. So here we used our brain, but here we used our method. Are you able to understand this point? Second one, probability x greater than 2. That means x is greater than 2 and less than infinity. You can put the equal sign here, doesn't matter. So fx of infinity minus fx of 2. Here you don't need the equal sign, which we are not getting. So answer is 1 minus fx of 2, which we were getting here. 1 minus fx of 2, right? And here minus infinity to 2 minus 2 plus to infinity, that you can do from here only, right? From here as well. If you see this particular thing, what you can see, you will take the integration from minus infinity to, here you need the equal sign, which is not there. 2 minus fx of x dot dx. And what about this one? Here you don't need the equal sign. Here also here you need the equal sign, which is there. Here you don't need the equal sign, which is not there. So that means everything is perfect. So 2 to infinity dot dx. Now you will say that, sir, 2 plus you have written. So yeah, 2 plus also I can write down, because I told you 2 and 2 plus both are same. In our communication system, 2 and 2 plus are same, right? This I already told you. Third one, probability of x greater than 2, greater than equals to 2. So how you can write down? So here you need the equal sign, which is there, but this is creating the problem. So fx of infinity minus fx of 2 minus. What is fx of infinity? That is 1 minus fx of 2 minus. What is fx of 2 minus equals to? 1 minus fx of 2 plus probability at x equals to 2. So no brain used here. Simple answer we are getting. Here we used our brain, but here simple way we have got the answer. Because the thing is, in the examination, brain doesn't work. Okay, in the examination, these method might be very helpful for you. If your brain is not working, then just go to the method, right? Because here on PrepFusion, we believe on both of the things, method as well and using the brain as well. Because eventually, when you get into the industry, or even if you get into the PSU, if you get into VLSI, wherever you go, you need to use the brain, not the method, right? Method are just to crack the examination. But cracking the examination is also important, because if you don't crack the examination, you won't get the admission. And if you are not getting the admission, then you will not be able to do well, right? It is very easy to say that examination doesn't define anything. Examination does define something, okay? The statement that examination doesn't define anything, that is absolutely wrong. This is very sad, but it is the harsh truth that your marks do matter, okay? Because if you don't get the marks based on the sympathy, no one will take the admission. No one will give you the job based on the sympathy, right? Even if you open your own organization, will you give anyone any job just based on the sympathy that this is a poor guy? If you are the CEO of the organization, no, you will not give, no. Because you know that I need to run my company. If I don't run my company, you can give him donation. You can give him some loan as well, but you will not give him job, right? So on sympathy, these things don't work. Your marks do matter. Sadly, it is the truth. So here what you will write down? 2 minus 2 infinity. Here as well you think about it. X greater than 2. X greater than equals to 2. Greater than equals to 2. Greater than equals to 2. So that means you will go from 2 minus to infinity. Are you able to understand this point? Here what do we see? Here equal sign is not required. So here we are having a problem. So 2 minus we are getting. Here also we will do the same thing. Greater than equals to 2. That means 2 should also be included, no? So I will go from 2 minus to infinity. Now someone will say that, sir, why 2 minus? We could have gone from 2 as well. We could have gone from 2 as well, because including the 2. But the problem is, let's just say, what if at 2 you are having the impulse fx of x. Here what if you are having an impulse? So if you are having an impulse at x equals to 2, then you cannot define the integration at x equals to 2, no? Basically, if I need to find out this probability, that means I need to take this impulse into action, because probability at x equals to 2 will be coming by this area. So if I am having the impulse here, that means I need to take the limit from 2 minus, no? So that this impulse becomes into action. Because I told you, for impulse, you will never define impulse, you will never define the integration of the limit at that particular point. You can never do 2 to infinity. You have to do 2 minus to infinity. So 2 minus to infinity. Right? Mod of x greater than 2. Can you solve it? So x should be greater than 2 and x should be less than minus 2. Right? Mod of x greater than 2. So if x is 3, 4, 5, everything will work. If x is minus 3, minus 4, minus 5, everything will work. So x is greater than 2, x is less than minus 2. So what you are saying? X is either greater than 2 or x is less than minus 2. So here for greater than 2 you have written, and less than minus 2 also you can write down. You can do it on your own, right? Basically here I cannot write down in this manner that minus 2 to 2. It is not minus 2 to 2. It is greater than 2 or less than minus 2. Greater than 2 or less than minus 2. This is the condition. So you can write down on your own, right? Now this particular thing and this particular thing you can write down on your own, because just compare with this. You will get the answer, right? Now mod of x less than equals to 2. Mod of x less than equals to 2. Mod of x less than equals to 2. That means x should be between minus 2 to 2. Say yes or no? Mod of x is less than equals to 2. That means x would be 1, 0, minus 1, everything will work. So x should be between minus 2 to 2. Or in the mathematics, we solve it, right? How do we solve it? Basically, what method I tell is that you first solve this particular thing. What you are getting? X equals to 2 and minus 2. So you make a line, x equals to minus 2, x equals to 2. Then you put any point. Let's just say I put 3. Then you put in this inequality. 3 is greater than equals to 2. 3 is less than equals to 2. Not true. That means this particular condition will not come. Then you put any point here. This particular condition will come. Then you put any point here. This particular condition will not come. So basically you solve the inequality taking the equal sign. Then you get the two values. You make these two values in this manner, and then put the example 3, then put the example 0, then put the example minus 3. Which condition is satisfied? This condition is satisfied. That means x will be between minus 2 to 2. But equal sign is also there. So equal sign will also be there. There you go. How will you write down the answer? Here we needed the equal sign, but here we did not need the equal sign. There you go. This is the answer, right? And if I need to think, how will I think? Fx of 2 will tell me minus fx of minus 2. So here what it has done? Less than 2, including the 2, but it has killed the minus 2 as well. Probability at minus 2 also it has killed. So what I will do? Probability at x equals to minus 2 I will add up. Okay, so these are the answers. These are all the answers. Is that clear to you? It was a good question. Not a simple question. I will not say very simple question, but we have seen the concept. Roughly around 1 hour we have spent only on this concept, because of what I feel is that from CDF PDF, this is the only concept which they haven't asked. Okay, till this point they did not ask. And usually they also know that people will remember this particular thing. But can we write down this particular thing as well? So that's why they can ask this particular question. Okay, now solve this question. Do it on your own. Okay, do it on your own. Options are also mentioned. You need to tick one of the option. So solve it, try solving it on your own. a random variable x is called symmetric about 0 if this is the condition. If this is the condition, then they are saying that random variable x will be symmetric. Now fx of x is CDF of x where x is symmetric about 0. So your random variable x is symmetric about 0, that means this condition is satisfied. In your case, this condition is satisfied. Now you need to find out probability of a mode of x should be less than equals to x. First question, second question, third question, do it on your own. Have some patience, try it on your own. Okay, I will take a break and then I will come back. You try doing it on your own. Yeah, welcome back. So did you try this question? So how would you start this question if this question is coming in the examination and let's just say only first one is coming? So would you analyze the condition first or would you solve the question first? You will try solving the question first, no? We can analyze the condition as well. But first intuition will say that, sir, I should go on to this particular expression. And then I will say that how I can use this particular condition, right? So I will, in the examination, I will start from here. So probability of a random variable mode of x taking value less than x. So I can write it down. This inequality we have already solved, right? We have already seen this inequality. So an equal sign is also there. So this is our desirable condition, right? All good, all fine. How I can write it down? I can write it down in this manner. Here I need the equal sign, so no issue. But here I don't need the equal sign, so there is an issue. So there is an issue, so I will put negative sign. Or how I can write it down? Fx of x minus fx of minus x. What does that mean? That means that I have killed the minus x as well, but you need minus x. What does that mean? That means you need to add the probability at minus x. This is what we have done. Is that clear to you? So this should be my answer. But none of the option is matching, right? None of the option is matching. You need to find out something to kill these two. I need to kill these two, right? This is the condition. In the options everywhere, fx of x is given. So I need to kill fx of minus x. Probability of x equals to minus x. This I need to kill. And how did I write it down? This should be clear to you. Say yes or no. Surely it is clear to you, right? Or you could have find out in this way as well, that probability of x equals to minus x would be given as fx of minus x minus fx of minus x minus. So from here fx of minus x you could have put in this particular expression, you would get fx of minus x and then this would become plus. So this you should be comfortable now. Now let's analyze the condition. From the condition, let's see what do we get. Is equals to right. This is the condition given. So here I can write it down in this manner. X less than small x. Say yes or no. Is equals to probability of x less than equals to minus x. But what do I want? I actually want equal sign here, so that I could convert it to our CDF. So I want a equal sign here. So basically, if I have written down this particular thing, that means what I have done? If I have written down this particular thing, that means 1 minus probability of x taking value less than equals to x. That means I am considering every value greater than x. What I am doing, I am considering every value greater than x, not including the x, but actually I need to include the x as well. So what I need to do here, I need to add the probability. Say yes or no. Are you able to understand this point? What I have done here? Are you able to understand what I have done here? Probability of x greater than equals to x. That means you need x as well and you need all these things as well. So what I have done, 1 minus probability of x less than equals to x. That means now this x is also killed. Since it is killed, I need to add it up. So probability of x taking value small x. Why I am doing so? I am doing so. Why is that so? Why I am doing so? So that now I can write it down as fx of x plus probability of x equals to x is equals to fx of minus x. So from here what you are getting, that your probability of x equals to x is coming out to be fx of minus x plus fx of x minus 1. There you go. This is something that you are getting, and this will answer your third question. There you go. Now from this expression, can you let me know what will be the probability of x equals to minus x? So basically, in place of x, you need to put minus x. So this will become plus x, this will become minus x. So basically from here, what did you get to know? That probability of random variable x taking the value minus x and random variable x taking the value plus x, both are same. So this also we got to know. And why I calculated the probability at x equals to minus x? Why did I calculate this? Because here I need this. So let's get back to our first question. Let's get back to our first question. This answers our third question. Third question have been already answered. Let's get back to our first question. In the first question where we were just 1 second guys. Yeah. So this was, here I was already there, fx of x minus fx of minus x plus probability of x equals to minus x. This was easy to write down, right? Now what I can do, I can replace the probability of x equals to minus x here. How I can replace it? Fx of x, fx of minus x plus probability of x equals to minus x, that is given as fx of x plus fx of minus x minus 1. So this and this is getting cancelled. What is the answer you are getting? 2fx of x minus 1. There you go. This is the answer, 2fx of x minus 1. What about this one? Try solving it on your own. Surely you will be able to solve. 101% you will be able to solve. Probability of a random variable x taking value greater than x. There is no equal sign. What does that mean? X greater than x. If you solve it, you will get two answers. This region will come and this region will come. That means x can take value greater than small x or x can take value lesser than minus x. Is that clear to you? How will you write down this particular thing? Can I write it down in this manner? 1 minus probability of x less than equals to x. Surely I can write down, right? X greater than small x. Basically, this is what you need. Excluding the x. So what I have done, 1 minus everything. So this is what you are getting. Plus, if I write it down in this manner, that means what I am doing, I am needlessly including the minus x. That means now I need to subtract the probability at minus x. Is that clear to you? Are you able to understand this particular point? Here what I need to do, for defining the CDF, I need to add a equal sign. If I need to add a equal sign, what I need to do? If I need to add a equal sign, that means I am including the probability at x equals to minus x. But this is what you don't need. You don't need the probability at x equals to minus x. That means you need to subtract it, right? So what you are getting? 1 minus fx of x plus fx of minus x minus probability of x equals to minus x. What is the answer you are getting? Fx of x then minus fx of minus x, and this would become plus. Are you able to understand this point? So what will happen? This and this is getting cancelled. The answer you are getting is 2 minus 2 fx of x, 2 into 1 minus fx of x. This is the answer you are getting. There you go. 2 into 1 minus fx of x. 2 into 1 minus fx of x. So C, A, D, these were the answer. A very good question which will clear your fundamental concept, and these kind of question could be coming in your examination. Are you able to understand this point? Right? So this is how this condition was given. First I tried to solve the problem, then I got to know that I am not going anywhere. Then I utilized the condition. From the condition I got these two expressions. One was the answer of third question. Then I utilized this condition to get the other answer. I know that this is how I can write it down. Here I wrote it down, and from here I just put the condition and got the answer. So better than like, don't depend much on the method. Which method I am talking about? This particular method that we learn here. Don't depend much on that. You should be having the concept as well. because if you depend too much on the method, then it will not work. You should be having the concept. Like here, directly I was able to think mod of x greater than x. That means I need greater than x less than minus x. If you need greater than x, that means 1 minus less than x including the x. And here, to define the CDF, I need fx of minus x. To define the CDF, I need the equal sign here. That means now I need to kill the probability at x equals to minus x. That means I need to subtract the probability at x equals to minus x. So I subtracted that, then I was having the expression, I got the answer. Is that clear to you? Very easy, very straightforward, right? So this was the answer. Okay. So these kind of questions are good. Not many people would be able to solve, but we have understood it in a very good manner. So we will be able to solve this kind of problems if these are coming in our examination. Well and good. Now let's end this lecture here, because it's been roughly around 3 hours. So we are ending this particular lecture here. Now for the next 1 hour, roughly around 1 hour, we are going to study mathematics only. In between we will solve some problem of random variable as well, but mostly we will be studying probability. Okay. So in mathematics, what we are going to study now, conditional probability we are going to see, which you might be already knowing. So you can watch it in a quick manner. Along with that, we are going to see integral calculus. So which is a topic of mathematics only, which is a topic of calculus only. Integral calculus also we are going to see. So for next 1 hour, it will be mathematics. In between, we will solve some problem as well, like this particular question we are going to solve. This is based on PDF only. Sorry, this is based on CDF or PDF, whatever it is. Then this particular question also we will solve. So this is mathematics. Sorry, this is your random variable random process, but this is conditional probability. This is purely mathematics. So we will study mathematics. In between, we will solve some problem as well. Okay. So don't ignore this part. The bottom line is don't ignore this mathematics part. So first we will see conditional probability. Then in between we will see the base theorem as well. And then we will study about integral calculus. And then we will start 2-dimension random variable. So as of now, we were defining only one random variable, no? X. Now what if 2 random variables are defined together? X as well and Y as well. 2 random variables are defined together. So now after that, what we are going to see, 2-dimensional random variable. So let's end this video here. Now for the next 1 hour, we are going to study mathematics. Okay. But don't ignore that part. Even if you have studied mathematics, watch that particular part in a quick manner. Okay then? Yeah. So let me end this video here. Let's meet in the next video. Thank you very much. Yeah, welcome back. So now we are going to study some mathematics, right? First we will see the conditional probability and then we will see integral calculus. So even if you have studied these topics in your mathematics, still I would say don't ignore it completely. You can watch it in a quick manner. Within 10 to 15 minutes, you can watch it completely, but don't ignore it completely. Okay. Just quickly go through it. So what do you mean by conditional probability? So conditional probability is given by probability of event A given that event B has already occurred. Probability of event A given that event B has already occurred. Let's understand by an example. So this is your random experiment. You are doing an experiment, that is you are rolling a dice. Now what is the probability that the given number is even given that it is greater than 2. So which event has already been occurred? That you have got a number greater than 2. So event B has already occurred such that the number is greater than 2. That means the number could be 3, 4, 5, 6. Right? What was your actual sample space? Like what was your actual experiment? This was your random experiment. When you roll a dice, what all outcomes you can get? 1, 2, 3, 4, 5, 6. These outcomes you can get. Now you are asked the probability of getting a number that is even. So even number could be 2, 4 and 6. Right? So what could be your even number? What would be your event A? That would be 2, 4, 6. But you don't need to find the probability of A. No. This is not they are asking. They are asking the probability of A such that B has already occurred. That means you already know that the number is greater than 2. You already know that when you roll the dice, you already know that the number coming would be either 3 or 4 or 5 or 6. Now what is the probability that number would be even? So you are having 2 chances out of 4. So what would be the answer? 1 by 2. There you go. So answer would be 1 by 2. What is given? The number is already greater than 2. So what you can get? 3, 4, 5 or 6. Out of these 4, any number you can get. Now they are asking what is the probability that it should be even. So that would be 2 divided by 4, that would be 1 by 2. So this is the concept, that this is how 1 by 2 is calculated. What is the formula? Let's see the formula as well. So formula says probability of A by B, that means probability of event A given that event B has already occurred, that would be A intersection B divided by B. Okay, so this downward, this remains downward only, and on the upper side intersection of both of them will come. What do you mean by intersection? So I said one thing, whenever I say or, that means addition, and that means union. Okay, what is union? This is the sign of union. I hope in the set theory you have studied these basics. And whenever I say and means multiplication, or you can show it by dot, and intersection. What is this intersection? Intersection is this sign. That means probability of event A and B. Probability of event A and B. Probability such that you are getting a number that is even and greater than 2. Even and greater than 2. So when you roll a dice, what is the probability that you get a number which is even and greater than 2? So what is the probability that it should be even? 2, 4, 6. And greater than 2 as well. That means this will not come. So 2 cases out of 6. 2 cases out of 6 divided by probability of event B. What is the event B? The number should be greater than 2. So when you roll a dice, number is greater than 2. 3, 4, 5, 6. So out of 6, there are 4. So by the formula as well, you are getting 1 by 2. Are you able to understand this point? So this is the meaning of conditional probability, which a lot of guys already be knowing, right? Very simple concept. One event has already occurred. Now what is the probability of event A such that event B has already occurred? Well and good. So from here, this part is important, that this particular formula is important for you, right? Whatever the formula that you are getting, this particular formula is important. From this formula, can you let me know what will be A intersection B? What will be the probability A intersection B? That would be, this B goes here. So what you will be getting? P A by B dot PB. Right? Basically, what was your P A by B? Your P A by B was P A intersection B divided by PB. So this PB goes here, you will get PA intersection B. Now, if A and B are independent events, what is the meaning of independent events? That means event A does not depend on event B and event B does not depend on event A. You see this question, you are rolling 2 dice simultaneously, right? So first die will show an even number and second die will show a 3. Basically, event A is that such that first die will show a even number and event B is that the second dice is showing 3. So getting a 3 on the second dice, will it be anyhow related to getting even on the first dice? No. Are you able to understand what I am saying? Getting a number 3 on second dice, whatever the number that you get on second dice, is that anyhow related to get a number on the first dice? No. First dice and second dice, they are not related with each other at all. That means they are 2 independent events. So here if I ask you, what is the probability of A? What will be the probability of A? First die shows an even number. So even number, that would be 3 by 6. Now let me know what will be the probability of B. Second die shows a 3, 1 by 6, right? If I ask you what is the probability of A by B, that means probability such that probability of getting an event A, probability of event A such that event B has already occurred. So on the second dice 3 has come. On the second dice 3 has come. Event B has already occurred. On the second dice 3 has come. Now what is the probability that on the first dice even number would come? Does that depend on B? No, right? On the second dice, if you are getting a 3, you are getting it, right? You are getting a 3. On the first dice, the number would be even, odd, it would be 1, 2, 3. Does it depend on the second dice? No, it doesn't depend on the second dice. So that would be equals to P of A only. And that would be equals to 1 by 2. And what would be P B by A? What would be your P B by A? That would also be equals to PB only. Because let's just say on the first dice, even number is coming. On the first die, even number is coming. So does that getting a 3 depends on this? Like whatever the number you are getting on the second dice, does that depend on the first dice? No. So that would also be equals to 1 by 6 only. And here one more thing you can see, P of B by A would be equals to PB intersection A divided by PA. So B intersection A is equals to A intersection B only. So from here you can get B by A dot PA as well. So both of these formulas are true. Okay. So this also should be there in your mind. And if A and B are independent, that means this would be equals to probability of A only. That means it will not depend on B. So what this is actually equals to? It is actually equals to this particular thing, right? Basically, first this is the condition. First this is the condition. Okay. First this is the condition. Now secondly, you know that your PA by B is actually equals to PA intersection B, or from here you can see what you can see, PA intersection B is equals to PA by B dot PB. Now since A and B are independent, so this PA by B would be equals to PA only. So if A and B are independent, then simply this intersection will be converted to multiplication. Intersection will be converted to multiplication if A and B are independent. If they are independent, then this would be the case. Okay. In a lot of cases, in 80% of the cases, you will get independent events only. We will see it in communication. So if they are independent, that means PA intersection would be equals to PA dot PB. So this should be there in your mind, and this should also be there in your mind. Okay. Let's see a theorem. The name of the theorem is not important. So what is the condition here? Here there are 4 events: event E1, event E2, event E3, and event E4. In those 4 events, one event A is common. That means A is occurring with E1 as well, A is occurring with E2 as well, A is occurring with E3 as well, and A is occurring with E4 as well. So can you write down the probability of event A? Yes, sir. The probability of event A would be equals to E1 intersection A, E1 intersection A. Basically, this area I have taken into consideration. E1 intersection A plus probability of E2 intersection A plus probability of E3 intersection A plus probability of E4 intersection A. So this could be equals to probability of E1 dot A divided by E1. You see here, A by B dot B. So A by E dot A by E1 dot E1. This could be equals to probability of E2 A by E2. Is that clear to you? In digital communication as well, this will be used. Okay. Probability of A. Everywhere it will be used. A by E1 dot E1. A by E2 dot E2. You are finding the probability of A. So how will you read it? Probability of event E1 multiplied with probability of event A such that E1 has already occurred, plus probability of event E2 multiplied with probability of event A such that E2 has already occurred, plus probability of event E3 multiplied with probability of event A such that E3 has already occurred. Or plus can be written as or, plus can be said as or probability of event E4 multiply with probability of event A such that E4 has already occurred. So let me read this statement again. Probability of event A would be equals to probability of event E1 and probability of event A such that E1 has already occurred, or probability of event E2 and probability of event A such that E2 has already occurred, or probability of event E3 and probability of event A such that E3 has already occurred, or probability of event E4 and probability of event A such that E4 has already occurred. So this would be the probability of A. This should be there in your mind. You should not be mugging it up. Everything is crystal clear to you. Every single thing is crystal clear to you. It will be more clear when we see the example. So these conditions are given that 1% of the people are having a disease. A particular disease is there, only 1% of the people are having it. That means 99% of the people are not having this disease. 99% of the people are not having this disease, right? So 0.01 here 0.99. Now test is 99% accurate. What is the meaning of this? You conduct a test which is 99% accurate. What is the meaning of this? So the scenario is like either you will be having a disease or you will not be having the disease. Either you will be having the disease or you will not be having the disease. But even if you are not having the disease, still the test can say positive. Are you able to understand this point? What I am saying? Even if you are not having the disease, still the test can say positive. If you are having the disease, test is saying positive. If you are not having the disease, still the test is showing positive. So this is the Venn diagram of saying positive. This is the Venn diagram of disease. This is the Venn diagram of non-disease. Disease is 0.01. This is 0.99. You don't know what is the probability of giving positive result. You don't know that. But you know that even if you are having the disease, still it can give you positive. Even if you are not having the disease, still it can give you positive. What they are asking? What is the probability that person actually has the disease? What is the probability that person is actually having the disease given that their test is positive? Their test is positive. Their test is positive. So test is positive given that test is positive, but this guy is having the disease. What this would be equals to? Divided by probability of having positive, right? You can get this very easily. How will you get this particular thing very easily? Because what they have given, probability of positive divided by the disease, that is equals to probability of positive intersection with disease divided by disease, that is equals to 0.99. So what you are getting from here, disease intersection positive, that is coming out to be 0.99 into probability of disease is 0.01. So the job of this particular thing is done, 0.99 into 0.01. But now what you need to find? Probability of positive. So probability is such that this particular test will give you positive result. Probability such that the test is giving you positive result. So what you can see here, disease intersection with positive plus no disease intersection with positive. That means the guy is having the disease. The guy is having the disease, and after having the disease, it is giving you positive result. This could be the case, or the guy is not having the disease, and even after not having the disease, it is giving you positive result. Two cases would be there. Is that clear to you? The guy is having the disease, even after having the disease, it is giving you positive result, or the guy is not having the disease, and even after not having the disease, it is giving you positive results. So this will be the probability of getting the positive results. So what is the probability of having the disease? That is 0.01. What is the probability of giving the positive result even after giving the positive results given that the guy is having the disease? So positive divided by disease is 0.99 plus what is the probability of not having the disease? That is 0.99 into failing here is 0.01. So this is actually coming out to be 2 into 0.01 into 0.99, right? So what is the answer you are getting? Probability of having the disease given that the test is positive. So 0.99 into 0.01 divided by 2 into 0.01 into 0.99. So what is the answer? 1 by 2. That means if you are in this hospital, even if your result is coming positive, still there is only 50% chances that you are actually having the disease. 50% chances are there that you are actually having the disease. 50% chances are there that you might not be having the disease. Is that clear to you? The result has come positive. Now 50% chances are there that you might be having the disease. 50% chances are there that you might not be having the disease. Is that clear to you? So answer would be 0.5. So this is the answer. Okay. So just don't focus much on that, because in mathematics you will again study it. Just because this will be used in our analysis somewhere in digital communication and even in random variable as well. That's why I put this particular topic here. Okay. Let's solve the questions now. CDF of random variable y is given. Fy of y. You need to find the probability of y less than 2 such that it is given that y is greater than minus 1. Okay. So let's find the probability. Probability of y less than 2 given that y is greater than minus 1. So it could be written as y less than 2 and y greater than minus 1 divided by probability of y greater than minus 1. Okay. What this could be written as? That y is greater than minus 1 and less than 2. So can I write it down in this manner? Divided by probability of y greater than minus 1. Now let me know what will be the answer of this one. Fy of, here you needed the sign, right? Here you needed the sign. So here you will put 2 minus Fy of, here you do not need the sign. So minus 1. Here I need to make the changes. What change I can make? 1 minus probability of y less than equals to minus 1. Do you agree to this point? You need y greater than minus 1. That means 1 minus less than minus 1 including the minus 1 as well. So what you are actually getting? So here you can see that y greater than 2, sorry, y less than 2 divided by y greater than minus 1 is actually coming out to be Fy of, here I can put, in place of 2 minus I can only put 2. Why is that so? In place of 2 minus I can only put 2. Why is that so? Because this is continuous, no? You can see Fy of y is continuous. This is a continuous graph. There is no staircase or anything like that. This is a continuous graph. So in place of 2 minus I can only put 2 only, divided by Fy of minus 1 divided by 1 minus Fy of minus 1. Right? All good? What is this? Fy of minus 1. I am only interested in this particular value. You let me know what will be the value of Fy of minus 1. So here in this particular graph, if I put Fy of minus 1, what that would come out to be? 1 minus e to the power 1 u of minus 1. What is the value of u of minus 1? 0. Usually what people will do is that they will only look at this particular thing. But you need to see that this particular graph is starting from y greater than 0. If you draw the CDF, how will you draw the CDF? If you draw Fy of y versus y, so random variable y is taking values greater than 0 only, right? Because what you will get at 0, this will be 0. What you will get at infinity, that would be 1. So it is rising from 0 to 1. So this kind of graph you will be getting. This is your Fy of y. So here also directly you can see the probability that random variable y taking value greater than -1, it is 100%, no? Probability that this particular thing taking value greater than -1, that is 100%. Why 100%? Because you know that y is taking values from 0 to infinity only. Y is not taking these values. Y is taking values from 0 to infinity only. Or you can see here, fy of -1 is coming. What is the value of u of -1? That is 0. So fy of -1 is coming out to be 0 only. So this particular thing is 0. And divided by 1 minus 0 would be 1 only. What is the value of fy of 2? So fy of 2. So 1 minus e to the power minus 2 into u of 2. What is the value of u of 2? That is 1 only. So what you are getting? 1 minus e to the power minus 2. So here fy of 2 is coming out to be 1 minus e to the power minus 2. Fy of -1 is coming out to be 0. 1 minus 0. So what is the answer you are getting? 1 minus e to the power minus 2. This is the answer we are getting. 1 minus e to the power minus 2. Okay. So here in place of y we can put 2. Y of 2 is 1. So 1 minus e to the power minus 2. 1 minus e to the power minus 2. Fy of -1. Fy of -1 was 0. Fy of -1 was 0. 1 minus fy of -1. Fy of -1 was 0. Or here only you could have said that it would be 1 only. Probability such that your random variable y is taking value greater than -1. Greater than -1. Always it will take value greater than -1 only. So this would be 1 only. There you go. Well and good. Okay, so this was CDF given and this question we solved. Let's try solving this question. There is a sample space S which is defined like this. That means what is your sample space? This sample space is S1, S2, S3, S4. Okay. Probability of S1 is given, probability of S2 is given, S3 is given, S4 is given, right? Now there is a random variable x of Si is defined such that it is I minus 2, value of I will go from 1 to 4 only. So what do you understand by this? That your random variable x will take values I minus 2. That means if I put I equals to 1, what will be the value? -1. If I put I equals to 2, what will be the value? 0. If I put I equals to 3, the value will be 1. If I put I equals to 4, the value will be 2. So random variable can take -1, 0, 1 and 2 value, right? Your random variable can take these values. Now what you need to find? You need to find PMF. That means what is the probability such that your random variable x is taking value -1. So when it will take value -1? When I is equals to 1. Basically x belongs to -1 when I is equals to 1. That means this would be equals to probability I is equals to 1, probability of S1. Are you able to understand this point? This -1 is associated with S1. This is associated with S2, S3, S4. So basically what really happened was that you are having this sample space, and in this sample space there are 4 points S1, S2, S3, S4. These 4 sample points are there. So S1 have been mapped to S1, this sample point. Since this particular sample point is having I equals to 1, that means this have been mapped to 1 minus 2, that is -1. This have been mapped to 0. 2 minus 2 will be 0. This have been mapped to 3 minus 2, 1. And this have been mapped to 4 minus 2, 2. So these are the values of small x, you can say, right? So probability of x equals to -1 will be equals to 1 by 6. Probability of x equals to 0 would be equals to 1 by 3. Probability of x equals to 1 will be equals to 1 by 3. And probability of x equals to 2 will be equals to 2 will be equals to probability of S4, that would be equals to 1 by 6. Okay. So what you are getting here? Random variable x is taking values -1, 0, 1 and 2, right? At minus 1 you are having 1 by 6, 1 by 3, 1 by 6, 1 by 3, 1 by 3 and 1 by 6, right? 1 by 6, 1 by 3, 1 by 6, 1 by 3. So this is the PMF. Okay, Px of x versus x. This is the graph. Minus 1, 0, 1, 2. So 1 by 6, 1 by 3, 1 by 3, 1 by 6. All good. So this is the answer. Okay. So yeah, that's about the conditional probability and these questions we have seen. Now we are going to move towards two-dimensional random variable. Also we will see integral calculus. So first we will see some questions on integral calculus. I am not going to give you the complete concept. Some questions we are going to see, and then we will move to our two-dimensional random variable. So till now we were defining only one random variable. Now we will define two random variables, right? So this is a very important concept, and usually it is confusing for a lot of students. So I will pause the video, I will change the slide, and then I will come back and we will study about integral calculus. Okay. Yeah, thank you. Yeah, welcome back. So continuing our mathematical part only. So now the thing is we need to study integral calculus. But now I'm not going to give you the concept of integral calculus. This you should be already knowing from engineering mathematics. If you haven't studied engineering mathematics, then from EMFT you can cover this particular concept. So you can go to YouTube and type integral calculus PrepFusion EMFT. So you will get this video. In this video, there is very high chances that most of the concept will be cleared. Like whatever that is useful in communication system, that particular concept will be clear to you. Is that okay for you? Because now we need to study two-dimensional random variable. So till this point what we were doing, fx of x dot dx. Now there will be two random variables. So here what was happening, random variable x was taking values from, let's just say, from 0 to 3. But now random variable x will also take the value, random variable y will also take the value. So x will take some value, y will take some value. So now integral calculus will be used, double integral will be used. Single integration we already know, right? This was taking the limit of x. Now this will take the limit of y as well. So before that, this is the prerequisite that you should be comfortable with the integral calculus. Now in this particular video, what we are going to do is that we are going to solve some problem on integral calculus. Some questions we are going to see, because those who have already studied it, they can revise it through the question. So basically those who already know this concept, for them it will be a kind of revision. Okay. So this integral calculus will be a kind of revision. Through the question you can revise it. So questions I have taken in a manner that will be used in our analysis. Is that okay for you? Understood? So if you haven't studied, then watch this video. If you have already studied, then you will be able to revise with these kind of questions. So what is the first question? That you need to draw the region R. X is greater than equals to 0, y is greater than equals to 0, x plus y is less than equals to 2. These kind of questions we have seen in our elementary classes. In class 11, 12, we have seen how to make the region R. So this is the first question, that you need to draw the region R. So let's draw the region R. So two axes are there, x and y, x and y. So x is greater than 0. That means all this region will come. Sorry. X is greater than 0. X is greater than 0. So this particular region will come. Right? Now what they are saying, y is also greater than 0. Y greater than 0, that means which region would come? This region would come. Y is greater than 0. So in both of them, what is the common region? This is the common region. No? That x is greater than 0 here, y is also greater than 0. So one thing we got to know, that we are talking about this particular region now. That x is greater than 0 and y is greater than 0. So we are talking about this particular region. Now second, what they have given, x plus y less than equals to 2. So the another inequality is x plus y should be less than or equals to 2. So how to make how to solve these kind of problems? What you will do is that you will first make this line. Forget about the inequality. First you make this line, x plus y equals to 2. So how this line will look like? This is how the line will look like. Slope is negative, right? Y equals to, let's make the diagram a bit bigger. What I can do is that I can make this diagram a bit bigger. This was your y-axis, this is your x-axis. X greater than 0, y greater than 0, these two condition. Next condition is x plus y less than equals to 2. So first I am going to draw this line. This is the line of x plus y equals to 2. You can see that y equals to mx plus c. So slope is -1 and it will cut on 2 here. Or what you can do is that if you put x equals to 0, what will be y? If you put x equals to 0, y will be 2. If you put y equals to 0, x will be 2. Right? X plus y greater than equals to 2. This line we have drawn, which is x plus y equals to 2. But x plus y less than equals to 2, this is what we need. That means either this region will be there or this particular region will be there. So which particular region will be there? How will you check? You take any random point in this particular region. Let's just say I take point 0, 0. I will put 0, 0 here. 0 plus 0 is less than 2. 0 is less than 2. Yes, it is true. That means 0, 0 will be included. That means this particular region will be your answer. This particular region will be your answer. Are you able to understand this concept? X greater than 0, x greater than 0, y greater than 0, x plus y less than equals to 2. So I draw the line of x plus y equals to 2. Right? Now less than equals to 2 or greater than equals to 2. How would I know which is less than equals to 2? So I will take a random point. This is a random point that I have taken and I put this random point in this equation. 0, 0, 0 is less than equals to 2. Yes. This particular equation is true. That means this would be my region. So what did you understand? X greater than equals to 0, y greater than equals to 0 and x plus y less than equals to 2. So x greater than equals to 0, y greater than equals to 0 and x plus y less than equals to 2. So that means our region of operation, our matter of concern is this particular region. Do you agree to this point? Our matter of concern is this particular region. This is our matter of concern. X greater than 0, y greater than 0, x plus y less than equals to 2. Say yes or no. Now what do you need to find? So this region I have drawn. Okay, better I should show by dots only. So this is the particular region that I have drawn. This is our matter of concern. What I need to find? First one, region R dx dy. What is the meaning of this dx dy? That in this particular region you need to find dx dot dy and then double integration. That means simply you need to find area. You need to find the area of this particular region. If dx dot dy and then region R is written, that means you need to find the area of this particular region. What will be the area? 1 by 2 into what is the base? Base is 2. What is the height? Height is also 2. So answer would be 1. There you go. Direct dx dy is written. That means you need to find the area of this particular region. Now second, they are asking xy dx dy and region R they have written. Now this is a particular function that they have given and you need to integrate this particular function with respect to dx dy. So here you have to put the limit. You have to put the limit of x as well. You have to put the limit of y as well. Here also you need to do the same thing. Here also you need to do the same thing. Here also you need to put the limit of x, you need to put the limit of y. But I am telling you one particular thing, that if direct dx dy is written, that means you need to find the area. So area you have done. But now there is a function xy dx dy. So now you need to put the limit. And how do we put the limit? For putting the limit, what do we do is that we take a strip. We can take a vertical strip as well, we can take a horizontal strip as well. Usually we take the vertical strip. So what I will do is that I will take a vertical strip here. So I have taken the vertical strip. Okay. Now on this strip, you let me know how will the limit of y will go. So here what is the value of y? Y equals to 0. And here what is the value of y? Y is equals to 2 minus x. So limit of y is going from 0 to 2 minus x. Limit of y is going from 0 to 2 minus x. How the limit of x will go? So what I will do is that now I will move this strip in x direction. First I have taken the limit of y. Now this strip will be moved in x direction. In x direction this strip will be moved. In x direction this strip will be moved. So value of x will be taken from 0 to 2. If you move this strip in the x direction, the value of x will be taken from 0 to 2. So value of x will go from 0 to 2. Always the constant limit you will put on the second integration, the variable limit you will put on the first integration. So limit of y is going from 0 to 2 minus x, limit of x is going from 0 to 2. 0 to 2 minus x, limit of x is going from 0 to 2. Always from lower limit to higher limit. Is that clear to you? Okay. Now I need to solve the integration. So first I am integrating with respect to y. So what I will do, limit of x is going from 0 to 2. I am integrating with respect to y. So x will be a constant now, right? And I can put dx here as well. Now you need to do the integration with respect to y dot dy. So let's keep this part as it is. This part is as it is. I don't care about this part. Y square by 2, 0 to 2 minus x. What you are getting? This part is there as it is. 2 minus x whole square divided by 2, and then you put 0, that would be 0 only. Okay, so let's write down this part now. What this part was there, x is going from 0 to 2, x as it is. Now this integration will give you, what this integration will give you, 2 minus x whole square, 2 minus x whole square divided by 2 dot dx. This particular integration, y square by 2, 0 to 2 minus x. So here in place of y 2 minus x, you put 2 minus x whole square divided by 2 x dot ds. So here x dot dx, and limit of x is going from 0 to 2. Is that clear to you? This 2 minus x could be written as x minus 2 as well, right? Negative sign you can take common, and already there is a square, so this can be written as x minus 2 as well. Just it looks good, that's why I am putting x minus 2, nothing else. It looks good, that's why I put x minus 2, nothing else, right? So what you will get, 1 by 2 can be taken outside, limit of x will go from 0 to 2, a square plus b square minus 2ab dot dx. 1 by 2 is outside, a square plus b square minus 2ab. So 1 by 2, limit of x goes from 0 to 2, x cube minus 2x square plus 4x dot dx. So 1 by 2, x to the power 4 divided by 4 minus 2x to the power 3 divided by 3 plus 2x square, 0 to 2. So 1 by 2, here 4 minus 16 by 3, just I am putting the limit, nothing else, plus 8. 12 minus 16 by 3 into 1 by 2. 20 by 3 into 1 by 2. So answer is 10 by 3. This is the answer. Well and good. Okay, I hope the calculation is correct. You can check the calculation on your own. Just I wanted to tell you that how we solve the problem. So first we will make the region. Always we will make the region. 3 equations were given: x greater than equals to 0, y greater than equals to 0, x plus y less than equals to 2. All the equations were given. I made the region. Now for this particular thing, dx dy, it was very easy. I got the area, right? But here there was a function. This was a function of xy. So now I need to take the strip. How will I take the strip? I will take the strip from, I will take the vertical strip. I can take the horizontal strip as well, but usually we take the vertical strip. In this particular video, you will find a lot of examples where I have taken the horizontal strip as well. Horizontal, vertical, whatever the strip you want to take, that you can take. So I am taking the vertical strip going from y equals to 0 to 2 minus x. So limit of y is going from 0 to 2 minus x, limit of x is going from 0 to 2. So you can see this. This is how we need to solve it. So now always the constant limit I will put in the end, and here I will put the variable limit. So x dot dx, y dot dy, y square by 2, 2 minus x whole square divided by 2, 1 by 2 is coming outside. This is becoming x square plus 4 minus, yeah, there you go, wrong. A square plus b square minus 2ab, right? Minus 2ab. So this would become 4x, no? Right? So x cube minus 4x square, x cube minus 4x square plus 4x dot dx, x to the power 4 divided by 4, 4x to the power 3 divided by 3, yeah, 1 by 2 is outside, 16 divided by 4, this would be, what this would be, 2 to the power 3 will be 8, 32 by 3, 32 by 3, 8. So 12 minus 32 by 3, 4 by 3 into 1 by 2. So that would be 2 by 3. So answer is coming out to be 2 by 3, not 10 by 3. My calculation error is there. So answer is coming out to be 2 by 3. Is that clear to you? All good? All fine? Let's go to the next one. Here x greater than 0, y greater than 0, x plus y less than 2. Till this point we have already made. Now they have given another thing, that is x plus y greater than 1. So you need to draw the region R. So can you draw the region R? Surely I can draw the region R. X plus y less than equals to 2. So till this point I have already made. Now x plus y greater than equals to 1. Again let's draw it on the next page, okay? Because I need to make the bigger diagram, no, so that you understand. So I will make the bigger diagram. X greater than 0, y greater than 0, you already know. That means I will be talking about this particular region. Now two more equations are there. X plus y less than 2. So x plus y equals to 2 I will draw. And then another equation is x plus y greater than 1. So x plus y equals to 1 I will draw. So these two I will draw. X plus y equals to 1 and x plus y equals to 2. Now x plus y less than 2, which was this side, right? Now x plus y greater than 1, what do you think which side it will be there? X plus y greater than equals to 1. So if I put this particular point 0 0, so 0 plus 0 is greater than 1. That means this particular point should not be included. That means it will be towards this side. Are you able to understand this point? X plus y less than 2. One equation was x plus y less than equals to 2. That means this was the region. Now x plus y greater than 1, this will be the region. How will you check? You will take this origin, you put this 0 0 here. So this particular region is not satisfying. 0 is not greater than equals to 1. That means this particular region would be the matter of concern. So what do you think, what is our matter of concern? Final matter of concern. Final matter of concern is this particular region. All this region is our matter of concern, because x should be greater than 0, yes. Y is greater than 0, yes. X plus y should be less than 2, yes. And x plus y should be greater than 1, yes. So this is our matter of concern. This is the matter of concern. All good? All fine? Now what we need to calculate? What was this point? Let's write down the point. 2 0, not 2 0, 0 2. X equals to 0, y equals to 2. X equals to 2, y equals to 0. This point will be 0 1 and this point will be 1 0. First one, you need to find this particular thing. That means simply the area. Area of what? Area of region R. Area of this particular thing. This dotted area you need to find. Right? So can you find the area? Yes. What I will do is that I will find the total area minus this area. Right? What I will do? This would be equals to, what is the total area? What is this total area? That would be 1 by 2 into base into height minus 1 by 2 into 1 by 2 into base is 1, height is 1. Basically I calculated this total area minus this area. This is what I am doing. Very simple for you. 1 by 2 base into height, 1 by 2 into 2 into 2. Here what is the answer that I wrote? This was actually 2, right? 2 get cancelled, this answer is 2. Yeah, so 1 by 2, 2 into 2. 1 by 2 base into height. Here 1 by 2 base into height. 1 by 2 base into height. So 2 minus 1 by 2. What you are getting? 3 by 2. Which is equals to 1.5. So this is the answer you get, 1.5 for the first question. Now for the second one you need to choose the strip. So let's solve the second one here. xy dx dy. What you need to do? You need to choose the strip now. Let's take the strip. Which strip I will take? Vertical strip I will take. So this vertical strip I am taking. Okay. in this vertical strip, how will my y will go? Here in this vertical strip, here what is the value of y? Y is 1 minus x. And here what is the value of y? Here y is 2 minus x. So y will go from 1 minus x to 2 minus x. Is this correct? Just think about it. First you have chosen the strip, right? Now you will move this strip as well. So if I am moving this strip will go upward, it will come downward as well. So it came down. So always, yeah, till this point, here as well, you are going from 1 minus x to 2 minus x, 1 minus x to 2 minus x, here as well, 1 minus x to 2 minus x. This strip will come like this now. The strip will come down. This is like a, just understand this particular thing. So this will go upward, it will come downward as well. It is coming downward. Now it has come here. Now here what is y? Y equals to 0. And here what is y? 2 minus x. So you need to break it down now. Are you able to understand this point? Did you understand this point? There is something different here. What is different here? That after this point, after this particular point, things are changing. So this particular strip will work when x is going from 0 to 1. What I am saying? This particular strip will work when x is going from 0 to 1. In this strip will keep on moving. So what is the limit of x? X is actually moving from 0 to 1 only, no? Right? If you are moving this strip like this, that means in the x direction you are moving from 0 to 1. So how will you break it? In x direction I am moving from 0 to 1. But in the y I am moving from 1 minus x to 2 minus x. 1 minus x to 2 minus x. xy dx dy. Plus, now here you need to choose different strip. This strip I need to choose. Because here what is actually happening? When your x is going from 1 to 2, when your x is going from 1 to 2, your y is going differently. Your y is going in a different manner. Y is actually going from y equals to 0 to y equals to 2 minus x. Is that clear to you or not? So two kind of strip I need to use. Always I will choose one strip and I will move it. Once I move it, I will get to know that how my y is moving. Here y is moving from 1 minus x to 2 minus x. Here it is moving from 0 to 2 minus x. And how the x is moving? In the x you can see that constant limit 0 to 1 and 1 to 2. So here constant limit x goes from 1 to 2, but y goes from 0 to 2 minus x. Okay, so you can solve this integration on your own now. How will you solve on your own? I will solve. Right, so I will solve it in a quick manner. X dx. Now this would be y square by 2, and here I need to put the limit. Okay, this will be a long integration, and then dx, and limit of x goes from 0 to 1. This is going to be a long integration, right? I will tell you a short method as well actually. So that's why I don't think I should solve it more. Right? You guys can do it on your own. What do you think? Right? You guys should be able to do it on your own. And here x is going from 1 to 2. X dot dx I need to do. This dx I can erase. Here I integrated y square by 2 I get 1 minus x to 2 minus x dot dx I need to do. Then here I integrated y. What I will get? Y square by 2 I will get. And then 0 to 2 minus x you will go. Dot dx you need to do. Okay. You solve it, whatever the answer you get, that would be fine. Now let me take this diagram again. Let me take this particular diagram again, and I will tell you one another method. What is that method? Let's see it. Okay guys, it is lagging actually. Let me pause the video, it is lagging. Yeah, so diagram is copied now. Yeah, so let's remove all these things. Let's remove all these things. Look, I said that I got to know that basically I need to calculate this particular thing. What is that? In the region R, I need to calculate dx, sorry, xy dx dy, xy dx dy. Right? This is what I need to calculate. And then I got to know that if I choose the strip, everything will become difficult here. I need to break down the strip in two manners, so things will become difficult for me. That I got to know. So what I thought, that I have already solved for this particular region. In the previous question only, I have already solved. In which question? In this particular question. So for the complete region, I have already solved the integration. That is xy dx dy for region R. For this complete region, I am calling as R. Right? So now this particular region, I will call this as R dash now. So this is my R dash now. R dash. R dash. Okay, R dash. So now what I am doing is that I am calling this particular region as R dash, and I am calling this particular region as R double dash. Which particular region? This region. This region I am calling as R double dash. So can I say that this integration xy dot dx dy, which I am calling as R dash. Which region? This region is my R dash. This is my R dash. Would be equals to what? Region R xy dx dy minus region R double dash dx dy. Say yes or no. Basically, you can see that R dash plus R double dash is making the region R. So what you need to find? You need to find R dash. That means you can do R minus R double dash. Although I need to calculate this particular integration, but I will calculate the integration in this region, and then I will subtract from somewhat I already know. I already know the value of this one. What is that? This is 2 by 3. This value is, I already know, that is equals to 2 by 3. Now you will say that, sir, actually in the examination again I will have to solve two integration. This integration I will have to solve, this integration I will have to solve. Yes, this you need to solve, but whatever the concept that we are going to study, in our probability, in random variable, what will happen is that this will actually become 1. And you would be already knowing it. What I mean to say is that we are going to use this concept in a two-dimensional random variable. That's why we are studying it. So there what will happen, this particular thing will throw 1, and you would already know it. We will see the example, it will be clear to you. So there what will happen is that it will be easy for you to calculate this particular integration. Otherwise you will have to take the limit and you will have to calculate in this manner, which will be large. But what you will do is that you will see that here, if I take the strip, in this particular region, if I take the strip, then this strip will go only from y equals to 0 to y equals to 1 minus x. This strip will go from y equals to 0 to y equals to 1 minus x. And in the x, it will go from 0 to 1. It will be very easy for me to calculate. And then I can subtract it from this whole integration. Although in the previous question, I have already calculated this whole integration, that is coming out to be 2 by 3. But in probability, what will happen is that this integration will become 1. How it will become 1, that we will see. But in probability, it will become 1. As of now, you think that this we have already calculated, so it was 2 by 3. So now our target would be that we calculate xy dx dy, taking the limit of x from 0 to 1 and taking the limit of y from 0 to 1 minus x. There you go. So I need to solve this integration only now, which has become much easier than this particular thing, right? So if this kind of thing is coming that you need to change the strip, then you would always do one thing, that instead of calculating in this particular region, I will calculate in this particular region, and I will calculate for this particular region. Then I will subtract both of them, and surely I will get this particular region. Okay, and in probability what will happen is that this whole region, this will throw 1. This integration will throw 1. Your double integration on this whole region will throw 1. And what if in the examination you need to find this particular region? So you would know that 1 minus this region. That would be your answer. Is that clear to you? Okay. So just another method I am telling. Now you need to solve this integration, which is easy for you. So 2 by 3, limit of x is going from 0 to 1, x is constant, y square by 2, 0 to 1 minus x dot dx. So this 2 will come outside. Here you are getting 1 by 3. Okay, sorry. 2 by 3 minus was there, no? 2 by 3 minus was there. Really sorry, guys. So 2 by 3 minus, what is happening here? X into x minus 1 whole square. This 1 minus x I am putting as x minus 1. X minus 1 whole square divided by 2 dot dx. Limit of x is going from 0 to 1. Okay. Two by 3 minus 0 to 1, x square plus 1 minus 2x would be there, no? So that will be multiplied with x. So x cube minus 2x square plus x divided by 2 dot dx. So 2 by 3 minus 1 by 2 will come outside. X to the power 4 by 4 minus 2x to the power 3 by 3 plus x square by 2, 0 to 1. 2 by 3 minus 1 by 2. So 1 by 4 minus 2 by 3 plus 1 by 2. 3 by 4 minus 2 by 3. 9 minus 8, 1 by 12. This is coming out to be 1 by 24 actually. So 2 by 3 minus 1 by 24. So 3 by 4 minus 2 by 3. 12, 9, 8. Yeah, 1 by 12, so 1 by 24. 15 by 24. 5 by 8. This is the answer we are getting. Okay. 5 by 8 is the answer we get. Okay, I hope there is no calculation error. So 5 by 8 is the answer you get. So are you able to understand? What we did, we just studied about the surface integration. This is known as surface integration, not line integral. This is known as surface integration. Okay. Here volume integral also you will study. Line integral, volume integral and surface integration also you will study. But in our analysis, only surface integration will be used. Line integration you already know, right? So surface integration in this kind of thing, it will be used. So in this second question, what was the important point? That first was choosing the strip. I got to know that choosing the strip is difficult here. So I already know the surface integration of the previous thing. I already know the surface integration of the previous thing, right? Of this particular region. So what I can do is that from this particular region, I can subtract this region. So I will get my answer. What answer I am getting? I am getting the answer as 5 by 8. That's it. Now we need to study about two-dimensional random variable, and that we will study in the next video. Okay. So in the next video, we will start two-dimensional random variable. So this was purely based on mathematics. Next video will be based on two-dimensional random variable. Okay then. Yeah. Thank you very much. Yeah. Hi everyone. Welcome back. So now we are going to study about two-dimensional random variable. So previously we used to have only one random variable x or random variable y. But now what if both of the random variables are coming together? Then what will happen? That we are going to see. But before that, there are some prerequisites that we have already seen in the previous video. The integral calculus we have seen and conditional probability we have seen. So I hope you have watched that previous video as well, because that is very, very important. I will be taking reference of the previous video again and again in this particular lecture. Okay, so that mathematical part was very important. Let's get started with the two-dimensional random variable. So let's just say I am given only one random variable x. If only one random variable x is given, so I can define its CDF, cumulative distribution function. So I can define the CDF in this manner, fx of x. What does it say? It says that probability of random variable x taking values lesser than equals to small x. And I can define its PDF as well, which is shown by this, and that is equals to simply the differentiation of CDF, right? If you differentiate the CDF, what you will get? PDF. And there was another relation. What was the relation? That fx of x is given by this, d by dx goes here. From here you would get this particular thing, right? Do you agree to this point? But here if you are putting the limit in terms of x, then here you should put another variable. That variable we were putting as q. Similar thing you can do with the random variable y as well. What would be its CDF? CDF would be that random variable, probability of random variable y taking values lesser than equals to small y. What would be its CDF? What would be its PDF? PDF will simply be differentiation of CDF. And from here, what is the relation between CDF and PDF again? So CDF would be given as running integration. This is known as running integration from minus infinity to y of the PDF given. So yes or no, right? Now what if I am taking both of the random variables together into action? So for that we will define joint CDF of random variable x and y. Here what I was saying, CDF of random variable x, CDF of random variable x. What this was? CDF of random variable y. Now what I will define? Joint CDF of random variable x and y. What does that mean? How I will define it? I will define it in this manner. X comma y. This is how I will define it. fxy x comma y. Here also somewhere in some textbook you will find that here also comma is given. So it is just a way of representation. This is just a way of representation. What does this joint CDF represent? So this joint CDF represent probability of random variable x taking values lesser than small x and probability of random variable x taking values lesser than equals to small x and probability of random variable y taking values lesser than equals to small y. Is that clear to you or not? There is and, okay, and if there is this and, so 99% of the times this and will be represented by comma. So in whole communication system, wherever you see comma, comma means and or intersection. Wherever you see comma, comma means intersection. Are you able to understand this point? So let's understand it more by example. Let's just say I have written fxy 2 3. What is the meaning of this? So x is related with 2 and y is related with 3. So probability of random variable x taking values lesser than equals to 2 and probability of random variable y taking values lesser than equals to 3. This is the meaning of fxy x comma y. Fxy x comma y. So this is known as joint CDF of random variable x and y. Is that clear to you? Now here when we used to differentiate the CDF, what we used to get? PDF. So here also we will define joint PDF as well. Joint PDF of random variable x and y. If we have defined the joint CDF, we can define the joint PDF as well, right? And how we will define it? Here what we used to do? We used to differentiate with respect to x. We used to get the PDF of y. So here also we are having the joint CDF. What we need to do? We need to differentiate it. But now we will differentiate it. We will partially differentiate it with respect to x as well and with respect to y as well. Do you know what is the meaning of partial differentiation? Let us say I have given you a function x square y. Now you differentiate it. You partially differentiate it with respect to x and with respect to y as well. Basically, partially differentiation with respect to x, partially differentiation with respect to y. So you need to do these two things. So what you will do? First you will differentiate with respect to x, keeping y as constant. So keeping y as constant, differentiation with respect to x, that would be 2x. Now you will differentiate with respect to y, keeping x as constant. So 2x is a constant value, differentiation of y will be 1. So final answer will be 2x. So basically partial differentiation means if you are differentiating with respect to y, that means only y will be variable, rest all constant. And if you are differentiating with respect to x, then only x will be variable, rest all constant. Okay, very simple meaning. So what you will do is that you will partially differentiate the CDF with respect to x as well, with respect to y as well, because this is the function of random variable x as well, this is the function of random variable y as well. So in both of, with respect to both of them, you will partially differentiate and you will get your joint PDF. Okay, don't get too much afraid of these like what do we call it, these notations. These notations are not the matter of concern. Problem solving is the matter of concern, right? So we will solve a lot of questions, like I will solve 8 to 10 questions here. So you will be very comfortable with this particular topic, because two-dimensional random variable is one of the, it is considered as one of the toughest topic of whole communication system, not only for random variable, for of whole communication system, but we will deal it in the best possible manner. Okay, so have some patience and just keep on seeing the notation. It is very easy to write down fx of y, x comma y, probability of random variable x taking value lesser than equals to x, probability of random variable y taking value lesser than equals to y. In between there is a comma, that means it is end. And then if I differentiate with respect to x with respect to x and y, then what I will get? I will get my PDF. Now from here, if I need to get fxy, what I need to do? So here, if differentiation used to go here, what it would become? Integration. If differentiation goes here, it would become integration, right? So here as well, if this differentiation goes here, what it would become? It would become integration as well. It would also become integration of this particular thing. Limit will go from where to where? Here limit we would use to go from minus infinity to x, but here the limit will go from minus infinity to x, along with that minus infinity to y as well, right? Limit of x will also go, limit of y will also go. Here if you are putting the limit in terms of x, if you are putting the limit in terms of y, so here you cannot put xy. So what you will do? You will put pq here. Okay, what you are going to put? You are going to put pq. So don't get afraid of these notations. Everything will come to you. Everything will be crystal clear. Okay, so just have some patience. What you need to do, you are just integrating with respect to x as well and with respect to y as well. Then you will get your CDF. Very simple thing. Just we are interrelating with one-dimensional random variable with the two-dimensional random variable. Is that clear to you? This slide is clear to you? Not tough at all, right? So we will move slowly only, okay? Because this particular topic is kind of typical for a lot of students, but we will move slowly. Let's go to the next slide. Now let's see the properties of joint CDF. So what is the meaning of this? fxy x comma infinity. So probability of random variable x taking values lesser than equals to x, comma, probability of random variable y taking value lesser than equals to infinity. Now just let me know, isn't it certain that 100% it is sure that the random variable y will take value lesser than infinity only? Isn't it certain? Yes, surely sir, it is certain. That means now what will be our matter of concern? Our matter of concern is only x now. So can I write it down with this, in this manner? Say yes or no. So this is your fx of x. If this particular thing is given, from here how would you get fx of x? So in place of y, what you will put? Infinity. That's it. If I put in place of y, if I put infinity, what it is saying? Probability of random variable y taking value lesser than infinity, which is sure, no, which is 100% sure. You are 100% sure that y will be taking value lesser than infinity only. So that means this is not our matter of concern now. Our only matter of concern is this particular thing. And what does this particular thing represent? CDF of random variable x. So this is actually known as marginal CDF of random variable x. Marginal CDF of random variable x. Is that clear to you? We will solve the problems, but as of now, is this property clear to you? Right? You understood that surely your random variable y will take values lesser than equals to infinity only. What about this one? What this will be equivalent to? Think about it. Probability of random variable x taking value lesser than equals to infinity. and probability of random variable y taking value lesser than equals to small y. So this is 100% sure. No? 100% it is certain that x will take the value lesser than equals to infinity only. It cannot take value greater than infinity. So this is not our matter of concern. So what is our matter of concern now? Only this is our matter of concern. So this can be represented as fy of y, because I know that probability of y taking value lesser than equals to y is known as fy of y only. So this is known as marginal CDF of random variable, marginal CDF of random variable y. Is that clear to you? Very, very important properties. Okay, usually people mug it up, they don't understand it, but we are understanding as well. How did we understand? You understood, right? Because x is not a matter of concern here, y is not a matter of concern, only matter of concern is x, only matter of concern is y. Well and good. What do you think, what will be the answer of this one? Fx of infinity, infinity. Probability of random variable x taking value lesser than equals to infinity. Probability of random variable y value taking value lesser than equals to infinity. What that would be? It is 100% sure that random variable x will take value lesser than infinity only. Also, it is 100% sure that random variable y will also take value lesser than equals to infinity only, because it cannot take value greater than infinity. What does that mean? That means this is a certain event, probability will be 1. Say yes or no. So fxy infinity, infinity would be 1. You don't need to mug up anything, right? You will think there. What is the meaning? Okay, x probability of random variable x taking value lesser than equals to infinity, and probability of random variable y taking value lesser than equals to infinity. What does that mean? That means it is a certain event. Surely they will take value lesser than equals to infinity only. That means probability will be 1. What about the other one? What about this one? What does it say? Probability of random variable x taking value lesser than equals to infinity, and probability of random variable y value taking lesser than equals to minus infinity. What does this show? And so let me know, I am telling you a statement, let me know if this statement is possible or not. Let's take the value of sorry, here x is written, no? Let's take this x value is 2. So I am saying that probability, find the probability such that your random variable x is taking value lesser than equals to 2, and your random variable y is taking value lesser than equals to minus infinity. What I am saying, find the probability such that your random variable x is taking value lesser than equals to 2, and your random variable y is taking value lesser than equals to minus infinity. Is this event possible? And there is in between and. That means you need to satisfy this condition as well, and you need to satisfy this condition as well. Can you ever satisfy this condition? No. Random variable y can never take value lesser than minus infinity. That means if you are not able to satisfy this condition, that means you are not able to satisfy the whole probability. So what will be the answer? 0. The point is y can never take value lesser than equals to minus infinity. If in place of minus infinity, if any number was there, let's just say 3 number was, let's just say in place of minus infinity 3 was there. So I would have said that I need to find the probability such that x is taking value lesser than 2 and y is taking value lesser than 3, which is possible. But y can never take value lesser than minus infinity. Right? If it cannot take value lesser than minus infinity, that means this particular probability will be 0. Are you able to understand this point? Okay. So we are not going to mug up anything. We are going to understand every single thing with respect to very basic formula. Just it feels like it is aptitude, right? Forget about communication, forget about engineering, forget about mathematics. It is just simple aptitude. Just treat yourself as a class 10th student and you are studying aptitude only. Okay. So this is simply aptitude. What do you think? What will be the answer of this one? Probability of random variable x taking value lesser than equals to minus infinity, not possible, right? This is possible, but this is not possible. In between there is and. Since this is not possible and one thing is possible, that means you cannot satisfy both of the condition. So what will be the answer? 0. Answer would be 0. And here both of the conditions cannot be satisfied. X also cannot take value lesser than minus infinity. Y also cannot take value lesser than minus infinity. So what will be the answer? 0. Is that clear to you? All good? All fine? So if one of them is minus infinity, your job is done. Answer would be 0 only. Okay. If both of them are infinity, then answer would be 1. If one of them is infinity, then you need to think, okay, y is not our matter of concern, only x is left. Here x is not a matter of concern, only y is left. So this will be the marginal CDF, this would be the marginal CDF phi. So nothing we are mugging up, we are just understanding it by the basic concept. So this particular slide is very, very important. More points we are going to see. Again, CDF is a non-decreasing function. Look, CDF, fx of x was non-decreasing function. This was a CDF, right? This was also a CDF only. And this is also a CDF. So whatever the property they used to follow, the same property this will also follow. That means it is non-decreasing function. So if x2 is greater than x1 and y2 is greater than y1, that means your fxy x2 y2 would be greater than or equals to fxy x1 y1. Say yes or no? Because it is a non-decreasing function, no? So if x2 is larger, then joint CDF with respect to x2 will also be larger. If y2 is larger, then joint CDF with respect to y2 will also be larger. If x1 is lower, then joint CDF with respect to x1 and joint CDF with respect to y1 will also be lower. There you go. Right? Very simple. Very, very simple. And value will be between 0 to 1 because this was also CDF, this was also CDF, this was also CDF. So value was always between 0 to 1. Value will always be between 0 to 1 only, because what they represent? They represent the probability. Although they represent the probability in a range, but surely they represent the probability only, no? And probability is always between 0 to 1 only. So they are always associated with respect to probability, and probability is always between 0 to 1. So this point is also clear. Now here I will write down a formula. Probability of a rectangle. What do I mean by that? What you need to find? Look, previously what we used to find? We used to find probability such that your random variable x is taking value between x1 to x2. Let's write down it as A, B, C, D. It will be more easy for you. Okay, let's not call y1, y2. A, B, C, D. So what we used to find? Probability of random variable x taking value between A to B, right? So on the upper limit, I needed the equal sign. On the downward limit, I don't need the equal sign. So yeah, this is the desirable condition. So answer would be fx of b minus fx of a. This was the answer, right? And we remembered it. So here also I will write down the answer. You try remembering it if you can. I will tell you very simple method you will be able to remember. But for solving the problem, we will see the concept. Look, we will solve this question with respect to formula as well, with respect to concept as well. So as of now, I am writing down the formula. And I will tell you how to remember this particular formula as well. And then we will solve a question. First we will solve with respect to concept, and then we will solve with respect to formula. So how will you write down the formula? And why it is known as probability of rectangle? So just think about it. Here what is happening? Your x is between A to B. Your x is between A to B. X is between A to B. This axis is x and this axis is y. So x is between A to B. And y is between C to D. Y is between C to D. So this is the range of x, right? Between A to B. And y is between C to D. So let's just say this is C, this is D. So y is between C to D. C to D. So this would be the range of y. So what is the common region? This is the common region, no? Are you able to understand this point? This is the common region, right? So isn't it like the probability of a rectangle? What would be this point? You can write down these points, whatever these points are there. Forget about it. So isn't it like a rectangle? So that's why it is known as probability of a rectangle. Okay. So what is the formula? fxy, take the higher limit bd plus fxy, take the lower limits ac minus lower limit from here, higher limit from here, ad minus higher limit from here, lower limit from here. So basically higher limit plus lower limit plus lower limit, higher limit minus higher limit, lower limit minus. And this is the desirable condition, no? That here you need the equal sign, here you don't need the equal sign, here you need the equal sign, here you don't need the equal sign. So you can put plus plus here as well. You can put plus plus here as well. And if you don't want to put plus, then mostly this particular option will not be mentioned. Which option will be mentioned? The option that will be mentioned will be without the plus sign, right? The option that they will mention in the examination, that would be without the plus sign. Because you know that b plus is equals to b only, a plus d plus is equals to d only. So it is very rare that this formula will be used to solve the problem. But what may happen is that they can simply frame an option that which of the statement is true. They will write down probability of random variable x taking value. Okay, really sorry guys, here it should be capital X, no? Find the probability of random variable x taking value between a to b. So this should be capital X. So let's write down in a correct manner. Probability such that random variable x is taking value between a to b and random variable y is taking value between c to d, right? So what will be the formula of this particular thing? So in the option they will mention this particular thing, so you need to click on this particular formula. Okay, so there you cannot derive it. Now we will see the concept that how this formula came, and you will be able to realize that without using this formula as well we can solve the problem. Well and good. So is that clear why it is known as probability of a rectangle, and how do you write down the formula? Higher limit, lower limit, lower limit, lower, higher, lower. That's it. Lower limit, higher limit will be coming with plus sign. Lower limit will be coming with plus sign. Lower, higher will be coming with negative sign. Higher, lower will be coming with a negative sign. All good? All fine? Okay then. Let's see this question. Let's understand the question now. So first let's understand the question. X and y are two random variables such that x is taking values 0, 1, 2. So what it is? Discrete random variable, and this is also discrete random variable. Both are discrete random variable, right? X is taking value 0, 1, 2, y is taking value 1, 2, 3. Their joint PMF is defined. The way we define joint PDF, in the same manner joint PMF can also be defined. What is the meaning of PMF? What was your Px of x? That was probability of random variable x taking value small x. What would have been your Py of y? Probability of random variable y taking value small y. What would have been your Pxy x comma y? So probability of random variable x taking value small x, probability of random variable y taking value small y. That's it. This is how you can define the PMF as well. So this kind of table you will see a lot of time in information theory. In digital communication as well, this kind of table will be there. So you should know what is the meaning of this table. So this tells the joint PMF of random variable x and y. So what do you think? What is the meaning of this 0.15? This says that probability such that random variable x is taking value 0. This 0.15, this is coming with respect to x equals to 0 and y equals to 1 is equals to 0.15. So probability is such that random variable x is taking value 0 and random variable y is taking value 1 is equals to 0.15. I am just telling you what is the meaning of this table. We are not solving the problem. Now what do you think? What is the answer of this thing? Probability of random variable taking value x equals to 1 and y equals to 3. X equals to 1 and y equals to 3, that means this is 0.17, right? X equals to 1 in this line and y equals to 3, which is this particular thing, right? What if I ask you probability of random variable x taking value 3? Can the x take value 3? No, there you go, answer is 0, right? Y can take the value 2, but comma means and, so x cannot take value 3, that means answer is 0. Are you able to understand this point, right? Now what they are asking, you need to find the probability such that your x should be taking value between 0 to 2, excluding 0, including 2. That means x can take value 1 and 2. So yes or no? They are asking the probability of x taking value 1 and 2 and 1 or 2 and y taking value between 1 to 3, excluding 1, including 3. That means it can take 2 or 3. Is that clear to you? What they are asking probability of random variable x taking value between 0 to 2, but 0 cannot be included. That means it can take value 1 and 2, 1 or 2 actually, not 1 and 2, 1 or 2 I should write down. 1 or 2, and y can take value 2 or 3. Because y can take value between 1 to 3, including the 3. So 2 or 3 it can take, right? So between what they have written 1 to 3. 1 to 3. So this could be equals to, let's just say random variable x is taking value 1 and random variable y is taking value 2. Will that be acceptable? Surely it will be acceptable, right? Random variable x is taking value, random variable, what they are saying, random variable is x is taking value 1 and y is taking value 2. Random variable x is taking value 1, y is taking value 2, plus random variable x is taking value 2 and y is also taking value 2. Basically what I will do is that 1, 2, 1, 3, 2, 2, 2, 3. All these cases I will take. Basically what I mean to say is that if random variable x is taking value 1, y can take value 2, y can take value 3 as well. So first case we wrote down, random variable x is taking value 1 and y is taking value 2. Or what could be the case? That your random variable x is taking value 1 only, but y is taking the value 3. Or what could be the case? That your random variable x is taking value 2 and y is taking the value 2 as well. X is taking value 2, y is taking value 2. Or what could be the case? That your random variable x is taking value 2 and y is taking value 3. X is taking value 2 and y is taking value 3. So these 4 cases would be there. Now let me know what is the probability of x equals to 1 and y equals to 2. X equals to 1 and y equals to 2, 0.03. 0.03 plus. Next what we need to find, x equals to 1 and y equals to 3. So x is taking 1 and y is taking 3. So that would be 0.17 plus x is taking 2, y is taking 2, 0.25 plus x is taking 2, y is taking 3, 0.1. Right? So what is the answer? 0.55. 0.2, 0.45, 0.55. This is the answer. Right? So by this table as well you could solve this problem, no? That what did you understand from here? That your x can take value 1, 2, x can take value 2, 3. That means y cannot take value 1, x cannot take value 0. This is the condition. So x cannot take value 0, that means all these will not come. And y cannot take value 1, that means this will not come. So only these will come. Are you able to understand this problem? With respect to diagram only. With respect to diagram, what we are saying is that from this particular probability, what do you understand? That x can take value 1, 2, y can take value 2, 3. So this can be taken, this can be taken, this can be taken, this can be taken. That means what is common between these guys? These are common. So addition of all of them will be the answer. Now let's solve it with respect to the formula that we have written. What does the formula say? This is written, formula will say fxy 2, 3 higher limit plus lower limit 0, 1 minus lower higher 0, 3 minus higher lower 2, 1. So let's find out the value of this particular thing. Here we will write down the answers, but let's find out the value of fxy 2, 3. What does it say? That probability of random variable x taking value lesser than equals to 2 and y lesser than equals to 3. Right? This is the meaning. X taking value lesser than equals to 2, y taking value lesser than equals to 3. Isn't it certain? What do you think what will be the probability? Probability will be 1. Because what they are saying, random variable x should take value lesser than equals to 2 and y should take value lesser than equals to 3, which is certain, no? That means all these cases will come. And when you add all these cases, 1 will come. You can see that 0.15 plus 0.05 plus 0.1. What it would be? 0.3, 0.4, 0.6, 0.9 and 1. That means what they are saying, random variable x should be taking value lesser than equals to 2 and y should be taking value lesser than equals to 3. That means all the cases would come. X taking value lesser than equals to 2, y should be taking value lesser than equals to 3. So this particular thing would be 1. What about this particular thing? fxy 0, 1. Probability of random variable x taking value lesser than equals to 0 and y taking value lesser than equals to 1. What do you think? What will be the answer? X should be lesser than equals to 0 and y should be lesser than equals to 1. That means x can be 0 and y can be 1. That's the only case. Just think about it. Think about it with respect to aptitude. That x should be lesser than equals to 0 and y should be lesser than equals to 1. So only this case is there, no? That means this probability will come into action, 0.15. Are you able to understand this point? What about fxy 03? Probability of random variable x taking value lesser than equals to 0, y taking value lesser than equals to 3. X taking value lesser than equals to 0 and y taking value lesser than equals to 3. That means all the values of y will come, but only value of x will come, that will be x equals to 0. That means you can take x equals to 0, y equals to 1, x equals to 0, y equals to 2, x equals to 0 and y equals to 3. That means all these will come into action. Are you able to understand this point? X equals to 0, y should be less than, x should be less than equals to 3, x should be less than equals to 0. What does that mean? That means x can be 0 only, because less than 0 is not possible. So only x can be equals to 0. Now y should be less than equals to 3. That means y could be 1, 2, 3. So x equals to 0, y equals to 1, x equals to 0, y equals to 2, x equals to 0, y equals to 3. So all these will come into action. So what will be the answer? 0.3. And what do you think? What will be the answer of this particular thing? 2, 1. Probability of x taking value lesser than equals to 2, but y should be lesser than equals to 1. So what do you think? What should be the answer? X should be less than equals to 2. X should be less than equals to 2, but y should be less than equals to 1. X should be less than equals to 2. That means everything would come 0, 1, 2. So this would also come, this would also come, this would also come. But y should be less than equals to 1. That means y cannot be less than 1. So y has to be equals to 1. So only this condition will come. Right? So x equals to 0, y equals to 1. X equals to 1, y equals to 1. X equals to 2, y equals to 1. So you add all of them. What you will be getting? 0.3. So 2, 3, this was 1. 0, 1, this was 0.15. Minus 0.3, minus 0.3. So what you are getting? Minus 0.6, that would be 0.4, and answer is coming out to be 0.55. So I just wanted to prove the formula, nothing else. In the examination, you are not going to do this particular analysis, right? In the examination, you will just think, okay, what this is saying? 0 to 2 excluding the 0, that means 1, 2 I can take. 1, 2, 3 excluding 1, that means 2, 3 I can take. So 1, 2 here, 2, 3 here. So 1, 2 is possible, or 1, 3 is possible, or 2, 2 is possible, or 2, 3 is possible. So I will add all of them. My answer will be 0.55. That's it. But you should know how to utilize this formula as well, because in the examination what may happen is that they will just write down this particular line and they will ask you whether this line is true or not, or they can frame this line in the options and they can ask you if this particular line is true or not, right? So this formula should be there in your mind. Higher limit, lower limit, lower limit, lower, higher, higher, lower. With higher, higher, lower, lower, plus sign would come. With higher, lower, lower, higher, negative sign would come. That's it. So this formula should be there in your mind. It may come directly in the examination, but it is very rare chance that you will be using this formula to solve a particular problem. The problem will be solved on your own. Now in this question only, what if someone asks you probability of x equals to 0? Find the probability of x equals to 0. In this question only I am asking probability of x equals to 0. What do you think? What will be the answer? So just think about it. If x is equals to 0, y could be 1, or if x is equals to 0, y could be 2, or if x is equals to 0, y could be 3. That's it. So if you need to find the probability of x equals to 0, then that means you just need to add this line. That's it. Can you compare this table? Just compare this table with A and B. let's just say this is A1 written, this is A2, this is A3, this is B1, this is B2, this is B3. What this will show? A1 intersection B1. Say yes or no. Probability of x taking value equals to 0 and probability of y taking value equals to 1. Probability of x taking value 0 and means this is comma, but actually it is intersection. So isn't it like A1 intersection B1? And isn't it like A1 intersection B2? And isn't it like A1 intersection B3? Now if I ask you, what is the probability of A1? Do you remember? What do you remember? The conditional probability. There I made this kind of thing, that let's just say there are 3 events, B1, B2 and B3. In all of the event, A1 is common. So what is the probability of A1? Let's make the diagram in a good manner so that you will be able to relate. Okay. Communication is nothing but simple mathematics. All important part is that you should be able to relate it, nothing else. If you are able to relate, your job is done. Right? This is how subject should be studied. Just we need to relate the things. So let's just say this event A is A1 and this is B1, B2, B3. If I ask you probability of event A1, what that would be? A1 intersection B1 plus A2 intersection B2 plus A3 intersection B3. We are doing the same thing here. If I ask you probability of x taking value 0, probability of random variable x taking value 0, 0.15 plus 0.05 plus 0.01 plus 0.1, so 0.15 plus 0.05 plus 0.1. What is the answer you will get? 0.3. Randomly, if I ask you what is the probability of taking y equals to 2, what do you think what will be the answer? Y equals to 2. That means if y equals to 2 is coming, then x could be 0 or it could be 1 or it could be 2. Basically, if I am saying that y is equals to 2, so x could be 0 taking y equals to 2 only, x could be 1 taking y equals to 2 only, or x could be 2 taking y equals to 2 only. So what will be the answer? Just you add this line. Just you add this line. So this line is showing probability of y equals to 2. This line is showing probability of y equals to 1. This line is showing probability of y equals to 3. This particular line is showing probability of x equals to 0. This particular line is showing probability of x equals to 1. And this particular line is showing probability of x equals to 2. And addition of all these probabilities should be equals to 1. Because this is only is happening. If x can take value 0, then y can take value 1. Or x is taking value 0, y taking value 2. Or x is taking value 0, y taking value 3. Or x is taking value 1, y is taking value 1. Or x is taking value 1, y is taking value 2. Or x is taking value 1, y is taking value 3. Or x is taking value 2, y is taking value 1. Or x is taking value 2, y is taking value 2. Or x is taking value 2 and y is taking value 3. Addition of all of them would be 1. And you can check, I have framed the problem in this manner only, that addition of all of them is 1 only. So now are you able to understand the meaning of two-dimensional random variable? This was a discrete random variable example. We will see the example with respect to continuous random variable as well. So are you able to understand the basic meaning now? Right? So if I ask you probability of y taking value equals to 2, so 0.05 plus 0.03 plus 0.25. So 0.05 plus 0.03 plus 0.25. Right? I have put the same thing now. 0.05, 0.03, so 0.8, 0.33, right? So this is the answer. All good, right? Yeah. So we will see these kind of examples again and again. Don't worry about that. क्या हो गया भाई? Just slide should be changed. अरे just one second, guys. Yeah. So we have solved this question. This question is clear to you, right? So first this was asked, then we verified the formula as well. This is method 2. This was method 1. Just we wanted to verify the formula, and then we understood about this particular table as well. From this table, everything we can determine, right? So we will see more problems regarding this particular concept only. But let's move to different kind of problem, or let's see the properties of a joint PDF now. We have seen the properties of joint CDF. We have solved one question as well. Let's see the property of a joint PDF. So what was your joint PDF? So when you partially differentiated your CDF with respect to random variable, with respect to X as well and with respect to Y as well, what did you get? You get your joint CDF. Okay. If you differentiate your joint CDF with respect to X and Y, you will get your joint PDF. Now you need to find the marginal PDF of X. What do you need to find? Marginal PDF of X. That means what you need to find? Fx of X. Right? So what someone will say? That sir, first I will find the marginal CDF of X. What someone will say that sir, first I will find marginal CDF of X and then I will differentiate it. What is this? Marginal CDF of X. Say yes or no. You can think like this. And how you can find marginal CDF of X? Sir, marginal CDF of X is very easy, sir. What I will do is that I will just kill Y. I am just making certain that Y should take value lesser than equals to infinity, which is certain. So from here I can find the marginal CDF of X as well. So sir, I have find the marginal CDF of X and then I will differentiate it. I will get the marginal PDF of X. So if CDF is mentioned, then I can follow this particular method. But what if PDF is mentioned? What if this joint PDF is mentioned? From here, how can you get Fx of X? What I am saying, joint CDF of random variable X and Y is mentioned. And from here, you need to get the marginal CDF. How will you get it? This is my question. So just let me know one thing. This will be a function of X only. No? This will be a function of X. Right? Function of X. Now let's just say your fxy is a function of X and Y both. Now you let me know, I will differentiate this particular thing with respect to Y and I put the limit of Y, let's just say from 1 to 3. So X will be a constant, right? What will be the answer you will be getting? Let's take the limit from 0 to 3. Okay, I am taking the limit from 0 to 3. So what is the answer you are getting? 9x by 2. So this was the function of both X and Y. But you differentiated with respect to Y and you put the limit of Y. So that means Y got killed. Right? In the final answer, your Y is not there. Y has been made a constant value. So similar thing you need to do here. What you need to do? You need to find Fx of X. Right? This could be a function of both X and Y. This could be a function of both X and Y. So what you will do is that you will differentiate it with respect to Y from minus infinity to infinity. Or whatever the limit is given. Let's just say Y is going from 2 to 3. Your random variable Y can take value from 2 to 3 only. So you will put the limit from 2 to 3. Your random variable Y can take value from 2 to infinity. So you will put here 2 to infinity. Are you able to understand this point? What I am saying? This could be a function of both X and Y. But in the final answer, you only need function of X. So what you are actually doing is that you are integrating it with respect to Y and you are putting the limit of Y from minus infinity to infinity. You are putting the constant limit of Y. So your final answer will come in terms of X only. Are you able to understand this point? So two ways are there. If marginal CDF is mentioned, marginal CDF is mentioned, what you will do is that from there, sorry, not marginal CDF, really sorry guys, this is your joint CDF, really sorry. If joint CDF is mentioned, what you will do? You will find the marginal CDF. You will find the marginal CDF and from here you will differentiate, you will get the marginal PDF of X. Now what if your joint PDF is mentioned? So from joint PDF, directly how will you get marginal PDF? Directly how will you get marginal PDF of X? So what you will do? This could be a function of both X and Y. I am not saying that always it will be a function of X and Y. It could be constant as well. But what you need to do, you just need to pick this one and put the limit of Y. That means what I am doing, I am putting limit from minus infinity to infinity. That means now I am killing Y. Y is being totally integrated. Only X is left. So this will be a marginal PDF of random variable x. Are you able to understand this point or not? Okay. Usually all these things are understood with respect to very complex mathematics, but we are not going into the complex part of mathematics. By the simple intuition, we are understanding what is happening here. These are purely intuition, right? No mathematics I am using. Directly we are able to write down the formula. Just think about it. If a joint CDF is given, I can find the marginal CDF and from there I can get the PDF. If joint PDF is given, that means this is telling about x and y both. But if I need to get the marginal PDF of x, that means I need to care about only x. So what I will do, I will integrate with respect to y, putting the complete limit of y. Because if I put the limit of y, then what will happen is that the final function will be in the terms of x only. And this is what I want. Is that clear to you? It will be very easy to remember and very easy to understand as well. And we will solve the problems, it will be more clear to you. Okay. So with patience, you keep on watching whatever that we are dealing here. And similarly, you can find the marginal PDF of y as well. So what would be your marginal PDF of y? Marginal PDF of y. That would be Fy of y. So someone will say that, sir, what I will do is that I will differentiate this particular thing. And how will you get this particular thing? That, sir, if fxy is mentioned, I will kill x. That means it is 100% sure that x would be taking value lesser than equals to infinity only. So from here I can get my Fy of y, and then here I can put it. What I can do? Here I can put it, and from here I will get marginal PDF of y. But what if joint PDF is mentioned? If joint PDF is mentioned, what I will do? Sir, here fxy x comma y is telling that both x and y are into action. But what I will do is that I will differentiate with respect to x, and I will put the limit of x from minus infinity to infinity, or whatever the limit is there. Let's just say x can go from 0 to 3, so I will put the limit from 0 to 3 only. If x can go from 1 to 5, then I will put the limit from 1 to 5 only. So now what will happen is that this will be integrated with respect to x, so x will be made a constant, and only this will be a function of y. Is that clear to you? So from here I will get my Fy of y as well. So these two concepts again very important, and very easily we have understood this kind of concept here. Say yes or no. Right? Very easily we have understood this concept. Well and good. Let's go to the next property. So your fx of x was also a PDF, Fy of y was also a PDF, and fxy x comma y was also a PDF, right? This was also PDF, this was also PDF, and this was also PDF. So all the properties of PDF, they will follow that it will be non-negative. You know that PDF will always be positive and area under the curve will be 1. So area under the curve, and here area under the curve will be taken as x going from minus infinity to infinity and y going from minus infinity to infinity. Because previously what was happening? Only x was there or only y was there. But now x and y both limit would be there. So area under the curve will be 1. X going from minus infinity to infinity, y going from minus infinity to infinity. Area under the curve will be 1. Right? Or here I should better write region R. Whatever the region this x and y are making, in that region R, your complete area would be equals to 1. Okay. So surface integration would be equals to 1. Are you able to understand this point? Whatever the region your random variable x and y are making, in that particular region, your surface area would be equals to 1. And here you already know that whatever the limit y is taking, in the whole limit, your area under the curve would be 1. Here also area under the curve would be 1. Right? Now there is something called independent random variable. Okay. So if A and B were independent events, A and B are independent events. So what was happening? Probability of A intersection B was equals to PA dot PB. So isn't it like intersection only? So that would be equals to fx of x dot fy of y. I am just interrelating, nothing else. Fx of x, fy of y. So in the question, if it is given that x and y are independent random variable, so you can do this kind of thing. Independent random variable. If x and y are independent random variable, then joint CDF of random variable x and y would be, joint PDF of random variable x and y would be equals to marginal CDF of random variable x multiplied with marginal PDF of random variable y. What I am saying, joint PDF slash CDF of random variable x and y would be equals to what? Marginal PDF or CDF of random variable x and y multiply with not x and y, yeah, only x, because this is x, this is y, multiplied with marginal PDF or CDF of random variable y. There you go. So don't feel like that, sir, there is a lot of things to remember. Just you keep on looking at it, you will be able to utilize it with respect to questions as well. With respect to the problems, you will be able to realize it. Okay, so we will solve a lot of problems and everything will be remembered. So don't feel like that, sir, there are a lot of things to remember, sir, I might forget it. Nothing like that. You are not going to forget anything. Okay, so here for interrelating, what did we write? If A and B are independent events, then events, probability of A intersection B was equals to probability of A dot probability of B. Right? All good? All fine? So let's revise whatever that we have studied till now. So not too much, just we are revising it. Random variable x was given. You can find CDF of random variable x. You can find CDF of random variable y. When you partially differentiate it, what do you get? PDF of x, PDF of y. Right? Then joint CDF is defined. What is the meaning of joint CDF? That means here it will take x and y both into action together. Both are into action together. That means x taking value lesser than equals to x, y taking value lesser than equals to y. Right? From here you can get that. If you partially differentiate it with respect to x and y, you will get your joint PDF of random variable x and y. And if you integrate your joint CDF, if you integrate your joint PDF, then you will get your joint CDF. Now these are the properties which we have already seen. Then this formula of probability of rectangle, this formula we see, we just saw that we need to remember it. Otherwise, with respect to concept as well, you can solve it. Then we saw the properties of joint PDF, that partially differentiation of joint CDF will be your PDF. Now this was very important. How would you get a marginal PDF of random variable x and marginal PDF of random variable y? So how will you get it? Fx of x, fx of y I need. So if my joint CDF is given, what I will do? In place of y, I will put infinity. Because in place of y, if I put infinity, I can get my marginal CDF of x. And if I differentiate my marginal CDF of f, if I differentiate my marginal CDF of x, what I will get? I will get my marginal PDF of x. And what if joint PDF of random variable x and y is given? If joint PDF of random variable x and y is given, and I need to find the marginal PDF of x, what I will do? I will integrate with respect to y, and I will put the limit of y. If I do so, what will happen is that there will not be any term of y, only term of x will be left, and that will be equals to marginal PDF of random variable x. And same thing I can do with respect to marginal PDF of random variable y as well, right? It will be non-negative, because PDF are non-negative. PDF will always be greater than 0, and area under the curve will always be equals to 1. So here this was curve, but this will be a surface. So area under the surface will be equals to 1, because here limit of x will also go, limit of y will also go. So area under the surface would be equals to 1. So surface integration would be equals to 1. Here this simple integration was equals to 1. Here surface integration would be equals to 1. And if x and y are independent random variable, then what will happen is that fx of y, x comma y would be equals to fx of x dot fy of y, and CDF of random variable x and y would be equals to marginal CDF of random variable x into marginal CDF of random variable y. Well and good, crystal clear. Now we can solve the problems. So one question, then second question. So a lot of question we are going to see. In between we will see a small concept, then again more questions. So we will keep on solving the problems now. Okay. So just revise whatever that we have studied in this 1 hour, and then let's start solving the problem. So don't try it on your own. If you want to try it, you can try it, but just think about it. How will we get the value of b? So let me pause the video, take some break. I will drink some water, and then I will come back and we will start solving this particular question. Okay. Yeah, welcome back. So we need to find the value of b here, and then this is the second question. You need to find the probability such that x plus y is less than 1, and then we need to find the probability such that x plus y is equals to 1. So this is a two-dimensional random variable. You can see this is the joint PDF is given. It will be mentioned in the question. Okay, joint PDF of random variable x and y is given. So let's compare it with the one-dimensional random variable. What I am doing, I am just comparing. Let's just say my fx of x is given as that it is e to the power minus x for x greater than or equals to 0, and it is otherwise 0. And let's put b here, b e to the power minus x. So what we used to do, what we can do is that we can make the graph of fx of x versus x. So I know that random variable x is taking value from 0 to infinity. It is taking value from 0 to infinity, and with respect to that we are having this particular graph. The graph is like before this it was 0, then at x equals to 0 the value is 1, and at infinity it will again come down to 0. So this is the graph. So what we were drawing? We were drawing x versus fx of x. Our random variable x is taking value from 0 to infinity, and this is our fx of x, which is at x equals to 0 the value is b, right? Similarly here, what is the scenario? Here there are three things. There is random variable x, there is random variable y, and then there is fxy x comma y. Here what was the scenario? Only two things were there, x and fx of x. Now here there are three things, x, y, or let's call this as y, x, y, and fxy xy. Basically x is there, y is there, and fxy xy is there. So here what they are saying, x is taking value from 0 to 2. So x is taking value from 0 to 2. This is the line of x. So this is the range of x, right? This is the range of x. Here x was taking value from 0 to infinity. Here this is the range of x. X is taking value from 0 to 2. And y is taking value from 0 to infinity. Y is taking value from 0 to infinity. So that means what is our matter of concern? What is our region of operation? Our region of operation is this much. X is taking value from 0 to 2, y is taking value from 0 to infinity. So this is our region of operation. This is our region of operation. Say yes or no. This is our region of operation. Do you agree to this point? So usually in one dimensional random variable, I can make x versus fx of x. But now in this region, you need to make fxy xy, which is equals to b e to the power minus x plus y. So making this graph is not possible, no? Are you able to understand this point? Like making this particular graph here, it is depending on x as well, it is depending on y as well. So we will not make this graph. Are you able to understand this point? Basically, we will not show the y-axis. Not y-axis, I should say, we will not show the vertical axis. Here this was the horizontal axis, that x was taking value from 0 to infinity, and on the vertical axis, I was showing the value of your PDF. Now, this is my horizontal plane. On the horizontal plane, what I am saying, value of x is from 0 to 2 and value of y is from 0 to infinity. On the vertical axis, here I am supposed to show the value of joint PDF. I am supposed to show the value of joint PDF, but that I am not going to show because making the graph will be difficult here. So why do we need to make the graph? No, I don't need to make the graph. Let's just say here I need to find the value of b. Do I need to make the graph? No. What I need to do? X is taking value from 0 to infinity. X is taking value from 0 to infinity. b e to the power minus x dot dx should be equals to 1. This is my job, right? Because I know that, what do I know? Minus infinity to infinity, fx of x dot dx will throw 1. So what I will do? From 0 to infinity, b e to the power minus x dx. Why 0 to infinity? Because x is taking value from 0 to infinity only. So b to the power minus x dot dx should be equals to 1. So here do I need this particular graph? No, what I need, I only need that x should be going from 0 to infinity. That's it. This is what I need. So x is going from 0 to infinity. So I integrated it. What I will get? B equals to 1 I will get. Is that clear to you? So here what I will do? Here I will only see what x is taking. This is how I will make the axis, x and y. I don't care about fxy. Fxy would be somewhere here towards me. This particular plane is here. The horizontal plane that you see, that I have made like this. So I only care about x and y. X is taking value from 0 to 2. X is taking value from 0 to 2. And y is taking value from 0 to infinity. That means what will be our matter of concern? Our matter of concern would be this particular surface. Our matter of concern will be this particular surface. What I need to find? I need to find the value of b. Here what we used to do? We used to integrate. But here we will double integrate. Because x is also varying, y is also varying. Then what we used to write down? We used to write down our PDF. And then we used to integrate the whole axis. We used to integrate the whole axis from 0 to infinity, right? With respect to x. From minus infinity to infinity. Although it is non-zero from 0 to infinity, that's why we just put 0 to infinity here. So what we used to do, the limit of x on the whole axis. The limit of x on the whole axis. But now, in the two-dimensional random variable, this axis have been changed to a plane. So now what I need to do, I need to integrate it over the plane. I need to integrate this particular thing over the plane, or you can say region R. And that would be equals to 1. So now are you able to understand this particular thing? Just compare it with one-dimensional random variable. In one-dimensional random variable, we used to make x versus fx of x, or you can say fx of x versus x. But drawing this particular diagram will be difficult. So in two-dimensional random variable, we will only care about x and y, and we will just see the surface. Okay, this is the surface. So in this particular surface, my surface integration should throw the value equals to 1. That's it. So here also I can choose the strip. I can choose the vertical strip. If I choose the vertical strip, what will happen? So in the vertical strip, you can see that value of y will be going from, value of y is going from 0 to infinity, and value of x is going from 0 to 2. So value of y is going from 0 to infinity, and value of x is going from 0 to 2. And this is given. I am just telling you the core concept, that how we are solving the problem like this. Otherwise, I could have directly said that, okay, just make the area and then integrate. This is how it is taught. But how do you compare two-dimensional random variable with one-dimensional random variable? Here also, if it was possible, we could have drawn the graph as well. Surely drawing the graph is possible. ChatGPT can draw the graph for you. But you cannot draw the graph, no. So I am not caring about the graph. Even here as well, I don't need to care about the graph. Only thing I care is how much value my random variable x is taking. So here also I am caring about only one thing, that how much value my random variable x and how much value my random variable y is taking. So x is taking from 0 to 2 and y is taking from 0 to infinity. There you go. Dot dx dy is equals to 1. So I can solve it, right? Surely I can solve it. So what I should do is that let's keep this on the second page, okay, and let's keep it here. So I will solve it. How will I solve it? You can differentiate, like constant limit are there, no? Constant limit are there. So you can integrate with respect to x, you can integrate with respect to y. Differently you can integrate, right? Because constant limits are there. So first I will integrate with respect to x, with respect to x. So b is already a constant, e to the power minus x dot dx. And then I will integrate with respect to y, e to the power minus y dot dy should be equals to 1. So this integration will be 1 only. And what will be this integration? E to the power minus x 0 to 2, there would be negative sign. This integration will throw 1 only, right? So b into 1 minus e to the power minus 2. If you put e to the power minus 2 and e to the power 0 would be 1, there is a negative sign. So what will happen? 1 minus e to the power minus 2 should be equals to 1. So from here, b value is coming out to be 1 upon 1 minus e to the power minus 2. This is the answer. Okay, so this is the answer of B. Did you understand this point? Okay, let's see the next question now. What your next question is saying? What they are saying? They are asking you to calculate probability of x plus y should be less than 1. What they are asking? Probability of x plus y should be less than 1. This is what they are asking. Let's again compare. In this question, if I had asked you probability of x less than 1, what you would have done? Where is x equals to 1? This is your x equals to 1. So what you would have done is that x less than 1. What you would have done? You would go here, and you would say that, sir, whatever my PDF is there, I will integrate it less than 1. That means minus infinity to 1. Value of x should be less than 1. That means I will integrate my PDF from minus infinity to 1. Do I need to care about the graph? I only care about the expression. I don't care about the graph. I need the expression of fx of x. Are you able to understand this point? I need the expression of fx of x, but whatever the graph is there, I don't care about that. Now I know that graph will be starting from 0. So 0 to 1. What is the value of graph? B to the power minus x dot dx, and then I can solve it. I will get my answer. What is the probability of a random variable x taking value lesser than 1? So what I would do, I would just integrate it. I would just calculate the area. Here what is the scenario? Here random variable x is there, here random variable y is there. Along with that, another condition, x plus y less than 1. So on this particular plane, here what you are making? You are making the line of x equals to 1. Right? And then you know that my matter of concern is x less than 1. What is my matter of concern? My matter of concern is x less than 1. Then you would know that this area would come into action. X less than 1. This area would come into action. So similar thing you will do here. What you will do? X plus y less than 1. That means now you will make the line of x plus y. How you will make the line of x plus y? Can you make the line of x plus y? Yes. X plus y equals to 1. That will be this line. X plus y equals to 1. That will be this line. So this line is x plus y equals to 1. X plus y less than 1 you need. That means if you put 0, 0, that means this region will come into action. So now your matter of concern will be this particular region. Your matter of concern will be this particular region. Let's just say this region I am calling as R. I will surely make this region in 2D as well, but just try thinking about it. Now in this particular region R, what you will do? In this particular region R, what I will do? I will take my joint PDF and I will just integrate it. This is what we are doing here as well. You are taking your PDF and you are integrating in the region which is matter of concern. What is the matter of concern? From minus infinity to 1. But you get to know that x is greater than 0. So matter of concern will be from 0 to 1. So what you are doing? You are taking your PDF and then you are integrating from 0 to 1. What is your matter of concern? So now what is my matter of concern? My matter of concern is this particular region. So now I will integrate my PDF in this particular region. So let's make it in a better manner in 2D. So in 2D, what did you get to know now? That already what was given? Already given was that x is from 0 to 2 and y is from 0 to infinity. This was already given. Already given that x is from 0 to 2. That y is completely there from 0 to infinity and x is there from 0 to 2. X is there from 0 to 2. This is already given. I don't need to care about the lower side. Why I don't need to care about the lower side? Because I know that y is from 0 to infinity. Y is from 0 to infinity. So this was already given that your matter of concern is this particular region. This is your matter of concern. Now what they are asking, in this particular region as well, what you need to calculate? You need to calculate such that x plus y is less than 1. X plus y is less than 1. So can you draw the line of x plus y equals to 1? Surely I can draw the line of x plus y equals to 1, which is this one. This line is x plus y equals to 1. So x plus y less than 1. X plus y less than 1 will be this region, right? X plus y less than 1 will be this particular region. So in this particular region, x plus y less than 1. How will you calculate x plus y less than 1? You will put 0, 0 here. 0, 0 is less than 1. Yes. 0 plus 0 will be equals to 0 only. 0 plus 0 will be equals to 0. So 0 is less than 1. Yes. That means this particular region will come into action. So now this is my matter of concern. So in this region R, I will take my PDF and I will integrate it. That's it. This would be my answer. Now, do you know how to integrate? Surely you know, right? You surely know how to integrate. So what you will do? In the region R, what you will do is that you will take the strip. You will take the strip, and since this line is x plus y equals to 1, so what will be this point? And what will be this point? This point will be x equals to 0, y equals to 1, and this point will be x equals to 1, y equals to 0. You have taken a vertical strip, so value of y is going from 0 to 1 minus x. So your integration will go from, you know that value of y will go from 0 to 1 minus x, and if you move the strip, x will go from 0 to 1. X will go from 0 to 1. Here what is given? fxy is given, that is b e to the power minus x, b e to the power minus x plus y, dx dy, and this is something that I need to calculate now, right? So I know the value of b, so what I can do is that x is going from 0 to 1, y is going from 1 minus x, value of b was 1 upon 1 minus e to the power minus 2, e to the power minus x, e to the power minus y, dx dy. I told you one thing, always we will first integrate with respect to y, because this is the variable limit. So what I will do is that 1 upon 1 minus e to the power minus 2 outside, x is going from 0 to 1, x is going from 0 to 1, e to the power minus x dx, and when you integrate e to the power minus y, that would be e to the power minus y divided by minus sign would come, and limit will go from 0 to 1 minus x. So what I can do, I can take the limit from 1 minus x to 0. Did you understand what I did here? I know that when I solve this particular integration, e to the power minus y, just one second guys. Yeah, so what I was saying, so e to the power minus y integration will throw e to the power minus y and then negative sign. So to adjust that negative sign, what I am doing, I am interchanging the limit 1 minus x to 0, right? Because I don't want to use the negative sign. If I use the negative sign here, that means the limit will go from 0 to 1 minus x. Limit will go from 0 to 1 minus x. Now if I kill that negative sign, that means I can interchange the limit. Well and good, very simple mathematics, nothing else. One minus e to the power x minus 1 dot dx, right? E to the power minus x, e to the power 0 1 minus e to the power x minus 1, x going from 0 to 1. So 1 upon 1 minus e to the power minus 2, x going from 0 to 1, e to the power minus x minus e to the power minus 1 dot dx. Okay, so when you integrate, what you are getting? E to the power minus x, and then there will be a negative sign, minus e to the power minus 1 x 0 to 1. Is that clear to you? Right? If I integrate e to the power minus x, what I will get? E to the power minus x minus sign, and minus e to the power minus 1 is there. So e to the power minus 1 dot dx, that will throw x 0 to 1. Well and good. So what I can do is that I can take out the negative sign, so this will become plus, and then I can interchange the limit. It goes from 1 to 0. So just I interchange the limit, nothing else. So what you are getting? E to the power 0 would be 1 minus e to the power minus 1. Here you will put, here also you will put. So this would become 2 e to the power minus 1. So this is the answer you are getting. 1 minus 2 e to the power minus 1 divided by 1 minus e to the power minus 2. This is the final answer that we are getting. Is that clear to you? Okay. The important part was understanding till this particular point. Once you have understood this particular point, then whatever that we have done in the last lecture, the same process we are following here, the surface integration. But are you able to relate your one dimensional random variable with two dimensional random variable? In one dimensional random variable as well, we were doing the same thing. Whatever that we are doing in the two dimensional random variable, the same thing we were doing in one dimensional random variable as well. Again, there we used to make the graph, but fx of x, the graph was not matter of concern. Only matter of concern was the expression. And the second matter of concern was how the value of x is going. So x is going from 0 to infinity, I would take the expression and then dot dx. Similarly here as well, x is going from 0 to 1, sorry, x is going from 0 to 2 and y is going from 0 to infinity. I will take the expression, I will integrate the complete surface and I will equate it to 1. So if I equate it to 1, I am getting the value of b. Very easily I am getting the value of b, right? Then next what I need to do? Next, x plus y less than 1 they are asking me to calculate. So here as well, in this particular scenario as well, x less than 1, how would I calculate? I will take the limit of x from minus infinity to 1 and then I will take my PDF and I will integrate it. So here as well, I will take my PDF, I will integrate it, but now what is the limit? X plus y less than 1. That means now this is a surface. So I need to do the surface integration. That's it. I did the surface integration. I got the answer. Might be some calculation error. I don't think there is any calculation error. Just to check it. Just check it once. I don't think there is some any calculation error, but the concept is clear to you, right? The concept is crystal clear. This is considered as one of the most complex topic of a random variable, which we are understanding in a very good manner. Why it is complex? Because people don't relate it with one dimension random variable. They directly study two dimension random variable, forgetting about one dimension random variable. So actually, one dimension random variable and two dimension random variable both are the same thing only. There is no difference. In one dimension random variable, you just need to do one integration, but here you need to do the surface integration. That's it. This is the only difference. If I introduce three dimension random variable, then what I will have to do? I will have to take a volume integration, right? If I am introducing three dimension random variable, let's just say I define random variable x as well, y as well and z as well, and with respect to that I define joint PDF, joint PDF, that is this. So now I will have to make four axes actually, x, y and z, and with respect to that I will have to make fx, y, z as well. Although three dimension random variable, till this point they never asked the question on three dimension random variable. Okay, only they asked question on one dimension random variable and two dimension random variable, because three dimension random variable will be very tough. So they don't ask question on that, right? But are you able to understand whether it is one dimension, two dimension, three dimension or n dimension random variable? Analysis is same. You take your PDF, you integrate it. In one dimensional, it will be simple integration. In two dimension, it will become surface integration. In three dimension, it will become volume integration. Are you able to understand this point? Are you able to relate the things now? So in communication, where we mug up the things, now instead of mugging it up, we are actually understanding the concept, right? Now, what do you think? What will be the answer of this one? X plus y equals to 1. What do you think? 0. Because what you are doing? You are doing the surface integration. Surface integration of a particular line, what that would be? That would be 0 only, no? If I ask you how much area this line is enclosing, 0 area. Line doesn't have any area. 1 line, 2 line, 3 line, 4 line. Yeah, this is having any area. But what will be the area of this line? 0 only, no? And just think about it. Probability of x equals to 1. In case of continuous, what is this? Continuous random variable. In case of continuous random variable, when there was only one dimension random variable, what was the probability of x equals to 1? 0. So in case of two dimension random variable, what will be the probability of x plus y equals to 1? That would be equals to 0. So here you need some region. What you need? You need some area. You need some area like this, so that you can calculate the line integration. Sorry, not line integration, so that you can calculate the surface integration. You need some area here. But in x plus y equals to 1, you will not get any area. That means answer will be simply equals to 0. And just think about it, no? What they are saying, x plus y equals to 1. That means x is taking a certain value and y is taking a certain value. If I say x is equals to, let's just say 1, because x can take value from 0 to 2. So what will be y? Y will also be certain, that would be equals to 1. But in this condition, x plus y less than 1. X plus y less than 1. If I say that my x is 0.5, so y could be 0.1, y could be 0.2, y could be 0.3, y could be 0.2222. So y has a lot of chances. That means y will have some range. X will also have some range. But here both of the values are fixed. If x value is fixed, then y value is also fixed. That means you are talking about probability at a point. And probability at a point will always be 0 in case of continuous random variable. So this is nothing but a probability at a point only, right? So this will be 0. Is that clear to you? Conceptually as well it is clear. This is a simple line, it should be 0. It is a simple point, it should be 0. So conceptually and mathematically, in both of the cases, you know that this region will not be there. This region R will be simply a line. So instead of surface, this is simply a line. If this is simply a line, that means this particular surface integration will throw the value 0 only. Clear? Let's go to the next question now. Okay. Joint CDF of a random variable x and y is given. You need to find these answers. The answer I have given, that is 0.1. For which particular question the answer is given? I guess for this particular question I have given the answer. So what you need to find? You need to find probability of random variable x taking value from 2 to 3, and joint CDF is given. What they have given? Joint CDF. What you need to find? First one. This is question A, this is question B. So question A. That means you need to find fx of 3 minus fx of 2. This is what you need to find. That means what do you need? I need fx of x. What do I need? I need fx of x. This is my requirement now. To solve this particular question, what do I need? Fx of x. That means what is given? Joint CDF is given. What I need? Marginal CDF. Can I find it? Surely I can find it. How will I find it? Fx of x is equals to fxy x comma infinity. So in place of y, what I need to put? Infinity. What I can do is that fxy, in place of x you put x only, but in place of y what do you put? Infinity. So you will get your fx of x. So in this particular expression, in place of y if I put infinity, here, yeah, now someone will say that, sir, here y greater than equals to 0, here y less than equals to 0. So y equals to infinity should be put here, no? Sir, you are saying that I need to put y equals to infinity. So y equals to infinity will lie in this range. Here they did not even talk about y. So if they are not talking about y, then by default you need to consider that this will work for y going from minus infinity to infinity. Are you able to understand this point? If y is not mentioned here, so by default you need to take that it will be going from y equals to minus infinity to plus infinity. That means here as well you will put y equals to infinity, here as well you will put y equals to infinity. So if you put y equals to infinity here, what will happen? This will become 0. So 5x divided by 4x plus 1. 5x divided by 4x plus 1. And this will be 0 only. When the limit of x goes from, because now I care about only x, limit of x goes from 0 to 4. What I am finding? I am finding fx of x. For finding fx of x, what I need to do? In place of y, I need to put infinity. Here I put infinity. Someone will have a doubt, sir, y equals to infinity should be put here. But if nothing is mentioned, that means by default you need to take that x is going from 0 to 4. If x is going from 0 to 4, then this is the expression. Then if they are not mentioning about y, that means if y goes from minus infinity to infinity, then this would be the expression. But if x is less than 0 and y is less than 0, then this would be the expression. If x is greater than 4 and y is greater than 0, then this would be the expression. Are you able to understand this point? When x is between 0 to 4 and y could be anything, then this would be the expression. When x is less than 0 and y is less than 0, then this would be the expression. When x is greater than equals to 4 and y is greater than equals to 0, then this would be the expression. Is that clear to you? Now here, this 0, basically this CDF is 0 for x less than 0 and y less than 0. So CDF is 0 for x less than 0. That means if you make the graph of fx of x, so it would be 0 for x less than 0. For 0 to 4, it will follow this particular graph. For 0 to 4, it will follow this particular graph. And after 4, it will follow this particular graph. If you put y equals to infinity here, so this will be 0, this will be 0. So it would be 1. So if I try making the graph, of fx of x, So it will go somewhat like this. Before that it will be 0. For x less than 0 it will be always 0. Between 0 to 4 it will follow this curvature, and after 4 it will become 1, which is pretty obvious, right? Because I know that fx of infinity should be 1 and fx of minus infinity should be 0. Now how this curve will go, that I cannot tell. I need to differentiate and all these kind of things I need to do. So at 0 what value it is throwing? It is throwing value 0 only. At 1 what value it is throwing? 5 by 8. At 2 what value it is throwing? 10 by 12. So let's make in this manner. However the graph can go, it can never be decreasing, that I know. So from 0 to 4 this is how it is going. The nature here is, this is your fx of x versus x. So this nature is 5x divided by 4x plus 1, and this nature is 1 and this is 0. So this is your graph of fx of x. But what do you need? You need the probability 2 to 3. Fx of 3 minus fx of 2. So 3 and 2 both will be lying here, right? So if you put 3 here, what you are getting? 15 divided by 16, right? If you put 2 here, what you are getting? 10 divided by 12. So 15 divided by 16 minus 10 divided by 12. I can do the calculation with the calculator. Zero point 0.104. 0.104. So this was the answer. Well and good. Okay. Now second question. Between 2 to 3, 1 to 4. What do you think? I will have to apply the formula here, right? Without the formula, I cannot solve this problem. Because otherwise, it will become very difficult. I will just have to apply the formula. Fxy is given, and which formula I am talking about? The formula that I told you to remember. Which formula I told you to remember? You understood the previous question, no? You understood the previous question for sure, right? What I needed fx of x. How will I get? Putting value of y equals to infinity. So here I put the value of y equals to infinity. Here I put the value y equals to infinity. If I put y equals to infinity, here I am getting 5x divided by 4x plus 1. And here if I put y equals to infinity, I am getting 1. So this kind of expression I am getting. This is my fx of x. Okay. Now this is something that I require. So for this, what I will do? I will apply the formula only. 3 4 plus 2 1 minus lower limit, higher limit, 2 4 minus 3 1. Now putting these values will be very difficult. Value of x is 3, value of y is 4. X is 3, y is 4. So x is 3, it will lie here, y 4 will lie here. So this particular condition will be coming. So x equals to 3 and y equals to 4. You put a very complex expression will come, no? Right? So let's try putting. So 5 by 4 x equals to 3 and y equals to 4. Right? This is what they are expecting me to write, 3 and 4. 5 by 4, 3 plus 4 to the power 3, 64. 3 plus, this will become 3 plus e to the power minus 64 divided by 3 plus 1, that would be 4, minus e to the power minus y square. So value of y is 4 only. So e to the power minus 16. So this is the answer of, separately let's write down, okay? Let's write down separately. So this was the answer of fxy 3 4, right? Now fxy 2 1. So value of x is 2, value of y is 1. So again you will lie in this region only. Value of x is 2, y is 1. So again you will lie in this region only. So 2 divided by 3, 2 plus 1 is 3, and 9, 27. So 5 by 4, 2 divided by here 1 I am putting, no, 1 e to the power minus 1. Now this will create problem, e to the power minus 1. Here it was 1 only. So e to the power minus 3. E to the power minus 3. This would be e to the power minus 3. So did you understand the point? You can solve the problem now. X equals to 2, y equals to 4. X equals to 2, y equals to 4. Again in this region you will lie. And then x equals to 3, y equals to 1. X equals to 3, y equals to 1. Again you will lie in this region. Right? So always you will lie in this region. You will write down the values, you will get the answer. So you can solve it. There will be long calculation. Although it will not come in the examination, I am just telling that who knows, sometimes you need to use this formula as well. So that's why it is just a revision that you should be remembering this formula. Otherwise the calculation will be long. A calculation will be long enough. You can do the calculation on your own if you want to do. Okay. So long calculation will be there. I should have framed the question in a better manner, such that calculation would be lesser. But now here the calculation is becoming longer. So I don't think I need to calculate it. You can just put the values and you will get the answer. How will you put the values? That is important. The value of x is lying in this region, value of y is lying in this region. What if x was lesser than 1? Sorry, what if x was minus 2 and what if y was minus 2? Then here answer would be 0, right? Probability would have been 0. This particular thing would have been 0. If let's just say here minus 1, minus 3 was written, that means x is less than 0, y is also less than 0. That means you would lie in this region. So that would be 0 only. Okay. But this is what they are not asking. They are asking 3 4 2 1 2 4 3 1. So you will get the answer in this manner. You can solve it. Let's go to the next question. Yeah, let's go to the next question. So before going on to the next question, we need to study conditional PDF. What do you think? What is conditional PDF? Do you remember the conditional probability? Probability of A by B. Probability of getting A such that B has already occurred. That was PA intersection B divided by PB. So this is just the notation. What is the notation? PDF of random variable x such that y has already taken some value, x by y. So don't be afraid of the notation. Okay, don't be afraid of the notation. Just understand what they are saying. A intersection B, no? A intersection B. That means you need to consider x and y together. I need to consider x and y together. That means you need to write down the joint PDF of x and y divided by probability of B, probability of B. That means in downward what will come? Marginal PDF of y. What I am saying, x by y, x divided by y, that would be equals to joint PDF of x, joint PDF of random variable x and y divided by marginal PDF of y. Is that clear to you? Similar thing will go here, y and yx. So y intersection x. What is the meaning of intersection? Comma means intersection only, right? Intersection means comma only. So xy comma divided by PDF of x. Here yx comma would come and then divided by PDF of x. So joint PDF of random variable x and y divided by marginal PDF of random variable x. This would be your y by x, y by x. Is that clear to you? Very simple. PDF of a random variable y such that x has already taken some value. PDF of random variable y such that x has already taken some value. Now from here what you can see, this particular thing could be written as fy by x multiply with fy and fy by x multiply with fx and fx by y multiply with fy. This is how fxy could be written. Is that okay for you? Right? So this is just, you need to compare it with conditional probability. Similar thing is there. X intersection y. Intersection means comma. Divided by y. Divided by y. So that solve the problem, it will become more clear to you. This question they are asking. The joint PDF of x and y is given. Okay. Find the marginal PDF fx of x and fy of y. Are x and y independent? Along with that, you need to find the conditional PDF as well. All these things you need to find. Well and good. So first let's find marginal PDF. Fx of x I need to find. So what was the formula of fx of x? Do you remember? If joint PDF is given, if joint PDF is given, how will you find marginal PDF? How will you find? Sir, joint PDF is given, sir. This particular thing is given. So what I would do, I will put the limit of y. I will put the limit of y. What it will do is that it will kill y completely. In this particular expression, it will kill y completely and only x will be left. Now let me know what will be the limit of y. From minus infinity to infinity. Minus infinity to infinity. But just see the expression. Ux is connected, uy is connected. That means actually your x is going from 0 to infinity. You can add the equal sign as well. And y is also going from 0 to infinity. Are you able to understand this point? Both x and y are going from 0 to infinity. So what you can do, from 0 to infinity, now whatever the expression is there, basically this fxy could be written as this fxy x comma y. This could be written as, this expression is equals to xy e to the power minus x square plus y square divided by 2 when x is greater than 0 and y is greater than or equals to 0. Otherwise it will be 0. So from 0 to infinity, limit of y going from 0 to infinity, what you will do, you will write down this whole expression. Dot dy, and it is going from 0 to infinity, right? So you are integrating with respect to y. So x will become constant for you. X will completely become constant for you, and you just need to integrate with respect to y. So this is the integration you need to perform. Y into e to the power minus y square by 2 dot dy. X is constant now. X is constant because you are putting the limit of y. Here what you are doing, you are putting the limit of y. You are putting the limit of y. Limit of y. So can you differentiate it? Try doing it on your own. You should be able to differentiate it. Y square by 2, what you will put? As t you will put. Y square by 2 will be t. So what it is becoming? Fx of x is coming out to be, just I am copying this expression, 0 to infinity y e to the power minus y square by 2 dot dy. So y square by 2 is equals to t. So from here what you are getting, y dy is equals to 2y will come, y dy would be equals to dt. And if y is equals to 0, then t will also be equals to 0. If y is equals to infinity, then t will also be equals to infinity. So what you are getting, fx of x, x e to the power minus x square by 2, t will go from 0 to infinity, y dy will be dt, and e to the power minus t dot dt. When you integrate it, you will get 1, right? So what is the answer you are getting? Fx of x you are getting as x e to the power minus x square by 2. This is your marginal PDF of x. Marginal PDF of x. Okay. What about fy of y? The same expression you will get. Ditto same expression. You can do it. How will you do it? If I need to get fy of y, I can do the same kind of integration here. If I need fy of y, what I will do? Fxy x comma y dx. X goes from minus infinity to infinity, but you know that x is actually going from 0 to infinity only. What is the expression of fxy? That is xy e to the power minus x square plus y square divided by 2 dx. I need to put the limit of x, right? Why put the limit of x? Because I need the final function in terms of y. I am putting the limit of x. What I will do is that I will take y common. So y e to the power minus y square by 2 will come common, 0 to infinity, y e to the 0 to infinity x e to the power minus x square by 2 dot dx. And when you integrate it, is x square by 2 divided by x square by 2 will be equals to t. Same integration here. What you will get? 1. So fy of y is coming out to be y e to the power minus y square by 2. And one more thing, this is not completely correct. Here I have written this is not completely correct. What did I forget? I forget adding u of x here, no? Because you are solving everything considering x is also greater than 0, no? Here x is also greater than 0. Are you able to understand this point? Here if I had directly written fxy expression, so where will this ux go? Ux will say that x is greater than 0, and here ui will also say that y is also greater than 0. So here also I need to add u of y, and here also I need to add u of x. So now this will be completed, right? So now this is completed. So you are having fy of y as well and fx of x as well. Next, what you need to find? Next you need to add a page first. Let's add a page. So next what they are saying, you need to find marginal PDF. No, sorry, not marginal PDF, conditional PDF you need to find. So this is what you need to find. F x divided by y, x divided by y. So what you will do, on the upper side x intersection y would come. That means x comma y should come, divided by fy of y should come. Fy of y should come, right? What is this? This is given here, xy e to the power minus x square by 2 e to the power minus y square by 2 ux uy. Can I write it down in this manner? Surely I can write down in this manner. Divided by, what is my fy of y is coming out to be? Fy of y is coming out to be y e to the power minus y square by 2 uy. So e to the power minus y square by 2 will cancel out, y will cancel out, ui will cancel out. So what it is coming out to be? X e to the power minus x square by 2 ux. This is your fxy divided by and it is actually coming out to be equals to fx of x. Similar thing will happen with, similarly you can calculate your fy divided by x, y divided by x, y divided by x. So that will actually come out to be e to the power minus y square by 2 uy. You can calculate it on your own. That will come out to be fy of y. Okay. Now in the second question, what they are asking? In the second question, they are asking that x and y are independent. X and y are independent. So what you will do? If x and y are independent, then this should be equals to this. So what is this? This particular thing is xy e to the power minus x square by 2 e to the power minus y square by 2 ux uy, right? What is fx of x? Fx of x is x e to the power minus x square by 2 ux. And what is fy of y? Y e to the power minus y square by 2 uy. Is this equals to this thing? Yes. That means x and y are independent. Or what you can see, let's go back here. If a and b are independent, if a and b are independent, then what you used to do? Probability of a by b would be equals to probability of a, and probability of b by a would be equals to probability of b. So similarly here, if x and y are independent. That means PDF of random variable x, PDF of random variable x such that y has taken already some value would be not depending on y. That means it would be equals to PDF of x only. And PDF of random variable y such that x has already taken some value will not be depending on PDF of x. It will only be depending on PDF of y. Is that clear to you? So fy by x should be equals to fy. So are we getting the same thing here? Fy by x is equals to fy. Fx by y is equals to fx. So here only I could have said that x and y are independent. So just we are interrelating everything with probability. Everything is interrelated with mathematics only. So needlessly you find this particular topic difficult. Okay, people will find this particular topic very, very difficult. You can ask anyone who is studying from any other resource. They will say that okay, 2-dimensional random variable, that means this is something different. 2-dimensional random variable is not different. It is 1-dimensional random variable only. Any dimension random variable is equals to 1-dimensional random variable only. You just need to have some patience and you need to solve the problem. You will be able to solve. Now people will just get confused. This expression, that expression, marginal PDF, conditional PDF, this PDF, that PDF. Nothing is there. Just relate everything with the probability and keep on solving the problems with respect to good amount of patience and you will be able to understand everything. So x and y are independent. Here only you can tell. Right? You would not have to do this analysis, or you could have done this analysis as well, that fx of x, fy of y, if I am getting this particular thing, then if I multiply both of them, I am getting fxy only. So they are independent. Let's go to the next question. Joint PDF is given. Value of x is going from 0 to 1. Value of y is going from 0 to x. Value of y is going from 0 to x. And otherwise it is 0. You need to find the value of k and then you need to find the conditional probability such that y is less than 1 by 8 divided by x is less than 1 by 2. So x is taking value lesser than 1 by 2, then find the probability such that y takes value lesser than 1 by 8. So try this question on your own. Use your full brain and try this question on your own. I will pause the video, I will have some break and then I will come back and we will solve this question. This question we will solve, then we will go to this particular question, then this particular question, third question, then just we will see the concept of joint PMF which we have already seen, and then we will solve this particular question, and with that we will be able to end this lecture. And again one more question we will solve, which is this. Okay, well and good. So yeah, let's try the problems on your own. First you try solving this particular question on your own. I will pause the video and then I will come back. Yeah, welcome back. So did you try this question? So when I see this question in the examination hall, what I would see that this is the question based on 2-dimensional random variable. That means I will have to make the surface. So let's try making the surface. Did you try making the surface? I guess if you are able to make the surface, then your job is done and it should not be that difficult. X is going from 0 to 1, right? Let's try making the surface now. So talking about x, x is between 0 to 1. So everything will be there between these 2 points, 0 to 1. Secondly, what they are talking about y. Y is surely greater than 0. That means this lower part is gone, right? What they are saying, y is greater than 0. So this is your y, greater than 0. So only this is my matter of concern now. Now another thing is, y is greater than 0 but y is less than x. So another equation that is given is y is less than x. So for what I will do, first I will draw the graph of y equals to x. So what is the graph of y equals to x? Graph of y equals to x will be like this. I can make like this as well. Basically I can make the graph completely like this, but I will not make like this. Why is that so? Because as of now I know that this is the part which is my matter of concern. So I will make my y equals to x graph only in this particular region. This I have made. Now what is the scenario? Y equals to x. So what will be this point? This point will be 1, 1, right? Because this particular graph is y equals to x. So if x is equals to 1, then y will also be equals to 1. This will be 0, 0. Now what is the scenario? What they are saying? Y should be less than x. That means x is greater than y. X should be greater than y. So region will be this region or this particular region? What do you think? So we can put any point in this region. Let's just say, let's put this point. What will be this point? This point would be x equals to 0, y equals to 1. So if I put x equals to 0 and y equals to 1, is this equation satisfied? No. 0 is not greater than 1. That means this particular region will not come. So which region will come? This region will come. Because x is greater than y, no? So here you can see that x will keep on increasing, but y will be in this range only. Basically, you can put any point. Let's try putting this point. Here, what is the value of x? 1 by 2. What is the value of y? 0. Right? So if I put x equals to 1 by 2 and y equals to 0, yes, this equation is satisfied. That means this particular region will come into action. So now what will be your region of operation? What will be our matter of concern? So this particular region will be my matter of concern. There you go. I hope you would have done this particular analysis on your own. At least you should be comfortable with this analysis, right? So now our matter of concern is this region. This is our region R. This is our region R. What we need to do? We need to find the value of K. So what I will do? I will calculate the surface integration in this region R. In this region R, what I would do is that I will calculate the surface integration. Now what is the value of my fxy? That is kxy dot dx dy. How will the limit go? So talking about the limit, again I need to take the strip. Taking the strip, what I will see is that the limit of x is going from 0 to 1. Limit of x is going from 0 to 1. Because if you move the strip, x will go from 0 to 1 and y is going from y equals to 0 to, what is this? Y equals to x. So y is going from y equals to 0 to y equals to x. Very simple, very straightforward, right? So very easily you make the graph and your job will be done. So the only part is, the major part here is to making the region of operation, where what is the matter of concern for you. Just make that region and your job will be done. So k is a constant that will come out. Let this x be as it is, x dot dx, x will go from 0 to 1, and here if I integrate y, what I will get? Y square by 2, and it will go from 0 to 2, right? If I integrate y, what I will get? This was kxy, no? This was kxy. So if I integrate y, what I am getting? Y square by 2, and then I put the limit of x here, what I will be getting? K 0 to 1. If I put x here, what I will be getting? X cube by 2 dot dx. So what I will be getting? K x to the power 4 divided by 8 going from 0 to 1, and this will be equivalent to 1, right? This particular thing will be equivalent to 1. So now I am putting this particular thing, whatever the answer that I am getting, equals to 1. So answer of k is coming out to be 8. So k came out to be 8. Very simple, very straightforward. K is your 8. So basically your fxy now is 8xy, right? Now what you need to find? You need to find the conditional probability of probability. What you need to find in the second one? Probability of y less than 1 by 8 divided by such that x is less than 1 by 2. That means probability of y less than 8 and x less than 1 by 2 divided by probability of x less than 1 by 2. This is what you need to calculate. So for this particular thing, what will be useful? Conditional, this joint PDF will be useful for this particular thing. Joint PDF will be useful, but here you will require marginal PDF. If I need to find the probability of x taking value lesser than 1 by 2, that means I will surely require the marginal PDF. But here your job will be done through joint PDF, because here you are talking about y as well, you are talking about x as well. So how will you calculate that? We will see. So here my job will be done by joint PDF, but here I will require marginal PDF as well. So let's first make our region of operation. This was our region of operation. So let's make the diagram again. Let's make the diagram here again. So our region of operation was this much. x is going from 0 to 1, and this equation is y equals to x. So this point is 1 1. This line is y equals to x, and this was our matter of concern. Now what they are saying, what you need to find, you need to find the probability such that y is less than 1 by 8 and x is less than 1 by 2. Y is less than 1 by 8 and x is less than 1 by 2. So where will be your y equals to 1 by 8? Y equals to 1 by 8, where it will be? Let's remove this as of now. This is my x axis, this is my y axis. So y equals to 1 by 8 would be somewhere here. This is your line of y equals to 1 by 8. So what they are saying, y less than 1 by 8, that means this will be the matter of concern now, and x less than 1 by 2. So where will be your x less than 1 by 2? X less than 1 by 2 would be somewhere here. Let's just say this is your 1 by 2, this is your 1 by 2, although it will be right in the middle, so let's call this as 1 by 2. So x is equals to 1 by 2. So what they are saying, y should be less than 1 by 8, that means this particular region, and x should be less than 1 by 2, that means this particular region. And in these region, which will be the matter of concern? Only this much part will be the matter of concern. Are you able to understand this point? Now this much part will be our matter of concern. Did you understand this point or not? Look, this thing came later on. First what was given? First this was given that x is going from 0 to 1 and y is going from 0 to x. So from there what we got to know, that this is our matter of concern. This much is our matter of concern. This triangle is our matter of concern. This is our region of operation. Then another condition was y should be less than 1 by 8. That means you are coming downward, and x should be less than 1 by 2. That means this much region is now now our matter of concern. So whatever the probability you are getting in this region, let's call this region as r dash. So this would be equals to, in the region r dash, you will take your joint PDF and you will integrate it. You will integrate your joint PDF in this particular region. And how will you integrate? How will you integrate? Here again you need to choose the strip. But how I should choose the strip? If I choose the vertical strip, what will happen? Look here, smartly I need to choose the strip. Let me show you one thing. You got to know what is our region of operation. So this is our region of operation, but here I need to choose the strip. So this is our region of operation that you have understood. So if I choose the strip in this manner, if I choose a vertical strip, let's just say if I choose vertical strip. So this vertical strip I have chosen, right? So when I move the strip, limit of x will go from 0 to 1 by 2, no doubt about that. But how the limit of y will go? So till this point what will happen? Limit of y will go from 0 to x, right? Because this line is y equals to x. What is this line? This line is y equals to x. So when this strip is moving, so till this point, till this particular point, the limit of y will go from 0 to x. But just as the strip becomes here, just as the strip comes here, the limit of y will go from 0 to 1 by 8. So you will have to break two limits if you are taking the vertical strip. If you take the vertical strip, you get to know that till this particular point, till this point, y is going from 0 to x. Y is going from 0 to x. But after that, what is happening is that y is going from 0 to 1 by 8. So this is our issue. So what I will do is that this time I will try taking the horizontal strip. If I take horizontal strip, what will happen? Let's try taking the horizontal strip. If I take the horizontal strip, so in horizontal strip, what do you see? Limit of x will go from, limit of x, here x is equals to y and here x is equals to 1 by 2. So limit of x will go from y to 1 by 2, and you move the strip upward. Always, even if the strip is here or the strip is here, always what is happening? X is going from y to 1 by 2. And what about the limit of y? If you move this strip upward, so y is going from 0 to 1 by 8. Are you able to understand this point? If you have studied the surface integration, then you will be able to understand. I have taken the vertical strip this time. So vertical strip, limit of x is going from y to 1 by 2. Limit of x is going from y to 1 by 2. And limit of y is going from, if you move the strip upward, and downward, what do you see? Limit of y is going from 0 to 1 by 8. Say yes or no. So this is how I can do it. Limit of y goes from, constant limit always we will put here. Limit of y goes from 0 to 1 by 8. But limit of x goes from y to 1 by 2. Right? Well and good. And now someone will be saying, sir, why I cannot write 1 by 2 to y? Why I cannot write 1 by 2 to y? So you should have watched the video of integral calculus. There I told you limit will always go from lower limit to higher limit. And here I know that condition is x greater than y. X greater than y. So here what you are saying, x is going from y to 1 by 2. X is going from y to 1 by 2. So basically this will be the lower limit only, no? Here value of x will be lower and here value of x will be larger. Forget about this particular thing. In this strip if you are moving, so here the value of x is low. That would be somewhat this point that I don't know. And here the value of x will be 1 by 2. So always you will go from lower limit to higher limit. Y to 1 by 2. Right? And in the upward side, y is going from 0 to 1 by 8. How it is going 1 by 8? You understand, right? So you just need to understand that our region of operation is this much this time. This, and this. This is our region of operation. Okay, this is our region of operation. This particular diagram that I have made. This, and this. This is our region of operation. So in the strip, limit of x goes from y to 1 by 2 and limit of y goes from 0 to 1 by 8. Okay. So here fxy is given as kxy. What is the value of k is coming out to be 8, right? So 8xy dx dy. So you are first integrating with respect to x this time. So limit of y remains as it is. Then if you integrate with respect to x square by 2, y to 1 by 2. Right? So what this will become? Four y 1 by 4 minus y square by 2 dot dy. Oh, dy was already there. Just I am integrating nothing else. 8y I took as constant. X square by 2. Limit is going from y to 1 by 2. So here if I put 1 by 2, I will get 1 by 4 minus y square. 1 by 4 minus y square. Y square by 2 I am writing. 1 by 2 minus y square I will get. If I put 1 by 2 here, so 1 by 4 minus y square, 2 I have cancelled out. So this will become y. This will become 4y. So here I will get this particular thing, right? And when I put it inside, so y minus 4y cube. This will be y minus 4y cube. So simply it is coming out to be y minus 4y cube dot dy. Right? 4y 1 by 4 and y square 4y cube. Yeah. So what you are getting now? Y square by 2 minus y to the power 4 divided by 4. So 4 will get cancelled. 0 to 1 by 8. So what you are getting? 1 by, I will just solve it using the calculator, okay? Whatever the answer I get, 1 by 8 to the square divided by 2. 1 by 128. 1 minus 1 by 8 to the power 4. This is what I am getting. 1 by 8 square divided by 2, 128. 1 by 8 to the power 20. So let me solve it using the calculator. Yeah. So after the calculation, this answer would come 31 by 4096. Okay. So this job is done. Which job is done? That we have find out y less than 1 by 8 intersection x less than 1 by 2. So this is coming out to be 31 divided by 4096. Now next we need to find probability of x taking value lesser than 1 by 2. So for this, what do you require? Just let me know what will be the answer of this. That means here what you will require, fx of x dot dx, x taking value lesser than 1 by 2. X is taking value from 0 to 1. That means now it will take value from 0 to 1 by 2. So what you would require? Fx of x you require. So what do you need? Fx of x. So first I need to find fx of x. How will I find fx of x? Very easily I can find fx of x. What I will do? Right? And now I need to put the limit of y. What I need to do? I need to put the limit of y. So how the limit of y is going? Limit of y is actually going from 0 to y equals to x. What I mean to say is that, again, if you see the region of operation, what I need to find, now I am finding the marginal PDF of x. What I am finding? Marginal PDF of x. What is my region of operation? Region of operation is this much. That I have already seen. This is my region of operation. From 0 to 1, 1 comma 1. Right? Now what I am doing? I am integrating with respect to y. That means I need to see the limit of y, no? So from where to where limit of y is going? So limit of y is not constant. Can you say that, sir, limit of y is going from 0 to 1? No. Limit of y is going from 0 to x. Limit of y is going from 0 to x. Basically, limit of y is going from 0 to x. Like in y direction, you are not going from 0 to 1. Always you are not going from 0 to 1. If you start from here, 0 to x, 0 to x, 0 to x, 0 to x. That's it. So limit of y is from 0 to x. Right? So limit of y is from 0 to x. So what is your fxy? That is 8xy, right? The value of ki came out to be 8. So 8xy dy. 8xy dy. Limit of y is from 0 to x. So 8x y square by 2, 0 to x. So 4x cube you are getting. So this is your fx of x, right? X square, x cube, 4x cube. Now what I need to find? I need to find probability of x taking value lesser than 1 by 2. This is what I need to find. So 0 to 1 by 2, 0 to 1 by 2, 4x cube dot dx. So that would become x to the power 4 divided by 4, that will be cancelled out, 0 to 1 by 2. So it would be 1 by 16. So this answer is coming out to be, for this particular thing, answer is coming out to be 1 by 16. So what will be the answer? So simply the answer would be 31 by 4096, 31 by 4096 divided by 1 by 16. So again let me pause the video and again let me do the calculation. Yeah, so the answer is coming out to be 0.121. Okay. So very easy question it was. If you see, like, people would find it tough, but if your concept is clear, you know how to make the diagram, everything is crystal clear to you, right? So we started from here. We need to find, you need to find the value of k. That is very easy. You will be able to find the value of k. You just need to work on the given region and you need to find the surface integration. You found out the surface integration, that would be equivalent to 1. So value of k is coming out to be 8. Now in the second question, you need to find the conditional probability such that y should be less than 1 by 8 and x should be less than 1 by 2. Here, in place of intersection, what I can do? I can put the comma as well. So x should be less than 1 by 2. So our region of operation was already this much. In that region of operation, x should be less than 1 by 2 and y should be less than 1 by 8. So now this is our region of operation. So you could have taken the vertical strip as well, you could have taken the horizontal strip as well. In vertical strip, I will have to break the integration in two parts. That's why I took the horizontal strip. In the horizontal strip, what I am getting? That value of x is going from y to 1 by 2 and value of y is going from 0 to 1 by 8. So that I put here, I got the answer for this particular thing, and then I needed to find the probability of x taking value lesser than 1 by 2. That means I would require here marginal PDF of x, fx of x I would require, and then from there I can get the value of x lesser than 1 by 2, and x is already starting from 0, so 0 to 1 by 2. So I need to find the marginal PDF of x. So for that, what I would do, fxy dot dy. Now I need to put the limit of y. So y is not going from 0 to 1, y is going from 0 to x, y is going from 0 to x, and directly, clearly you can see from here y is going from 0 to x. So that I put here 8xy dot dy. So 8x y square by 2, 4x cube I got, and then I calculated the final answer, and then I divided them. There you go. Very simple. Yeah, sorry for the interruption, guys. I got a work in between. So we have solved this question. Now we need to solve this particular question. fxy is given. The limit of x is given. The limit of y is given. You need to find the probability of y taking value between 0 to 2. So this is something that I need to find. Probability of y taking value between 0 to 2. So from here I got to know that I would need the marginal PDF of y, right? I would need the marginal PDF of y. If I have the marginal PDF of y, then my job will be done. But for finding the marginal PDF of y, you need to take reference of this one. And when you take the reference of this particular thing, your answer will come in terms of c, no? So you need to kill this c. Basically, you need to find the value of this c. Are you able to understand this point? This c is a constant, no? Like in the previous questions, we were finding the value of this constant, right? K. We found the value of this constant. The value of k came out to be 8. That's why our answer came at some value, as some numerical value. If you want the answer in some numerical value, that means it should not be coming in terms of c. So first you need to find the value of c, then you will solve the problem. So if they are asking this particular question in the examination, then most probably they will give the value of c. Basically here they will write down some constant value, okay, most probably. But here we are learning this particular topic, so that's why we will solve the problem on our own. We will find the value of c. So for finding the value of c, what you will do? You know one particular thing. What do you know? That in my region R, like x is going from some particular value to particular value, and y is going from some particular value to some particular value. So in this region R, if I calculate the surface integration in this region R, if I calculate the surface integration, that will be equals to 1, and using this particular identity I can find the value of c, right? So what I will do now, I will find the region R, which is very important. So what is given? X is going from 0 to 2. So let's talk about x first. So x is going from 0 to 2. So one thing you understood, that everything will be between 0 to 2 only. So in this region everything would come. Till this point you got these 2 points, right? Now this time what they are saying, that y is less than x and y is greater than minus x. So basically again you need to draw 2 lines, y equals to x and y equals to minus x. So you need to draw y equals to x and y equals to minus x, because 2 inequalities are there, y greater than x and y less than x and y greater than minus x. So this line is y equals to x and this line is y equals to minus x. So first inequality will say that y should be less than x, that means x should be greater. So just think about any point. If this point is 2, so what this point will be? 2 comma 2, because y is equals to x, and what this point will be? 2 comma 2. Now take any point. Let's just say I take this point. This point will be x value is 1, y value is 0. So if I put this point here, y value is 0, x value is 1. In this inequality I am putting y value 0, x value 1, that means it is satisfied. So this will be the region of operation. So what will be the graph of y less than x? This is the graph of y equals to x. The graph of y less than x will be this much, right? This much, the downward region. What about this particular thing, that y greater than minus x? So either the region will be this one or region will be this one. Basically either the region will be this one or the region will be this one. So what will be the region? So y should be greater than minus x. So let's take any point. Let's take up any point. Let's take the point here. Let's take the point. Let's take this point only, 1 comma 0. So if I put y equals to 0, then there is a minus sign, and x equals to 1. So 0 is greater than minus 1. Yes, that means this particular region is satisfied. So this inequality is saying that the region is downward, and this inequality is saying that the region is upward. So what will be the region? This common region will be there. Are you able to understand this point? So now this is our matter of concern. This particular region is our matter of concern. Did you understand how did I calculate the region? This should be done by you on your own. At least this much calculation you should be comfortable. You should be doing this much calculation on your own. So this is our region of operation. Okay, like some very good level of problems we are solving here. Okay, very good level. What we need to do in this region, we need to integrate and we need to find the value of c. So what I will do, I will choose the strip. I can see that value of y will be going from minus x to plus x, right? Value of y will be going from minus x to plus x, but value of x will be going from 0 to 2. So value of x will be going from 0 to 2. Value of y will be going from minus x to plus x. Cx x minus y dx dy, that would be equals to 1. Now this integration you should be able to solve. So this time there is a minus sign in between, so you have to break the integration. No, basically if you solve this particular thing, what you will get? If you solve this one, what you will get? Cx square minus cxy. So cx square dx dy, cxy dx dy. So how will you break it? X is going from 0 to 2, y is going from minus x to plus x, right? So cx square dx dy minus x is going from 0 to 2, y is going from minus x to plus x, cxy dx dy. So first I will solve the integration of y, then I will solve the integration of x. So if I solve the integration of y here, what I will be getting? Cx square dx will come outward. Integration of dy will be y, then plus x minus x will become 2x. So now I will do the calculation in a quicker manner, okay? Because you can do this calculation on your own. So this is coming out to be 2x cube actually, dot dx. Integration going from 0 to 2. How did I do it? Dy, this will be constant. Integration of dy will be what? Y only. Limit going from plus x to limit going from minus x to plus x. That means 2x would come. So 2x will be multiplied with cx square. That would be 2cx cube. Well and good. Now if you integrate it, what you will be getting? 2c x to the power 4 divided by 4 going from 0 to 2. This is what you will be getting. So integration I have done only in one step. What about this one? So here what you will do is that cx dx, that will be common, and y square by 2, and limit of y you will be putting from minus x to plus x, and x will be going from 0 to 2 dot dx. So if you put plus x here, x square will become, if you put minus x here, again it will be x square only. So this integration will throw 0. So this particular thing is equals to 1. So what you are getting? 1 by 2, 8c, c is coming out to be 1 by 8. So when you solve this integration, c is coming out to be 1 by 8. All these should be done on your own, right? Because this is not the tougher task. This is the simpler one. C is coming out to be 1 by 8. Now what we need to do? We need to find fy of y. Say yes or no. C is 1 by 8. So basically my fxy is done. Now this was my first task. My fxy is done, which is 1 by 8 into x minus y. Now next is I actually need to calculate this particular thing, and here I would require fy of y. So how do I calculate fy of y? So I know that fxy x comma y dot dx, and now I need to put the limit of x. So will I put the limit of x from 0 to 2? What I am saying is that here I need to put the limit of x, right? If I need to find marginal PDF of y. So you can see that x is going from 0 to 2. So you should put x from 0 to 2. Is that so? Wrong. No. You cannot do it. X is going from 0 to 2. No. Like this you cannot do it. No. This is your region of operation. So how will you define the limit of x? First make the region of operation. First make the region of operation. Let's do it on the next page. So first I will make the region of operation. What was my region of operation? So this was my region of operation. In this region I was working, right? In this particular region I am working. Here I know that this point will be 2 comma 2. This point will be, actually this point will be minus 2 comma minus 2, right? Sorry, plus 2 comma minus 2. plus 2 comma minus 2, 2 comma 2 plus 2 comma minus 2, 0 comma 0. This is your x, this is your y. Very, very important point of this question, because everyone would have done the same thing, that sir, x is going from 0 to 2, just put it. No, actually you need to take the limit of x. So in this particular region, how the limit of x is going? So I will choose the strip, no, if I need to take the limit of x. In this particular region, how the limit of x is going? So how will you define it? You need to choose the strip. So if I choose, let's just say if I choose this strip. So what was the equation of this line? Y equals to x. And what was the equation of this line? Y equals to minus x. So here I will say that, sir, my limit, my strip will go from, my limit of x will go from, limit of x will go from y to, limit of x is going from, because here x equals to y and here x is equals to 2. On this line x is equals to 2. So limit of x is going from y to 2. But this strip will always work. If your limit of x is going from y to 2, then move this strip. If you move this strip upward, what will happen? Y will go from 0 to 2 only, because let's just say if this strip come downwards, what I am saying is that if this particular strip is coming downward, then what will happen? Just as it reaches here, x will change its limit, no? X will change its limit, because this particular equation is y equals to minus x, or you can say x equals to minus y. So now your x will be going from minus y to x equals to 2. So here this particular strip will say that x is going from minus y to 2. Here this strip is saying that x is going from y to 2. So when you move this strip upward and downward, so from here to here the strip is saying something different, and from here to here the strip is saying something different. Is that clear to you or not? So this is how you will take the limit of x. It's not that sir x is going from 0 to 2. Doesn't make any sense. You need to see in the region, in this particular region of operation. You are working in this particular region, so you will take the strip. X is going from y to 2 and here x is going from minus y to 2. How the y is going? In this particular region, y is going from, in this particular region, y is going from 0 to 2, right? If you move the strip upward, so y is going from 0 to 2. Here y is going from 0 to 2, right? And what about the, this is the region 1, this is the second strip, where x is going from minus y to 2 and y will go from minus 2 to 0, because I always told you from lower to higher we need to go. So y will go from minus 2 to 0. Is that clear to you or not? So if I need to find my fy of y, then I will find it for two different regions. In one condition I will put that if my limit is from y 0 to 2, if my y is going from 0 to 2, then what will be my fy of y? So there what I will do is that fxy xy dx dy, sorry, not dx dy, dot dx, and x will go from y to 2. Is that clear to you or not? When your y is between 0 to 2, when your y is between, basically you let me know in this particular region what is the range of y. Y can take the value between minus 2 to plus 2. Say yes or no. Just as you made the diagram, you got to know that y can take the value between minus 2 to plus 2. So if you write down your fy of y, so what will happen? Here some expression will come, here some expression will come, and if your y is greater than 2 or less than minus 2, then fy of y will be 0, because you know that fy can take value between minus 2 to 2 only. Then you got to know that if y is taking value between 0 to 2, when y is taking value between 0 to 2, then limit of x is something different. Limit of x is from y to 2, and when your y is taking value from minus 2 to 0, then your limit of x is something different. What is your limit of x? Then your limit of x is minus 2 to, sorry, then your limit of x is from minus y to plus 2. A very good point we are seeing here, okay? Very, very good point. And believe me guys, 99.9999% student will fail here if this question is coming in the examination. A very, very good question. So blindly just looking at the question, you will never solve the problem of two-dimensional random variable. Always you will make the region of operation. Once the region of operation is made, what you need to find? You need to find the marginal PDF of y. So if I need to find the marginal PDF of y, first thing I will see that from where to where my y is going. In this particular region, from where to where my y is going from -2 to +2. Now in this region, how my x is going? So in this region from -2 to +2, how your x is going? So for that you have to choose the horizontal strip. So you will say that, sir, in this particular region x is going from y to 2, and in this particular region x is going from -y to 2. So that means I need to break it into two parts, 0 to 2 and -2 to 0. Okay. So this calculation I have to do now. Is that clear to you or not? So I will get the answer of Fy of y here, and then what I will do? After that, I will calculate this particular thing. But just think about it, what we need to find? Probability of taking y taking value between 0 to 2. So do you really think that you need to solve this particular part? What I am saying, do you think that you need to solve this particular part? Because what is required? You need to find the probability of y taking value between 0 to 2. This is what you need to find. Say yes or no. Random variable y taking value between 0 to 2. So you will require the marginal PDF, but you will require the marginal PDF only in the range of 0 to 2 only, no? If the question was find the probability of y taking value between -1 to 2, then you would say that, sir, from 0 to 2 this PDF will come. Then you will say that, sir, from 0 to 2 this PDF will come, and from -1 to 0 this PDF will come. So then you would find both of the PDF. But as of now, my matter of concern will be only this PDF, no? So why would I care about finding this particular PDF? Basically, here what I will write down is that if your y is between -2 to 0, then some answer would come. And if your y is between 0 to 2, then some answer would come. Now when I find this probability, what I will do? I will integrate from 0 to 2 Fy of y. Then I will go here. What I will see from 0 to 2, what is the value of Fy of y? This is the value. So I will put this value here, and then I will do the integration, and I will get my final answer. That means what will be my matter of concern? Only this will be my matter of concern, no? So if you want to get this particular value, that means you need to solve this integration only. There you go. So needlessly, I will not solve this particular integration. Okay, only I will solve this integration. So I will add a page. I will tell you a shorter method as well, that how you can solve it in quicker manner. Like this is a longer method. Here you need to find Fy of y, but there will be a shorter method as well. Okay, you try thinking what could be the shorter method, but as of now, let's go by the longer method only. Limit of x is going from, because in the examination, at first glance, this method will click, right? At the first glance, this method only will click. What is the value of fxy? This is a very good question actually. Who made this question? AI. Okay. What I do is that I frame some question roughly, and then I put it in ChatGPT, and then I ask them that please modify the question in a very good manner. You can just frame a question and then put in the ChatGPT, and you tell it that you make it on the tougher side. You make this question on the tougher side and conceptual. Then they can reframe the question. So this is what I do. Okay, I use ChatGPT a lot nowadays for teaching purpose. Okay, never use AI for your personal things, right? Let's just say you broke up with someone, or you got into a fight with someone, then you are feeling down and you share your feelings with AI. This is what nowadays people would do, right? But never ever do it. You never know how they can use the information against you. Okay, so for studying, for professional work, always you can use AI, but for personal work, never ever use it. Okay, I have seen some memes as well on Instagram that like some guy is using AI for talking to some girl. Okay, this kind of meme I saw. So then I realized that okay, people would do it. People would be doing these kind of things. But yeah, it is not. It is risky actually. Okay. Yeah. So x square minus xy dot dx. So x is going from y to 2, right? So 1 by 8 is outward. X cube by 3 minus x square y by 2. from complex expression we will be getting basically. Okay, this will be a complex expression. So let's write it down. Here 2 would come, so 1 minus 2y minus y cube by 3 plus y cube by 2. Is that so? Okay, let's check back again. X into x minus y x square x cube by 3 minus x square by 2y. X is going from y to 2. Then I put 2 here. Wait a minute, yaar. If I put here 8 by 3 would come, no? 8 by 3, what I am doing? This would be 8 by 3, right? 8 by 3 minus, if I put 2 here, so 4 2y, then I put y cube minus 3 and then plus y cube divided by 2. Yeah. So if you solve it, what you are getting here? 1 by 2 minus 1 by 3, 1 by 6, right? So this I can solve. 1 by 3 minus y by 4 plus y cube by 48. Okay, this is your fy of y, but with the condition that your y is between 0 to 2. Your y is between 0 to 2. But you don't care about this fy of y. Now what you need to do? You need to find probability of random variable y taking value between 0 to 2. So y is taking value between 0 to 2. So 1 by 3 minus y by 4 plus y cube by 48 dot dy. So y by 3 minus y square by 8. Let me check back the calculation. I am not comfortable with the calculation. I don't think this calculation is correct. So let me check the calculation and you also proceed in the calculation. Yeah, so actually I was going in the right direction only. Everything was correct. Calculation was correct. You just need to put the value. So it might happen that in the examination it may feel like that, sir, y to the power 4 divided by 4, something is going wrong. But actually when you solved it, answer is coming out to be 1 by 4. Okay. So a good answer, 1 by 4 is coming. So that's the answer. Okay, well and good. So it was a good question. Let's understand method 2. Let's think about it. Let's think more before going into mathematics. What you need to find? The probability of y taking value between 0 to 2. This is what you need to find. So let's get back here. This was the question. They are asking probability of taking y value from 0 to 2. That means x can take any value, no? If I say I am having two random variable x and y should take value between 0 to 2. I am not telling anything about x. That means x can take any value. That means x can take value from 0 to 2. So value of x could be anything. Value of x could be anything. Value of x could be anything. But value of y should be from 0 to 2. Value of y should be from 0 to 2. Just think about it. Value of y will be from 0 to 2 from that will be in which region? Think about it. Value of y from 0 to 2. Here y is equals to 0. Here y is equals to 0. Then y is equals to something. Then something. Then something. Let's just say y equals to 1 here. Then something. Then something. Then something. Then something. Y equals to. So 0 to 2 will be here. Value of y will be 0 to 2 here. And x could take any value. X could take any value. So aren't we talking about this region only? Are you able to understand this point? Value of y from 0 to 2 and value of x could take anything. So in horizontal direction you could take anything. Someone will say that, sir, I can take this as well. Yes, you can take this as well. But y should be from 0 to 2 only, no? Y should be from 0 to 2 only. So that means what we are talking about? We are talking about only this particular region. We are talking about only this particular region. So what you needed to do? You need to find the you need to find the surface integration in this particular region. Now, are you having this doubt that whole region will come 1? So this is like half. So answer should be half. Don't do it, okay? So this is surface integration. It is not dx dy. It is not only the area. It is the surface integration. Surface integration with respect to this function. So there is a function as well, no? Like those who don't have a good idea of integral calculus, they will think that, okay, sir, Sir, this is complete 1 because this complete area would be 1, that I already know. This is what I have equated. So this complete area would be 1. So sir, now you are saying that I need to integrate from here to till here. That means I need to integrate in this particular surface. So the whole is 1. So this is like half. So answer should be half. 1 minus half will be equals to half. No, don't do that. You are integrating with respect to a particular function, which is this function. So this particular function can change the scenarios, no? Basically, this particular function will have different value in this region and this particular function will have different value in this region. So this function is having different values in both of the region, no? Are you able to understand this point? Cx into x minus y, it will be different here, it will be different here. So your surface integration will also be different. So this is actually coming out to be 1 by 4 and this downward will come out to be 3 by 4. Is that clear to you? So okay, don't use your brain like this, that half, so answer should be half. No, because if this question is coming in the examination, surely in the option half will be mentioned. So did you understand this point, what I was saying? That y is from 0 to 2, y is from 0 to 2 and x could take any value, x could take any value. That means we are working in this region. So what I need to do, I need to calculate the surface integration. If I am directly considering the, what we are considering, I am directly considering the joint PDF. If I am directly considering the joint PDF, that means I need to integrate with respect to x as well, with respect to y as well. You know that x is going from 0 to 2 in this region. In this region, x is going from 0 to 2. And if I take a horizontal strip, what I would see, that my y is going from 0 to x. You are not going to put y is going from minus x to x. In this particular region, if you take a horizontal strip, then x is going from 0 to 2 and y is going from 0 to x. Y is going from 0 to x. So you put the value and you solve this, you will get the answer 1 by 4. Do it on your own, okay? If I mean something to you, if this channel means something to you, if communication system means something to you, if gate examination means something to you, then you will do the calculation on your own and you will check whether you are getting 1 by 4 or not. And in the comment section, you will type down, yes sir, I got the value 1 by 4. Okay? That means you are actually enjoying the lecture, you are actually learning from this lecture. And those who have already studied this subject, they would realize that what kind of depth has been covered here. Are you really able to understand the meaning of two-dimensional random variable now? Okay? So how random variable y is taking value, how random variable x is taking value, and how they are together taking the value. This is something that we are learning, right? So yeah, this was a very, very good question. I spent roughly around 30 minutes on this question, just to make you understand that if you are finding fy of y, directly don't go here, okay, x is going from 0 to 2. Always two-dimensional random variable, that means I will make the region of operation first. If I am making the region of operation, now I know that if I need to find my fy of y, that means now I need to put the limit of x. So this was absolutely wrong. This was absolutely wrong. So now I will go to my region of operation and now I will see that my y is actually going from minus 2 to 2. My y is actually going from minus 2 to 2. In this range, when my y is going from minus 2 to 2, how my x is going? So when my y is going from minus 2 to 0, then my x is going from minus y to plus 2. Minus y to plus 2. And when my y is going from 0 to 2, at that time my x is going from y to 2. At that time my x is going from y to 2. As per the question, I am interested only in fy of y from 0 to 2 only. Fy of y from 0 to 2 only. That's why I will calculate this particular thing and I will get my answer from here. So I calculated this particular thing, I got my answer. Okay. And if I don't want to find the marginal PDF, directly I need to think. Directly how will I think is that they are asking y should be between 0 to 2. Y should be between 0 to 2. So x could be anything. That means this is the region of my operation. There you go. So very easily I could have got the answer here. But the important part was that how you find the marginal PDF. Right? Okay. So let's do this question. Here actually when AI framed this question, they framed the question in this manner that find the value of k. But this task you can do on your own, right? How you can find the value of k? You will make the region of operation and then you will do the same thing, right? So you can find the value of k on your own. In the region of operation, what you will do, fxy, xy, dx, dy, that should be equals to 1. So that task you can do on your own. So as of now, what I will do is that, अरे भाई क्या वैल्यू थी यार? Was it 8? This is not a live lecture. I guess it was 8 only. We can verify. Okay, we can verify. As far as I remember, it was 8. So you can find the value of k, it will come out to be 8. As far as I remember, it was 8 only. Okay. Now what you need to find actually? You need to determine the conditional PDF fy of x y by x. Here they are saying that x is taking value 1 by 2, which we can put later on. Basically, what this would be equals to, you know that this would be equals to your joint PDF divided by your marginal PDF. Say yes or no. Joint PDF divided by marginal PDF. Once you calculate this particular thing, what you need to do, x equals to 1 by 2 you need to put. So what you will do, here you will put x equals to 1 by 2. Okay. So what is the task here? What is the task? The only task is I need to calculate this particular thing, because joint PDF is already given. What I need to calculate? I need to calculate fx of x. So what I need to calculate? My only task is I need to calculate fx of x. So what do I know? I have to do this particular thing. Then I put the limit of y. So how will I put the limit of y? From here, that y is going from x to 1. No, always draw the graph. So how will you draw the graph of this one? So what all information are given? That your x is greater than 0. First information is that x is greater than 0. That means you are working in this region now. X is greater than 0. So this is your x, this is your y. So from the first information you got to know that x is greater than 0. And second information you got to know that y is less than 1. Y is less than 1. So let's make y equals to 1. This would be your y equals to 1. So y is less than 1. That means now this is your region of operation. Right? X cannot be negative, y is less than 1. So this is your region of operation. Now what is the other information? That x is less than equals to y. That means now I need to make the graph of x equals to y as well. So I made the graph of x equals to y as well. This is the graph of x equals to y. X equals to y. And this was the graph of y equals to 1. So what will be this point? This point will be x equals to 1 and y equals to 1. Say yes or no, right? Now what they are saying, x should be less than equals to y. X should be less than equals to y. So either this region will come or this region will come. So let's take any random point. Let's take this point. Here your x value is 1, y is 0. So put here 1 should be less than equals to 0. Is this inequality true? No. That means this region will not come. So which region will come? Upper region will come. So this is saying that downward region should come. This is saying that upper region should come. And this is saying that x should be greater than 0. So what do you think, which is the common region? This is the common region. Very easily I can see that this is the common region. Say yes or no. Right? This is the common region. So till this point you should be having the habit of making this kind of graph. So this is my region of operation. If I needed to find the value of k, then I could have find the value of k as well. How would I find it? I will integrate in this region R. So in this region R, what I would have done, I would choose a strip. I would choose a strip, vertical strip if I am choosing. So your limit of y is going from x to 1. Limit of y is going from x to 1. And limit of x is going from in this direction if you go. Limit of x is going from 0 to 1. 0 to 1. This is, let's just say this was kxy dx dy. So when you solve it is equals to 1. So when you solve it, k should come out to be 8. Okay. Now what is our task? Our task is to find fxy dot dy. I need to put the limit of y. I need to put the limit of y. So what I will do, I will take the horizontal strip and you can see that y is going from x to 1. So y is going from x to 1. Did you understand this point? If you take this horizontal strip, you know that y is going from x to 1. So y is going from x to 1. What is your fxy? 8xy. So 8x is constant, y square by 2. So this will become 4. X to 1. So 4x into 1 minus x square. This is what you are getting, right? fxy you put, fxy I put 8xy, and y is going from x to 1. Here also you can see y is going from x to 1 only, or in this diagram as well you can see y is going from x to 1. So always better you make the diagram, because if you don't make the diagram you will surely mess up here. You will do this kind of mistake. Okay, the answer would be different. Yeah, so y is going from x to 1. Well and good. Yeah, y goes from x to 1, and then y square by 2 4 x y square, and x to 1 1 minus x square. So this is my fx of x. This is my fx of x. This I need to calculate at x equals to 1 by 2. So what I need to calculate? Fx of x equals to 1 by 2. So 4 into 1 by 2, 1 minus 1 by 4. So that would be 2 into 3 by 4, 1.5, right? And in this question, if you put x equals to 1 by 2, what you will be getting? Basically, what is the value of fx y? X equals to 1 by 2 you need to put, and in place of y you need to put y only. So that is equals to 8, x value I need to put 1 by 2. And I need to see that x equals to 1 by 2 if it is taking or not. Basically, value of x takes the value 1 by 2 or not. Yes, it takes. Value of x goes from 0 to 1. Value of x goes from 0 to 1. So yes, it takes the value 1 by 2. So that's why I will be able to go to 1 by 2 here into y. So what will be the answer I will be getting? 4y. What you are getting? 4y. So basically, what will be the answer of this particular question? Answer of this particular question, they are asking f of y by x, f of y by x, small y, x equals to 1 by 2. So that would be equals to what? So on the numerator, what value you will put? X equals to 1 by 2y, that would be 4y, and in the denominator what you will put? 1.5, or you can say 3 by 2. So the answer would be 8y by 3. This is the answer. Okay. So what they are asking? PDF of random variable y, PDF of a random variable y such that x has already taken the value 1 by 2. So that is 8y by 3. X has already taken value 1 by 2. So what is the PDF of y? This is what they are asking, that is 8y by 3. This is the answer. All good? All fine? Very easy question. This was very straightforward. You just need to write down the formula. Then in fx of x you need to put 1 by 2. So you find out the value of fx of x. Very easily you could find out the value of fx of x. How would you find out the value of fx of x? You need to put the limit of y, then you put the limit of y square by 2, 4x here, 1 minus x square, fx of x you got, then at 1 by 2 you check the value, that would be 3 by 2, right? So this value is coming out to be 3 by 2, and fxy, xy was already given, and you need to put x equals to 1 by 2 here. So I need to put x equals to 1 by 2 here, so 4y divided by 3 by 2, so 8y by 3. This is the answer you are getting, okay? Joint PMF, we have already discussed about it. What is joint PMF? So what was your Px of x? It would tell the probability of random variable x taking value small x. So what would be your Pxy, xy? Probability of random variable x taking value small x and random variable y taking value small y. Very simple. It is PMF, right? Joint PMF or simple PMF should be very simple for you. What would be your marginal PMF? So from the joint PMF, how would you find out marginal PMF? What do you think? What I need to find? What I need to find? I need to find this particular thing. Let's just say my random variable x is taking value 0, 1, 2, and my random variable y is taking value 2, 3, 4. Now what I need to find? Px of 0. That means I need to find the value such that x takes value 0. This is what I need to find. So what I would do, x can take the value 0 when y is 2, x can take the value 0 when y is 3, and x can take the value 0 when y is 4. Are you able to understand this point? X can take the value 0 when y is 2 or 3 or 4. That means what you will do? You are having this marginal PDF. In this marginal PDF, whatever the value of y is there, you will put all the values of y. If you are not able to understand with respect to the formula, you will understand with respect to the question as well. Or just try thinking, no, just try relating it with PDF. In PDF, what we used to do, if I need to find fx of x, what I would do, I would take this and then I integrate with respect to y and put the limit of y. That means whatever the value y can take, all I will put. So here as well I am doing the same thing. Integration has been changed to summation. This PDF has changed to PMF. PDF has changed to PMF, and all the limit of y I am putting, all the limit of y I am putting. So whatever the y can take the value, y can take the value y1, y2, y3. So all the values of y I will put. So don't stress much on the formula, you will understand it. Don't stress much on the formula, you will understand it. Okay, don't worry about it. We will solve the problem, everything will be clear to you. Here what I would do, here again I will take the joint PMF, but now I will put all the values of x. Okay, we will understand it with respect to a question. If you are not able to understand, don't worry. What about this one? Conditional PMF. Conditional PMF would be x comma y divided by marginal PM divided by marginal PMF. Divided by well and good. Okay, very simple thing. So forget about all this, forget about this slide. This slide you don't even need to revise, you will directly revise this question. This question has everything. So what they are saying, the joint PMF of random variable x and y is given. X can take the value 0, 1, 2 and y can take the value 1, 2, 3. You need to find all these things. Y taking value 1, y taking value 2, y taking value 3, x taking value 0, x taking value 1, x taking value 2. Then x is greater than 2, y is less than 1, x plus y greater than 3, x equals to 1, y equals to 3. All these things you need to find. Just think about it, what this PMF is representing. Px, y, what this PMF represent? PMF represents us that random variable x takes value small x and random variable y takes value small y. If I ask you what is the value of 1, 2, what does that mean? I am telling that random variable x should take the value 1 and y should take the value 2. So what I would do, I will put the value small x equals to 1 here and capital Y, small x equals to 1 here and small y equals to 2. So I will get k into 1, 8k I will be getting. Here you put 2, so 3 into 2, 6, and here you put 1, so 8k you are getting. So what you will do in these kind of problems, you will make a table. Here you will put the value of x and on the other side you will put the value of y. What you will do here, you will put the value of x. X can take value 0, 1, 2. So x can take value 0, 1, 2. And here you will put the values of y. Y can take value 1, 2, 3. Y can take value 1, 2 and 3. Now what this space will represent, let's make the table like this. Now what this space will represent? Probability of random variable x taking value 0 and random variable y taking value 1. What is given? Pxy is given. This is what they are saying, that this is PMF. Although we used to represent PMF in this manner, but the question paper setter can represent PMF in any manner, right? So this is the PMF that they are saying. So what this PMF represent? This PMF tells that random variable x take value small x and random variable y takes value small y, right? So probability of this taking value 0 and taking y taking value 1. So this is given as k into 2x plus 3y, k into 2x plus 3y. So x is 0, y is 1. So if you put x equals to 0 here, y equals to 1, what you are getting? 3k. X is 0, y is equals to 2, what you are getting? 6k. X is 0, y equals to 3, what you are getting? 9k. Now x is 1, y equals to 1, x is 1, y equals to 1, 5k. X is 1, y equals to 2, x is 1, y equals to 2, 8k. X is 1, y equals to 3, 11k. X equals to 2, y equals to 1, x equals to 2, y equals to 1, 4. X equals to 2, y equals to 1. 4 plus 3 is 7k. X equals to 2, y equals to 1. Yeah, x equals to 2, y equals to 2, 4 plus 6, 10k. And x equals to 2, y equals to 3. So 9 plus 3, 13k. Are you able to understand this point? The same question, the first question that we saw, this is the same question. The very first question that we saw. There this table was already given, now we are making this table. Now you know one thing, that x and y can take values between all these points only. That means, what do you understand? That 3k plus 6k plus 9k plus 5k plus 8k plus 11k plus 7k plus 10k and plus 13k would be equals to 1. Say yes or no? Because x can take 0 and y can take 1, or x can take 0, y can take 2, or x can take 0, y can take 3, or x can take 1, y can take 1, or x can take 1, y can take 2. So all these combined will be, all this addition will be equals to 1. All the probabilities I am taking into action. All the probabilities I am taking into action. So let's add them. 30, 9, 18, 30 plus 18 plus 19 and 19 plus 5, what that would be? 24. 24 plus 18, 72k. Okay, what it is coming out to be? 72k, and that is equals to 1. So value of k is coming out to be 1 by 72. Okay, let's check the calculation again. 0, 1, 3k, 6k, 9k, no issue. 1, 1, 5k, 1, 2, 6, 8k, 1, 3, 11k, 2, 1, 7k, 2, 2, 10k, 2, 3, 13k, and you add all of them, 18, 30, 18, 30, 48, 48, 11, 59, 59 plus 5, 64, 64 plus 8, 72k, k is equals to 1 by 72. So this is the answer of k is coming. Did they ask the value of k? No. Now they are asking probability of y equals to 1. So y can take value 1 when x is 0, x is 1, x is 2. So what do you think, what you need to do? Y should be equals to 1. That means you will add all of them. So probability of y equals to 1 would be 15k. That would be equals to 15 by 72. 5 by 24. Right? Probability of y equals to. So in the same manner you can find out everything, no? Y equals to 2. What that would be? 24k. 1 by 3. Let's just say I find for x equals to 1. And this would be capital X, not small x. X equals to 1. So 5k, 8k, 11k, 19, 24k. This is also coming out to be 24k. Right? X equals to 2 also you can find what will be the answer? 30k. That would come out to be 30k. So 30 divided by 72. Right? So these are the answer. Next, what they are asking? X should be greater than 2 given that y is less than 1. Probability of x should be greater than 2 given that y is less than 1. X greater than 2. X should take value greater than 2. X should take value greater than 2 given that y is less than 1. Y is less than 1. It is not even possible. Right? Y cannot take value lesser than 1, no. Y can never take the value less than 1. So here let's change this question. At least it will make some sense. Okay. Y should be less than equals to 1. What does that mean? probability of x taking greater than 2 intersection with y taking value lesser than equals to 1 divided by y taking value lesser than equals to 1. So y taking value lesser than equals to 1, that means y can take value 1 only. So this probability I need to write down. So probability of y taking value equals to 1 is 5 by 24, and y taking value lesser than 1 and x taking value greater than 2, that means x can take value 3 and y can take value 1. So only one condition will come, which is x can take value x greater than 2. अरे यार भाई क्या क्या क्वेश्चन फ्रेम किया मैंने ये. This is also not possible, no? So here also equal sign. Here also equal sign. Okay. So x taking value greater than equals to 2. So x can take only one value, which is 2, and y should take value lesser than equals to 1. That means y can take only one value, which is 1. So this answer would be there, 7k. So what that would be? 7 by 24. ये क्या हो रहा है भाई? 7k, अच्छा 7 by 72. Let's write it down. This is 7k, right? You understood, right? X should be greater than equals to 2. That means x can take only value 2, and y should be less than equals to 1. That means y can take value only 1. So 2 and 1, that means 7k will be the answer, no? So answer will be 7k divided by y should be less than 1. That means y could be equals to 1 only. So what this would be? 15k. So answer is 7 by 15, right? X plus y should be greater than 3. What do you think? What will be the answer of this one? X equals to 1 and y equals to 3. X equals to 1 and y equals to 3. 11k will be the answer, right? X equals to 1 and y equals to 3. Y equals to 3. X equals to 1, y equals to 3. So what will be the answer? If you go here and come here, this will be the answer, 11k. Right? So answer will be 11k here. 11, what is the value of k? 70 by 2. 72. Value of k is 72. So let's solve this one. X plus y greater than 3. So probability of x plus y greater than 3. So here now you need to think that my x can take value 0, 1, 2 and y can take value 1, 2, 3. So now x plus y should be greater than 3. What does that mean? That means if x is 0, maximum y could be 3. Basically, x plus y should be greater than 3. So what do you think? What all cases can come? X equals to 0, y equals to 1. Can this case come? No. X equals to 0, y equals to 2. Can this case come? No. X equals to 0, y equals to 3. Can this case come? No. Because x plus y should be greater than 3. So what all cases can come? Think about it. So which all cases will come? Now I will directly write it down. So the cases that will come will be x equals to 1 and y equals to 3, or x equals to 2 and y equals to 2, or x equals to 2 and y equals to 3. Only these cases will come, because 2 plus 3 5, 2 plus 2 4, and 2 plus 2 4, 2 plus 3 5, and 1 plus 3 4. That's it. These cases will come. 0 1 cannot come, 0 2 cannot come, 0 3 cannot come, 1 1 cannot come, 1 2 cannot come, 1 3 can come, 2 1 cannot come, 2 2 can come, 2 3 can come. So these cases can come. So 1 3, 1 3, 2 2, 2 2, and 2 3, 2 3. These cases can come. So what will be the answer of a probability of x plus y greater than 3? That would be 21 34k. 34 by 72. This will be the answer. Okay, this is the answer. 24 34 34k, 34 by 72. Very easy question. You just need to make the table and your job is done. Just make the table and everything is done. Well and good. Let's go to the last question. But I think I need to take a break. You try it on your own. You should be able to do it. Very easily you should be able to do it. Try this question on your own. Joint PDF is given, right? You draw the diagram. X should be greater than 0, y should be greater than 0, x plus y should be less than equals to 2, and x plus y should be greater than equals to 1. You draw the diagram, you find the region of operation, and then you find the probability. Do it on your own. I need to take some break. I need to drink some water because it's been roughly around 55 minutes. And then we will end this lecture. Okay, yeah, thank you. Yeah, welcome back. So did you try this question? X should be greater than 0, y should be greater than 0, and x plus y should be less than or equals to 2. So three conditions are given this time. What all three conditions are given? On random variable x and y, they will take the value in this manner. In which manner? That your x is greater than 0, y is also greater than 0, and x plus y should be less than 2. X plus y should be less than 2. So let's just say if this point is 2, this point will be 0. If this point is 0, this point will be 2. So this is the equation of x plus y equals to 2. So where will be x plus y less than 2? So if you put 0 comma 0 in this equation, if you put 0 comma 0, is it satisfied? Yes. That means this will be the region. And along with that, they are saying that greater than 0, x should be greater than 0 and y should be greater than 0. So what will be your region of operation? So till this point, you should be comfortable with the region of operation. This will be your region of operation. This is your region R. Right? So this I am calling as region R. So one thing you know that in this region R, if you take your fxy and calculate dx dy, that will come out to be equals to 1. Right? You can calculate this particular thing. In this region R, can you calculate fxy dx dy? Yes. How will you calculate? You will take the strip, y will go from 0 to 2 minus x and x will go from 0 to 2, and in that manner you can calculate, right? Now what you actually need to find? You need to find the probability of x plus y greater than 1, greater than equals to 1. What you need to find? You need to find probability of x plus y greater than equals to 1. That means again you need to take another region, x plus y greater than equals to 1. Which region it would be there? So this is the equation of x plus y equals to 1. This is the equation of x plus y equals to 1. And what you need to take? X plus y greater than equals to 1. So that would be here or here. Like if I put 0 comma 0 here, 0 plus 0, so 0 is greater than 1. Is it satisfied? No. That means what will be your region of operation? So basically I need to find the probability in this region. I need to find the probability in this region. This is what I need to find. So what I actually need to find? So total region I was calling as R. So I am calling this particular region as R dash. Okay, or yeah, R dash. I am calling this region as R dash. So what you need to find? You need to find this particular thing. R dash fxy xy dx dy. Have we seen this example before? Yes. Because here if I take the strip, it will be difficult for me. Because if I take the strip here, this example we have already seen in the last lecture. Right in the beginning we saw this example, right? If I take the strip vertically, so what will happen? If I take the strip vertically, what will happen is that I need to change the strip here. Here I need to change the strip, right? And what if I take the horizontal strip? Let's say if I take the horizontal strip. So in the horizontal strip also there will be problem. Why is that so? Because if this horizontal strip goes here, then the limit will change, you know. Like if I take the horizontal strip, that means in this strip what will be the value of x? So value of x will be from 1 minus y to 1 minus y to 2 minus y. Here x will be going from 1 minus y to 2 minus y, right? And here your x will be going from x equals to 0 to 2 minus y, x equals to 0 to 2 minus y. So both in the horizontal strip there is a problem, in the vertical strip as well there is a problem. You will have to do the integration 2 times, which will take a lot of time. So in the strip there is a problem. But what do you know here? If I call the whole region as R, this region as R dash, so can I call this region as R double dash? So what do you know here is that your surface integration for the whole region is equals to surface integration for R dash plus surface integration for R double dash. Say yes or no. And you know that this will be equals to 1. And what you need to find? You need to find it for R dash. So what you can do is that 1 minus for R fxy x comma y dx dy, and that would be equals to So this is r double dash. This r double dash is coming here because I know that finding r double dash is easy for me, right? Finding the surface integration for r double dash will be easy for me because here if I choose the strip, then what I will say, the limit of y is going from 0 to 1 minus x. The limit of y goes from 0 to 1 minus x. So it will be very easy for me to find out, right? But here this particular thing would be difficult. So instead of calculating this particular thing, what I am calculating this particular thing and then I am subtracting it from 1, right? So this is the trick that we have played here. So what I need to do here I have chosen the strip. Strip is going from y equals to 0 to y equals to 1 minus x. Y equals to 0 to y equals to 1 minus x. And x is going from 0 to 1 because this point will be 1 comma 0. So x is going from 0 to 1. X is going from 0 to 1. And what is your fxy dx dy? That is 3 by 2 xy dx dy. And that will be equals to your answer basically. That will be your answer. What your answer is saying, that this will be equals to probability of x plus y should be greater than equals to 1. So have I solved this integration somewhere? Surely I have solved. Where I have solved? In the beginning of the slide. You will see that this integration have been already solved by us. Where it have been already solved by us? I guess here, right? xy dx dy 0 to 1 minus x. So this integration have been already solved. It will give you value 1 by 24, right? So it will give you the value of 1 by 24 which have been already solved. So I can use this value here, right? Am I doing it correctly? Everything is correct here, no? So xy into dx dy from 0 to 1 minus x, 0 to 1. So this have been solved here. 2 by 3 is constant and it is giving me 1 by 24. Yeah. So I can go to this slide. So 3 by 2 is constant. So 0 to 1 minus x, 0 to 1. So this is giving me 1 by 24, right? So it was giving you 1 by 24. So you can see that the answer would be 1 minus 1 by 16. So that would be equals to 15 by 16. So this will be the answer. That's it. This is the end of this lecture. Okay. So we have studied about two-dimensional random variable. It will again come back. In the 5th or 6th lecture, this two-dimensional random variable will again come back. And all these concepts will also again come back. But till this point, you have understood it in a very good manner. So quickly revise all the questions that we have done. Quickly solve all the questions that whatever that we have solved, solve all the question on your own. Okay. Once you solve it, you will have a very good confidence in this particular topic, which is considered as one of the toughest topics of a complete communication system. That's why I wanted to deal it in the beginning, because usually this particular topic is dealt in the last because it is tough, right? But we wanted to deliver the tougher things before in the starting only, so that you are at this time you are very enthusiastic, right? You are having the good enthusiasm for studying communication system. So at this time you can understand tougher things as well, right? So yeah, that's it. This is what we have understood. This is your two-dimensional random variable that we have understood. Next we need to study about statistical parameter of random variable that we are going to see in the next lecture. Okay, so we will talk about mean, mean square value, variance, standard deviation, nth order movement about origin, nth order joint movement about origin, nth order movement about mean, nth order joint movement about mean, correlation, covariance and correlation coefficient. Okay, so all these things we will talk in the next lecture. Yeah, thank you very much. Yeah, hi everyone. So now in this video we need to study about statistical parameter of random variable. So these are the parameters. Okay, first one is like they can ask you what is the mean of random variable x, what is the mean square value of random variable x, what is the variance of random variable x, what is the standard deviation of random variable x. So all these are defined with respect to one dimensional random variable. Okay, one dimensional random variable, and these are defined with respect to two-dimensional random variable. That what is the correlation between random variable x and y, what is the covariance of random variable x and y, what is the correlation coefficient of random variable x and y. So they are defined with respect to two-dimensional, they are defined with respect to one dimension. And here if joint word is not coming, what does that mean? If I say nth order movement about origin of random variable x and nth order joint movement about origin of random variable x and y. So they are defined for both 1D and 2D. Okay. So we will understand the meaning of each of them one by one. They are very simple. This lecture will be very simple. Okay, very straightforward. So we will understand the meaning of each of them. You will understand every single thing. Okay, don't worry about that. So nth order movement about origin for random variable x and nth order joint movement about origin for random variable x and y. So if the joint word is coming, that means it will be defined for 2D. If joint word is not coming, that means it will be defined for 1D. So we will study about all of them one by one, but first we need to study about one operator. So this operator is known as expectation operator. So what could be given in the question? It will be mentioned that x is a random variable. You find the expectation of random variable x. Find the expectation of random variable x. We will study all of them, but before that we need to study about expectation operator. So what will be mentioned? A random variable x represents all these things. You need to find the expected number of chocolates the child will receive. So what you need to find? You need to find the expectation of random variable x. So how do you find the expectation of random variable x if PMF is given? So what is this? This is PMF only, no? What is the meaning of PMF? Random variable x is taking value 1, random variable x is taking value 2, random variable x is taking value 3. So discrete values it is taking. So how would you find the expectation of x if PMF is given? If PMF is given. So what you will do? What value these random variable can take? So this random variable can take, what you will do is that you will tell that the random variable can take values 1, 2 and 3. And what all are the probabilities associated to these random variables? So with respect to 1 it is 0.2, with respect to 2 it is 0.5, and with respect to 3 it is 0.3. Now what you will do is that you will take the value and multiply with its probability, plus you will take the value, multiply it with its probability. Then you will take the value and multiply it with its probability. There you go. So what you will be getting? 0.2, 1, 0.2 plus 1 plus 0.9. So you are getting 2.1. So this is the expectation of random variable x. What does that mean? That means that if the child is spinning the wheel, so basically what was the scenario here? There was a wheel. Basically there was 3 sections. Right? How will I make 3 sections? This is how I can make 3 sections. So here 2 chocolates you can get, and here 3 chocolates you can get, and here 1 chocolate you can get. So this guy will spin the wheel. So getting chocolate 2 probability is 0.5, getting chocolate 1 probability is 0.2, and getting chocolate 3 the probability is 0.3. So if this guy is spinning the wheel, there is chances that he will end up getting 2.1 chocolate. Actually he can never get 2.1 chocolate, no. He can get 2 chocolates or 1 chocolate or 3 chocolate. But it is said that if this experiment is done 1000 times, then it might happen that in the end of the 1000 time he will be having roughly around 2100 chocolates, because expectation came out to be 2.1. That means if the wheel is spinning for 1 time, then expected value of chocolate the child can receive would be 2.1. So if you are doing the experiment for the 1000 time, then the chocolate you will receive could be 2100. This is the expected value. So nearly around this much chocolate it will get. Nearly around 2100 chocolate the child will be getting. But as of now our target is to focus on the formula. What does the formula say? That whatever the value it can take, whatever the value a random variable can take, multiply it with its probability and keep on adding up. So it can take value 1, probability is 0.2. It can take value 2, probability is 0.5. It can take value 3, probability is 0.3. So answer is 2.1. So what will be the formula? Expectation of random variable x is given by, although formula is not important, what you will do? You will take all the values of random variable x and also you will take its probability and you will keep on adding up all of them. So I equals to 1, I equals to 2, I equals to 3, I equals to 4, everything will come into action. So here what we actually did, expectation of x was, what we did, first value we took, x can take value x1, that means it can take value 1. Then we multiply it with its probability. Then we took the value 2, then we multiply it with its probability. Then we took the value 3, then we multiply it with its probability. So this is what we done. 1 into 0.2, 2 into 0.5, 3 into 0.3. Answer is 2.1. Well and good, very simple. Now what if PDF is given? So here if PDF is given, then expectation of x will be given by, what you need to do? You will integrate for all the limit. You will integrate for all the limit. Now you will see whatever that is written here. What is written here? X is written here. So I will write down small x. Here x is written, I will write down small x. Okay. Now I will write down the PDF of small x. X into PDF of small x. So whatever the function is written here, just write it down in the smaller manner here. Whatever the function here, capital X was written, just write it down in small x. Let's just say in the bracket, if x square was written, what I would have done? Whatever the function that is written here, write it down in smaller function. Now you let me know, this is a function of x. So what is the PDF of random variable x? That is fx of x dot dx. So this would be your expectation of x square. Now you are finding expectation of x. So expectation of x square would be this. Expectation of x is this. Are you able to understand this point? So what this E is doing? What this E is doing? Whatever that is there inside, it will make it smaller, and this is a function of x. This is a function of x. So let's write it down as g. So this is a function of x, right? Since this is a function of x, that means here the PDF of x will come. If this is the function of x, so here PDF of x will come. If this was a function of y, so PDF of y will come. If this was a function of z, PDF of z would come. Is that clear to you? So we will see all these examples. So this is our expectation. What you need to find? You need to find the expected value of x. Expected value of x. What it will do? You need to integrate for the whole limit. Then what you need to do? Capital X, small x. Fx of x. Since this is a function of x, so here I will put the PDF of x only. Dot dx. Now x is actually going from 0 to 1. You are integrating with respect to x, which is going from 0 to 1. So here you have put the limit from minus infinity to infinity, which you will change from 0 to 1. Small x as it is. Now what is your fx of x? That is 2x dot dx. So what will be the answer? 2x cube by 3 from 0 to 1. So answer is 2 by 3. This is the answer. Okay. So 2 by 3 is the answer. Very simple thing. Did you understand? Let's write down more things here. What if they were asking you expectation of x square plus 3? What you would have done? What did I tell you? Whatever that is written here, capital X will be replaced with small x. Capital X will be replaced with small x. Now this is a function of x. So what you will put here? PDF of x. This is a function of x. That's why I am putting the PDF of x here. If this was a function of y, I would put the PDF of y here. If this was a function of z, I will put the PDF of z here. Is that clear to you? Dot dx. Now I can solve it. Okay. So a random variable y is defined as y equals to ax plus b. A and b are constant. X is a random variable whose PDF is fx of x. You need to find the expectation of y. What I need to find? I need to find the expectation of y. So what I will do? Minus infinity to infinity. Here what is written? Capital Y, so small y. Now this is a function of y. So which PDF I would require? PDF of y I will require. But do you know the PDF of y here? No. I only know the PDF of x. I don't know the PDF of y. I only know the PDF of x. So what do I do now? So what I will do? Expectation of y. You know that y can be replaced with ax plus b. Ax plus b. Now what this expectation operator do? It will make the integration. Whatever that is inside, capital X will be replaced with small x. Now this is a function of x. So PDF of x will come. There you go. Is that clear to you? I tried doing by this particular, really sorry guys, here you will integrate with respect to y only, no? Everything is of y. So you will integrate with respect to y only. but you got to know that you are not having the PDF of y. So what you would do, you would find the expectation of ax plus b. You would find the expectation of y, which is expectation of ax plus b, right? Now I know that I have the PDF of a random variable x. So what I will do, whatever that is inside, capital X will be replaced with small x. Now this is a function of x, so I need to put the PDF of x only, PDF of random variable x. So PDF of random variable x is fx of x dot dx. So now I can solve this. How will you solve this? Minus infinity to infinity ax dot fx dx plus minus infinity to infinity b fx dot dx. Say yes or no. So here you can take a as common. Now what will be this? What I have done, I have taken a as common. Basically I am taking a outside because a is a constant. No, a is a constant, a and b are constant. So a I am taking outside. So what do you think, what is this? Expectation of x only, right? And if I take b outside, what do you think, what will be the answer of this particular thing? Minus infinity to infinity x fx dot dx. What that would be? 1, right? So what will be the answer? B. So what you got to know here, expectation of ax plus b is coming out to be a into, is coming out to be expectation of ax plus expectation of b. So this is coming out to be, a is a constant which can come outward, expectation of x, plus b is also a constant, so expectation of any constant value will be that constant value only. So what do you see here? This is the thing that you can see. This is the conclusion that we have made. So what did you get to know here? That expectation always look for randomness. You can see that eventually the expectation operator is put only on the randomness. Which is the randomness here? In ax plus b, where is the randomness? Randomness only random variable x is having. So expectation operator will always look for the random variable. X is a random variable, so eventually the expectation operator is working only on the random variable only. Are you able to understand this point? So constant, either it will be taken out or expectation of constant will be the same constant only. Is that clear to you? We will see more example, we will see everything, but as of now we are just getting started and we have seen a very important point. What is the point that we have seen? This was the very important point, that here I was not able to calculate the expectation of y, but I know that y could be replaced as ax plus b. So if I put ax plus b here, then I would know that this is a function of x. So now I need to put the PDF of random variable x only. So I put the PDF of random variable x, I got this answer. Okay. So now let x, y, gx, x1, x2, all these are random variable, a, b, c, alpha are constant. So you let me know what will be the expectation of ax plus by. So what it will do? Expectation of, in between there is a plus sign. So expectation of ax plus expectation of by, right? Here also it was doing the same thing, plus sign was there. So expectation of ax plus expectation of b. So expectation of ax plus expectation of by. Now this is the random, right? And y is also random. A is a constant, b is a constant, so a can be taken out. So a into expectation of x plus b into expectation of y. Say yes or no. What will be expectation of c? Expectation of constant, what that would be? Constant only, because c is a constant, no? So expectation of constant will be constant only. What do you think, how will you break it? So here as well, randomness is there in x1, x2, x3, xn. So what you will do? A into expectation of x1, because in the plus it can be broken. With respect to plus, with respect to plus, the expectation operator can be broken. So a expectation of x1 plus b expectation of x2 plus c expectation of x3. This kind of answer we will be getting. Because b is a constant, so a is a constant, it can come out. B is a constant, it can come out. C is a constant, it can come out. So very simple thing, very, very straightforward. Nothing difficult is there. And so on. Here you will see alpha expectation of x. What will be expectation of gx? So what you will do? Whatever that is inside, what is inside? Small gx, right? But this capital X should be replaced with small x. Now this is a function of x. Since this is a function of x, that means you will put the PDF of random variable x. dot dx. There you go. So expectation of gx would be given as, here this capital X will be replaced with small x. Since this is a function of x, so you will put the PDF of random variable capital X only, right? And if PMF is given, then similar thing, g of xi, probability of random variable taking value x equals to xi, and you will do all the addition. Just integration is replaced with the summation, nothing else, right? Although it will be used only, this will not be used anywhere, it will not be used. Wherever it is used, we can solve the problems, no need to worry about that. Now you let me know this particular thing, if x is greater than 0, then will this be greater than 0 as well? Because this is already greater than 0, because you know that this will always be positive, and you are already saying that this is also positive. So positive into positive, and then you calculate the area, that would be positive only. So yes, expectation of x will also be greater than 0. So if your x is greater than 0, that means expectation of x will also be greater than 0, right? What about this? Can you solve this one? Surely you can solve this one. What you will do? Inside, let's try solving it. What do you get? A square plus b square plus 2ab. I just solved this square function. So a square into x square plus b square plus 2ax into b. So plus 2abx. Now what I can do? A square is a constant. So expectation of x square plus expectation of b square. What that would be? B square only plus b square plus 2ab is a constant. Expectation of x. This is the answer. Okay. What is the answer? A square expectation of x square plus 2ab expectation of x plus expectation of b square will be b square only. There you go. This is the answer. Okay. So just I am telling that any kind of problem you can solve in this manner. So first, if you feel like that, okay, there is some equation, I will not say it is an equation. If there is some expression which you can simplify, so first you simplify, then you know that summations can be broken. Summation, or even like here I will not put negative sign, but here I should put negative sign. Summation or negative sign, they can be broken. They can be broken. Okay. So these sign can be broken like this. But multiplication cannot be broken. What I mean to say is that, let's just say expectation of xy is there. So you cannot say that, sir, x and y both are having the randomness, so I will do this. No, you cannot do it directly. Plus sign and minus sign can be broken like this. Expectation of ax1 plus expectation of bx2, and then a and b are constant, so taking outward. But here you cannot do this. Or like this, that, sir, y I will take outward and then expectation of x. Or, sir, I will take x outward and expectation of y. All these things you cannot do. Both are random variable, no? Both are having the randomness. X and y both are having the randomness. If both are random variable, both are random variable, both are having the randomness. So you cannot do that expectation of x multiply with expectation of y. No, this you cannot do. Okay, this will be true, but only in some specific case. Which case, that we will see. But usually you cannot do it. Okay, and y taking outward, all these things you cannot do. So only with respect to the constant you can do, or with respect to plus minus you can do. Is that clear? So everything about expectation operator is clear to you. We started with here. PMF is given, very simple calculation. PDF is given, you need to integrate. Whatever that is given, put it here. This is a function of x. Put the PDF of x. Your job is done. Then we saw this very important property. Expectation of y will be a into expectation of x plus b. Right? And then we saw these properties which are very, very simple, very, very straightforward. Now we are going to start studying about mean, mean square value, variance and everything. Okay. So we will study it, but I need to change the slide. So I will pause the video, I will change the slide, and then I will come back and we will start studying about mean. Okay. We will start from mean. Okay. Yeah. Thank you. Yeah. Welcome back, guys. So we have studied about expectation of random variable. Now we need to study about mean of a random variable, right? So what is the mean of a random variable? So mean of a random variable is nothing but it is the expectation of random variable only. Basically, whatever that we have studied till now, that was mean of random variable only. It is just a different name. Okay. So expectation of random variable is nothing but the mean of random variable. So if a PMF is given and if I ask you what is the mean of random variable x, so what you will do? You will take all the values of x and you will multiply with its probability, and you will add all of them. And with respect to the PDF, what you will do, so here what you will see, whatever that is written inside, so small x is capital X is written inside, so I will make it small x. Now it is a function of x, so I will put the PDF of x here dot dx, and I will integrate for whole limit, right? Now a random variable x is given, another random variable y is defined as y equals to sin x. You need to find the mean of random variable y, but the PDF of random variable x is given, so you are not having the PDF of random variable y. So what you will do, you need to find the mean of random variable y, that means you need to find the expectation of random variable y. So expectation of random variable y, what is y equals to? Y is equals to sin x. Why I am doing so? Because I am not having the PDF of random variable y, I am having the PDF of random variable x. Now what I will do, expectation operator, what it will do, it will take an integration sign, it will integrate it for the whole limit. Now inside sin capital X is written, so I will write down small sin x. Now this is a function of x, so I will multiply with the PDF of x dot dx. So I will get my answer here. Okay. So whatever the answer is there, that answer I will get. So did you understand this point? That whatever the function is there, this is a function of x, so you will put the PDF of x. If this was a function of theta, you will put the PDF of theta. If this was a function of gamma, you will put the PDF of gamma. Well and good. Now there is something called movement about origin. Okay, movement about origin. So if they are saying that first order movement of random variable x about origin, so what you need to find, focus on this particular thing, movement. Movement means expectation only. Did you understand the meaning of mean? Did you understand the meaning of mean? Mean is just expectation. Now we are seeing what is the meaning of movement. So movement means expectation. Movement of what? Random variable x about origin. And what is the order? First order. First order movement of random variable x about origin. And which order? First order. Okay. What this would be? Second order movement of random variable x about origin. Which order? Second order. So that would be equals to expectation of x square, right? And what this would be, let's write down in a good manner. First order movement of random variable x about origin, and power would be 1. So that would be equals to expectation of x, and this is equals to minus infinity to infinity x fx of x dot dx. And what is the name of this? Mean, right? Mean of random variable x, right? Now what you are getting here, expectation of x square. So what you will do, whatever that is inside capital X square, so you will make it small x square. This is a function of x, so you will put the PDF of x. Now this is also having a specific name. This was having the name of mean, so this is known as mean square. So this is known as mean square value of random variable x. This name you need to remember. Okay, you need to remember this name. What is the name? Ex square is known as mean square value of random variable x. Although we will write down everything in the conclusion, but you should be remembering that Ex square is known as mean square value of random variable x. Is that okay for you? Will you be able to remember? Surely you will be able to remember. Now nth order movement of random variable x about origin. So movement about origin, and it should be nth order. So what that would be equivalent to? X to the power n, since this is a function of x only, dot dx. So this name you need to remember. From this slide, what is important part? This is the important part. Mean square value of random variable x, this is equivalent to Ex square. Okay. Now we will see movement about mean. So similar thing is there. First order movement of random variable x about mean. So this Ex is shown by mu x. Okay. Mean is actually mu capital X. Really sorry guys. Mean is shown by capital mu x. Okay. This mean can be shown by capital mu capital X. Mu capital X. So mean can be shown by mu capital X. So here also we are talking about mean. So this can be shown by mu capital X. Now this is the mean of random variable y. No. So here I will write down mean of random variable y. This is the mean of random variable y. Mean of random variable y. So here I will write down mu y. This is the mean of random variable x, so I will write down mu x, right? So mean is actually shown by mu x, okay? So movement about mean, first order movement about mean. So what is this? Now do you remember the property of expectation operator? Yes sir, I remember the property of expectation operator. The minus sign can be separated. Now you just let me know, will this be a constant value? Sure sir, surely it will be a constant value, no? This mu x is a constant value, no? You will solve this particular integration. Integration is going from minus infinity to infinity. Or you remember the previous example, 1 to 2 x square into x dot dx. These kind of things you are doing, right? Basically x dot fx of x dot dx. So limit of x is constant, no? Limit of x is constant. So this will be a constant value. Mean will be a constant value, no? Mean is surely a constant value, right? We were getting the answer 2.1. So that was a constant value. So mean will be a constant value. And you know that expectation of any constant value will be the same constant value. And what could be expectation of x? Expectation of x could be written as mu x. And what is this? Mu x only. So mu x minus mu x would be equal to 0. So first order movement of random variable x about mean will be 0. This statement could be written and they can ask whether the statement is true or false. So you will be able to tell, yes, the statement is true. First order movement of random variable x about mean. Okay. Now second order movement of random variable x about mean. Movement of random variable x about mean. Which order? Second order. So what this will be equivalent to a square plus b square minus 2ab. You agree to this point? Right? A square plus b square minus 2ab. Now you know that this can be separated. Now you also know that 2 mu x will be a constant value. So 2 mu x I can take outside. Expectation of x. Is that clear to you? What really happened here? 2 mu is a constant value and expectation of x, right? Now this could be expectation of x square only. Now mu x square is also a constant value, no? Mu x square is also a constant value. So this will be equal to mu x square only minus 2 mu x. Expectation of x could be written as mu x again. So what you are getting? This became 2 mu x square. Simple calculation, very simple calculation. First we solved inside whatever that is there. Then x square, mu x square. 2 mu is a constant value that I can take outside. Expectation of x is mu x. So 2 mu x square you are getting. So what you are getting? Expectation of x square. Expectation of x square minus mu x square. And you can write it down in what manner? Expectation of x square. What is mu x? Basically expectation of x is mu x, nothing else. Expectation of x is mu x. So I can write it down. Sorry. Expectation of x square minus expectation of x whole square. So this basically, this is coming out to be second order movement of random variable x about mean is coming out to be expectation of x square minus expectation of x square. This is what it is coming out to be, and it has a special name. What is the name? This particular thing has a special name. This is known as variance of random variable x. Variance of random variable x. So this is also having a special name, and that is shown by sigma x square. So variance of random variable x is coming out to be ex square minus ex whole square. Will you be able to remember it? Surely you will be able to remember it. So this slide, this point I ask you to remember, and this point I ask you to remember. So let's write down the conclusion. So what was the mean of random variable x? Mean of random variable x was expectation of x only, and you know what expectation operator would do? X fx of x dot dx, taking integration from minus infinity to infinity. What do you mean by mean square value? So it is basically expectation of x square, nothing else. Mean square value is expectation of x square minus infinity to infinity x square fx of x dot dx. What was the variance? So variance was given by sigma x square. Variance was given by sigma x square. So you don't need to remember this definition. If you want to remember, you can remember. If you forget this definition, then also it is fine. But whatever the final result we got, what was that? Expectation of x square minus expectation of x whole square. This should be remembered. And there is something called standard deviation. Standard deviation, that is nothing but the under root of variance. So if in the question, if they are asking you standard deviation, what you will do? You will just calculate the variance and then you will take the under root. So it is just the under root of variance. So can I write it down in this manner? Right? So in the question, if standard deviation is asked, you just need to calculate the variance and then you take the under root. So from all the slide, this is what you need to remember. That's it. Mean is expectation of x. Mean square value is expectation of x square. And variance is sigma x square, which is equivalent to expectation of x square minus expectation of x whole square. And your standard deviation is nothing but the under root of variance. Okay, well and good. Now let's take care of this particular expression. Sigma x square is equals to ex square minus ex whole square, right? So from here, what you can write down? From here you can see that ex square is equivalent to what? Ex square is equivalent to sigma x square plus expectation of x whole square, right? So ex square is equals to sigma x square expectation of x whole square. What this was known as? Mean square value, right? Mean square value of a random variable x. So let's write down in this manner. This was known as mean square value of a random variable x. It is having another name, that is total power of random variable x. Total power of a random variable x. Okay, this particular thing, sigma x square, this is known as AC power of random variable x. And here what you have done, you have taken the mean and then you are doing the square, mean and doing the square. So this is known as DC power of random variable x. So this slide is the whole conclusion, whatever that you need to remember. That's it. You will be able to write down the first order movement, second order movement, all these things you will be able to write down. And this is the slide which you need to remember. That's it, nothing else. Mean you remember, mean square value you remember, expectation of x square. Variance you remember, expectation of x square minus expectation of x whole square. Standard deviation is nothing but the under root of variance. Then they can ask in terms of power as well. So you would remember the formula of variance. From there you would see that, sir, if I add both of them, I will get expectation of x square. So expectation of x square is known as mean square value of random variable x. That means it shows that total power of random variable x. And sigma is the AC power and ex whole square is the DC power. Not tough to remember. If you just remember that this is the DC power, then by default it will be the AC power. So DC power plus AC power will be the total power. So either you remember that sigma x square is the AC power, or you remember that ex whole square is the AC power. So any of the thing you need to remember. Okay. So I usually remember this particular thing, that mean square. This is the square of mean. Square of mean. So this shows that DC power of random variable x. Okay. And this shows the AC power of random variable x, and this is the total power of a random variable x. Well and good. Let's see some questions. PDF of random variable x is given. You need to find its mean and variance. What you need to find? Mean and variance. So first thing is that they have given that random variable x is taking value between -1 to 3, but they did not give the value of k. Can you find out the value of k? Surely you can find out the value of k. Whenever you need to find out any constant or any variable, what property you will apply? You know that total area under the curve will be 1. What is the total area? K into 4. That would be equals to 1. So k is coming out to be 1 by 4. Okay. So this is your PDF. PDF is given, right? And you can define the PDF as well. How you will define the PDF? That fx of x is 1 by 4 when your random variable x is taking value between -1 to 3. Otherwise it is 0. Right? Now what you need to find? You need to find the mean. Mean of random variable x. So expectation of x will be equivalent to -∞ to infinity x fx of x dot dx. Now x is taking, actually it is taking value, basically fx of x is non-zero between -1 to 3. Look, x could be non-zero between -infinity to infinity. This x could be non-zero between -infinity to infinity. But fx of x is non-zero between -1 to 3. So this multiplication will be non-zero between -1 to 3 only, right? There x will remain as it is because this is the variable x, but fx of x is 1 by 4 dot dx, right? So 1 by 4 x square by 2 minus 1 to 3. So 1 by 8 9 minus 1. So mean is coming out to be 1. So what is the mean? So here what I can write down, expectation of x, or sometimes you represent it as mu x as well, or sometimes you represent it as x bar as well. Mean of random variable x bar, that is coming out to be 1. Now what I need to find? I need to find the variance. So first thing what I will do, I will write down the formula that variance of random variable x is given as expectation of x square minus expectation of x whole square. So this particular thing I am already having, but I need the expectation of x square. So now my expectation of x square I need to calculate. So what that would be equivalent to? Minus infinity to infinity x square fx of x dot dx. So your fx of x is non-zero between -1 to 3. X square could be non-zero between any limit, but fx of x is non-zero between -1 to 3. So x square divided by 4 dot dx, right? So what you are getting? X cube divided by 12. So 1 by 12 x cube minus 1 to 3. So 1 by 12 27 minus 1. 1 by 12 x cube 26 by 12. 26 by 12. So 13 by 6. 13 by 6. It is coming out to be 13 by 6. 13 by 6, right? So what is your sigma x square now? Sigma x square is 13 by 6 minus, this was 1. So 1 square will be 1 only, no? 1 square will be 1 only. So what is the answer you are getting? Did I do the calculation correctly? Yeah, this would be plus. I was thinking that there is something wrong, right? Here basically this will be minus and then minus 1. So this will be plus, no? 28 by 12. You will be getting 28 by 12. Okay. So 7 by 3. 7 by 3 minus 1 square. So what you are getting? 4 by 3. So your variance is coming out to be 4 by 3. This is the answer, right? And what was the mean? If I need to write down the mean as well, so your mean was actually coming out to be 1. So very simple thing, very simple thing. Okay, also this is a standard PDF. Okay, we will study about it in the next lecture only. We are going to study about some standard PDF. This is known as uniform PDF. Here you can see that fx of x is having the same value, no? It is having the value 1 by 4. It is not a function of x. It is nothing. It is a constant value. It is a uniform value. So this is known as uniform PDF of random variable x, which we are going to study in the next lecture. Okay, so for this there is a certain formula which I will ask you to remember as well. B minus a whole square divided by 12. So what you are getting? 16 by 12, 4 by 3. So that would be your variance. So your variance is 4 by 3 only. So we will remember the standard formula for this particular PDF as well. Okay, so there I will ask you to derive everything on your own. So all the derivation, all these steps you can do on your own. In place of 3, I will be putting B. In place of minus 1, I will be putting A. Okay. Try this question on your own. You can surely do it. Have some patience. You already know the mean. Expectation of y will be equals to expectation of ax plus b, and you need to find the variance as well. So how will you find the variance? Have some patience. You will be surely able to do it. Just write down the simple formula, the way formula says, and try doing in the same direction. Okay, I will have to take a break because I am having a cold. Okay, so I will take the break in 30 minutes or 40 minutes. Right now I'm taking the break after 20 minutes, but in between 30 to 40 minutes I will be taking the break because I am having the cold. Okay, so you try doing it on your own. Yeah, so did you try this question? What you need to find, y is equals to ax plus b is given. First you need to find is that mean of random variable y. So what will be the mean of random variable y? Mean of random variable y could be written as mean of expectation of random variable y. So expectation of random variable y could be written as expectation of ax plus b as well. And you know that it can be broken down into a into expectation of x plus b, because b is a constant, a can come outside, a into expectation of x plus b. So this is the first step that is done. Expectation of y or mean of y is equals to a into expectation of x plus b. Constant can come outside, constant can be taken as common, and this is already a constant value, so this will be having expectation of b only, right? What we need to find? We need to find the variance now. So variance of y would be equals to what? Mean square value of y minus expectation of y square. So this particular thing we are already having, we need to find this particular thing. So what we need to find? Expectation of y square we need to find. Expectation of y square we need to find. Can this be written as expectation of ax plus b? Surely it could be written as expectation of ax plus b whole square as well. So expectation of a square plus b square plus 2abx, right? A square expectation of x square plus expectation of b square will be b square only plus 2ab expectation of x. Very simple, right? Expectation of y square I need to find ax plus b whole square. So a square b square plus 2abx. Then what I will do, a square I can take common. So a square expectation of x square plus expectation of b square will be b square only plus 2ab expectation of x, right? So this is your expectation of y square. Now I need to find sigma y square. So sigma y square is a square expectation of x square plus b square plus 2ab expectation of x, right? Minus bracket sign. Basically I am putting down this particular thing here. Expectation of y square I have put. Now expectation of y, what was the expectation of y? A into expectation of x plus b whole square, right? So what you are getting? A square expectation of x square plus b square plus 2ab expectation of x minus a square this square. Look, there is a minus sign, although in the bracket what will come? Everything will be positive, right? In the bracket everything will be positive. So if there is a minus sign and if I open the bracket, then every positive sign will be converted to the negative sign. So a square plus b square plus 2ab expectation of x. Did you understand this point? Did you understand this equation? Very simply, expectation of y square I have put, which is this one. Then expectation of y whole square I need to put. So expectation of y is a into expectation of x plus b. Then this square plus this square plus 2ab expectation of x. Then there is a minus sign. So with the minus sign you open it up. So what do you think? This and this is getting cancelled out. B square and b square is getting cancelled out. So what is the answer you are getting? Oh. So sigma y square, what I am getting? A square expectation of x square minus a square expectation of x. I think I should add a page. Okay, let's not. So let's write down the last step on the next page only. So in the last step, what I can see, sigma y square is coming out to be a square expectation of x square, a square expectation of x square plus, not plus, minus a square expectation of, what you are getting, minus a square expectation of x whole square. Is that fine for you? Right? Now what you can do, you can take a square common. So what you are getting? If I take a square common, so expectation of x square minus expectation of x whole square. This is what I am getting. So your sigma y square is coming out to be a square into, what is this? Sigma x square, right? This is sigma x square. There you go. So your y was given as ax plus b. You need to write down the mean. What you will do? Mu y is equals to a mu x plus b. Mean of y would be equals to a into mean of x plus b. And if you need to write down the variance, so variance of y would be equals to a square sigma x square. So variance will kill the constant values. What does variance do? Variance will kill the constant value. But mean, what mean will do? Mean will not do anything with the constant value. Mean will not do anything with the constant value, but variance will kill the constant value. Along with that, here this was the constant value, it will make it square as well. So this is the conclusion that we have made. And from here, if someone asks you what is the value of expectation of y square, so you will simply say sigma y square plus mu y square. So you can do the square and you can get the value, right? So expectation of y square, we are not remembering any answer, but here we have remembered the answer, or you can say it is kind of method, you can say. What does the method say? The method simply says one thing, that is mu I, expectation of y you need to calculate, that means a into expectation of x plus b. If you need to calculate the variance, so variance of y would be equals to a square into variance of x, that's it. And if you need to calculate the mean square value of y, what is this? Mean square value of y, or you can say total power of y. So you are having the AC power, you are having the DC power as well. From there you can calculate the mean square value as well. Well and good. So this is the conclusion that we have written. Mu y would be equals to a into mu x plus b, and sigma y square would be equals to a square sigma x square. Y equals to minus 2x plus 3 is given, mu x is given, sigma x square is given. You need to find sigma y square, you need to find mu y, and you need to find that total power of random variable x divided by total power of random variable y. So let's find out all these things. You know that mu y square would be equals to a square. What is the value of a? Minus 2. So a square sigma x square. Well and good. Okay. So 4 into sigma x square was 4 only. So answer is 16. So sigma y square is 16. What is your mu y? Mu y is minus 2 mu x plus 3. So minus 2 into 3 plus 3, that is coming out to be minus 3. So what all answer you have got? Till this point we have got that sigma y square is coming out to be 16 and sigma and mu y is coming out to be 3, minus 3, right? Now total power of random variable x. Total power of random variable x means expectation of x square. What that would be? Sigma x square, that is 4, plus mu x square, that is 9. You remember this thing, no? AC power plus DC value whole square. So this is the DC power. DC value, I just said this DC value. Average, mean. Basically there are three kind of name. Mean, you can call it average as well. You can call it DC value as well. Okay. This is equivalent to expectation as well. And this is equivalent to expectation of x mu x. So these are the names. So this is how I remember. Mean, square of mean, or you can say square of DC value. This is nothing but the DC value, right? So what you are getting? 4 plus 9, 13. And expectation of y square would be equals to what? Sigma y square, that is 16 plus 9, 25, right? 16 plus 9. Mu y square. So minus 3 square will be 9. So 25. So here what is the answer you are getting? 13 by 25. Total power of random variable x divided by total power of random variable y. 13 by 25. This would be the answer. Well and good. Okay then. A random variable x is taking values between 1 to 5 with probability is shown. You need to find the mean and variance. So first let's find the mean expectation of x. So you know how do we find out the mean? Take the value, multiply with the probability. 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 What you are getting? 0.5, 0.5, 1, 1, 3. Expectation of x is coming out to be 3. Well and good. Okay. Take the value, multiply with the probability. Take the value, multiply with the probability. 3 into 0.4, 4 into 0.2, 5 into 0.1. Right. Now what I need to find? Variance. So for variance, what I need to do? Expectation of x square minus expectation of x whole square. So how will you calculate expectation of x square? The way you calculated expectation of x, right? Expectation of x square. How will you calculate? Here what you will do? You will take the value of x square and then you will multiply with the probability. Basically x is given, no? Now what I will do? I will make a table where x square I will write down. 9, 16, 25. And what will be their this is x square. And what will be their respective probabilities? That would be the same only, no? Basically if x is taking value 1, then x square will take the value 1. So what is the probability of x square taking value 1? That is equivalent to probability of x taking value 1. That would be 0.5. Are you able to understand this point? What I am asking, what is the probability of x square taking value 4? So that would be equivalent to probability of x taking value 2. Actually it would be plus minus 2, right? X could be plus minus 2. But you know that this is already equals to 0. So probability of x equals to 2 is 0.2. So probability of x square taking value 4 is equals to 0.2 only, no? Are you able to understand this point? So this table will not change, only the x square value I am changing. So this probability will remain the same. Probability will remain the same. So what will be your expectation of x square? So what you are doing the square and then multiplying. 0.1 plus 4 into 0.2, 0.8, 9 into 0.4, 3.6, 16 into 0.2, 3.2, 25 into 0.1, 2.5. Is that clear to you? Right? Well and good. So you will not have to make this table again and again, right? Without even making this table again and again, you will be able to tell the answer. Say yes or no. Okay. So what you are getting? 9, 45, 5, 7, 10.2. Let me do the calculation again. 9, 45, 45, 5, 7, 7, 8, 9, 10, 10.2. Yeah, expectation of x square is coming out to be 10.2. So what they are asking? They are asking sigma x square, that is 10.2 minus 3 square, that would be 9. So that would be equivalent to 1.2. So here the answer is 1.2 and here the answer was 3. Mu x was 3. Okay. So variance was 1.2 and mean was 3. Is that clear to you? So this is how you can calculate. Very easy. In case of PMF also it is very easy. In case of PDF as well it is very easy. Everything is very easy here. Next question, PDF is given 1 by 2 mod of x e to the power minus mod of x. You need to find the mean, variance and 17th order movement about origin. Okay. All these things you need to find out. So let's go one by one. First thing, let's find out the mean. Expectation of x. So that would be equivalent to minus infinity to infinity x fx of x dot dx. Here x is going from minus infinity to infinity only. Here they did not mention the limit of x, no. So by default you will say that x will go from minus infinity to infinity only. Okay. So here it will go from minus infinity to infinity. Minus infinity to infinity. 1 by 2 is a constant value which I can take outside. So what I will do is that 1 by 2 will be a constant value, minus infinity to infinity x mod of x e to the power mod of x dot dx. Do you remember something, even function, odd function? Is it a even function or odd function? Odd function, right? This is an odd function, no? I'm only talking about this thing. I'm only talking about this particular thing. If you just calculate this integration, what will be the answer you will be getting? Basically, what I mean to say is that, can you break down this limit into two? That minus infinity to infinity. First, I am breaking down as minus infinity to 0. Okay. So minus infinity to 0, I am putting the limit of x. What does that mean? That means here x is negative. So how will the mode open? The mode will open with the negative sign, right? So this will be x square e to the power x dot dx. Mode will open with the negative sign, so here negative sign. Plus again 1 by 2. Limit goes from 0 to infinity. Now x is positive, so x, mode will open with the positive sign. Right? Now will you solve this integration? It will take a lot of time. So what you need to think here, in place of x, if I put minus x, in this function, in place of x, if I put minus x, what I will get? The same function again, no? So basically this is, sorry, not the same function, just the negative of that. So basically this is a odd function. And if it is an odd function, what does that mean? That means the integration will be 0. Do you know that calculating the whole area of odd function will be equals to 0? Odd function. Is this a odd function? Yes. Whatever that you see on the positive side, just the negative I am seeing. Take one mirror image and then another mirror image. Yes, it is a odd function. What does that mean? The total area will be whatever the positive area you are getting, the same negative area you are getting. So total area would be 0. Are you able to understand this point? Or basically what you can do is that here in place of x you can put minus x. So you will get the same thing. What I mean to say is that here in place of x you will put minus t. So what you will get? Dx equals to minus dt. And how the limit will go? If x is minus infinity, then t will be plus infinity. And if x is 0, then t will be 0. So, and next what you are putting? In place of x you are putting minus t. So here you will get t square e to the power minus t dot dt 1 by 2. Already there is a negative sign. Now this negative sign, what it can do? It can interchange the limit. So limit will go from 0 to infinity. Right? And in place of t I can put x as well now. Basically t is just a variable, no? So in place of t I can put x. So in place of t now I can put x. So x square x dot dx. Right? Something wrong I have done. ये क्या हो गया? ऐड कैसे हो गया भाई? Okay, yeah. Already there was negative sign. So negative sign became plus. Another negative sign would be there. Basically, in place of dx, you would put dt here, no? What I mean to say, this is a very simple, very simple integration. So already there was minus 1 by 2. You are putting the limit. From where you will put the limit? If x is equals to minus infinity, then t will be equals to plus infinity. If x is equals to 0, then t will also be equals to 0. T square. In place of t, in place of x, what you need to put? Minus t. And in place of dx you need to put minus dt. So this minus minus became plus. Now what I need to do? I just need to interchange the limit. I need to make the limit from 0 to infinity. So here if I need to make the limit 0 to infinity, then negative sign would come, right? So negative sign would come. So limit would go from 0 to infinity. So this is 0 to infinity. Okay. So this is same as this thing. So if you add all both of them, what you will get? 0 only. Or you can simply see this is a odd function. Integration of odd function for complete limit would be equals to 0 only. That's it. Very simple thing, very straightforward. If you have covered signal system, if you have covered basics of mathematics, then you would know that odd function will throw 0 integration, right? So expectation of x is equals to 0. Okay. Yeah, so this is the thing. Now we need to calculate the variance. So for calculating the variance, what I need to do? Expectation of x square minus expectation of x whole square. So what would be your expectation of x square? So expectation of x square would be equivalent to minus infinity to infinity x square fx of x dot dx. So minus infinity to infinity x square What is your fx of x? So 1 by 2 I can take outside, mod of x e to the power mod of x dot dx. Mod of x e to the power minus mod of x dot dx. 1 by 2 is already outside dot dx. Is that okay for you? Now you know that this is even function. This is even function, because in place of x, if you put minus x, you are getting the same expression. So if it is a even function, can I write it down in this manner? 0 to infinity x cube e to the power minus x dot dx. Did you understand this point? This is a even function, no? So at least this much point you agree, right? If this is a even function, that means whatever the integration it will throw for the positive value, the same integration it will throw for the negative value as well. That means I can break the limit from 0 to infinity, multiply with 2. 0 to infinity, multiply with 2. So x square here, and then mod of x, the same function. Now you know that x is positive here. You are putting the limit from 0 to infinity. So basically x is positive. And if x is positive, that means mod of x will open with plus x. So what you are seeing here, 0 to infinity x cube e to the power minus x dot dx. So this is what you need to calculate now. Is that clear to you? So this is our question now, that this is something that I need to calculate. If I am able to calculate expectation of x square, if I am able to calculate this particular integration, then my job is done. So we need to go to now signal system. Do you remember what was the Laplace transform of e to the power minus t ut? That was 1 upon s plus 1. What was the Laplace transform of t e to the power minus t ut? That was 1 upon s plus 1 whole square. What was the Laplace transform of t square e to the power minus t ut? That was 2 s plus 1 whole cube. And what was the Laplace transform of this particular thing? Basically, we just need to differentiate and then add a negative sign. So 6 s plus 1 to the power 4. Right? Now you know that Laplace transform is given as, how it is given? Laplace transform is given as minus infinity to infinity x of t e to the power minus st dot dt. Right? Now here, in place of s, if I put 0, what I will be getting? Minus infinity to infinity x of t dot dt. What is our x of t now? Minus infinity to infinity t cube e to the power minus t ut dot dt. Because of this ut, the limit can change from 0 to infinity. So 0 to infinity t cube e to the power minus t dt. Say yes or no. So you are finding the integration of t cube e to the power minus t dt. What that is coming out to be? Whatever the Laplace transform you are having, in place of s you put 0. So in place of s, if I put 0, 6 upon s plus 1 to the power 4. In place of s, if I put 0, what I will be getting? 6. So what is the answer you are getting? 6. So t cube e to the power minus t dt is giving you 6. So x cube e to the power minus x dx, what it will give you? 6 only. There you go. So what is the answer you are getting? 6. This is the answer. So this is the answer of your variance. So sigma x square is equals to ex square, that is 6 minus 0 whole square. So that would be equivalent to 6 only. There you go. This is the answer. So variance is 6. What was the mean? 0. What do you think? What will be the answer of this one? 17th order movement about origin. Do we have the page? No, we don't have the page. So 17th order movement about the origin. What you need to find? So let's do it here. It is very simple actually. Movement about origin and 17th order. So what that would be equivalent to? Minus infinity to infinity x to the power 17, x to the power 17, 1 by 2 outside, mod of x e to the power minus mod of x dot dx. Now let me know what is this, even or odd? Odd, right? If you put in place of x, if you put minus x, what will happen? Minus sign will come outside. Positive sign, minus sign will come outward. So this is an odd function. And if it is an odd function, that means integration will throw 0. That's it. 17th order movement about origin. That would be equivalent to 0 only. Well and good. Okay. So all answer we have put 6 here, 0 here, and for this one as well, 0 answer. Okay. Let's go to this question. Random variable x represents the number of time dice needs to be thrown till 3 is observed for the first time. Find the expectation of x. What it is saying? What do you think? What is your random variable x here? Random variable x is number of times dice needs to be thrown till 3 is observed. So number of times dice needs to be thrown till 3 is observed. This is your random variable x. Now what should be your sample space? What do you think? So if I throw the dice one time, basically what you are doing, you are throwing the dice until 3 is coming. So you throw the dice, on the first time only 3 will come. So what you will do, you will stop here. Say yes or no. So how many times you throw the dice? Only once. Are you able to understand this point? Then what you did? You throw the dice. On the first time 3 did not come, but on the second time 3 came. So how many times did you throw the dice? 2. Now what you did? You throw the dice. First time 3 did not came. Second time 3 did not came. Third time 3 came. So number of times you throw the dice is 3. So you are doing the experiment until you get 3. So what may happen? Then you get 3, and this process may keep on going. So x can take value 1, 2, 3, 4 and so on. So what do you think? What will be the probability of a random variable x taking value 1? That means you throw the dice one time and you get 3. Let me repeat the statement again. You throw the dice one time and you get 3. What is the probability of that? 1 by 6. Now what is the probability of random variable x getting value 2? You throw the dice 2 times. On the first dice, you throw the dice 2 times. You throw the dice 2 times. On the first dice, you do not get 3. Apart from 3, any number you can get. On the second dice, you get 3. On the first dice, you should not get 3. That means any number you can get. 1, 2, 4, 5, 6. Any number you can get. 5 by 6. And on the second dice, you need to get 3. So 5 by 6 into 1 by 6. Probability of random variable x taking value 3. That means 3 times now. On the first dice, you should not get 3. Any value but not 3. On the second dice as well, any value but not 3. On the third dice, 3. Right? And so on. In that manner, it will keep on going. So this is your probability of taking all these values. What you need to find? You need to find the expectation of x. So expectation of x would be equals to what? If random variable is taking value 1, probability is 1 by 6. If random variable is taking value 2, probability is, if random variable is taking value 2, the probability is 5 by 6 into 1 by 6. If random variable is taking value 3, then probability is 5 by 6 into 5 by 6 into 1 by 6. If random variable is taking value 4, then probability would be 5 by 6 into 5 by 6 into 5 by 6 into 1 by 6. So if you have enough practice, then directly this step you will be writing in the examination hall. You will understand, okay, x is the number of times dice is thrown. So 1 time, 2 time, in that manner I will throw the dice. So in 1 time only if I am stopping, that means I am getting 3. In 2 times if I am stopping, that means first dice I did not get 3, second dice I got 3. So 5 by 6 into 1 by 3. Sorry, 5 by 6 into 1 by 6, and in that manner you will keep on going. So this is the last step that you are getting, expectation of x, right? So I will just copy it. You just need to solve this summation now. So this has become a question of aptitude. So what you will do, 5 by 6 into expectation of x. This is what I will do. So basically I will multiply this first term with 5 by 6. So what I will be getting, 5 by 6 into 1 by 6, because there are infinite terms, no. Now I will multiply this second term with 5 by 6. So what I will be getting, 2 into 5 by 6 into 5 by 6 into 1 by 6. This term is being multiplied with 5 by 6. Now this term will be multiplied with 5 by 6. Basically all the terms are being multiplied with 5 by 6. So all the terms are being multiplied with 5 by 6. So now 3 into 5 by 6 into 5 by 6 into 5 by 6 into 1 by 6 and so on. Now subtract both of them. What you are getting? What I am doing, I am subtracting both of the equation. Equation 1 minus 2. So expectation of 1 x divided by 6, that would be equals to 1 into 1 by 6 plus 2 into 5 by 6 into 1 by 6 minus 1 into 5 by 6 into 1 by 6. So that would be equals to 5 by 6 into 1 by 6 plus 3 minus 2 will be 1. So 5 by 6 into 5 by 6 into 1 by 6, and in that manner it will keep on going. Okay. So what is the answer? A upon 1 minus r. What is the value of r? 5 by 6. Right? A upon, what is the value of r? R is 5 by 6, no? So if you multiply 5 by 6, then again multiply with 5 by 6. So a upon 1 by 6, a upon 1 minus r. R value is 5 by 6. So 1 by 6 divided by 1 by 6. What is the answer you are getting? 1. So expectation of x divided by 6 is equals to 1. That means expectation of x is coming out to be 6. This is the answer. So what they are saying, that means in 6 throws it is expected that you will get 3 at least once. In 6 throws it is expected that you will get 3. And just think about it, no? Like on the dice, how many numbers are there? 6 numbers are there. So expectation, what expectation will do? Expectation will say that I will take the worst case. That on the first dice you are getting 1, on the second dice you are getting 2, on the third dice you are getting 3, on the fourth dice you are getting 4, on the fifth dice you are getting 5, on the sixth dice you are getting 6. That means what you are getting? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this is the general case expectation will take. So it is surely expected, no, that in 6 dice, in 6th throw, at least you will be getting a 3. So what they are saying, x represents the number of times you need to throw the dice. That means it is expected that you need to throw the dice 3 times such that 3 is observed for the first time. Like, are you able to understand interpret the meaning of expectation here? This is what I am saying. Just try interpreting the meaning of expectation here. Let's just say I design a dice where I can get 8 values. Where I can get 8 values. 1 I can get, 3 I can get, 4 I can get, 5 I can get, 7 I can get, 8 I can get, 9 I can get, 11 I can get. Yeah, so these values I can get. Now if I ask you, find the expectation of random variable x, and random variable x is such that it represents the number of times dice needs to be thrown such that 4 is observed for the first time. What will be the answer? Expectation of x will be 8 only. Why 8? Because 8 values can come. So although we will not use our intuition in the examination, we will solve by this. But once the answer comes, we can match it with the intuition. Are you able to understand this point? Okay. Let's go to the next question. Not the next question, next concept actually. Okay. So now we have studied, we were studying about movement about origin. Now we will study about joint movement about origin. Joint movement of a random variable x and y about the origin. So joint movement of order 1, 1 of random variable about the origin of random variable x and y. So what they are saying, movement about the origin, that means x minus 0, y minus 0. What is the order? 1 of random variable x and y. So this is given by expectation of xy. So what was your expectation of x? Expectation of x was minus infinity to infinity x fx of x dot dx, right? So what would be your expectation of xy? Xy, whatever that is written inside, capital small xy. Now, what do you think what should come? What kind of PDF should come here? Joint PDF will come, right? Because this expectation you are calculating for random variable x as well, for random variable y as well. So here what will come? Joint PDF will come. Dot dx dot dy, and here you will put the limit of x as well, you will put the limit of y as well. We are going to solve very good questions here, okay? So what you understood? Expectation of xy, expectation of xy, it is known as rxy as well, okay? What it is known as rxy. What I will do? Minus infinity to infinity, minus infinity to infinity, xy, fxy, x comma y, dx dy, and it is having a specific name which is known as correlation between random variable x and y. Correlation between random variable x and y. So this particular formula is important. Is that okay for you? Correlation between random variable x and y is given by exy, that is shown by rxy, minus infinity to infinity, xy, fxy, x comma y, dx dy. Is that okay for you? All good? Joint order movement of order rk about the origin for random variable x and y. So about the origin you need to find the movement of order r and k. What that would be equivalent to? You will take the limit of x and y. You will take the limit of x and y, x to the power r, y to the power k, fxy, x comma y, dx dy. Very rare chance that anyone would ask it, but still if in the examination they are asking it, you should be having the concept that you should be able to calculate this particular integration, okay? So very easily you will be able to calculate this particular integration, but from this slide this is the important part. Correlation between random variable x and y is given by xy, fxy, xy dot dx dy, okay? And the notation is rxy. So this notation should also be clear, and this definition should also be clear. Joint movement about mean of order 1 comma 1 for random variable x and y. About what? About mean, okay? So what will be the mean of random variable x? The mean of random variable x is mu x, and what will be the mean of random variable y? That will be mu y, okay? So what they are asking? Movement about mean. Movement about mean. What is the order? 1. Movement about mean. What is the order? 1. So it could be given as x minus mu x into y minus mu y. So let's solve it inside. What you are getting? X into y, x into mu y minus mu x into y plus mu x mu y. So what you are getting? Expectation of xy minus mu y is a constant. So mu y expectation of x minus mu x is a constant. Mu x expectation of y. Mu x mu y both are constant. Well and good. So expectation of xy minus mu y, expectation of x is mu x minus expectation of y is mu y plus mu x mu y. What you are getting? This and this is getting cancelled. So what you are getting? Expectation of xy minus mu y could be written as expectation of y, and mu x could be written as expectation of x. So I can write it down, expectation of x into expectation of y. So this is what it is coming out to be, which is first order 1 comma 1 order movement of random variable x about random variable x and y about mean. So this is how it is coming out to be, right? And again this is having a specific name. So this is known as covariance of random variable x and y, that is given by cxy, sometimes covariance, or sometimes sigma xy as well. Whatever the notation they use, they will write it down. Covariance sigma xy or cxy. Screen इतनी white क्यों लग रही है भाई? Why this screen is looking white? Okay, so Cxy or sigma xy, this is what they will write down. That is coming out to be Exy minus Ex into Ey, right? And can I write it down in which manner? In this manner as well, that Rxy minus mu x mu y. There you go. So this particular answer is not answer, this particular box is also important. Here if I don't add it in a box, then also it is fine, whatever the answer you are getting, but let's keep the box. But this is the final conclusion that is important, and this is the final conclusion that is important. So what we understood, covariance and correlation. The name looks same, okay? Covariance and correlation, the names are kind of same, but they are totally different. One is expectation of xy, one is expectation of xy minus expectation of x dot expectation of y. Okay, so covariance and correlation. If this is star important, then this is 3 star important. Okay, like we will be talking about covariance more. So covariance is the boss, this guy is the boss, because covariance is already having correlation. Okay, so covariance is the boss. So correlation between random variable x and y is given as expectation of xy, and that is given as minus infinity to infinity minus infinity to infinity xy fxy x comma y dx dy. What do you understand by covariance? So covariance is sigma xy, or it could be written as cxy as well, and that is exy minus ex ey. That is, what is your exy? Your exy is rxy minus mu x mu y, which is equals to cxy, right? Now correlation coefficient, there is something called correlation coefficient. This can also be asked in the examination, correlation coefficient. So the name is correlation coefficient, that means you think that it should be related with correlation. No, correlation coefficient is actually related with covariance. So correlation coefficient is actually covariance of random variable x and y divided by standard deviation of random variable x and standard deviation of random variable y. Okay, sigma xy divided by sigma x into sigma y. What is sigma y? Standard deviation of random variable y. What is sigma x? Standard deviation of random variable x. What is sigma xy? Covariance of covariance between random variable x and y. Okay, you know the definition of covariance as well, you know the definition of correlation as well, everything you know. So this is the slide complete conclusion. So with respect to random variable x, what you define? Mean and variance. With respect to random variable y, what do you define? Mean and variance. With respect to random variable xy, what you will define? And here I will write down that you define fx of x as well, and here you define fy of y as well. But with respect to x and y, what you will define? Joint PDF, and along with that, what you will define? Rxy, and you will define sigma xy, or you call it covariance of random variable x and y. So this was your correlation and this was your covariance. Correlation, covariance. Covariance is the boss. Covariance is the boss. Second guy is the boss. So exy minus ex ey. Okay. Correlation coefficient is sigma xy divided by sigma x dot sigma y. The name is correlation coefficient, but it is associated with covariance only. Well and good. Now w is equals to ax plus by is given. You need to find the mean square value and variance of w. What you need to find? Mean you need to find. What is x? X is a random variable. This is a constant. This is a constant. Constant. X is a random variable. Y is a random variable. What we need to find? We need to find the mean of random variable w. Then we need to find mean square value. That means, and then we need to find variance. So these things we need to find. So do it on your own. I will take a pause. You can surely do it on your own. Whatever that we have studied, in that manner you try doing it, everything will be clear to you. Okay, so you try doing it on your own. I will take a break and then I will come back and I will solve it. Yeah, welcome back. So did you guys try this question? We need to find expectation of a random variable w. So that could be equivalent to expectation of random variable ax plus by. So a is a constant. So a into expectation of x plus b into expectation of y. यार ये टेढ़ा कैसे जा रहा है सब? b into expectation of y. So that would be expectation of x could be written as mu x plus expectation of y could be written as mu y. So expectation of w is coming out to be a mu x plus b mu y. So everyone would have done it, right? Next we need to find mean square value. So for finding mean square value, what I will do? I will do the square of this one. A square plus b square plus 2ab, right? Square I am doing. So what you are getting? A square expectation of x square plus b square expectation of y square plus 2ab expectation of xy. Say yes or no. This is the answer. No need to mug up. Okay, no need to mug up. Very easily you can derive it. If this question they are asking, very easily you can derive it. If this question they are asking, very easily you can derive it, right? Just constant value are taking outside, very easily you can do it. But now whatever the result we are getting for this one, what we need to find? Variance. So that result we will remember. So what we need to do? This minus this. This is what we need to do, right? Expectation of w square minus expectation of w whole square. So expectation of w square is given as a square expectation of x square plus b square expectation of y square plus 2ab expectation of xy minus. You need to do the square of this one and then you need to subtract it. So what will be the square of this one? A square, basically I am doing the square of this one, a square plus b square plus 2ab mu x mu y, right? And then I will open this bracket, that means all the positive sign will become negative sign. So what you are getting? A square expectation of x square minus mu x square, expectation of x square minus mu x square plus b square, expectation of y square minus mu y square plus 2ab, expectation of xy minus mu x mu y could be written as expectation of x into expectation of y. Do you recognize this particular thing? Expectation of x square minus expectation of x whole square. What is this? Sigma x square, right? Plus b square. What is this? Sigma y square plus 2ab. What is this? Covariance of random variable x and y. Covariance. So, since we are writing down everything in terms of sigma, so here I will write down covariance of random variable x and y. So this is your final answer. Is that clear to you? So expectation of w, no need to mug up. Expectation of w square, no need to mug up. Final answer you need to remember. What you will do? This slide is of no use. So do you remember w is equals to, not w, y equals to ax plus b. Here y is already given, so I will use something different. Let's use z equals to ax plus b. So what was your sigma z square? So sigma only cares about randomness. Constant value was there, sigma x square. B is there. It is not having any randomness. It is a constant value, right? Since it is a constant value, it is gone. So sigma z square was a square sigma x square. Here ax plus by. So a is also having randomness. B is also, sorry, x is also having randomness. Y is also having randomness. So a square sigma x square plus b square sigma y square plus 2ab sigma xy. So it's like the formula of a square plus b square plus 2ab. So a square sigma x square plus b square sigma y square, and 2ab is having both x and y. That means I will use here covariance. So what is this? Always remember, this is the covariance. And don't forget what is sigma xy equals to. Sigma xy is equals to exy minus ex into ey. Okay, very simple thing, very simple. Well and good. So let's make this question more challenging. What we can do, one of them we can make negative, 3x minus 2y. W is equals to 3x minus 2y. This is what we are doing. So x mod is given. What is that? What does that mean? Here this is the meaning. Here this means expectation of x. Although in the theory it will be written. If this question is coming in the examination hall, they will write down that it is the mean square value. That means it is expectation of x square. Okay, this is given. And what is this? This is covariance. So they will write it down in the examination. So all these things are given. What you need to find? You need to find the mean square value and variance of W. So first thing, I will think about mean. So what I will think? 3 into expectation of x minus 2 into expectation of y. So 3 into expectation of x I already know, minus 2 into expectation of y. Expectation of y is 2. 3 into expectation of x is 1 by 2, minus 2 into expectation of y is 2. So 3 by 2 minus 4. What that would be? Minus 5 by 2. Mean square value. If they are asking me mean square value, do I remember any formula for this? No, I don't remember any formula. So what I will do? Simply expectation of W square I will do. So A square plus B square minus 2AB. So 12 xy. Right? So what I will be getting? 9 into expectation of x square plus 4 into expectation of y square, 12 expectation of xy. So you are having this value, expectation of x square you are having, expectation of y square also you are having, but expectation of xy you are not having. So for that I can use the covariance formula. So what does the covariance says? Covariance says that I am equals to expectation of xy minus expectation of x into expectation of y. So covariance is given, that is minus 1 by 2 under root 3. So that would be equals to E of xy minus, what is your E of x? 1 by 2. What is your E of y? 2. So E of x is 1 by 2. E of x is 1 by 2. E of y is 2. So what you are getting? Expectation of xy is equivalent to 1 minus 1 by 2 under root 3. So this is your expectation of xy. Okay. Although this was not asked, but here it will be used. So our expectation of W square, that is coming out to be 9 into 5 by 2. 9 into 5 by 2 minus, sorry, plus 4 into 19 by 2 minus 12 into this value is 1 minus 1 by 2 under root 3. Okay, 45 by 2 plus 38 minus 12 plus 6 by under root 3. So whatever you get, you will get it. Okay, you can solve it, right? So I will write down the answer. I will solve it and I will write down the complete answer. Yeah, so the answer we are getting is 59.16. Okay. Next, we need to find variance. So although we are having the value of EW square as well, we are having the value of EW as well. So we can easily find the variance, but let's apply the formula that we remember. So variance formula, what we remember? A square sigma x square. Basically, what is your W? W is given as 3x minus 2y, right? 3x minus 2y. So your sigma w square would be 9 sigma x square plus minus 2 square, that would be 4 sigma y square plus 2ab, but here there is a negative sign, no? So this will also be negative. So 12 cxy. Say yes or no? Understood? Did you understand this point? This formula I am applying, nothing else. This formula, a square sigma x square plus b square sigma y square plus 2ab sigma xy. So 9 sigma x square plus 4 sigma y square minus 4 into 3, 12 cxy, right? So directly I will put 9 sigma x square. Okay, we are not having the value of sigma x square as well. So from here we need to find the values of sigma x square and sigma y square as well. So what is the value of sigma x square? 5 by 2 minus 1 by 4, right? 5 by 2 minus 1 by 4. And what will be the value of sigma y square? So this will be 19 by 4. No, sorry, 9 by 4. What would be your sigma y square? That would be 19 by 2 minus 4. 11 by 2. 10. Yeah. So 9 by 4, 11 by 2. Yeah. So 9 into, this is 9 by 4 plus 4 into 11 by 2 minus 12 into minus 1 by 2 under root 3. Well and good, right? So you will solve this, you will get the answer. Another answer could be simply I could have done this square minus this square. This also I could have done. That means 59.16 minus, what answer I was getting here? Minus 5 by 2. So plus 5 by 2. So this is 2.5. So 51.96 plus 2.5. So 6, 4, 4, 54.46 I will be getting. 54.46. So let me solve this one and let me check if 54.46 I am getting or not. Yeah, actually we did a mistake here, right? Blunder it was. Expectation of W, what was expectation of W? Minus 5 by 2, no? So minus 5 by 2 whole square. So this would have been the answer. Basically answer would have been 59.96. That was a very bad mistake from my side. That was 45.71. So this answer was 45.71. Here also you would get the 45.71 as well. So this was actually the complete method, that you find out E of W before and then you find out E of W square as well, and then you get sigma W square, and this is just the formula. Okay, so two methods are there. Whatever you want to use, you can use it. Next, to find the correlation coefficient of random variable x and y. Correlation coefficient. What we need to find? Correlation coefficient. Correlation coefficient of random variable x and y. That was given as sigma xy divided by sigma x into sigma y. So sigma xy are you already having? Sigma xy are we already having? No, we are not having sigma xy, right? Yeah, so we are having no covariance. Covariance. This is your sigma xy, no covariance. So minus 1 by 2 under root 3 divided by. Are you having sigma x? Yes, sigma x is under root 9 by 4. What is sigma? Sigma x square is 9 by 4. So sigma x would be under root 9 by 4. That means you can write it down as 3 by 2. Basically sigma x square is 9 by 4. So sigma x would be under root of 9, that is 3, under root of 4 will be 2. And what would be your sigma y square is given as 11 by 2. Sigma y is equals to under root 11 by 2. So you can solve it whatever the answer you get. So this was your correlation coefficient. Sigma xy upon sigma x dot sigma y. So sigma xy was already there, sigma x was already there, sigma y was already there. So this question was just purely based on the formula. Whatever the formula that we have studied, we just revise over the formula, nothing else, right? So purely it was formula based. Well and good. Let's move to the next. So there is an important note. In the statement, what could be written? That random variable x and y are orthogonal. So if your random variable x and y are orthogonal, what is the meaning of that? That your exy would be equals to 0. Orthogonal random variable. That means your correlation will be equals to 0. Correlation will be equals to 0. So what about your covariance? So covariance is given by exy minus exey, right? This is how your covariance is given. Now this is equals to 0. So your covariance would be coming out to be minus mu x mu y. So first could be mentioned orthogonal, that your random variable x and y are orthogonal. So how would you remember that E of xy is equals to 0? Whenever they talk about orthogonal in whole electronics, they talk about 0. Do you remember orthogonal signal? xt x1t dot x2t conjugate you integrate dot dt is equals to 0. Then your x1t and x2t are called orthogonal, right? So whenever you talk about orthogonal, you talk about 0. Do you remember orthogonal vectors, orthogonal matrix? There as well you talk about 0 only. Orthogonal matrix means there also you multiply two matrix equated to 0, right? So here also orthogonality means simply means something should be equated to 0. So x and y are orthogonal random variables. That means E of xy should be equal to 0. If you remember E of xy is equal to 0, then you can write down everything, right? Uncorrelated. If it is given that x and y are uncorrelated random variable, that means expectation of xy, E of xy would be equals to E of x dot E of y. Okay, basically you can separate them. Is that okay for you? Expectation of xy would be equals to expectation of x dot expectation of y, right? So you can say that my rxy, this is my rxy, right? It would be coming out to be mu x mu y. And what was your cxy? Your cxy was equivalent to E of xy minus E of x E of y. So what they are saying, uncorrelated, but here correlation is not equals to 0, covariance is equals to 0. Are you able to understand this point? What they are saying, that they are uncorrelated, but still your covariance is equals to 0. Your sigma xy is equals to 0. Your correlation is not equals to 0. It feels like that, sir, correlated. Correlated means correlation, but no, it has nothing to do with the correlation. It has something to do with the covariance. That's why I said that covariance is the boss. Here I said, who is the boss? Covariance is the boss. So whatever we will be talking about, mostly we will be focused towards covariance. So don't remember anything. Just remember this particular thing and this particular thing. That's it. Only these two things you need to remember. Are you able to understand this point? X and y are orthogonal. E of xy is equals to 0. X and y are uncorrelated. That means E of xy is equals to E of x dot E of y. X and y are independent. So x and y are independent means any function of x and any function of y, and you take their expectation, that would be equivalent to expectation of gx capital X, any function of random variable x dot expectation of not having enough space, uncorrelated, independent, expectation of any function of random variable x, any function of random variable y would be equals to expectation of random variable x into expectation of random variable y. Basically here any function could be there. Basically what does that mean? 2x plus 3 into y square plus 2. So this will be equals to expectation of 2x plus 3 multiply with expectation of y square plus 2. If your x and y are independent random variable, if your x and y are uncorrelated, then only this relation is true. This relation is not true for uncorrelated. So this is the difference between uncorrelated and independent. Okay. So here strictly random variable x is written. Strictly random variable x is written. Here strictly random variable y is written. But here any function of random variable x, any function of random variable y. Okay. Is that okay for you? Right. And another thing you already know, that if your x and y are independent random variable, then this particular thing is also true. So basically whatever uncorrelated is having, independent is already having that. But whatever independent is having, uncorrelated is not having. Are you able to understand what I am saying? Whatever independent is having, uncorrelated is not having. But whatever uncorrelated is having, independent is surely having. Right? So these two things are there for independent random variable. So let's see the again major difference between independent and uncorrelated random variable. So if I am saying that x and y are independent random variable, that means any function of random variable x and any function of random variable y, if you are calculating their expectation, so that would be equivalent to expectation of gx, expectation of hy. Okay, basically expectation of x square plus 3 dot expectation of y square plus 2y plus 4. But for uncorrelated, only x and y should be there. That means expectation of xy would be equals to expectation of x dot expectation of y. And if this is the scenario, then surely your covariance will also be equals to 0. So don't care much about correlation. Okay, we will not care about much of correlation, but we will care about correlation at all. Okay, we will care about covariance. Okay, not correlation, we will care about covariance. So covariance is 0 here, which you can write down from here very easily. But here you cannot say that if x and y are uncorrelated, that means you cannot say that this would be surely equal. No, you cannot say. Okay, you cannot comment much about this. So here not equals to sign, but here equals to sign. This is the difference. And if x and y are independent, then they are surely uncorrelated. But if x and y are uncorrelated, then they may or may not be independent. Is that okay for you? All good? So statements in the line, there could be written that x and y are independent random variable. So you should know this particular thing and this particular thing. X and y are uncorrelated. Uncorrelated means cxy is equals to 0. Uncorrelated. Okay. Expectation of xy is equals to expectation of x dot expectation of y. Now what is the meaning of covariance? Covariance means expectation of xy minus expectation of x dot expectation of y. So that means they are equal. So c of xy covariance is equals to 0. Okay. And orthogonal means, what is the meaning of orthogonal? Orthogonal means expectation of xy is equals to 0. All good? All fine? So let's see this question. fxy is given, xy divided by 9. You need to find the covariance of random variable x and y. Then you need to check independency, orthogonality and uncorrelation. Basically they are they are correlated or not. They are uncorrelated or they are correlated. Basically this particular thing and this particular thing you need to check. So first thing is you need to find the covariance of random variable x and y. What you need to find? Covariance of random variable x and y. So that would be equivalent to expectation of xy minus expectation of x dot expectation of y. This is what you need to find, right? Covariance. That means you need to find expectation of xy as well. You need to find expectation of x as well, and you need to find expectation of y as well. How will you find expectation of xy? Whatever the region it will enclose, in this region, what you will do? xy, fxy, xy dot dx dy, right? How will you find expectation of x? So whatever the limit of x is there, x dot fx of x dot dx. And how will you find expectation of y? Whatever the limit of y is there, y dot fy of y dot dy. You would require fy of y, you would require fx of x. marginal PDF of random variable x, marginal PDF of random variable y. So you know that how to find this one, you know how to find this one, then you can integrate. You are already having this particular thing and you know how to integrate over a surface as well. So do this thing on your own. Do everything on your own. I will pause the video, take a break. You should be able to do this particular question. Now everything we have studied in the last lecture. That's why I spent 3 hours there. Every particular surface I was taking, I was telling you this particular formula you can use, like this is how you can integrate. So we have spent 3 hours in the last lecture only for this purpose. Now this lecture will be very easy for you. Otherwise things would have become very complex. So do it on your own. Okay, I will post the video, you do it on your own. Yeah, welcome back. So let's do this question. Here random variable x is taking value between 0 to 2 and y is taking value between 0 to 3. So random variable x is taking value between 0 to 2. I told you whenever there is a question based on 2-dimensional random variable, the first task would be always you make the region of working. So region of working would be random variable x taking y taking value between 0 to 3 and x taking value between 0 to 2. Right? So this will be our region of working. Here we need to talk about everything. Right? So I can take the strip or whatever I want to take. There I will take here. Right? So eventually to solve this problem I need to find fx of x and fy of y as well. So how will I find fx of x? So you remember one thing, that fx of x will be a function of x. That means what I will take, I am having my fxy, but I will integrate with respect to y. If you are integrating with respect to y, that means you will take the horizontal, or I would say not horizontal, vertical strip. So limit of y is going from y equals to 0 to y equals to 3. Y equals to 0 to y equals to 3. So what is given? X by y 9. dy y equals to 0 to 3. So what you are getting? X by 9 outside, y square by 2, 0 to 3. So it is coming out to be x by 2. So your fx of x is coming out to be x by 2 for the limit of x going from 0 to 2, right? Limit of x is actually going from 0 to 2 only, no? For the limit of x going from 0 to 2, this is your fx of x. And if I need to calculate fy of y, what that would be? X going from, what I will do, I will take the horizontal strip, right? So I will take the horizontal strip, and in this horizontal strip, what do I see? For value of y going from 0 to 3, x is going from 0 to 2. X is going from 0 to 2. I don't need to write it down. This is very pretty obvious, right? Very obvious. And here also the same thing, xy by 9, but dot dx, right? So y by 9 will come outside, x square by 2, 0 to 2, so 2y by 9. So this is your fy of y. You are getting fy of y as 2y by 9 with values of y going from 0 to 3. There you go. So two things you have got, fx of x, fy of y. Here only you can see one thing, that your fxy x comma y is equals to fx of x, fy of y. If you multiply both of them, what you are getting? X by 2 into 2y by 9. What you will get? Xy by 9. And that is equals to fxy only. So from here only your job is done. Which kind of job is done? From here only you can say that x and y are independent. X and y are independent. And if they are independent, that means surely they will be uncorrelated as well. What did I say? If x and y are independent, then surely they will be uncorrelated as well. Without even finding all these things, I just said that x and y are independent. Along with that, I can say that x and y are uncorrelated as well. Y are uncorrelated as well. Right? Next, I need to care about what I need to care about. I need to care about expectation. I need to care about orthogonality now. Right? I need to care about orthogonality. So from here, what I need to find? Expectation of xy. Because if your expectation of xy is coming out to be 0, If your expectation of xy is coming out to be 0, then you can say that it is orthogonal, right? X is going, you can take any strip, x will go from 0 to 2, y will go from 0 to 3. Very simple. X will go from 0 to 2, y will go from 0 to 3. And directly you can see here is that it will surely not come out to be 0, right? Or you can see xy. What is the value of fxy? Value of fxy is xy by 9. Value of fxy is xy by 9. Dot dx dy. Limit of x going from 0 to 2, limit of y going from 0 to 3. 1 by 9. This is x square, right? So x cube by 3 going from 0 to 2. Then y cube by 3 going from 0 to 3. So 1 by 9 into 8 by 3 into 9. So what is the answer you are getting? 8 by 3. Expectation of xy is coming out to be 8 by 3. Simple integration you can solve it. X cube by 3, y, here you will get y square, so y cube by 3, 1 by 9 was constant. Then 8 by 3, here you will get 27 by 3, which is equals to 9 only. So 8 by 3 is the answer, right? And if I ask you expectation of x, so what that would be equals to, x is going from, what is the limit of x? X is going from 0 to 2. X is going from 0 to 2. X fx of x dot dx. So 0 to 2. What is your fx of x? Your fx of x is x by 2. So what you will get? X square by 2 dot dx. So here you will be getting x cube by 3. So it would be 6 from 0 to 2. What is the answer you are getting? 8 by 6, right? And what will be your expectation of y? Y is going from 0 to 3, right? Y is going from 0 to 3. And what is the function of fi of y? Function of fi of y is 2y by 9. So it is 2y square by 9. dy, what you will be getting? 2y cube divided by 27, 0 to 3. So what is the answer you are getting? 2. So what you can see directly here, expectation of xy is coming out to be 8 by 3, which is not equals to 0. Along with that, expectation of x is 8 by 6 and expectation of y is 2. If you multiply both of them, expectation of xy is actually coming out to be expectation of x dot expectation of y, which was pretty expected as well, because here only I said that they are uncorrelated. So yes, so what did you understand? They are independent, they are uncorrelated, but they are not orthogonal. There you go, your job is done. This question is also done. Okay, let's solve the next one. You need to find the variance of random variable z. So all three conditions are given. So first let's find the variance of random variable z. What that would be? Variance of random variable z would be equals to 9 into random variable, variance of random variable x, 16 into variance of random variable y plus 2ab. So 4 into 3, 12, 12 into 2, 24. 24 and then covariance, right? 9 sigma x square plus 16 sigma y square minus plus 2ab actually, but this is a negative sign. So minus 24 cxy. Now x and y are uncorrelated. This is the answer. This is the answer. But let's check the first condition. X and y are uncorrelated. Uncorrelated. X and y are uncorrelated. So what you will think? X and y are uncorrelated. So what you will think? Okay, x and y are uncorrelated. That means this particular thing is there, right? This particular thing is there. Now, what do you think? What will be the value of cxy now? So sir, cxy is given as exy minus exey. I am just telling that in the exam how will I solve it. Otherwise I would have directly said that uncorrelated means covariance should be equal to 0. So this is your covariance, that should be equal to 0. But how will you think? Uncorrelated, that means expectation of xy is equal to expectation of x dot expectation of y. That means both are equal, so cxy is equal to 0. So answer for the first one would be sigma z square would be equal to 9 into sigma x square plus 16 sigma y square. That's it. For the second one, if x and y are orthogonal, okay, you will think orthogonal. Orthogonal means surely it has something to do with 0. So what will be my cxy equivalent to? Here you will put 0, so that would be equal to minus mu x mu y. If I put exy equals to 0, so 0 minus expectation of x into expectation of y. So expectation of x I am putting as mu x, expectation of y I am putting as mu y. So what will be the answer I will be getting? Sigma z square would be equals to 9 sigma x square plus 16 sigma y square, and here in place of cxy what I will put? Minus mu x mu y. So what answer I will be getting? 24 mu x, sorry, mu x mu y, 24 mu x mu y. So whatever the condition is given, based on that you can get your answer. And what about the third one? So third one and option A and option C will be same only, because if x and y are uncorrelated, if x and y are uncorrelated, then this is the condition. If x and y are independent, then also this will be the condition. No? At least minimum condition this will be there. If x and y are independent, then this condition will be there, no, for sure. Because for independent, what did we write? For independent, any function of x and y could be there. So g of x could be equals to x, h of y could be equals to y. So at least this condition would be there for sure. So in the independent as well, this answer would be the same. Okay. So A and C will have the same answer. This is the answer of B. Well and good, very simple. Let's move to the next one. X can take, now this time x is your discrete random variable. X is a discrete random variable which can take value -1, 0 and 1. Probability of x taking value -1, 0 and 1 are same, that is equals to 1/3. Y is equals to x square. You need to find expectation of x, expectation of y and expectation of xy, and then you need to comment on all these things. Okay. So first what I need to find? Expectation of x. So what I will do? I will take x and multiply with its I will take x and multiply with the probability of it. So I will take the value of x, I will multiply with the probability. I will take the value of x, I will multiply with the probability. I will take the value of x, I will multiply with the probability. What is the expectation of x? 0. Now I am not having the PDF of y, no, or PMF of y. Here it is discrete random variable, so we will talk about PMF. So expectation of y I need to calculate. So sir, I am not having the PMF of y. So why do you need to calculate the PMF of y? X and y are interrelated, no? So basically you need to calculate expectation of x square, nothing else. Are you able to understand this point? So what you will do? You will do the x square. You will do the x square and will multiply with its probability. You will do the x square and you will multiply with its probability. You will do the x square. You will do the x square and then multiply with its probability. What is the answer you will be getting? 1/3. This will be 1 into 1/3. This will be 1 into 1/3. Answer would be 2/3. Next I need to find expectation of xy. So what do you think what I will do? X and y are having some relation, no? So x cube. In place of y I need to put x square. So x into x square will be x cube. So what I will do? You will do the cube of x and then multiply with its probability. You will do the cube of x and multiply with its probability. You will do the cube of x and multiply with its probability. So what you will be getting? -1/3 plus 1/3, again 0. So what do you see here? Expectation of xy is coming out to be expectation of x dot expectation of y. Along with that, expectation of xy is also coming out to be 0. Expectation of xy is coming out to be 0, that means orthogonality is done. Expectation of xy is coming out to be expectation of x dot expectation of y. That means uncorrelation is also done. They are uncorrelated. Are you able to understand this point? From here, uncorrelation, right? And from here, you can say orthogonality. What about independency? So sir, for independency, sir, I need to check something. What I need to check? Sir, I need to check the PMF. Basically, if they are independent, so I will have to check the PMF. That PMF of xy should be coming out to be as PMF of x multiply with PMF of y. This is what I need to check, sir. This is what we are thinking. Yeah, ideally you should check, but think about it, no. X is already depending on y and y is already depending on x. Directly you can see here, no, that x is depending on y and y is depending on x. Are you able to understand this point? X and y are related with each other. Sorry, x and y are depending on each other, no. Like if x is taking value -1, then y has to take value 1 only. Are you able to understand this point? If x is taking value -1, y has to take value 1 only. Y cannot take any other value. So value of y is depending on x. And if value of y is 1, then x can take either value -1 or it can take value 1. So if y is fixed, then x is also fixed. That means x can take only 2 values. So x and y are depending on each other, no? So they are not independent. Okay? X and y are depending on each other. Depending on each other. That's the bottom line. Well and good. Okay. Let's go to the next question. So this is a very simple question. If fx of x is equals to fx of minus x, then you find the expectation of x. What does that mean? That fx of x is equals to fx of minus x. That means PDF of random variable x is even. PDF of random variable x, random variable capital X is even. Say yes or no. Fx of x is equals to fx of minus x. That means PDF of random variable x is even. This is the meaning, right? So you need to find the expectation of x. So what will be your expectation of x? Minus infinity to infinity x fx of x dot dx. What is this? Even. And what is this? Basically, if I say my gx is equals to x, so this graph is even or odd? G of minus x will be equals to minus x. That means it is equals to minus gx. That means this is your odd. This is odd. And do you remember odd multiply with even? Odd multiply with even. What that would be? Odd only. So this whole function, if I say that my h of x is x fx of x. Okay? My h of x is x fx of x. So what this kind of function is there? Now I am saying that also given that fx of x is equals to fx of minus x. So what you will do, if I calculate h of minus x, what that would be? Minus x fx of minus x. Now I know that fx of minus x is equals to fx of x. So this is your h of minus x. So h of minus x is equals to minus x fx of x. What does that mean? This is coming out to be minus h of minus x is coming out to be minus of hx. What does that mean? That means this h of x is odd. Very simple thing, no? This will be odd only. Only thing I need to prove that this will be odd. And if this is odd, that means the whole integration will be equals to 0. So if your PDF is even, then your expectation of random variable x will be 0. For an even PDF, if your PDF of random variable x is even, then its expectation will be equals to 0. This is what I am concluding. If your PDF is even, then your expectation will be equals to 0. All good? All fine? Now this thing is given. You need to comment on orthogonality, independency and uncorrelation. fxy is given. The complex expression is there. Can you make the region of working? Surely I can make the region of working. Comment on orthogonality, independency and uncorrelation. So all the things which we have already seen. So what I need to make? First I need to make the region of operation. Region of working or region of operation, whatever you say. So x square plus y square should be less than 1. What do you think what I will do? X square plus y square should be less than 1. So first I will make the graph of x square plus y square is equals to 1. What is this? This is a circle, right? I hope you know this is a circle. So this is a circle. X square plus y square is equals to 1. But what they are saying, x square plus y square should be less than 1. That means this particular region will come. Basically what they are saying, x square plus y square should be less than equals to 1. So if you put x equals to 0, y equals to 0, what you will get? 0 plus 0 should be less than 1. 0 is less than equals to 1. Is it satisfying? Yes. That means this particular region will come into action. Okay. This particular region will come into action. So what I need to check? Orthogonality. So what I need to find? Expectation of xy. This I need to find. Dx dy. Also I will have to find uncorrelation. For that I would have to find expectation of x as well, expectation of y as well. So that we will see later on. But as of now, let's find out expectation of xy. So what you need to do? You need to choose a strip. What you will do? You will have to choose a strip here. Right? This is the region of operation. So in this manner, this question will become difficult actually, right? If you choose the strip, so from where to where y will go? So y will go from minus 1 minus under root 1 minus x square to under root 1 minus x square. And x will go from, what this point will be there? X equals to minus 1, 0, x equals to 1, 0. So x will go from minus 1 to plus 1 and y will go from minus 1 under root 1 minus x square to under root 1 minus x square, and then you will have to solve the integration. The integration will become difficult. Yeah, sorry for the interruption. So what I was saying that you can solve this surface integration, but the calculation will be a bit on tougher side, right? So what we will do? So we will use the concept of our EMFT. In EMFT, do you remember the cylindrical coordinate system? What do? We work in the rho direction and then we work for theta, or actually we use the term phi. So first we work for rho and then we go for phi and then we go for z and then we get our full cylinder, right? Similar thing we are going to do here because the integration is tough, no? So what we will do? What I will do is that I will make this circle, but now the circle will not be made with respect to x and y. The circle will be made with respect to our r and theta. So what I will do? I will, from the center I will work for r. From the center I will work for r, and then I will move for the theta angle. This is my x, this is my y. Right? Actually, this should not be y. This should be y actually. This should be y. So I will work in the direction of r, and then I will work in the direction of theta. I will get the complete circle. Basically, I need to cover this particular region. No, I need to cover this particular region. So I will work in r, and I will work in theta. So those who have studied EMFT, they will be able to relate it. So x will be replaced with r cos theta, right? From here you can see that x is r cos theta, and y will be replaced with r sin theta. And what will be your dx dy? So dx dy will be equivalent to r dr d theta. Do you remember all these things? Say yes or no. Right? So this is how we replace all these things. And now I need to solve this integration. Expectation of xy was equivalent to what? In the region R, xy, fxy, x comma y, dx dy. So in the region R, xy, what is your fxy? 6 by pi into 6 by pi x square plus y square dx dy. But now what I will do is that x is equals to r cos theta, y is equals to r sin theta. So what you will get? R square cos theta sin theta. Then 6 by pi is a constant value. X square plus y square will be equals to r square. And in place of dx dy, what you will put? R dr d theta. There you go. Are you able to understand all these lines? What I did was, here I took that, I saw that the limit will be difficult, integration will be difficult to solve. A lot of under root and all these kind of things will come. So what I did, I replaced my x and y with r cos theta, r sin theta. So now I am getting this particular expression. Here the limit of x and y would be there, but now the integration you are doing with respect to r and theta. So what you can see is that your theta will be going from 0 to 2 pi. The limit of theta will be going from 0 to 2 pi. You starting from here 0 to 2 pi, complete path you will move. And from where to where your r will go? R will go from 0 to 1. What is the radius here? Radius is 1. What is the radius of the circle? That is 1. So R will go from 0 to 1. So 0 to 1 and theta is going from 0 to 2 pi. So complete disk you will be covering. Basically this is the disk, no? It is like a disk. So this is what you need to do. R goes from 0 to 1. You are in the direction of R you are working from 0 to 1, 0 to 1, 0 to 1, and in the direction of theta you are working from 0 to 2 pi. So here in the direction of R I am going from 0 to 1. In the direction of theta I am going from 0 to 2 pi. There you go. So what you will do? R square is there. R to the power 5 would be there. Total R to the power 5 dot dr. And here it would be 6 by pi. Right? And limit of R is going from 0 to 1. And here cos theta sin theta. If I multiply and divide by 2, what I will get? 2 cos theta sin theta divided by 2 into d theta. So what is this 2 cos theta sin theta equivalent to? That is equivalent to sin 2 theta. So it is sin 2 theta divided by 2 d theta. And limit of theta is going from 0 to 2 pi. You can solve this integration on your own. This integration will come out to be 0. And you can see that sin 2 theta is having a period of pi. So in 2 pi there will be 2 cycles. So this integration you can solve on your own and this will come out to be 0. So total answer is coming out to be 0. So expectation of xy is coming out to be 0. What does that mean? X and y are orthogonal to each other. Right? X and y are orthogonal. So first thing is done, that is orthogonality. Say yes or no. Very simple thing. If you are comfortable with the EMFT first chapter, or if you are comfortable with mathematics as well, in the mathematics as well we study these kind of things. Whenever you are having the center at origin, then x you can assume as r cos theta, y you can assume as r sin theta, and dx dy would be r dr d theta. And from there you can get all these things. Okay, x you replace with r cos theta, then by replacing this, basically doing all this calculation you are getting answer 0. Even if you are not comfortable with that, so once you study those chapters you will be comfortable, no need to worry. So expectation of xy is coming out to be 0. Well and good. So x and y are orthogonal. Orthogonality is checked. We need to check independency and uncorrelation. So for checking uncorrelation, or if they are uncorrelated or not, so you would require expectation of x, right? You would require expectation of x. And how will you do this? X into fx of x dot dx. And here you will put the limit of x. How your limit of x is going? So x will be going, you will take the horizontal strip, and from there you can calculate it. But before that, all these things secondary part. What is the major part? Major part is, first I need to calculate fx of x, no? First, this is the major part, no? First you calculate fx of x, then you go here. So first calculate fx of x. So how will you calculate fx of x? fxy x comma y dy, and you will put the limit of y here. What is the limit of y? Y is going from minus under root 1 minus x square to under root 1 minus x square. Minus under root 1 minus x square to under root 1 minus x square. Right? So your fxy is 6 by pi x square plus y square. 6 by pi will come outside. X square plus y square dot dy. And limit is going from right. So 6 by pi x square, basically what I need to do, 6 by pi, whatever the limit is there, x square dot dy plus y square dot dy, whatever the limit is there. This limit you can put. So what you are getting, 6 by pi, x square is outside, and then dy. So this is 2 under root 1 minus x square, right, plus y cube by 3. Basically this will be 0 only, right? Why it will be 0? No, why it will be 0? It will not be 0. Sorry guys, it will not be 0, right? So whatever the answer you are getting, but from this answer you will understand something pretty good. Under root, this is your x, right? Under root 1 minus x square plus 1 by 3 is outside, 1 minus x square to the power 3 by 2 minus, and this will become plus 1 minus x square to the power 3 by 2. So this will become 2 times. You can solve the integration. This is what you will be getting, right? And what is the constant? This is your fx of x. This is what you are getting as fx of x with the limit of x. Like basically if your y is going from minus under root 1 minus x square to under root 1 minus x square, then x is going from minus 1 to 1. So with the limit that x is going from minus 1 to 1, this is your fx of x you are getting. Say yes or no. This is the fx of x. Just understand one thing here. What do you understand here? In this limit, in this particular limit, your fx of x is even. What you are saying, when your x is between minus 1 to 1, at that time your fx of x is even, and if it is even, then its expectation will be equal to 0. There you go. Here we proved it, no, that if your fx of x is equal to fx of minus x, that means your expectation of x will be equal to 0. But in the limit, you need to see the limit as well, from minus 1 to 1. That means limit is symmetric, my graph is also symmetric. Let's just say whatever the graph we are getting, whatever the graph that I get between 0 to 1, the same graph I am getting between 0 to minus 1 as well. Let's just say only this graph was there, the limit was between 0 to 1. Even though this graph could be symmetric, but random variable x was taking value from 0 to 1 only. So you cannot say that expectation of x will be 0. Are you able to understand this point? It should be even. Just by looking at the expression, let's just say I wrote down e to the power minus x square, and I am putting the limit of x from 0 to 1. Will you say that it is symmetric? Although it feels like that, sir, in place of x, if I put minus x, it will be symmetric. But symmetric around what? It should be symmetric around origin, no? So before origin, it is not even there. After origin, it is giving you some expression. That I don't care. But it should be symmetric about origin. So limit of x is going from minus 1 to 1. In this minus 1 to 1, it is symmetric. And if it is symmetric, that means its expectation is 0. The ditto same analysis you can do for the y as well. The same analysis, exactly the same analysis you will do. You need to find fy of y. Then what you will do? You will put the limit of x. How will you put the limit of x? In this direction, you will put the limit of x. So what will be the limit of x would be coming? The limit of x would be coming would be under root 1 minus y square to under root 1 minus y square. Exactly the same expression will come. Ditto same expression will come. Okay. So just let me write down the expression of fy of y. So fy of y will have just the same expression. What you will get? 6 by pi, 6 by pi, because everything is symmetric here, no? 6 by pi y square into 2 under root 1 minus y square plus 2 by 3 1 minus y square 3 by 2, going from minus 1 to 1. So here as well, what you can see, this is the expression, and from here also you would see that in the range of y going from minus 1 to 1, fy of y is equals to fy of minus y, and from here you will see that expectation of y is equals to 0. So what did you see here? Expectation of xy is equals to 0 is equals to expectation of x is equals to expectation of y. Along with that, expectation of xy is equals to expectation of x dot expectation of y. So from here what you are getting, that orthogonality is also there and uncorrelation is also there. So orthogonal and uncorrelated, both done. What about independence? Think about it and let me know. You see the expression of fxy, x comma y. What about independence? X and y are independent random variable or not? Look sir, you will say that sir, I need to multiply fx of x and then I need to multiply fy of y. If I multiply both of them, clearly it is visible that it will not come out to be equals to fxy x comma y. Basically, if you multiply this particular thing with this particular thing, will it come out to be equals to this particular thing? Absolutely not. So directly from here you can say that sir, if I go by the mathematics, this is by the mathematics, that sir these are not equal. That means not independent. But just once think about it, without even doing the calculation you can tell that it will be independent. Without even doing the calculation, it will not be independent, sorry. Without even doing the calculation you can say that x and y will not be independent. They are depending on each other, no? Basically what you are saying that x square plus y square should be less than 1. That means x and y will be taking the value such that x square plus y square should be less than 1. What I mean to say is that random variable x and y will be taking values such that x square plus y square should remain less than equals to 1. That means if I say that my x is 1 by 2, then your y has to be under root 3 by 2. Oh sorry, less than under root 3 by 2. Basically if x is 1 by 2, then y is equals to 0. This will work. But y should be less than under root 3 by 2, no? So value of y is depending on the value of x. So x and y are surely depending on each other. If they are depending on each other, that means x and y are not x and y are not independent, are depending on each other. That means they are not independent. There you. So if only independency is asked, do you have to do the calculation? No. If you use your brain smartly, only about independency, uncorrelation, orthogonality, you will have to do the calculation of exy, ex, ey. All these calculation you will have to do. But only independency is asked. If only independency is asked, you can use your brain and then you can say that sir x and y are depending on each other, so they will not be independent, right? So we have seen this case that orthogonality is there, uncorrelation is there, but independency is not there. Although your expectation of xy is equals to expectation of x dot expectation of y, but independency is much more than that. Independency will say that along with expectation of xy is equals to expectation of x dot expectation of y, I will be expecting this thing as well. If this thing is done, then my job is done. If this particular thing was there, then it was independent as well, along with that it would have been uncorrelated as well. But if this thing is not there, then it cannot be independent. And without even doing the calculation, by using our brain, I could see that x and y are depending on each other, so they can never be independent. Now in this question, I am only asking one thing, that x and y are independent or not. So just think about it, no? X and y are depending on each other. If you make this graph, what kind of graph you will be getting? If you make this region, what kind of region you will be getting? X is greater than 0 but less than y. X is greater than 0 but less than y. So x less than y, that means y is larger. Y is larger. Greater than 0 but y is larger. This is the region. And what about y? Y is less than 1. Y is less than 1. So till this point you should be comfortable in making all these region. So y is less than 1. So x will be between 0 to 1. Basically this will be the region of operation. And this is your y equals to 1. This point will be 1 comma 1. So this will be the region of operation, region of working. So this region you can make on your own, and directly you can see here is that x and y are depending on each other. You can see x should be less than equals to y. So if, let's just say if y is 0.5, then x has to be less than 0.5. So value of x is depending on y. That means they are not independent. That's it. So you are not going to find fx of x. You are not going to find fy of y. Then you will say, sir, fx of xy is equals to fx of x dot fx of y. This thing you are not going to do. Just by looking at the expression, you can say that they are not independent. There you go. Okay, well and good. Now solve this question. Only mathematics, purely mathematics it is. Just you need to apply the formula and you will get the answer. X and y are two random variable. Expectation of x is given. Sigma x square is given. Sigma y square is given. What is this? Correlation coefficient. This is your correlation coefficient. What you need to find? You need to find correlation and covariance. So this is your correlation coefficient is given, which is equals to sigma xy divided by sigma x, sigma y. Right? So what is your sigma x? Sigma x is under root 6. And what is your sigma y? Sigma y is 3. So what would be your sigma xy? That would be minus 2 by 3 into sigma x will be under root 3 and sorry under root 6 into 3. So answer would be minus 2 under root 6. So this is your sigma xy. This is the answer. Very, very straightforward. Nothing is there. And what next I need to find? Covariance. Sorry, correlation. Correlation I need to find, which is E of xy I need to find. Right? So you know that if I know sigma xy, that is equals to rxy minus mu x mu y. If you don't remember the expression, you remember the expression of E of xy. Basically, usually we remember this expression. E of xy minus E of x into E of y. So from here, what is rxy is coming out to be? Sigma xy, what is sigma xy? Minus 2 under root 6 plus 2. There you go. This is the answer. Basically, this goes here. So this will become plus and then 2 into 1. Mu x into mu y is 2. Mu x into mu y is 2 into 1. That would be 2. And this goes here. So exy or rxy, whatever you call it. Expectation of xy or rxy you can call it is equals to minus 2 under root 6 plus 2. And here it was very simple. Correlation coefficient was given. That is minus 2 by 3 and that is equivalent to sigma xy, that is equals to covariance divided by sigma x into sigma y. Sigma x is under root 6, sigma y is 3. So 3 into under root 6. So answer is minus 2 under root 6. This is the answer. Well and good. Okay. Now which of the statement is true? If x and y are orthogonal. So they are talking about orthogonal and uncorrelation. So let's write down the condition. Orthogonal. Orthogonal. If orthogonal means expectation of xy would be equals to 0. So what would be your sigma xy? Sigma xy would be 0 minus mu x mu y. That would be equals to minus mu x mu y. Right? And if this is 0, that means rxy would be equals to 0. So rxy is 0 and this is 0. Right? And what about uncorrelation? Uncorrelation means expectation of xy is equals to expectation of x dot expectation of y. Right? What is this expectation of xy? This is your rxy is equals to mu x mu y. If uncorrelation is there, then this particular thing is true. Along with that, this was given as rxy minus mu x mu y. So if both are equal, this would be equals to 0. Very simple thing. This should be done on your own. If you are not able to solve this problem, that means you are not putting your concentration in the class. You need to put the concentration to solve this kind of problem. Very simple it is. Just remember the condition. Orthogonal, expectation of xy is equals to 0. Uncorrelation, expectation of xy is equals to expectation of x dot expectation of y. That's it. Job done. Right? So yeah, this is the end of this lecture. But now we are going to see some mathematics. Basically, our statistical parameter has ended. We have studied about mean square value, variance, movement about origin, joint movement about origin, then movement about mean, joint movement about mean, correlation, covariance and correlation coefficient. So all these statistical parameter we have seen, right? So this chapter has ended now. But in the next chapter, what we are going to study? We are going to study some standard PDF. There we will see Gaussian PDF, we will see our uniform PDF, and some other kind of PDF also we will see, right? So for that, what we are doing? For that, we are studying some basic mathematics. Some basic mathematical points we are going to see here. That will help us to understand the next lecture. So for the next lecture, we are building up our concept now. Is that clear to you? So first let me answer this. First you answer this particular question. If f of t dot dt is having an area of a, basically if I solve this particular integration and my answer is a, then what will be the answer if I solve this particular integration? That will be a into a. Say yes or no. If I solve this particular integration, my answer is a. If I solve this particular integration, my answer will be a into a. Say yes or no. Basically you can put t by a is equals to alpha. So dt would be equals to d alpha by a. Sorry, dt will be equals to ad alpha, ad alpha. Then you can put minus infinity, because if t is minus infinity, then alpha is also minus infinity. If t is infinity, then alpha is also infinity. F of alpha, and in place of dt you need to put d alpha. A goes here. So what is this? This is equals to capital A only. So what is the answer? A into A. So yes, answer is A into A only. So this thing you should be knowing. Now if you have studied signal system, you will be able to tell me what will be the answer of this area. E to the power minus x square dot dx. What is the answer? Under root pi. Say yes or no. Do you remember? If you don't remember, then from now onwards you will remember it. E to the power minus x square dot dx. If you calculate the whole area from minus infinity to infinity, answer would be pi, under root pi. Okay? Say yes or no. You will be able to remember? E to the power minus x square dot dx. Going from minus infinity to infinity, that would be equals to under root pi. Okay? And how will you remember? Those who have studied signal system in a good manner, they will be able to relate. E to the power minus 80 square. What did I tell you? Under root pi by a, e to the power minus omega square by 4a. You remember this thing? In place of a, if you put 1, e to the power minus omega square by 4 under root pi. And to calculate the area, what you will do? Omega equals to 0. So if you put omega equals to 0, you are getting under root pi by a. But here a is equals to 1. So under root pi. Right? All good? All fine? Now, is this an even function? Yes. If it is an even function, then what you can do? E to the power minus x square dot dx. Right? If it is an even function, so whatever the area you are getting from 0 to infinity, the same area you will be getting from minus infinity to 0 as well. Right? Whatever the area you are getting from 0 to infinity, the same area you will be getting from minus infinity to 0 as well. So that's why I can break it down like this. So what will be the area I will be getting here? Under root pi by 2. Okay? Under root pi by 2. Because basically this is the half area, nothing else. Now from minus infinity to infinity, e to the power minus x square by 2. What do you think what will be the answer? Under root 2 pi. Why is that so? Because minus infinity to infinity, in place of x, what I am putting? X by under root 2 whole square dot dx. So in place of t, I am putting t by a. In place of x, I am putting x by under root 2. So whatever the previous answer I was getting, I just need to multiply with under root 2. So what is the answer I am getting? Under root 2 pi. So from now onwards, what you will remember? E to the power minus x square divided by whatever that is there. Whatever the number is there, that will come in the under root. Like with the practice, you will be able to remember all these things, okay? As of now, only thing that should matter you is this. If you remember this thing, then you will be able to tell this particular thing as well. And if you remember this particular thing, then you will be able to tell this particular thing as well. So e to the power minus x square by 2 dot dx. If I ask you integration from minus infinity to infinity, directly you should be able to tell that sir, this would be the answer. Under root 2 pi would be the answer, without even thinking anything else. Say yes or no. Will you be able to tell the answer? Surely you will be able to tell the answer, right? So yeah, this is the mathematics that I ask you to remember. Now there is something called Q function. It is a kind of function only. Okay. So there is something called Q function. Like any kind of function I can define, no? Like modulus function. Modulus function is fx of x mod x. Signum function is fx of x signum x. A quadratic function could be ax square plus bx plus c. So in the same manner, there is something called q function. So this is a function. So this is a function. What is the definition of this function? The definition of this function is 1 upon under root 2 pi e to the power x to infinity e to the power minus x square by 2 dot dx. This is the definition of q function. 1 by under root 2 pi integration limit x goes from infinity e to the power minus x square by 2 dot dx. I will tell you a way to remember this. Don't worry about it. I will tell you a way to remember as well. But first let me find the value of x of minus infinity. Can you let me know the value of x of minus infinity? Surely you can let me know the value of x of minus infinity. What that would be equivalent to? Put minus infinity e to the power minus x square by 2 dot dx. So 1 by under root 2 pi is outside. What this will throw? E to the power minus x square will throw under root pi. Whatever that is there downward, that will come in the under root. So what you are getting? 1. So x of minus infinity is 1. What do you think? What will be the value of x of 0? For x of 0, 1 by under root 2 pi from 0 to infinity e to the power minus x square by 2 dot dx. 1 by under root 2 pi into e to the power minus x square dot dx. From minus infinity to infinity is giving you under root 2 pi, but the limit is from 0 to infinity now. That means it is half. And why directly half? Because it is a even function. In place of x, if you put minus x, it is a even function, so simply half. So what is the answer you are getting? 1 by 2. And what about q of infinity? So 1 by under root 2 pi q of infinity. So going from infinity to infinity e to the power minus x square by 2 dot dx. You are taking the limit from infinity to infinity. If I go from a to a on a graph, how much area I am covering? 0. That's it. 0. What is the answer? 0. So at minus infinity, you are having the value 1. And then here the value you get 1 by 2. At minus infinity, you are having the value 1. Here you are having the value 1. Then you get 1 by 2. And at infinity, you are getting the value 0. So this is how the graph is going like this. Say yes or no. The graph is kind of going like this, right? From 1 to 0. So this is your q function. Isn't it just opposite of your CDF, cumulative distribution function? Cumulative distribution function will start from 0 and it will go to 1. And your q function is starting from 1 and going to 0. So kind of you will remember that it will go from 1 to 0. You will be able to remember the graph, no? At least you will be able to remember the graph from 1 to 0. What is the graph of q function? Now I am telling you a way to remember that definition. So what you will write down? So only thing you need to remember is that here e to the power minus x square will not come, e to the power minus x square by 2 will come. So e to the power minus x square by 2 will come. Now you will think that, sir, how much area this will throw? This will throw 1 by under root 2 pi area. So this will throw under root 2 pi area, but I will have to divide by under root 2 pi here, because I know that q of minus infinity is equals to 1. So in that manner, in my brain, I will think, okay, q of minus infinity is equals to 1. Now I will be thinking about the limit. So like in a longer run, confusion would be there, sir, minus infinity to x, or sir, 0 to x, or sir, x to infinity, sir, what was the limit? I don't remember. But you will remember the graph. Okay, sir, at minus infinity, the value was 1. So there is no chance that limit could go from infinity to minus infinity to x. This limit cannot be there. Why is that so? Because if x is equals to minus infinity, then it should throw the value 0. But it is not actually throwing the value 0. It is throwing the value 1. So by your own, you will think, okay, the limit has to go from x to infinity. Like in a longer run, how will you remember that? I am telling. Okay. Like my job is done here. I wrote down everything. I explained everything and my job is done. But as a student, how would I think? How would I remember? That I am telling you. Okay. So q function. One thing I need to remember, e to the power minus x square by 2 will come. And when we study Gaussian PDF, you will be able to remember this particular thing as well. No need to worry about that. The confusion will be about here what will be the amplitude. Like someone will be saying, sir, it is 1 by 2 under root pi. Or sir, it was under root 2 pi. So what you will think? E to the power minus x square by 2. Okay. So area will be under root 2 pi. So here it was 1 by under root 2 pi. Well and good. Okay. Then e to the power minus x square by 2 dot dx. Now confusion will be about the limit. So how will you think? Okay, sir, I remember the graph of q function. It is just opposite of CDF. It will go from 1 to 0, 1 to 0, 1 to 0. That means at minus infinity it is 1. So limit has to go from minus infinity to infinity. That means from x to infinity. There you go. So this is how you will be able to define your q function. In the longer run, this is how I can keep it in my mind. Otherwise, you keep on revising it and you will be able to remember the definition. So only definition that I am asking you to remember is definition of q function. Okay. Right. Now some things are there which you can keep in your mind. So basically what will happen is that this q function will be used at a lot of places. So basically in digital communication as well it will come into action, in random variable as well it will come into action, in random process as well it will come into action. So let's just say my answer is coming out to be x q 0.3. This is what my answer is there. Basically q and the value of x could be between minus infinity to infinity. So this is my answer. But in the option something else can also be mentioned, because this is just a function, no? You got your answer q 0.3, which is just a function. It is nothing but just a function. So I can define some other function. Let's just say I define some px function in this manner, that it is going from minus infinity to x, e to the power minus x square by 2 dot dx. This is how I am defining my some other px function. So I can give my answer in terms of px as well, no? This q of x could be converted to p of x as well, just by doing some calculation. We will do this kind of question, but I'm just telling that we will do all the calculation in terms of q function, and 99% chances are there that in the option q function only will be mentioned, but 1% chances are there that they will define some other function and they will say that you need to give your answer in terms of this p function. Some other function could also be there, f function could be there. So different kind of functions are possible. Are you able to understand this point? Okay. So regarding that particular thing, we are going to see something now. What we are going to see? First thing is that q of x plus q of minus x is always equals to 1. You can think about it. This is the graph of q of x. Can you draw the graph of q of minus x? Yes. This will be the graph of q of minus x. And if you add both of them, what will happen? 1 plus 0 will be 1. Half plus half will be 1. 1 plus 0 will be 1. So q of x plus q of minus x. Q of x plus q of minus x is always equal to 1. So q of minus x will be equal to 1 minus qx. So if your q of x is having some definition, so q of minus x also has some definition. So that definition is something like this. You don't need to remember this definition. Only difference is here it was going from x to infinity. Now it is going from minus infinity to x. And yeah, one more thing. Again here the same thing. Like if I am putting the limit of, if I am differentiating with respect to, if I am integrating with respect to x, and I am putting the limit in terms of x only, so this is not correct, no? So actually I should have put t here, right? I should have put t here. Why t, you understood, no? The same thing we have already seen. Like if my limit is there in terms of x, then I cannot put x here, no? Limit is there already in terms of x. So what I will put? I will put t here. So in place of everything, here I should have put t. Because some people will be having the doubts that, sir, if you are putting x equals to minus infinity here, then here also if you need to put x equals to minus infinity. But no, that is wrong. Here it should be t. Should be t. Should be t. Right? So in the similar manner, q of minus x is also having a definition. Here it was going from x to infinity, it is coming from minus infinity to x. All good? So this is the definition of q of minus x. In the similar manner, there is a function defined, complementary error function. There is something called error function and there is something called complementary error function. So what is the relation between error function and complementary error function? So let me write it down again. Basically, how will you remember? Error function plus complementary, error function plus complementary error function. This stands for complementary and this stands for error function. So error function plus complementary error function is also equals to 1. This is what you need to remember. Q of x plus q of minus x is equals to 1. Error function plus complementary error function is equals to 1. Now how these two are interrelated? So these two are interrelated as error function of x is equals to 2q under root 2x. Basically, let's just say you got the answer x of 0.3. But in the examination, what could be mentioned? 1 by 2 ERFC 0.3 by under root 2. You solved a particular question. You solved a question based on digital communication. Your answer was Q 0.3. But actually, what was the option mentioned? This was the option mentioned. So you need to click on this one, no? So you need to convert this to this one. So how will you convert? You will use this formula. So again, the second thing I am asking you to remember is this, that how your Q of x and error function of x is interrelated. Will you be able to remember? Surely you will be able to remember. And similarly, if I need to relate this thing with the error function, how will I relate it? 1 by 2 is outside. So error function, complementary error function of x is equals to 1 minus error function of x. So this is how it can be related. Because both addition is equals to 1. Addition of both of them is equals to 1. This is what you can remember. Okay. This is the second thing. This is this thing I ask you to remember, and this also thing I ask you to remember. That's it. You don't need to remember this particular thing, because your answer would be in terms of Q of x. You need to convert it into error function. So always 1 by 2 complementary error function x by under root 2 is equals to Q of x. So Q of x is equals to 1 by 2 error complementary error function of x by under root 2. Okay. So this is what you need to remember. Now in the similar manner that Q of minus x is having some definition, so error function of x is also having some definition, which is this. And similarly this is your complementary error function and this is your error function. So similarly your error function is also having some definition. So these guys are also having the definition. This definition is also there, this definition is also there, but you don't need to remember the definition. What you need to remember? Q of x plus q of minus x is equals to 1. Okay. Error function of x plus error function of plus complementary error function is equals to 1. Error function plus complementary error function is equals to 1. How q function and complementary error function are interrelated? So q function is equals to 1 by 2 complementary error function x by under root 2. So q of x is equals to 1 by 2 complementary error function x by under root 2. And how these two will be interrelated, that you can do on your own. So these three boxes that I have put, these you need to remember. That's it. The definition, just for your reference, I have put that error function of x is having this definition. Complementary error function of x is having this definition and error function of x is having this definition. They are having these definition which are not important to remember, but the relation between complementary error function and q function, this you need to remember, and the relation between error function and complementary error function, this you need to remember, and the relation between q of x and q of minus x, this you need to remember. Very easily you will be able to remember these three things. Is this okay for you? Along with that, you need to remember the definition of q function as well. Definition of q function along with the graph as well. Definition and this graph, and surely you will be able to write these values as well. Now why I did all these things? Because of this particular question. Okay. So what I feel is that this year or next year, what they can do, because in digital electronics, like from now onwards, this q function will keep on coming. In the digital electronics, completely it will keep on coming, this q function. And usually answer are always mentioned in terms of q only. But what I feel is that what they will do is that they will mention the answer in terms of p. And they will define the p like this. So what I have done here, that you did some calculation. You did some calculation and your answer came out to be q of 0.4. But options were mentioned in this manner. Options were mentioned in this manner. And there in the question only they defined p of x like this. Now what is this p of x? I don't have any idea. This is how they have defined your p of x. Your answer came out to be q of 0.4. But these were the options mentioned. Then you saw what is this P. Then you went to the question and they have defined the P in this manner. Now you need to click on one of the option. Which option you will click on? Think about it and solve it on your own. Pause the video, solve it on your own. Did you understand the question? I solved a particular problem in my examination. My answer came out to be Q of 0.4. But in the options, I saw these options. Okay. Then I saw, sir, what is this P? My answer is coming out to be Q of 0.4. But what are these kind of options? I know 1 by 2 is the value. 1 by under root 2 pi is also a value. What is this P? So for that I looked here. Now I need to click on one of the options. Which option you will click on? Do it on your own. Let me take a break and then I will come back. So do it on your own. Okay. Okay. So let's get started. So what is our answer? Basically our answer is Q of 0.4 that I am having. Now I need to convert it into P of X. So what is the definition of P of X? That is going from 0 to X, they have given e to the power minus t square dot dt. And what is the definition of Q of X that I already know? That is, sir, 1 by under root 2 pi integration e to the power minus x square by 2 dot dx x to infinity. This is what I already know. Where I need to go and not x here, I should put t here, right? E to the power minus t square by 2 dt. Now I need to relate both of them, right? So let's start from Q of X and try going towards P of X. This is what I will try. So here I can see that e to the power minus t square is there, but here e to the power minus t square by 2 is there. So what I will do? T by under root 2 I will put equals to alpha. Say yes or no. T by under root 2 I will put equals to alpha. What I will get from here? dt is equals to under root 2 d alpha. Why I am doing so? You will realize 1 by under root 2 pi. Now if your t was x, if your t is equals to x, then alpha is equals to x by under root 2. And if your t was infinity, then alpha is equals to infinity only. E to the power minus. In place of t by under root 2, what you need to put? Alpha. T by under root 2, you need to put alpha. So e to the power minus alpha square dot d alpha dt is equals to under root 2 d alpha, right? Dt is equals to under root 2 d alpha. So this under root 2 comes here. This under root 2 comes here. So what you are getting? Under root 2 will get cancelled out. So under root pi into Q of X is equals to x by under root 2 to infinity e to the power. In place of alpha square, can I put t? Surely you can put t. So this is what I have got. This is not the answer, but kind of I am reaching towards P of X, right? This thing and this thing. I am reaching towards P of X. But now the problem is limit 0 to x, but here you are going from x by under root 2 to infinity. So one thing I can see that x by basically P of x by under root 2. What will be your P of x by under root 2? So that will be from 0 to x by under root 2 e to the power minus t square dot dt. 0 to x by under root 2 e to the power minus t square dot dt, P of x by under root 2. Right? And one thing also I know. What do I know? Basically two parts I am dividing. I am trying to relate both of them. So here x by under root 2 is there, so I try to relate by, how did I try to relate? Here I put x by under root 2, or what you could have put here? Under root 2x you could have put here. Basically in place of x you could have put under root 2x. If you don't want to follow this process, now let's follow this process only. Or here you could have done the same thing, but yeah, let's follow this process only. Or we can do another thing as well, that under root pi into x, under root 2x also I could have put. In place of x I could have put under root 2 into x. Then under root 2 will get cancelled out. But this is not I am doing, forget about it. This is something that I am doing. P of x by under root 2 is coming out to be 0 to x by under root 2 e to the power minus t square dot dt. Now I know that from 0 to infinity e to the power minus t square dot dt will throw what? Under root pi divided by 2, right? Under root pi divided by 2. because from minus infinity to infinity it would have put under root pi, but now the limit is half, so under root pi divided by 2. What this will be equivalent to? From 0 to x by under root 2 e to the power minus t square dot dt plus x by under root 2 to infinity e to the power minus t square dot dt is equals to under root pi by 2. Now you are approaching to the answer. What is this? P of x by under root 2. Why did I break it down like this from x by under root 2? Because x by under root 2, x by under root 2, something I can relate. So P of x by under root 2 plus, what is this? X by under root 2 to infinity e to the power minus t square dot dt. This is your under root pi q of x, and that is equivalent to under root pi by 2. So your answer is in terms of q of x, but you need to represent it in terms of p of x. So you need to get out of q of x will be equivalent to what? So under root pi divided by under root pi in all the terms. So you will be getting 1 by 2 minus 1 by under root pi p of x by under root 2. There you go. So what was your answer? Q of 0.4 was your answer. So your Q of 0.4 will be equivalent to what? Under root pi p of 0.4 divided by under root 2. There you go. So 1 by 2 minus 1 by under root pi p of 0.4, this is the answer. So what I highly suspect is that this year the question is coming like this. All the time, all the students, everyone, what do they do? We remember all the formula in terms of Q, right? In digital communication, a lot of formula will come. We will remember all the formula in terms of Q. So always our answer will also come in terms of Q only. But what they would do, they will define some another function and they will give the answer in terms of that another function. So you should be knowing that how to relate both of them. So this is how you relate. Whatever the definition you know, you try going towards that particular definition. If that is not working, then try relating both of them, and you would know one thing, that I already know the result of integration, and then I can interrelate the things. So this is how you can interrelate. Is that clear to you or not? And along with that, what you will remember? You will remember these things: relation between error function and complementary error function. Q of x plus Q of minus x is equals to 1. Q of x and complementary error function is having the relation of 1 by 2 error function, complementary error function of x by under root 2, and then this is the definition of q of q function. So this is the most important one. You need to remember the definition of q function: 1 by under root 2 pi x to infinity e to the power minus t square by 2 dot dt. Let's meet in the next lecture. In the next lecture, we are going to study about some standard random variables and their PDF. So uniform PDF we are going to see, and quotient PDF we are going to see. So let's end this lecture here. Let's meet in the next one. Thank you very much.